Hello and welcome to Django for Everybody. One of the things that I like to do at the beginning of each class is sort of say why. Why should you take this class? Why did I make this class? And in particular, why Django? There are some questions like, ooh, why not Flask? And I'll get to that. So I just want to take you back in time a little bit. 3 years ago, I was a happy professor. We were teaching Python for our beginning users in our data mining, and then I thought it was really important to learn a second language. And so I taught PHP for our web dev. I like PHP. It teaches you like how the web really works. I taught SQL and I loved that and taught about all the good stuff. And then we taught JavaScript, jQuery, and JSON as well. And I had been building that class literally for 5 years. I had been building the graders for it, the stuff. And one of my metrics as a teacher is how far do my students get at the end of class? And so I look at 15 weeks, and what was the last assignment? And then that to me is the way I judge whether or not I've done well or not. And over the years, I try to get the students farther and farther, and I adjust the first part of the class to be more efficient so that I can be more effective at the end. And so I can put more useful stuff, because there's so much in the beginning classes that is just like, oh, the mechanics of it. And you got to learn the mechanics, and then you can apply those mechanics, but you just can't start off and say, here, cut and paste these 4,000 lines of code. It does you no good whatsoever. So 3 years ago, I had a very well-developed PHP class, and in not too many words, I was told that they didn't want me to teach PHP for web dev anymore because everybody wanted to do Python. And a lot of people were actually doing Flask in some of the more advanced classes, like our mobile application classes. So I was told to switch to Python, sort of told to switch to Flask. I've done Ruby on Rails, I've done PHP, which is pretty raw, I've done Cake PHP, which is a framework, and I've done a lot of programming with and without frameworks. And another teacher taught a class using Flask, and I didn't like how that class turned out. I looked at the end of what they were doing at the very end, and I thought, whoa, that's not very much stuff. But I started with an open mind. And so I actually had a whole year when I was teaching PHP. For one whole year. They let me teach it for the last year. That's also when I developed web applications for everybody, and that's also become a MOOC as well, which I love, and I think a lot of people use it. They use it. It's really a great MOOC. And I'm still convinced that learning more than one language is a good idea. So you might want to take web applications for everybody after you take Django for everybody. So I would go everywhere I would go. I would ask everyone that I would meet, do you use Flask or Django? I mean, luckily, 5 years earlier, there was like 25 choices in Python. But by 3 years ago, it really narrowed down to Flask and Django. There's other cool ones like Sanic that are specialized. But Flask and Django are kind of like the big ones that everybody, not Web2Py, there were so many of them that I'm like, oh man, which one am I going to pick? And that's the problem with PHP frameworks, is there's so many of them. Although Symfony and PHP is kind of winning. So I would ask people, Django or Flask? And people would give me very passionate responses. They would say, Django is the greatest thing ever and Flask is absolute trash. I would go on to the next person. They would say, oh, Django is trash and Flask is awesome. 50% of the time they would love one thing and hate the other one. It was amazing. I really got no trend whatsoever. And so about halfway through that, I'm like, I'm getting no data. I mean, I'm getting half the people love one thing and hate the other thing. And so I changed the question. I stopped asking whether it was Django or Flask, because they were saying, what do you like? I was really asking, what do you like better, not what should I teach? And so I said, look, I can only teach one, Django and Flask, and which would you teach first? And then which would you teach second? What order? And then universally, everybody just had to accept the fact that Django was way better, way better to teach as the first class. And so I felt I got really strong data on that. So I picked Django. I wanted to use Django, and in retrospect, it's brilliant, right? I've been working on this Django class for two and a half years now. And each semester I make it better. Each semester I improve the slides, and I do that thing where I try to like compress the beginning and get efficiently done with the beginning part so that I can do better stuff at the end. And I'm really pleased. And so what you're seeing in this Django for Everybody's MOOC is that 2 years of careful engineering of the class. And I'm really proud. You can go to projects.djfree.com and see some of the things that the students have built. I'm amazed at how much they can actually build on their own, and literally couldn't have done it with PHP, couldn't have done it with Flask. Django is the only way that students would be able to produce complete functioning websites with a real user interface at the end of 15 weeks. And so that to me made Django a great success. And I'll close with, I just got done looking at the most recent Python programmer community survey, and I was surprised to see that the #1 use that they had of Python was web applications, and the #2 use that they had was data applications, which floored me, because I know that Python is great for data applications and it's just super dominant. Part of the reason that it worked out that way is it wasn't like web was twice as much. Python is used for so many things, and so there was a lot of things on the list, and then web just edged out data analysis by a little tiny bit. You can be critical of Python web development, and my answer is, if it's not perfect, it's going to be perfect, because people like to write in Python and they don't want to write in Rust or Elixir or Scala. Those are harder to learn, and honestly, whatever the shortcoming of Python web development, it's going to get fixed. So welcome to Django for everybody. I really enjoyed, and I've been looking forward to the moment where this was mature enough and well enough developed to become a MOOC, and so here we are, and I'm glad to make your acquaintance. Cheers. Hello, and welcome to our lecture on dynamic web content. It may seem kind of weird to be talking about building web applications, when we start out talking about building web applications, that we're going to talk about protocols and stuff. But in a way, when you are building a web application, if you don't understand the protocol and you just sort of say, I changed this little bit of code and I hit refresh and some magic happened, you really are cheating yourself in terms of becoming a really good web application developer, because ultimately these protocols are what enable web applications, and as you go forward and use frameworks, you don't need to know all these things in detail, but when you debug your applications, you absolutely do. And I don't know if you've had your Firefox console or looked at things and watched. There's so much complexity going on, and when you're using a web application, hopefully everything works and that complexity is hidden from you. So if you have some interest in this and want to go even lower to sort of more of the network protocols, not just the HTTP protocols, I've written a free book on networking called Introduction to Networking, How the Internet Works, that you are welcome. You can buy a print if you want, but it's also completely free, like every book that I write these days. And so if we take a look at what we're going to really be talking about in this lecture and in this web application course, is the different technologies that are used to, in effect, produce a web page, right? So we have a web page over here. You go to URL data.pr4e.org/page1.htm, and here comes a page, and this is like a super simple page. But there are so many technologies, like how browsers work with JavaScript and jQuery and CSS and eventually Vue and things like that. That's a whole set of front-end technologies, and then there's sort of back-end technologies like Django or Flask and databases. And we're gonna learn in this. My focus in this class is less about how to make it all look beautiful, although that's important, and more about how to deal with the back end. So what we're going to see is these technologies that define the look and feel and the interactivity of your web pages, but also then how data and HTML, CSS, and JavaScript are served up by the remote server. And so the internet here is in the middle. The browser is sitting on your laptop or your phone or whatever, and it has all these technologies built into it. It makes requests, and then the server comes back with responses. And so the simplest version of this protocol is that you click on a tag, and when you click on that tag, you get a new web page. Now, if you watch your debugger console, you will see that sometimes it's 120 different request response cycles used to construct the page. But in a sense, they're all the same. Now, as we move to things like HTTP2, there are ways to pull down multiple documents in a single connection, but we'll stick with the old HTTP1 way of thinking about it. In the simplest form, the browser asks for a document and then retrieves the document and then shows the document, and that is the basic request response cycle. So if you look at how this works, that browser is an application running inside your computer on your laptop or your phone. That is a piece of code. And in that, it's got a connection to the screen or the keyboard or the mouse or whatever, and it's watching for events, meaning that you're going to go and you're going to click somewhere, and then this application is going to respond to the events. So in a web page, in the simplest case, you got stuff that you can click on and stuff that you can't. And you go find your way through whatever to click on part of that web page. And that click is intercepted by the application, whether it's Chrome or Firefox or Safari, running on your piece of equipment. And then that application then opens what's called a network socket, a socket across the network to a web server, and sends a request. And that request, as we'll see in a bit, is a specially formatted request. It has a GET command, and then it has the URL that it wants to get from the web server. And then the web server does a bunch of work inside itself, maybe reading disk files and running programs, generating what it is that you want. And then it sends the response back on that same socket connection. So there's like this socket connection through which all of this stuff is viewed. And so the HTML is the kind of the basic thing that comes back. As we go further, we'll see that it's not just HTML that comes back, but other things as well that come back. And so when the browser receives that HTML, then it says, oh, I know what HTML is. I've got this header 1 tag. Here, let me change the color of this thing so you can see it a little better. Yellow is way better. Okay, so when the browser receives this page, it sort of sees it and it looks at it, and then it looks at all the HTML. And so part of this course is to understand the syntax of HTML. That itself is how to build good HTML and CSS and how to make it look beautiful. But ultimately, something in that HTML plus its CSS plus its JavaScript leads to a visual display of the page, and then that's the thing that you see. And so this is the request response cycle. So up next, we're going to talk about what these network sockets are, or the things that fundamentally underlie this request response cycle. Hypertext Transfer Protocol is the protocol that browsers use to talk to servers. Now, we've used it for all kinds of other things because it turns out that it's a super simple and super elegant protocol. Now, this goes to a long time ago. This protocol was invented in 1990, which is like going on 30 years ago. Yeah, going on 30 years ago now, or more. And there were many protocols. You would have one piece of software, and there was server software and client software. You had to match them up, and then you talk to the right port with this server software. And one of the inventions of Tim Berners-Lee and Robert Caillou at CERN was that we came up with this notion of, instead of lots of pieces of software, we would have one piece of software called a web browser, and it would be multi-protocol. And so we have this thing called the URL, or Uniform Resource Locator, and we just sling these around. We just use them. But these things, this was itself an amazing innovation in 1990, because in the old days it'd be like, use this piece of software and talk to this address. So the URL captured three really important, very separate things. The first thing it did is it allowed for multiple protocols. Now, the one that you mostly have seen is HTTP or HTTPS, but that's a protocol. FTP : or mail-to : might be the other ones that you've seen. And then a host, and then a document. And that host is a domain name, which is a nice symbolic way to get a server address. And that eventually resolves to an IP address like 141.206.14.22 or something. And then the document within that server, and that /page1.htm is the document in the server. And I'm just saying before 1990, there were many protocols and we did many things. But after 1990, this one protocol, HTTP, found its way into so many awesome solutions that it's by far, other than email, the dominant protocol that we use on the internet. Like I said, it was invented at CERN by Tim Berners-Lee and Robert Caillou to retrieve documents and images. And as soon as they built it, because it was all the other protocols that came, most of the other protocols were kind of complex because we're computer scientists and we make complex things and we love complex things and we're very, very good at complex things. But this was, when the web was being built, Tim and Robert were not like, we're going to make the greatest thing ever. We're just going to make a simple thing. So they made a simple thing, but it turned out to be the greatest thing ever because different engineers would be like, oh, wow, I can use that a little different way. And it was, the grounding of it was super simple. And the basic concept was you connect to a server, you figure out where it is, you send a single command with a bit of extra data, and then you get back something, a document. It could be an image, it could be data, it could be HTML. And it was really amazing, right? And so the sockets, the underlying sockets are the things that make the phone call. HTTP is what we do once this phone call has been established. So one of the things that made the internet so successful starting in the 1960s was a radical openness, we're all around the same campfire feeling, very friendly, respectful, that still allowed criticism. There wasn't like one super genius that designed this or one company that designed this. This was a collaboration. And the collaboration was around a set of open standards and meetings to help build these standards. And they were called RFCs. They were called Request for Comments. And there was a group that built these called the Internet Engineering Task Force, the IETF. And the request for comments is a fun notion. We're looking here at a September 1981 document, which is 40 years old about now. And it's called a request for comments. And the idea is, as engineers, we might have a design that everyone thinks is the greatest thing ever, but we should always question. No design is perfect. No design is beyond question. No design is beyond commentary. And so even when they're 40 years old and used worldwide and dang amazing, we still say there is room for improvement. And so this talks about, I think this one's IP, and there's an IPv6. There's another one, if you look for this RFC that we're looking at here, there'd be IPv6, and you'd start reading it. And it's pretty dense reading, but as an engineer, it gives you all the details to build a router or build a piece of software or build whatever. And these are 100% public documents. And the idea is that no company, because literally the companies that were around in 1960, if they had said Burroughs or Sperry owns the internet or Digital Equipment owns the internet, they're all out of business because they didn't make good choices, but the market was able to make good choices. And because the commons were these open standards and open specifications, new companies like Sun Microsystems and new operating systems like Linux could come in, and even Windows could come in and participate as full participants because they just read these specs and all of a sudden they're interoperating with everybody else. This is fundamental and foundational to how the internet works. And I'm not saying you're supposed to go read them, but it's just fascinating to understand that the entire technological infrastructure upon which the internet is built is free, license-free, royalty-free, and you could build a brand new gadget and you could hook it to the internet by reading these specifications. You don't have to pay a developer's license or nothing. It's cool. Sorry, I'm just a little bit too excited about that. So let's take a look at one of these in particular. Now this is probably supplanted, but we'll look at RFC 2616. They go up in numbers, and so this is HTTP, Hypertext Transfer Protocol. And if you wanted to build a web browser or a web server, you could read this document. Go ahead, read the document. And if you read down far enough, you'll say, oh, this is how you make a request. Blah, blah, blah. It's got a header, and it's got like a carriage return line feed, and then a message body, and you got to do this, and this is what it looks like. This is how it works, right? And so at some point, you're deep in this document, and you're finding out, in this page right here of this document, how your browser is supposed to format it. And this tells both the client and the server what the rules of the protocol are. Now, it's a lot easier to just for me to tell you. So you connect to the server on a socket, usually port 80 or port 443, and then the client is supposed to make the first sound. It makes first request. It sends a line with a carriage return line feed at the end that has the characters. There's other ones, but get, GET, space, a URL, space, and then a protocol. And right now I'm using this HTTP 1.0 because I can do it by hand, right? And so you ask for a document, and then you can optionally send some header information, things like what language this person at this browser prefers, what are the capabilities of this browser, what version browser we have. So there's a series of things. You say, give me this document, and here's something about the browser that's requesting the document, including information like cookies that are being said. Now, so this, in case you want to know who is doing this request because you've logged somebody in and set a cookie to indicate that they're logged in, that's all sent on this GET request. But we'll not send the headers. There's actually incoming headers and then outgoing headers. We'll see these when we start looking at Firefox's debugging console. And so this is an entire interaction that you can do on your laptop. Now, I'm not going to do it for you, but I would note that the program Telnet that this uses has been removed from most computers. It makes me sad. They think of it as a security hole because it doesn't use encrypted connections. Like port 80 is not an encrypted connection. But ultimately, you can install, go search on your favorite search engine and find out how to install Telnet. But if you get in a command line, whether it's a Windows command line or a Mac command line or a Linux command line, and you get Telnet properly installed, you can type the following command: telnet datapr4e.org 80, and then hit enter. And at that point, so Telnet originally was used to log into computers, but if the server we're talking to and the protocol that we're talking to is simple enough, and in this case HTTP1 is simple enough for us to be able to do this, we're actually talking to the server, because remember I said that these are applications. Your browser is not talking to files. Your browser is talking to an application on a server, and the server might give you back a file. So it's really talking to a piece of software, and we'll see this in more detail in the next section. And so what will happen is, because the HTTP protocol requires that the client speak first, we have to type. Now, if you can get this working and type wrong things, and type a couple enters, new lines, you will see that you're talking to a piece of software, and it will say, you have violated my protocol. You're not talking to a thing that has any online help or user interface or anything like that. You're talking to a server, and your job is to request some data using the proper format because you read the specifications about the proper format, right? So in this particular one, it's easier to cut and paste this, because some of these servers, if you don't type fast enough, they'll be like, you're not a software, you're a human, quit playing with me. Like you talk to Facebook or something, and you can talk to Facebook and see what happens on port 80. And it will time you out really fast. So it's good to have a cut and paste buffer. So you paste this get command in. And the other thing that's important is you got to put an extra blank line. And this extra blank line is to indicate that you're not going to send any of those headers. If we were going to send things like what language we would prefer or what formats we would prefer as a browser, the browser has certain languages and other configurations and login information, and that can get sent up to the web server along with the request for the document. And we would be able to type them in here. But we're not going to do that in this very simple. We're just going to say enter, which means no more headers. If you were putting in headers, you type header, 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 and then enter on a blank line, and then the server would know that our request was finished. But we can just ask for a page, and then what the server does is it sends us back two pieces of information. First, it sends us headers. The first header is HTTP 1.1 200 OK. That's actually a status line. Now, you'd have to go read the documentation on what that works. But for example, 200 means that you got a document. Another one that you might have seen is 404. It might say 404 not found. So if you go to a web page and it doesn't exist, something will say 404 in your browser, usually, unless it says, here's a search box, go find it. But there's a status, and so the thing that you're typing, page1.htm, may or may not be on this server. If it is, then you'll get a 200 OK and the data, or you'll get a 404 not found. And then we get some response data, some header response. And this header response looks pretty much like the same format of the data we would have sent into the browser if we were sending things like that in there. Here it's what the date is, what the server we're using, last modified, and one of the important things is what kind of content are you about to see. Content type in this case is text/HTML, which means the thing coming next. And then there's a blank line, and the blank line is our indication as we're reading this data that we've finished the header, which is really metadata about the page we're retrieving, and the actual page itself. And so the rest of this page is the actual data, and we know the format of it because we were told before the page starts. This could be image/PNG. This could be XML, application/XML. Then it could be JSON. It could be like anything. And then the browser is supposed to, and if this was an image, it would be like garble, 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 right? It would be all garbled stuff that we can't really see, but the browser knows what a PNG or JPEG looks like, and it shows it to you. And it basically uses this text/HTML to tell you what's going on. And so this then, your browser has read all this information. It has both the metadata and the data about the retrieved page, and then its job is to sort of produce a pretty rendered version of the page and show it to you. And that is the request response cycle. Again, you don't have to do this. You can just sort of believe that it's done here. But if you want to install Telnet on your system, it's not a bad thing to install Telnet. It's kind of a classic, fun thing. It's far less useful than it was in the early days because we used to use Telnet to test everything. Now we've got like browser developer consoles that are way easier than Telnet. But it's kind of a cool thing. Feel free to do this, and you'll be like, I know what's really going on. And so I'm a big fan of using the console, of using the terminal, of using text-based interfaces. I think they're actually way more accessible. I think it's awesome. And in a way, all these fancy graphical user interfaces distract us from the simplicity of what's going on inside of computers, because you think, well, where's the button? And the answer is, oh, there's probably some command inside this computer that does what the button does. So I have a former student of mine who actually wrote the scene in, I think, maybe it was Matrix 2. I think this was Matrix 2. Yeah, Matrix Reloaded. And this scene where Trinity is breaking into the power grid and she is using the console. And it turned out that the way this scene was written is it was written exactly as a hacker, whether that's a hacker with bad intent or good intent, because there are hackers with good intent who are trying to break into your system so they can tell you, you pay them to break into your system so that they can tell you your vulnerabilities. But you can take a look at the analysis of this little scene, and just this sort of is just one of the cool things about me teaching people about how to use the command line, and increasingly me teaching people about how to use Linux. I really think that it's okay to know your Mac and Windows command line, but really increasingly the world in the server world, and we're starting to work on web servers in this class, and you might as well start learning some Linux because that's an important skill. Just writing some Java code or Ruby code or Django code, that's a skill, but knowing how to start the server, debug your application, find log files, etc. in the command line is really important in real production systems, because we're going to play in some simplified environments to make it a little easier, but those simplified environments go away once you go into real production in a real job. And so I'm really into teaching you Linux, command line, etc., etc. So up next, we're going to show you in Python, in effect, as few lines as I can possibly show you, how a browser works, how a browser sends the HTTP protocol, how a server reacts to the HTTP protocol and returns documents. So that's what's coming up next. So network sockets are like phone calls for computers. And literally in the 1960s, when they were designing the concept for network software, that is the concept that they came up with. And that is that, in a sense, we make a call, we talk on the call, and we hang the phone up. And as as computers were going to share data, and some computers were going to have data and other computers were going to want data, they thought, oh, the way to do this is not necessarily have a permanent connection to that data, because there's going to be so many computers and so many sources of data and so many computers that want to consume those data. And of course, in 1960, they had no imagination that there would be billions. They just thought there would be 10,000, and they thought that was a lot. But they came up with a protocol that basically said, when you don't have continuous permanent access to data, you actually make a phone call, you know where the data is at, you kind of say, you dial up, you grab the stuff, you get it back, and then you let the connection go. And so it means that with billions of computers, each talking to each other, the network isn't so complex. And so there's this connect, talk, disconnect. Connect, talk, disconnect. And it's the way the phone system in our world scales to all the people, and it's the way the internet scales to all the people that want to use that internet. So this is made inside of software using an abstraction or library called sockets. And sockets really are computer phone calls. You know where you're going to call. You can start the call, wait for them to answer. Once they answer, there is a two-way communication. It's kind of like a file, except that you can simultaneously read from the file and write from the file. Although it's important for the two cooperating pieces of software to know who's going to read first and who's going to write first, because it's like if, when you pick the phone up after it rings, we all know to say, hello. And that's kind of a protocol. Who talks first is a protocol. And then the person goes like, who is this? And then eventually conversations happen pretty naturally. Somebody talks, listens, someone else talks, listens, and that works. But there's complicated protocols. And you can think of this not necessarily as the browser on your laptop or phone as talking to data on the server. It actually is talking to another program. And so even when it's just retrieving a file, it's talking to an application on that server, and that application is reading the file and sending it out. And we'll see that eventually, how we have to do that when we're doing things like uploading pictures. We upload pictures and then we have to actually serve them back out. We can't just say, oh, the pictures are there, you can grab them. Because sometimes not everyone can see every picture. And so part of the software application decides, if you are allowed to see this picture, I will send it. If you're not allowed to see the picture, I will not send it. And so that's where it's a piece of software that you're talking, even if you're looking at a picture. Sometimes that software is really simple and you barely notice it. But there is software in the loop. It's not like you just go straight to data. It is really two pieces of computer software talking to each other, and we use the internet as that intermediary to allow that conversation to happen. So if you read my book about the TCP/IP, you'll learn this in super great detail. But every computer has an IP address. It is a number. There are two kinds of addresses. There's IPv4 and IPv6. IPv4 version 4 is the one that's got 4 dotted numbers, like 142.16.42.14. But within each of those, they have what's called a TCP port number. And because this whole internet thing is applications talking to applications, we need to have a good way to know which application we're talking to. And that's where TCP port numbers come in. And you can think of this as like a phone extension. So you have a phone number and then you have, extension 1436. And so TCP port numbers are like that. So we can not have a specific address for every application, but an application that has an address and a port within that address, or a phone number and an extension within that phone number. And so you can look these things up. Port 25 is used for email, server-to-server communication. In the old days, we used this thing called Telnet. We'll talk about that on port 23. And so the client is on the right-hand side, and it might be a computer where you've got a keyboard and it's you, or it might be a server that's got some mail that's being forwarded from somewhere. And they all talk and they connect to an IP address. In this case, 74.208.28.177 is the IP address of this computer. And then port 25 is the extension where one computer sends email to another computer. And each of the arrows in between them is a separate protocol. So if you're talking to an email server, you expect to talk an email protocol. And if you're talking to a login server, you have a login protocol. That's kind of the simplest one. Or a web server. Web server can be on port 80 if it's unsecure. Preferred, of course, is HTTPS, which is on port 443. If you have a mail application like, say, Thunderbird that's reading Gmail, it talks to ports 109 or 110 or a couple of other ones that are ways for a mailbox application to talk a protocol to a server-based mailbox to retrieve the new messages or delete a message or view a message or whatever. So there are these ports on servers that have protocols, and then we can build software on our clients that talk these protocols. The one we're going to be playing with the most in development mode is port 80, and in production mode, port 443 for the HTTP for web documents basically, and web application documents. So up next, we're going to take a quick look at the Hypertext Transfer Protocol. I always want to call it Hypertext Transport Protocol, HTTP, and that is the protocol that we talk to port 80 or port 443. So now we're going to build a very simple browser and server in Python. Okay, so we import a library, import socket, and that just like import math or import whatever, that pulls in a library into Python. Sockets are built into Python. It's very cool, and it's very, very simple. So sockets kind of function like files, but they're files that we can send data to and receive data to. But when you're using a file in Python, you've got to first open it. And so the opening of a socket is really a two-step process. First, you create the socket, and that socket sort of lives in your computer as an endpoint that's not yet finished. It's the endpoint that you're going to send and receive data to inside your computer. But then we have to actually make the phone call. So socket.socket, and don't worry too much about this syntax, we don't change it. Socket.socket basically says make a phone. That's what we're making. And then mysock.connect, that second line, is dial the phone. And we're dialing the phone to a domain name, data.pr4e.org, and a port in that domain name. So that is the call. Now, if we made a mistake, right, if we were dialing and not talking to the right server, or that server didn't exist, this connect would blow up, meaning we'd make a phone call, a data phone call to a server that doesn't exist. That line is what's going to blow up. But as you continue down to the next line, if it gets that far, now you put try and excepts around this if there was but I want to keep this really short, so I'm not putting in all the stuff, all the error checking. So connect might blow up. Socket.socket won't blow up because it's like, unless you don't have networking at all in your computer, but it's unlikely these days. But mysock connect is like dial the data phone to this endpoint, and it includes the port 80 that we talked about before. And now we need to send a command. And in this command, it's exactly what we talked about before. It's exactly what we sent via telnet. It's a get, followed by a space, followed by our URL, followed by a space, followed by a protocol HTTP/1.0, and then we hit the enter. Now it turns out in network world you actually hit two things. It's the /r/n is a return and a new line. And you have to hit it twice, the enter at the beginning of the first line, and then remember we had to put that blank line in because to say no headers. Now we would put in between here, we'd put all our headers in there if we were going to do that, but we're not going to do that. And then you have to use encode, and encode means that the data sent across the internet is generally sent in what's called UTF-8. Inside of Python, the data is in Unicode, so that you can put literally any character in a Python string, and then preparing it to send it out across the internet, we kind of encode it into the more dense more compressed UTF-8 format, rather than we don't send strings across the internet in Unicode in general. I mean, it's very rare, but you'd have to control both ends. We want to send them in UTF-8, and so the string get blah blah blah, that's a Unicode string in Python, and .encode says convert this into a UTF-8 string, and so command cmd is a variable that has a UTF-8 string in it. And then we say send. Now remember I said that you can simultaneously send and receive on these sockets, but the protocol tells us whether the first thing we're supposed to do is listen or talk. And we're the browser in this case, and so we're supposed to talk first. So we send the request out, and that's just like you typed it in Telnet, because in effect you're scripting Telnet. Telnet, we liked Telnet in the old days because it was kind of like a socket. I could connect to any host, any port, and type things and see if it's broken or not. And then the protocol says once the server has received the first line, any headers, and then the blank line, then it's to return it. So then the next part of this is we're going to have a little loop. So the protocol tells us we are supposed to receive data until the socket's closed. And at the bottom of that telnet, you saw that it sent a bunch of lines, like 4, I think, and then it closed it. That's what's going on here. We are retrieving data, and then this receive, this actually waits. If the server is coming slow or the network is slow, this piece of Python will be sit. Oh, got a little bit, up to 512 characters. It will wait until it's gotten 512, or it's done and it's got 100 or so. But the receive is a blocking, waiting operation in Python. It says, give me up to the next 512 characters. Now, usually the network's so fast that the Python doesn't even wait because the operating system already has it. But we get it, and if we get no data whatsoever, that is our indication that the network connection, the socket has been hung up on, closed by the remote server, and away you go. So that's why we are going to break if the length of the data is less than 1. And if not, we're going to simply print out the data, but we're decoding it. And that's because the data that comes in is in UTF-8, but the print statement wants to print Unicode. And so decode says, here's a variable that has UTF-8 in it, convert it to Unicode for printing inside of Python. So because this data is externalized to us, we encode it before we send it, and we decode it when we receive it before we use it, because Python inside itself doesn't use UTF-8. Python inside itself uses Unicode, which is awesome and a whole separate conversation. I'm just kind of bringing that up to remind you how important it is, because we're not going to write much of this in Python, really, and all this stuff is taken care of for us in web servers when we get to that point. But it's just a good time to review Python's strings and Unicode and encode and decode, because it's really important. So if you run this and you've got it right, it runs pretty simply. Let's get the color back. Get back to yellow here. So if you run it in your system, Python socket1.py, all the work is done up here before you see your first output, and then all this output that you see is just this loop running. And what you see is really the exact headers that are coming from this server, and then you see a blank line, and then you see the actual page that's coming out. And you don't see it, but at the end here, the connection gets closed, and you break out, and you're done. And then we close our end of the socket. The far end was already closed. That's how we know to stop reading data. And then we hang ourselves up so that our local system does not end up with a bunch of half hung up phone calls. And so that's basically how we talk to a socket in Python. Now, that was literally 10 years ago how I would debug applications. I would like telnet or write a little thing like that and dump all the headers. And that got really tiring, really boring, really tiring. And so browser developer mode is going to be your friend. In a way, browser developer mode, and I'm going to have a separate video on this, browser developer mode lets you look at the sent headers, the received headers, the received data, the sent data, what URL it went to, and it's super awesome, especially because a lot of web pages have like 40 to 150 request response cycles. So you don't want to debug them all by hand. You just let the browser do its thing and say, what was that second one and what went wrong in the second one? I spend a lot of time when I'm debugging web applications using the developer mode, and that's why I have a special little video that gets you familiar with it. And I tell you, by the time you've done web stuff for a little while, you're going to know your browser developer mode. So next we're going to talk about writing code in the server to respond to these requests. So we build a browser in Python. It's time to build a web server in Python. So remember that what we've got here is we've got, the browser is an application, and we've made this a Python application now that sends this GET request. So we have effectively, like I said, built the world's simplest browser, and that sends a GET request. The server does something, and then it sends the response back. And now we're going to kind of change this, right? We're going to assume the browser exists, and it's like, okay, because we're going to be the server folks, right? So now we're going to look in greater detail at what goes on in the server. And so here is a very, very simple web server. It's a few more lines than the simplest web browser, because we have to put a little bit of error checking in with some tries and accepts. Okay, so let's walk through what this code does. Okay, let me change the color again to black. If you're from Microsoft and you can tell them to make a key to change the color on the scribbler, I'd greatly appreciate it. Oh, and then I went down a page too. Okay, so we're going to pull in some more stuff from the socket. We're going to pull in some stuff from the socket right here, and so we're going to make a function called create server that we're going to call right down here, and it's going to print out how you're supposed to access it and then start the server. Now the whole idea of the server is the server is woke up to wait for incoming connections. So the server already exists. So when you start talking to a web server, that server's in that computer already. The server software is already running, registering its interest in incoming request. So that's what we do. So when this Python program starts, it's going to sit there and wait in an infinite loop for incoming requests. So the first thing we do is we're going to make a socket. This looks very much like the time we made. It's an endpoint. It's not actually making the phone call. Remember I said this socket call is making the phone. So we're saying we're going to make a phone, and it's up to us later to decide if we're going to make a phone call or receive phone calls. And then this next thing is like the connect, except this is I am willing on port 90 to receive the phone calls. Now it turns out there's only one program on port 90 that can receive phone calls. So this might blow up. You might try to do this, port 9000. And if you run this twice, and you can do it in 2 windows on your computer, the second one will blow up and say, you can't have port 9000 because another piece of software has it. But as long as there's only one running, away you go. And that's part of this whole try except thing, because if you run this twice, it's going to blow up the second time, because you cannot receive phone calls on this server on port 9000 with 2 applications. One application gets the phone calls. That's what socket listen says. The 5 on there says, dear operating system, if I'm busy handling 1 phone call, you can hold on to 4 more and queue them, and then I'll come back and get them for you. And that you're asking the operating system to queue incoming calls. Don't just say you're busy, shut down. If you didn't say this, listen 5, if you were busy writing the data for phone call 1 and phone call 2 came in and you weren't ready for it right that instant, it would just deny the phone call. So that's what listen says is, dear operating system, hold those temporarily, I'll get back to you, which is how it works. And then what happens is we go into this accept. Now this accept is, I'm at the phone, I've registered what my number is and what my extension is, and I'm ready to pick the phone up. Let me know. So this accept is blocking. It stops, and it just sits there. And it can sit there forever. Just literally forever. If nobody calls it, nothing happens. The next line never runs until you blow it up or the server goes down. So that accept is a blocking. And the reason we do this accept, well, we have to establish the phone call first, right? So then this next line runs only when a phone call is received. So that means that on the browser side, we already connected, we made the phone call. Now we haven't sent any data yet, right? And so this is just now, at this point, somewhere out there's a piece of client software that has done a socket.connect, and we have done accept, and our accept has succeeded in the server, the connect has succeeded, and we are ready to talk. So the phone call has been made. Now the question is, who's going to say hello? And this is where the HTTP protocol solves our problem. The server knows that the client must speak first. So it just does a receive. Now you'll notice the receive and the send are the same function calls because it's a two-way thing. Whatever the browser is sending, the server is receiving, and whatever the server sends, the browser receives. And they can do it simultaneously if they can figure it out. But usually you kind of like say, it's your turn to listen and my turn to send, and then I'll listen. And usually they kind of go back and forth. In this, there's only one step. The server listens, gets the GET request, sends the data back. And so then we're going to read some data, and we're going to get 5,000 characters. We're going to get the whole thing. Remember, it's one line. It has a GET request in it. It has the optional parameters in it. And so we're going to split it. Now again, we've received it as UTF-8. We've got to decode it for UTF-16. I mean, not UTF-16, Unicode inside of Python. And then we split it based on new lines because the GET request is on one line, then header, 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 and then the blank line to tell us that we're into the headers. And we're only going to take, in this, we're just going to look at that first line. We're not going to do anything with it. Most servers actually look at the line to figure out what document to send. It's a very simple server. It sends the same document no matter what the URL is. All we do with the URL is we print it out to prove that we got it. And then we construct a response. And in this response, again, go back to RFC 2616 and it will tell you what this response is supposed to look like. It sends back a 200 OK. Remember, this is all the stuff we saw. Probably I cut and pasted it from a working thing. We tell it that we're sending it back in content type text HTML, the character set UTF-8. Remember I was telling you that. A blank line, and then some HTML. HTML body, hello world body. And I'm throwing in these /r/n's, which is the network's version of new lines. And then you will notice that I encode it before I send it because it's Unicode inside of Python and it needs to be sent as UTF-8 because the phone, when you're in a socket, the thing that's going across the socket almost always is supposed to be UTF-8. So we encode it. And then because the protocol says so, as soon as we send the data, we close the connection. Now remember that the client had to close the connection too. So we close it, it's half closed, and then the client gets all of its data, gets the indication that it closed, knows it's finished all the data, and then the client shuts its side down. And so there are two hang-ups. It's kind of like a phone call. The person hangs up, and then click, you hang up. Now you can't really keep talking, but you do want to have both sides hang up, and that shutdown is what's going on. And then the rest of this is all try except for various things. So we clean up our socket so we don't have to restart our server when our software blows up. And so the rest of it's pretty simple. And then, so this while one, the first browser will talk and then it'll send some data and then it'll go back and wait for the next phone call. And that's what's going on. The next phone call comes in, it sees a GET request, it sends the data back, then goes and waits for another phone call. So this is an infinite loop that sits and waits for incoming phone calls, and it answers the same thing. So it's like you call this phone number, and it goes, and you go, I would like a pizza, and it says hello world, and then click, and then you call it up and say, I would like a car, and it says hello world, click, and then you say, I would like to register for this class, and it says hello world, click. So this is not a very flexible server. You will build far more flexible servers. But it's the one I could build and fit on a single page in a slide deck. So to run this, if you you download this code, and it's a tiny bit of code, and you run it, so you go somewhere, maybe your laptop, maybe Python Anywhere. I don't know if it works on Python. It probably doesn't work on Python Anywhere because you can't actually talk to ports. But let's just run this on your laptop, and you start the server up somewhere, get a hold of my sample code, or download it from here, server.py, and it's telling you this is just output from the server. And this is the moment at which it's waiting, right? It's waiting. The server could wait for hours at this point. But I just give you this in a print statement so you can copy that and put it into your browser. So you paste localhost 9000 into your browser, and then the server is printing that it got a GET request for the / document from this browser. That's what the browser sent. I mean, we're talking from Firefox browser to the little web server that we just built. Now there's a second GET request that you don't even know because you didn't ask for it, and that's because the browser is built in to ask for a URL called favicon.ico so that it can make an icon, and that icon ends up in the tab or wherever in your browser. And so that's like an icon for the website. So you didn't ask the browser to do this, but it's a thing browsers do. And you'll see when you're looking at your debug logs, when you're building stuff, that it's a favicon. And so this happens like blink, blink, and now it's waiting again, right? And you could hit refresh, or you could go start a different browser, and you would see these GET requests. Every GET request you're going to see in your browser and your server. So it's working, and it works really well, and you're welcome to go ahead and play with it and try it all out. So now what we're going to do is build a simple web client, and that'll talk to our server. So the other web client we made, talk to data.pr4e.org, this one is going to talk to yourself. So it's this, it almost looks identical, right? We're going to make a phone, we're making a phone. We're going to connect to localhost. 127.0.0.1 is the IPv4 connection, what's called loopback, right to the same host. We're talking to port 9000 because that's where we've got our web server running, that little web server we just wrote. And then we're going to send a GET request, a valid GET request to this thing, HTTP10, and then 2 new lines, and we're going to encode it into UTF-8 before we send it. Then we send it, and then we just have a loop that prints it all out, and then when the socket gets closed, we hit a break, and then we close our end of the socket. So the server clicks the phone, and then we're done with our data, but we've already printed it out, and then we hang up the phone on our end to kind of clean everything up all the way in between everything else. So this is a very simple web client. And so now you can run the web server, right, just like we did before. And instead of talking in a browser, we run this client. And this client gets a header of HTTP1 OK, its content type HTML, it gets a new line, and then the body, and we're done. Now, I mean, it's not a browser, but it is a client that's talking HTTP. And so now you'll notice that this server sort of sits and waits for incoming calls. You could run this over and over on the client, run the client over and over again, right? And then you would see more requests. But in general, the server is destined to just sit and wait for hours potentially until a client connects to it. And then at some point, you'll just abort this server. And then if you Control-C or blow this up somehow, this will fail. The client will fail, and it will fail. It will fail in this connect code. So if you want to play with it, try to run this client without running the server, and you'll see that the connect, which is the part of actually making the phone call, this will continue to work, which is make me a phone on my current computer, and then connect is make a call to the remote computer. That will blow up. And then if you wanted to play with this, you could put some try and accepts around it, say remote computer is not responding on port 9000. That's if you blew up. You could put a try and accept around that. But I'm not doing it because it don't fit on my slides. So here is an even simpler web client that we can use. And again, you can get this code from my sample code. We don't talk to this. There's a higher level thing that so the previous client talked to sockets, so I could show you the low level. But because we spend so much time talking about to URLs, we then have a URL lib. So I'm just going to use URL lib. And this could be a local host or it could be whatever. I'm just going to make a 4-line URL lib call. And so I just do a URL open of that same URL. Now we're operating at the HTTP level because the concept of URL is not a socket concept. The concept of URL is HTTP concept. And we just get, in effect, what looks like a file handle to us, and we loop through it and print it all out. So we run our server, and the server sort of says this and waits. And then when we run our client, it basically hits our server, and we can see in the server window. You got to do these two things in 2 windows, right? You got to do these things in 2 separate windows. So in the server window, it'll sit and wait, and then in the client window, when it runs, you'll see the client will make the request to the server, or blow up if the server is not running, and the server will see the GET request, and then the data will come back to the client. So you sort of do this in 2 things, and you can run the client over and over and over again, and you'll see every time you run the client, the server sees it, responds, and away you go. And again, our server always says hello world no matter what, which is delightful and classic. It's a classic. So you actually can watch when you're running Django. There will be a way for you to see when you're running Django locally and you start the server up. This managed we'll do this later, managed pi.run server, and then you talk to it and you will see all the GET requests. And so Django, when you run it locally, you can debug a lot of what's going on. So you can see like the favicon that it's asking for, and that is 5 or 6 HTTP requests to produce that little Django web page. And so that will be something that you will learn how to do. And so that sums up what we're doing in this. At the beginning, you look at it very simply. Pretty soon, you'll just be looking at the developer console, and it'll all make sense to you. I want you to be able to know that you can dig as deep as you want to and understand all of these protocols that are going back and forth. Okay? Cheers. Hello, and welcome to another walkthrough for Django for Everybody. In this walkthrough, we're going to talk about the browser debugger console. And so this is something that in the old days was only in Firefox, but eventually everybody built it in, and you used to have to build a plugin. And it shows up at different places. And so in Firefox, it's here under Tools. It turns out that you can kind of go to any of these things because these are they're just different tabs here. In Chrome, we do View, Developer, JavaScript Console, and then you see a similar kind of thing here, right? So I'm going to do it in Firefox here. And so you can see things like you can see the document object model, you can see the JavaScript console. This little error hardly matters. It's because it's such a simple page. You can actually debug JavaScript code. You can watch the network. You can play with CSS, etc., etc., etc. Performance cookies are in here. So there's a lot of things that you can do. I'm going to start and show you right now. We're at the very beginning class. I'm just going to show you some of the most basic things here. I'm going to clear this out and then refresh the page. And so what you see here is you see each request response cycle, right? And so I came up here as if I type this. Let me clear it again so you see it. I'm going to type this. I'm going to press enter. And that tells the browser to go retrieve this page. So it connects to the server, www.drchuck.com, and gets the document page1.htm. This favicon.ico, that's basically getting this little favicon right here. That's the little thing that shows up in the tab bar. And so websites can have a file, and later we will actually make a favicon. But what I want to show you from a request response cycle is you can see some detail here. So let's go up here, and you can see detail. You can see that this was the URL. We sent a request, a GET request. We got back a status code. The status is the first thing. 200 is an OK. 404 is not found. And we used HTTP version 1.1. The request headers, they always show you the request headers, response headers first. So these request headers are actually part of the HTTP protocol where we are telling things like what my preferred language is, what kind of documents we can handle, and cookies that we're sending back in. We'll learn more about all of this stuff. And so this is actually when the browser makes the connection to port 80, sends the GET request to the URL it's interested in, GET http www.drchuck.com/page1.htm space http 1.1, and then after it sends these, and this is pretty much the format, accept colon blah blah blah, and so that is and then it sends an empty line, and then it's done, and then the browser sends back first a set of headers. What the content type is very important. The size is sometimes in here. gzip means that it compressed it on the way. And so these are the response headers. And so if I go to an error page, not a page.htm, So now I'm going to clear this. And what's happening here is it's putting up a page from my hosting system. But the most important one here is this, and that is the 404 error. And so it was going and it sent a GET request to http://drchuck.com notapage.htm, and it got back a 404 not found. So that was that 404 not found is a different status code that said this is a thing that's not there. 500 means the server had an error, and we'll talk about all these codes. But the point is you can debug all this stuff quite nicely. So let me go back to page1.htm. So let's clear this and refresh it to make sure we got it all right. Okay, so we grabbed the page, and now I can, another thing that you probably by now have figured out to be able to do is inspect element. So now you're actually looking at this document object model, right? And so this document object model is not necessarily the code that came back from the server. If I go here to network and I click on get and I look at the response, this is the response down here. This is what actually came back from the server. And then the browser parses this and turns it into what's called the document object model. So this is the source. Now, just as for fun here, you'll notice that I can change the document object model here, right? If you are cool, you can switch to the second page. So you'll notice the document object model changed, and what I saw up here changed as well. And so this is like inspect element. I can do something like, I can even add here, I can add some CSS, style equals color :red semicolon. And if all goes well, there you go. You see I switched the color. This is the document object model. Now the server was completely uninvolved in that. And later we're going to write a lot of code to mess with the document object model. So the server is still, it doesn't have the red in here. It didn't change this to cool. So this is what we originally got from the server. And this is what we've got in the browser. And so once that page comes from the server, you or JavaScript can mess with that page. So it's pretty dang cool. Okay, so now I'm going to clear it, and I'm just going to click on this second page, which is an anchor. Let's inspect it. Well, it's an anchor tag, and so it's going to do another GET request. And so this time it went and grabbed page 2, and there's the second page. And you can go back to the first page. And so there's a lot of things that you can see. This persist logs is an important feature. That means that it keeps them crossed more than one request, and disable cache means that sometimes the browser wants to keep a copy of something, and you, while you're debugging, you want to say, hey, go get the original every time. And so this, right now I'm starting you on very simple pages, but if you take a more complex page, and I can never remember where it is, view, developer, network, let's go here. If you take a more complex page with a bunch of things in it, and you hit refresh on this page, you will see that it does a GET request, but then as it parses that GET request, it finds things like all kinds of stuff, right? So here this took 44 response cycles, 1.6 megabytes, and it took almost 1 second to download all that stuff, right? It took a second to download it. And so if you scroll all the way up to the top, the original GET request was to this URL, which is /lessons/rrc, which is the URL. But then if you were to look at the response, and I don't want to see that, I want to see the actual HTML. So if you look at the response, you see all these URLs for more stuff, some CSS or from JavaScript, some who knows what. And so then what you see is you see it then retrieving all these other things that it needs to actually construct the page. Some CSS, grabbed a font, it grabbed jQuery, it grabbed time ago. That's a little thing like, and then grabbed a bunch of JavaScript and fonts and this, and then the translate. So you see this little translate thing? It's doing that. And so you'll see that's how it quickly builds up to about 44 request response cycles to produce a page. Now, so that's just my quick introduction to this. You may not see these little drop downs like this. You might have to turn them on in preferences. So you go into preferences somewhere. I turned them on a long time ago. I probably couldn't even find it, but you might see it. The other thing that I would suggest is don't use Safari. because Safari's trying to hide too much stuff. Like, it doesn't even show you the URL unless you click on it. So Safari's kind of a pain in the neck. And so I would suggest that for this class, you either use Firefox or you use Chrome in addition to using Safari. Safari is fine for daily use, but I just find it as a debugger, it's bad, which is really sad for Safari. They made Safari unfriendly to software developers, which means we're not going to test our stuff on Safari, which means if it breaks, too bad. Okay, well, enough of that little Safari diatribe. Again, I hope that you found this walkthrough for Django for Everybody, as usual, helpful. Cheers. Hello, and welcome to this lecture on the structure of a Django application. It's a little early to be going through all the detail, and there'll be some things that we're not really going to understand until a little bit later in the course. But I wanted to sort of show you the lay of the land so that as we add features, you realize that there's sort of a method to the madness. And so Django is a way of building web applications. Django has a pattern within itself that it organizes folders in a certain way and puts files in certain places. And we're going to build these projects and applications, and you're like, why are these things organized the way they are? Well, it has to do with the fact that if you go from one Django project to another Django project, you can fit right in and understand how things are going to work. So the important terminology that's, a bit frustrating is there is projects and applications. And from Django has this notion of you have applications, and you might have a project, which is really basically a website, and then some applications. But if you had two projects, you could share applications between them. And so it's one or more applications per project, with the ability to potentially reuse a application across multiple projects. And so we're going to work with my DJ4E samples, which I hope you have downloaded somewhere, at least so that you can look at the files, look at the folders, look at the names of the files, and look at the contents of the files. This will all make more sense when you get a little farther down the road. So here is an ls statement, ls-l, DJ4E samples, and hello. This is within the folder DJ4E samples. There are two basic folders. One is, in effect, the project-wide settings, which is the same name as the folder that we're in. So it's DJ4E samples / DJ4E samples. And then there's the first application, which is hello. And there's a couple things here, like the __ init.py. You'll notice it's an empty file. It's just some bookkeeping that helps Python know that there are files that contain classes and objects in here. Settings.py and urls.py and wgsi.py is kind of like the traffic cop for this entire application that routes things coming into the right, this entire project that routes things to the right application. And then within the application we have some files. And you really are going to learn a lot about object-oriented programming because all these files contain objects. So Django is a large piece of software, and you change its behavior by defining objects that accomplish things and then in effect registering those objects. So a common thing will be to take something like admin.py or models.py, create a data model, and then tell the admin user interface that you didn't write how to show your model, and so you write stuff in admin.py to communicate into the admin user interface how your data model that Django currently knows nothing about is supposed to be shown, etc., etc. And so there's a lot of files, and we will talk through these files. Now, this is an example of a request response. It's a web application, and so what we'll talk about is once a request makes it into the server, it's going to do some work and then produce a response. But in that, we're going to look at all of the work that goes back and forth. And there's effectively like a routing step where it picks what part of your application to route this request to. There is a view part, which is going to receive it and potentially store data. Some would call that the model. The storing of the data is certainly the model, but the receiving of the possibly new input data, like you're going to create a new thing, that would be the model. And then the view, at some point you got to finish it and send something back out, and that's the purpose of the view. We call this pattern for building web applications, model view controller. And it's not like you can't build applications any other way. It's just by saying, it's a terminology that I can say going forward, that's the model, that's the view, and that's a controller function. And you don't have to know it right now, but these are words that they're loaded and have valuable meaning to us to be able to do. So at some point in this picture on the left side, we have a browser. DOM stands for the Document Object Model. And at some point, the person clicks somewhere in the current web page they're looking at, and the web browser intercepts that and says, oh, okay, I've got your click right here. The web browser intercepts it and then makes a socket connection across the internet, which we've seen before, and then does a GET request. And that is what then goes into the server. And so the three functions are the routing, the views, and the models. And there is an overall configuration file, the settings.py, which is sort of how you just say, oh, here's my view files, read these view files, read these model files. So the settings.py kind of controls everything. But when a request first comes in, it consults urls.py, and then for the project, and then it will include urls.pys from each of the applications. So once it's chosen what view to run, it looks at the URL, pulls out the pieces of the URL, and finds the views in views.py. That's a Python file that has the destinations for these incoming URLs. There's a file called forms.py, which we'll see later, that is used to make the forms aspect, the part that you fill in, as pretty as possible. And then we take the resulting data that we're going to send back and we merge that in through what's called a template. And then if there's any data that we need stored, we call the model and we store that in a database. And there's this file called model.py, which informs how we store data in the database. And then when that's all done, we read potentially new data from the database, merge that into a template, and then send a response back to the browser, and then that response is all shown to the end user. And so that really is the request into the server through a Django application, pulling data from various places, merging a template back in, and then sending a response back to the application. So up next, we're going to talk about virtual hosting. Now, in general, you're not going to have to worry about this. It just kind of explains how something like Python Anywhere is able to manage a whole lot of domains on a single system.
Hello and welcome to a demonstration for Django for everybody. This is to install Django on Python Anywhere. In a sense, we're going to just be getting started. This is a bit tricky because there's a tutorial on how to write your first Django application. There's a tutorial on how to set up django.org on Python Anywhere. And neither of these are exactly perfect. So what I've got is an assignment that sort of walks you through a series of things that lay down some necessary things for this class. And so the first thing we're going to do is you should have a Python Anywhere account. And you should be able to log in on the Python Anywhere account, and you should be able to get somewhere. So this is my Dr. Chuck. This is my account that I use to I used to be a student on this. There's other accounts that I have for the production stuff, but this is one of my student accounts. And so the first thing you're going to do is you're going to use a console, and you're going to start a bash shell. So this is actually Linux, and I love Python Anywhere. I love the fact that we're learning Linux. Hopefully you'll just get a little more comfort with Linux as we go. But this is where you're going to do a lot of the command line of the system. So we're going to do make dir virtual environment. You might be able to make this Python 3.7 or Python 3.8. The later that Python is, the better. This is going to take a while because it's going to create what's called a virtual environment that allows you to have your own version of Python, your own set of installed Python libraries, and virtual environments are a wonderful thing in Python because then you don't have to ask the owner of this system, which is Python Anywhere, hey, could you upgrade the Python? Turns out you can upgrade the Python all by yourself. So we will sit and let this, oh, there we go. It ran right away. And ran right away. So let's go do the next thing. The next thing I know takes a long time. So the next step is to install Django. Now this is pip is installing software. So it's going to download a bunch of software and then it's going to install that software and it's installing it in our Django 3 environment, right? And so this is not installing it for the whole system. It's just installing it for us. And so you'll get used to the idea that you've got to work on the Django in your appropriate Django environment. And we're using Django 3.0 in this situation. As the recording of this, Django 3.0.2 is out. Django 3 is quite nice. So we'll just sit and watch this for a while. So it's finished, and now we have it installed. Now there's a command that gets us into, this is redundant right now because we're already in it, but work on Django 3 and make sure that you're in it. Then the next thing to do is grab this command and make sure your Django version is right. If that says 3.02 or later, then life is good and you have your Django working. Now, I want to also have you install some of the sample code in the class. Let me get this started and I'll explain what's going on. So this is GitHub, and this is code that I maintain, and I can update this code and I can send it to you. And so this is a lot of sample code. So if you go to DJ4E tab, I hit the tab key to do completion there. There is a bunch of files in here, and this is the kind of sample code that we're going to go through in the class. And so we need to add the requirements. Pip, again, is the dependency manager. There's a file requirements.txt that says, hey, we need a whole bunch of libraries. And so let's install those libraries. Now, in your first Python applications, you're not going to need all of these libraries, but I want to get them installed into your virtual environment early on so that as we go along, you're not going to add a feature like social authentication, which is this little application right there, like social authentication, and then oops, we had to install a thing. So I want to get all that stuff installed at the beginning. And this will take a little while, so we'll just pause for a bit. Okay, so that finished. And now what we want to do is run a command, manage.py check. You're going to run this command a lot. And this, we're in actually a Django application, and this Python manage py check reads through your files and these files that point to other files, looks for syntax errors, and it's a good way to check the sanity of your application, because if it won't pass this manage.py check, it's not going to start. We haven't even tried to start this application yet and put it up on the web. For now, we're doing that. So don't worry about this message. We'll get to that later. We can say Python 3 manage make migrations, and in this one it's going to say no change detected, and then we're going to run migrate, and that will create a bunch of database tables. Don't worry too much about that. So we've finished there. Now we're going to actually pick up in the Django application, but we're going to basically make a new Django. We're going to make a folder. So we're going to go back to our home directory. CD tilde says go back to home directory. And we're going to make a directory called Django projects. This is so you can have more than one of them. We're going to go into that directory, CD Django projects. And then we're going to start the project my test site. Now what this does is this actually created a whole bunch of files in my test site. Okay. Now we do have to edit one file. I'm going to edit this file. Now I have a whole thing on how to edit files on Python Anywhere. I'll do it I'll do it the way you probably will do it, and that is use this files screen. Oops, I have to go back and get my shell, dang it. Console, open like a new tab. You'll find that you'll want to go back to that console. So here I am. I want to edit some files, so I can go into Django projects, my site, and then settings.py is the file that it's telling me to edit. So it's just my site, my site. It's a little weird that the name is doubled. You got to go down to around line 28 and say add quote star quote. And that has to do with protecting what systems can talk to this web server, and we're just going to say anybody can do it. Do not set this default. Forget this warning. It's a lie. We are not in production, we are in development. So then we have to say save. So then we'll save our file. Okay, so let's go back. We had to do that. Here's different ways of editing the file. You could use nano on the command line, that's cool. I just use this #1 way to do that. VI is really cool, but we won't do that. Okay, so now we need to convince Python Anywhere to run the application. Okay, and so that is under another tab. That is under, and I'm going to open this in a new tab. So now I have these files. Actually, I don't need this tab anymore. I have my, oh, I should oops. I should say Python 3 manage.py check here just to kind of be creative. Yeah, that's good. So you always want to do Python 3. I'm in this file, the site, the actual website that has manage.py in it. Python, actually, you don't have to say Python 3 anymore. It's after the year 2020. So you can say Python manage.py.check. You'll see me type Python 3 all the time because old habits die hard during the transition from Python 2 to type Python 3. So that's good. That suggests that this application in Django projects is in good shape. So now I have to go look at this web app setup. And what's going on here is this is Python Anywhere's way of taking the code in that folder and running it and giving you a web address for that. And so the first thing you got to do is you got to set this up. This is correctly set up. You got to point to the folder that has that manage.py in it. And if I go to the console and type pwd, print working directory, you see home Django Dr. Chuck's my site. And this is the file that has the folder that has manage.py in it. So these two things have got to be right. This code here has also got to be right. When you see this, it's going to start out really big. Throw it all away, throw the sample away. I give you the entire code to put in there. And again, it's all setting up which site. And then, we also have to set the virtual environment in this web tab. Go back to the web tab. We've got to set this virtual environment. And I want that to be, you gotta go and change the name of it. Don't do the same as me. This is for my virtual environment. So it checks, yep, there's a good virtual environment. So you gotta have this source code, working directory, WSGI configuration file, and virtual environment set properly. We'll come back to this. These are error logs. And if all goes well at this point, let's double check the assignment. Hit the reload. It's what it says. So every time you change your code, you have to tell Python Anywhere. So this takes a little bit. And if all goes well, I will open this URL in a new tab. And it worked. Debug is true. Please leave debug true, or else this course is going to be really tiresome for you. Okay? So that's the first step. But then we have a little bit more work to do. We're going to add a polls application. So we're going to go back into that. I'm already in that folder. I'm in that folder, and then I'm going to start an application. Oops. Come back. I'm going to build an application. This is a way to create a bunch of source codes. So one of the things about Django is that it comes with batteries included. And so in this particular case, it's writing a bunch of code in a folder named polls. Okay, and so that's now in polls. And then we go continue on our, now we're going to pick up in this Django tutorial. So we said start at polls, we did that. And we're going to edit a file, polls/views.py. And we're going to, I'll copy this code here. Open a new tab. And Django projects, my site, polls, views.py. So I'm going to put that code from the tutorial in there. Okay, so that code is in the tutorial. Going back to the tutorial, it says create a file called urls.py in that same folder and put in this code. So I'll copy this. So I'm going to create a new file here, urls.py, new file. Let's put that stuff in there and save that file. Then we go back, and then we are going to go in the my site. So polls urls.py is an application. My site is for the entire site. And so I'll grab this code also. This file already exists, so we go my site, settings. This is the only folder that has settings.py in it. Oh, I wasn't supposed to edit settings. I was supposed to edit URLs. And this looks pretty good. We'll just add the line. Well, actually, we got to do all of it because we have to import the include. So this little import include, this little part here was there. So this was, I copied this. These are all, of course, comments. So all these files are just some Python. This is setting a variable called URL patterns to an array, and path is a thing that returns an object. And so you can go read all the, and you should read all the documentation. And then I will save this. And then let's go back. Now, every time you see here when it says Python 3 manage run server, you want to go do Python 3 manage check. So that's like do everything but run server except run the server. And again, you could get errors here and read those errors. They're tracebacks. You'll say, oh, no comma found. Let me just make a mistake so you see what happens. I'm not making mistakes. Come back. Let's go into this file. Let's forget a parenthesis. Okay? Let's save it. Shocking. See? So now, when I did a Python 3 manage py check, it blows up and it tells me, oh, something's kind of funky around line 22 of urls.py. Looky look. I mean, my editor even told me that. So there we go. So I fix that back up and I say save. And now I go back and I type, by the way, you can hit up arrow and you can run a command again. Python 3 manage.py finds no issues. So then what do we do to test our application? We go to the web app. Now we've got these guys set up. We don't have to change those. They're all set up again. So we hit the reload button. Take a little bit of moment. Then we go over to our actual application. Now this looks like a failure, but it's not, because it turns out that that little bit of code you run is sitting in polls. And so that's the code that you ran. And so at this point, you have completed the assignment. I got a little bit about errors down there. But so we walked through that. Wasn't too bad. Getting things set up is often the hardest bit. But hopefully, in a little bit of time, you'll have it all working. And then we'll start adding things to our application. So hope this was helpful. Cheers.
Hello and welcome to our lecture on HTML, the hypertext markup language. So we're going to place this in the context of our request response cycle, and sort of here's us in the request response cycle in our browser and what we're seeing. We make a click, it goes across the network to the web server, runs some code, maybe talks to a database, formats up some new stuff, and we get the response. Then HTML comes out, and then that's parsed to make the DOM, and what we see is the document object model. And we're going to ignore most of that in this lecture. We are really only going to talk about this part here, and that is what this response is. It's HTML, and it is parsed, and it's read through, and it's used to construct the document object model, which then shows what we see. And so HTML is just a technique of using some special characters, less than and greater than, to add tags to indicate what we want to see, like the paragraph tag. The paragraph tag, that's a paragraph tag. Strong tag makes things bold. Emphasize tag and a paragraph tag. And so we have these tags and we just mark up. We're communicating meaning. If you're old enough to remember, word processors used to have ways to look at the actual codes that were being stored in the word processor file. So the web is, the HTML and hypertext transport protocol and all that stuff is a relatively recent invention, and we're doing so many cool things with it. It's continuously evolving, and really, we're less than, we're in a 20 years old, and so we're doing so much with it. It's continuously evolving. So HTML and CSS are really kind of at the edge. Looking back in the early days, if we take a look at what HTML was really intended to do, it worked on a Next computer in the early 1990s, and so this is the Next browser, which came from CERN, and it had everything in a new window. Images were not shown in line. And then there was the NCSA Mosaic browser, which was the first browser that was universally available on Unix, Windows, and Macintosh. And you see things like gray background and blue links and highlighted links that you visited in purple. And so in the early days, it was nothing like what we see today. In the early days, we were just amazed and happy that we could see a link, and you'd click a link and something would happen. But today, money is to be made based on making stuff super beautiful, and the number of pixels, and how things line up, and how things are shoved over, and how navigation looks. And so today we need to create beautiful web pages, whereas in the old days, we were just amazed to have web pages that worked in the first place. And of course, computers have gotten much faster, capable of handling video and images. Back in the old days, images were costly, both for network bandwidth and for the time it took your computer to display them. And so that just affected how we did it. And it's kind of fun to use the Wayback Machine, otherwise known as the Internet Archive, to go back and look at some of these older web pages and realize that it's still amazing that a lot of them pretty much work. And in the good old days, HTML was kind of a Wild West. The browsers did not want to show broken HTML as broken HTML, and so they compensated for it. And so in the old days, we had things like tags that could be uppercase. We would have a paragraph tag that didn't finish. We would have li tags that didn't finish. We would have attributes that didn't even have double quotes in them. So there was all kinds of stuff, and literally you can take this bad page and you could put it into a web browser and it will still display. So HTML, while it technically is a very precise language and you can make syntax errors, browsers are extremely flexible in terms of parsing it. Now, you're not going to get predictable results. Like, browsers can go into what's called quirks mode. And so in order to create the standards environment that we have today, Tim Berners-Lee, one of the original founders of the World Wide Web, helped found an organization called the World Wide Web Consortium, or the W3C. And it really decided that instead of just letting people write a browser and having HTML be defined by the browser, instead they would write a spec for what HTML was, and then multiple vendors could produce the browsers. And it took a while for this to become successful, but there was a need for every vendor to build a web browser, and so they worked with the World Wide Web Consortium. And like the mid and late 90s, 95, 96, well, 94 through 98, 99, the World Web Consortium created a lot of wonderful standards around the World Wide Web. Now, once we started having rules, then we tend to want to follow those rules. And so tags need to be lowercase. Attributes like this image source equals, you have to have double quotes around them. You have to have open tags and closed tags, open tags and closed tags. And so there's a set of rules, and now we are much more precise about our HTML, and we try to write it as precise as we can so that we get the best performance and the best sort of rendering out of the browsers that we can possibly get. Because if you don't write precise HTML, then the browsers are going to make decisions as to how to render things, whereas if you write precise HTML, then you really are in control of how the browser lays things out. So up next, we're going to talk about HTML itself, look at some HTML documents, and take a look at the syntax of HTML. Welcome back. So let's talk about some of the basic syntax of HTML. The first thing is to look at the overall document layout. And they start with an HTML tag. You might have a thing called a doc type up here, and we can put in one if we like, but HTML is the outer tag, and then there is a head tag and an end head tag. And this is sort of non-printing information. We set styling up, we declare the title of a page, perhaps load some JavaScript, and then the printable page of the content is in between a body tag, and mostly what we're going to talk about is the stuff that we put in as page content. So you'll find that there are special file names that we use. It really has to do with the fact that what we do is we make a directory within the web server, and when we go visit the directory, the web server looks through a series of files that it's configured to look to, things like index.html, index.htm, or index.php, and each one has a slightly different order and a slightly different set of things. It might even be called default.htm or default.asp if you're on a Windows box. It is configurable, so different systems do things differently, but usually index.htm is probably the safest thing unless you're doing PHP, which we will be doing later in index.php. And so those are usually the safe bet. Now, when you're viewing things off of disk, which we can do, if you download all the code that I've got in html.zip, then you'll have to open the index.html by hand. So we can put multiple files in the same directory, and then we can use them in what are called relative links. And so we can easily create links between one file and another. And so you'll tend to see, if you look at the zip file, that you've got a whole bunch of files in the same directory. And with little anchor tags, they point back and forth between each one. And so, like I said, you got tags like the paragraph tag, the strong tag, and the emphasize tag. They have to start, they have to stop. But another thing that's really important about HTML is the fact that most of the time we are logically marking up the text. And so we're saying we want this stuff right here to be a paragraph. But the end of the lines that we put in the HTML that we write are not really that important. What happens is depending on the width of the browser, if you change the width of the browser, the text will be rewrapped. And that's because there's still a paragraph, but we don't want to hard code it because we're not working on paper. Sometimes browsers are really large, sometimes browsers are really small. Sometimes you're on a phone, right? And on a phone, browser's really small. And so you don't want to tell exactly how many pixels it is wide, except when you start doing really fancy layout. But in things like paragraphs, you just say, hey, make it a paragraph and rewrap it. And that also, the rewrapping then also changes how tall the pages are, because the narrower pages, it kind of extends the page down. But the white space inside of the HTML is really generally ignored, and the lines are generally ignored. There are some tags, like the pre-tag, that changes that, so white space is respected and new lines are respected. But most of the time, we just let the browser rewrap things, and it's good. You have beginning tags and ending tags. So here's a beginning tag, and then here's the ending tag. The slash is our indication of an ending, and they're paired. And they're also nested. So this P tag has a strong tag within it and an M tag within it, and that's totally okay because this whole thing is a paragraph and this is a piece of bold text. So they have a beginning and end, and slash is the end. You can also have self-closing tags that have like an image tag that has like a slash, and that means that you don't have to have like a slash image over here. That's the same. You just put a slash here and it self-closes. Another thing that you will get used to is the fact that you can put on the opening tag attributes, so key value pairs. And you'll go define what you go read the documentation on the image tag, and it'll say, oh, put a source attribute on to say what picture, what file we want to display as the picture. The image tag is to show pictures, basically. So given that less than and greater than and other things are special characters, we have to have a way to print the special characters. So how do we print a special character? Well, we use ampersand LT semicolon, and there's a whole list of these things. HTML special characters. And you can look them up. And there's some that are kind of fun, like the special characters for the deck of cards. There's mathematical special characters. And you go look these up and you can find them. The key thing is they're cute, and you'll see that I'll use some of these arrows in the things that I'm doing. But the key ones that you really need to know about are less than, greater than, and ampersand. And just because ampersand becomes a special character, less than, greater than, or ampersand are really the special characters in HTML. And so to represent less than, you do ampersand LT, ampersand GT, and ampersand AMP semicolon to get those things right. HTML comments, like in any programming language, any situation, the start of an HTML comment is less than exclamation dash dash. It's a little clunky, but we just want to make sure it's really clear. And so dash dash less than comments can go across many lines if that's what you want to do. So that works as well. Links is a critical element of HTML. It's why search engines work. It's why, when I first saw it, I'm like, I click on a thing and there's a new page. Isn't that amazing, right? And so hyperlinks is the H in HTML. It's the H in HTTP. And so it is how we, in effect, use this thing that we're sort of just scribbling on to create knowledge that Google then can extract. And so the anchor tag, the A tag, is the tag that we use to do these things. And so, there's a header one, a paragraph, and the anchor tag this is the start tag, and this is the end tag. And so the text that's clickable is second page, and you can see that it's clickable right there. It is styled with a underline and blue to indicate that it's a link. And so there's the href, which stands for hypertext reference, and then it's an attribute, so it's key value with double quotes, and then this is another URL. And so that's like, in effect, putting that URL up and going into that next page. So it's a hotspot. In the early days, and I'll show you a few of these links were like the coolest thing ever, and so we made them pretty colors, like the blue with the dash. People didn't when they first saw the web, they didn't know to click places, so we sort of styled them quite brightly. And then because you were often scanning and searching the whole web, because the web wasn't so big in the beginning, we would mark them as purple after you'd been to it. So you could sort of slowly but surely work your way through the whole internet as it existed back in the old days and keep track of the ones so you didn't have to go back to the ones that you'd seen before. And that was an absolute link, and here's one with a relative link, and that assumes that we are now in the same folder, same directory on the server, where we have href, and so here's the start tag, here's the end tag, and then first page is the clickable stuff. And you'll note that that is a purple link because I have already been there, because page1.htm was exactly where I just came from. And so you click on that, and then you can go back and forth, and those are the pages we played with in the HTTP lecture. And so these absolute references are references that start with, HTTP or HTTPS or whatever, and relative references don't. And so that basically means that this page1.htm file has to be in the same folder as whatever file we happen to be viewing right now on the same server. So if you want to switch folders or switch servers, you have to use absolute references. And if you are just moving between files on the same server, you can use relative references. Images are a lot of fun. In CSS, we'll see how to wrap text. One of my favorite things was to wrap text. There is an image tag, which we saw before, image, and then the source equals is the attribute, and then in quotes the name of the file. And it can either be an image that's all by itself. In this case, this paragraph is what we're seeing, and you can see that this image is a tiny image, but it's sort of like blah, 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 blah. The image right here works kind of like a character. You got to be careful because the images can be really big. That's why I made a tiny image. And you could even, for example, in this case, I have an anchor tag, and the clickable part of the anchor tag is an image. So if you click right there, that will move you to lists.html. And so you can make an image be a hypertext reference as well. Now we're going to do much more with these things, and this is just, at this point, the basics. Lists are an important part of HTML. There's ordered lists and unordered lists. And so the unordered list starts with the UL tag and ends with a UL tag, and then that sort of bounds the whole list. And then each list element starts with an LI, list item, and /LI. And I want a little bit of spacing. If you don't put them in paragraphs, you don't quite get the default spacing. This blank line's really coming from the paragraphs. So I'm putting a list of paragraphs, basically. It doesn't have to be a list of paragraphs. You could make a little denser list with a list of links or something, but I'm putting paragraphs in. And so you can see that I have LI to end LI, LI to end LI. I'm putting some links in here, etc., etc. And so dot, 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 and it puts all the bullets in. It does the indenting automatically. We'll see in a bit how we can control all that formatting and do different things if we want to do those different things. But for now, we're just going to play with the default formatting and learn the HTML, which is our way of representing that we want a list on the screen, but we're not so fancy about exactly how it's supposed to look. So in HTML, we really are looking for the meaning of the page, not how pretty it is. Tables. Tables have a bit of a checkered past. In the early days, people tended to use tables to lay pages out on grids. And they would just put, a paragraph here and a paragraph here and then a paragraph underneath it, and they would move them around, and they would put images in some of the table cells. And that turned out to be really bad, and that notion of tables as graphic layout is long gone, and we use CSS now, which is the next lecture. But tables were always a good idea for tabular data. And so if you have something that sort of makes sense, is like a list of cars with some make, model, and mileage columns and a list, then you mark them up. And so the table markup is pretty straightforward. We start a table with the table tag, and then we have a series of rows using the tr tag, tr to /tr. And then if there's a header line, which can be formatted a little bit different, we do a th to /th. And then this basically says it's going to be a 3-column table because we have 3 table headers, 1, 2, 3. And then we're going to put TDs for the data. TD stands for data, 1, 2, 3. And so that's the Ford, edge, and then the mileage of that, and on and on and on and on as we go. And so it's not hard to build them. You kind of have to keep track of how many of these things you've got. And there are tricks where you can make a table that has like 4 things, but then in one row this expands so that's, I can't erase it. Can't erase it. So there are ways to do things where a data element spans more than one column, call span, for example. But the key to tables is that we use them for tables. We don't use them for arranging things that are not themselves row, 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 row. So I'm going to stop there. I'm going to record some exploration of some sample code at www.webapplicationsforeverybody.com/code/html. And I really am intending that you will, these are very simple pages, but the idea is to look at them in developer mode and take a look at them, and then you can see how the various things work. And you can also then look at the source code and see, oh, here's how a pre-tag works. Or where's the pre-tag? No. Oh. Yeah. So we look at the source code, take a look at things, and show that the line wrapping does not actually matter. We look at pre-tag in another one. So I'll record some walkthroughs of all this sample code, but I encourage you to take a look at it because it has a lot of good examples of the basics of HTML. And so HTML is a continually evolving thing. It's a very creative space. It's a lot of fun. We have to be really tempted. We have to avoid the temptation of trying to make everything look pretty in the HTML, but instead delegate that to the CSS, which is what we're going to talk about next. Hello and
welcome to Web Applications for Everybody. In this screencast, we are going to play with some of the sample code, and you can either download it and play with it on your own computer, or you can look at it in your text editor, or if you just want to browse it, you can browse it here and take a look at the version that I'm using. It's really been intended that you look at this in the developer tools, and so you can do things like, say, inspect element. And so here we are. This will also be a little more valuable even when we're doing CSS, but you can see the document object model. Now, the interesting thing here is it shows something I'm always talking about, is the difference between the document object model and the source code. So this is the document object model. It's kind of stylized. If you look at the source code, you have to say view page source. And so the source code, this is literally exactly what's in the file. And if you go look at this file in a text editor, you will see this. And if you're looking at it here, it doesn't quite look exactly the same, and some things have been done a little bit differently. You know, they kind of got this extra stuff, and this is kind of after the browser has looked at it. And when we start talking about JavaScript and changing some of this dynamically, you'll see this part is the document object model, but the source never changes. The source is what was originally downloaded when the server sent this back to us. So let's take a basic look at this. I'll hide this unless I need it. I'll go back and forth between the source. So we have a basic document, HTML, with a head tag and a body, and then a header. And of course, here's our header. We're using default styling, and paragraphs are an important part of things. You can squeeze this up as much as you want. White space sort of doesn't matter, right? So this white space kind of doesn't matter here. The fact that this has got extra space, it doesn't much matter. And so you can see an anchor to a strong tag that leads to a boldness. Let's just go ahead and look at it here in the inspect. We'll go down here, we'll find like a strong tag, that's the bold. We got an emphasize tag, and if you look a little farther, you'll see there is the anchor tag, which is the whole anchor tag is this whole tag from the A to the /A list.htm. That's where we're going to go if we click on this text right here. And so you can see, now this is a relative link, and it turns it into an absolute link, and that's because the browser knows where we're at. And so it sort of prefixes everything up to that to the relative link. But that's nice, because if we look in folders, we will see that these folders are all here. Here, let me go find you that folder. It's pretty deep in my... Later, this will all make wonderful sense to you. I do a lot of stuff with web. Code, HTML. Okay, so here we have, after all that, here we have the files, right? And so this is index.htm, and index.htm is right there, and list.htm. And so if I click here, I'll go to list.htm, and that'll pull this other file up. And so these guys are all in the same folder together. It just means that I can use relative links to go moving between them. A tag that's really becomes more important, especially as when we're talking about writing code inside HTML and showing people code, is the pre-tag. And so the pre-tag, and you can just say inspect to hop right down to where the pre-tag is. The pre-tag respects spaces, so all these spaces happen, the new lines happen, and it also shows it in monospace font. Now you can change all these things once we get to CSS, but pre-tag, when we're printing debug out from, not in files like this, but when running code, sometimes it's good to print debugging out in with pre-tags. So let's go to the next page. And so here's a whole series of things we're going to play with. This is a unnumbered list. This whole thing is an unnumbered list from top to bottom. So when I highlight this, you see the whole beginning to end of the list. Then each item in the list has a start and end li tag, right? Down, down, down. So here's this. We should learn about tables. and there's a href, there's another relative link, and so this is sort of my jumping off page to get to all those other things, right? Learn about tables, etc., etc. And so you can see these. We probably use just to take a look at the source code of this page. And so that's the source code that I typed in, and you can see the li tags, the p tags. I'm putting p's inside of li's to get space. Let's see if I can sort of show you that. So if you look at this and you look at the li tag, the li tag is that, and the paragraph is what actually creates the vertical and horizontal space, right? So that orange that you're seeing, that's paragraph. There's space that the paragraph tag has preset. So that's how I do that, putting paragraphs and hrefs, and so that's what this all looks like. So let's take a look at special characters. And so this is an interesting thing because it's not really what came out, because less than requires ampersand LT, but it's kind of processing that. So let's take a look at the source code to this one, because that'll be more instructive. So ampersand LT, ampersand GT, ampersand amp. This is an ampersand in HTML, and then just the letters AMP semicolon. Semicolon's not special. There are only really 3 truly special characters: less than, greater than, and ampersand. And you can put all kinds of fun stuff, clubs, hearts, and diamonds. And so you got the clubs, hearts, and diamonds, some arrows, stuff like that. What's nice is browsers just have these built in, although they're not necessarily the sexiest or coolest things. And I think what happens when I go back on this link is I go back to the list. So that's just special characters, and you'll notice that the default styling that says we've seen this one, and this is how the web worked 1,000 years now, back in the 90s, is you sort of, oh, it's kind of nice that it's turning purple. And you'll notice that Google does this as well when you're doing Google searches. It actually lets the links change color after you visited them. So let's take a look about links. We look at links. I'll view the source of this guy. Absolute link, ahref, right? And then /a. This is the clickable text, right? Between the beginning tag and the ending tag. The attributes are on the beginning tag. Another attribute that you can add, and I do it all the time, is target equals blank. And that basically is the way we say, open this up in a new tab. So you'll notice pop up in a new tab. And so that's where that one goes when it pops up. And so you can decide whether or not you want this to go in the same page back or in a new page. And then I got to close the tab to get back. And now I'll go back, because that's just a relative link to list.htm, so I can go back and look at the next thing. Let's take a look at how images are represented. So so this is just a paragraph that has an image in it, right? So it's a paragraph, but there's the image. Source equals medium.jpg. If you look in my folder, you see the image right there, medium.png. You don't see the suffix because Mac is trying to hide it from me. And so that's just, you see the space here and here. The image doesn't have any space. We could add some with CSS later, but the paragraph is what's adding that space. Then we have just a regular old paragraph. I'm not supposed to use the center tag. We'll get to the how to center stuff, so that's what that is saying right there. And you can have an image that's right in the middle, so you see where that image is. I think of images, if they're right in the middle of text, they're like a giant character, and so that's how that works. And you can even sort of stick an image as the thing inside of a link. So here's the anchor tag. It's that bit right there, and then the anchor tag body is an image. And so if I click on that, it's going to go back to list.htm. You'll notice these all go back to list.htm, so I can work on the next thing, right? Tables. Again, you're not supposed to use tables for laying out like blocks of text, which we used to do. We used to do things like use tables to draw borders around things, which we'll see in CSS. But now that's totally verboten, and you're supposed to look at tables in a way that they're, nice and pretty. So let's do a view source here. So let's see, there's our table, our slash table, and a table row. Now let's take a look at the DOM. So apparently I didn't put a T-body. We're supposed to put a T-body in there, and I didn't do it, but this is the DOM. The DOM put it in. That's put in by the parsing, and so clearly I made a little mistake in my HTML because I didn't put a T-body tag, and so that was added by the browser. As it was parsing and reading through this, like, oh, he forgot his T-body. So it just like slapped one in for me. And I think the mistake is this is my header row, and I think that should be like a T-head. So there I go, bad HTML. It's the story of my life. And then I've got the rows, and you'll notice that the DOM is kind of prettier. So sometimes I do this. The DOM is indented nicely. So this isn't really the source code. This is the data that represents this visual, right? It is the thing that you're seeing, but it read this from the file or from the server, parsed it, and produced the document object model. I only say that like a million times. Okay, so back we go to the lists. We're making pretty good time. So here's some really bad HTML. I'm going to view source on it, and again you'll see sort of the difference between the document object model. When you're debugging these things, you will have to sometimes view source. Sometimes document object model will be the only way to debug it, and sometimes view source. So this is the one that's got bad stuff, like H1 is uppercase. This paragraph tag is not terminated. This UL tag is uppercase. This LI is not terminated. I don't have double quotes here. So there's a series of mistakes that I've made in this HTML, but it looks pretty good. And you'll notice in the document object model, it's fixed all that. Now, each one is lowercase. The P tag is finished. There are double quotes, meaning the document object model is not just your HTML source code. It's like the sensible, parsed, pretty version of the HTML source code, and so, this UL tag, these LI tags are now done. The UL's lowercase, everything's lowercase. So it's like, I'll take care of your mess. I'll patch up and fix your HTML, and then I'll display it for me and make sense of it. So the document object model is not the same. It is sort of like a sweet, awesome, better version of it. But this is what changes that. So let me just show you something, how I can change the document object model. Let's see. Let me see if I can change this text. I change the document object model. That changes. So I'm actually, but that didn't change the source code here. The source that it was retrieved to produce it, but I can change the document object model. And later in the class, we'll write code that will actually change the document object model. So we'll change this. We'll call this be going to lists yet again. So I can change the document object model. Doop. So you see it changed it. So when we change document object model, what we see in the browser changes, but the source doesn't change. Did I say that enough times? So let's click on this and go back to lists. Okay, so some HTML can be broken so badly so that it doesn't render at all. Whoops, that didn't work so well. I'll do a view source on it, and then I will let you figure out why this doesn't work, why this doesn't show. You take a look at the source, you figure it out. I hope this has been helpful to you. See you on the net.
Hello everybody, and welcome to our lecture on cascading style sheets, CSS. Of course, this follows right on the heels of our HTML lecture. I'm going to use a bunch of examples from webapplicationsforeverybody.com, and you can just bring these up in your browser. I love to place everything that we talk about in the context of the request response cycle, because that's the whole Web Applications for Everybody. You, of course, are out here. You do a click, it sends a request, a HTTP request, maybe talks to a database, gets some stuff back, sends some stuff back. This is the request response cycle right here. And the thing that comes back is HTML. And then that is parsed, put into the document object model. And the thing that you then see, the pixels you see on your screen, are from the document object model. And so that's what we've been doing so far. And so far, in that HTML lecture, we just talked about this, what the format was when you parse the response. So what we're going to talk about today is we're going to talk about, in addition to that, we're going to go and pull another file, a CSS file, CSS, and that is going to inform the document object model, and it's going to change how things look out here. And so, we'll have some CSS in the HTML, but we'll also have some CSS in separate files that make separate request response cycles. So we're going to be putting files like our HTML files in here and our CSS files in here. So we're going to be serving them a little bit, but mostly what we're worried about is sort of the form, how to make the DOM look pretty. And that's sort of what CSS is all about. So in addition, I would like you to install this thing called Web Developer from Chris Pedrick. Chris Pedrick has been doing this a long time, before there were even developer consoles in browsers. And it's funny that the developer consoles don't do what this does. And I don't use all of its features, but it has some wonderful features for CSS, in particular turning on and off various styles. And so it's a great way to sort of dig through CSS issues in addition to the Web Developer console. And you can do a lot of sort of fine debugging, but there's some real nice stuff with Web Developer. It's just a plugin for your Safari or your Chrome or your Mozilla browser or whatever. So please install that. I recommend it, and some of the assignments actually require it. So like I said in the HTML lecture, the HTML started out with, we were just amazed in 1995 when we could see a page with a gray background and blue links, and it was lists, long lists of links, and the links turned purple, and we would click on a link and another page would come up, and we were like, holy mackerel, this is the future, right? And we were so happy. And our curiosity was piqued. We did interesting things. But, in the 10, 15, almost 20 years since all that, it's become a business. And in business, the look and feel for the average non-nerd user, they don't care that there's a request response cycle. They just want to do a thing, talk to their friends or look up information or whatever. And so the CSS is in the middle of this time frame, that the ability to precisely lay things out and make pages beautiful became super important for the web to take its sort of leap into commercialdom. So if you look at the Yahoo web page, for example, this is just a screenshot I took a while back. They do studies as to how much white space is in between those two pieces. And they'll add a pixel and take away a pixel, and they'll see how their revenue goes. And so these user experiences, these visual looks and feels are highly tuned and highly sort of taken care of. And so CSS needed to be able to precisely have a pixel perfect layout in every browser. And so CSS is a very, very precise thing. HTML has become precise, but we don't want to do our markup and layout in HTML. I showed you tables previously, and in really early versions of HTML, we used tables to create look and feel, and that was never good. So one of the things you can do with the Chris Pedrick Web Developer plugin is you can show a page without CSS. And what you should expect when you see a page without CSS is it's sort of beautiful even without CSS. It's beautiful in a logical and a structure. And so here's my web applications for everybody website, right? It's got cool stuff. It's got these little things that go over there. It's got the little border. The color's gray here, and it's a little lighter gray, and this wraps around, and it looks really awesome, right? Well, turn CSS off, and you should still see a page that you could effectively navigate. It's like going back in time to a simpler time of, okay, I want to see this. This is really a list of links at the end of the day, and there you go, it's a list of links. And the default is I've already clicked on lessons, so lessons is purple now. And here's this video, and if you scroll up and down on this, I mean, it's really fun to go to a website and, turn CSS off and see how good their HTML developers are and how pretty it is. And so it's supposed to be pretty in a simple way. And what's nice about this is it really leads to good accessibility, meaning some people do not see the graphics, they hear the page read to them. And this way, this is how it's read. And the simpler and more beautiful and elegant your HTML is, the easier it is for a person who has reduced visual ability to understand your site. And that is I remember the joy of hearing from people who were using the web and Gopher in the early days, how they all of a sudden could go anywhere and see anything and do anything in a way that that visually impaired people could never do for like hundreds of thousands of years. And it's joyful. And then what happened was we ended up with this really nasty markup, and then it was like the web was simple and they loved it, and then the web became ugly and nasty and HTML became nasty, and they're like, the world is horrible because now you go to all these cool websites, but I can't go to these cool websites because I'm visually impaired. And now we're back to that. We're back to beautiful HTML, simple HTML, and then beautiful web pages, and CSS is the matter. Okay, I think I've done enough advertising for CSS and accessibility and beautiful HTML. So ultimately, if you look at how this thing is assembled in your browser, there is an HTML page that is pulled down, and then there is CSS, sort of both inside the document. Sometimes there's CSS in the document. If you look at this, not that it matters, there's a little bit of CSS in that document, and then a whole bunch of other CSS that brings all the beauty to this. Sometimes it even takes some JavaScript and whatever. And so we understand that the HTML does not have the beauty in it. The beauty comes from the CSS. And that is part of what we try to do, is learn CSS. So if you're going to be like a coder and you're not going to be a graphic designer, you still need to know enough CSS so that you don't write horrible HTML, so that you know what a really good CSS developer is capable of doing on your behalf. And on large projects, including like Sakai project, which is an open source learning management system, this allows separation of concerns. And you can have people that specialize in the back end and the HTML, and then a web designer can, the web designer, so if you think of the developer, usually there's a back end, and then they generate, from the back end, they generate the HTML, and then the designer will build the CSS. The designer will often have skill enough to sort of tweak the HTML if the developer built bad HTML. So they kind of meet in the middle at the HTML, with the developer mostly being responsible for building the back-end developer. And then the front-end designer can then tweak the HTML a little and then tweak the CSS. And so the HTML is where the back-end developer and the front-end developer come together, but it means that you can have lots of people working, and you can develop highly specialized skill sets in larger projects. I know that my skill set is in this side. I am not skilled in this side, right? I can clunk my way through CSS, and everything that you'll see is my CSS, and you'll be like, whoa, that's not very good. And if it even looks pretty of mine, I'd probably use Bootstrap, and I cheated and found a CSS framework, and I didn't build it, I just did it. Now, there are people who are smart enough to build Bootstrap. They can build such gorgeous websites, and my job is to build beautiful HTML that then they can add CSS to and make it super gorgeous. So the CSS basic syntax is different than HTML, right? HTML is less thans and greater than. CSS has curly braces. I don't really know who invented the first. I should find that out and go videotape that person. But it has curly braces and semicolons, so it kind of looks like a little bit of C. And it's really a set of rules. And it's not sequential, although the order does matter, because what comes later has more importance than what comes earlier in CSS. But it's not like code that gets run. And so the anatomy of a CSS rule is that there is some kind of a selector. And in this case, the simplest selector is the tag that we want to affect. We want to affect the body tag. Now, there's only one body tag, but you could have a P for a P tag and say, I would like to do this to all P tags. And so it's implicit, kind of like SQL, in that a body tag means for all body tags. There's an implicit loop for the whole document. And we'll see how to reduce that later to it, so it's not always the whole document. But for now, a tag means a tag there by itself means every tag in this document. And then there's a series of rules, and so this is really when to apply. This is sort of what aspect, and there's a whole list of aspects that you can have, and then what you want to do. I want to make the font size 100%, I want to use Arial, and then sans serif, etc., etc., etc. Holy mackerel, my little pen is undoing itself. And so then these end in a semicolon, and you can have a bunch of these, right? You can have just one, you can have more, but that's the basic idea. Is a CSS rule is go find a part of this document and paint it. I like to think of this as like, go find a thing and then run a paintbrush over top of it that is this paintbrush. That is the paintbrush that you go select a piece of the document and then paint it yellow or paint it bold or whatever. That's kind of how I think about it. Now, I'll admit I am just I'm really a very weak CSS developer, and I need a cheat sheet. And if I'm going to do CSS, having this even a single page cheat sheet is super helpful for me, just because I don't use it all the time. And so the attributes like background color and the border dash bottom, you know, for me, they're all very self-explanatory. They're really easy to understand, or if you don't understand them, you just Google and you go Stack Overflow. But like for me, I'm like, is it border bottom or bottom border? I just can't remember that stuff, and so I just have to have a cheat sheet whenever I work. And this is one cheat sheet that I happen to like. And these are the kind of properties that we're going to be playing with. Color, the background color, how to align it vertically, how to align it horizontally, padding, which is space on the sides, etc., etc., etc. So there's just tons of CSS properties, and there's tons of great documentation on each of these CSS properties with little samples all over the place. And I have my own samples as well that I'll do some recordings and walk you through like line by line on my sample code as well. But this is the kind of stuff that we're going to play with in CSS. So up next, we're going to talk about how we connect CSS and HTML together. So welcome back. Now we're going to talk about how you use CSS within HTML, how you take these CSS rules and apply them to the various parts of HTML. And there are three basic ways that we do this. One is we take an HTML tag and use the style attribute and just put those little CSS key value, CSS settings right there, very close. The other thing is you can put it in the background of the HTML document, usually in the head area. And the other, probably most common thing, especially when the styles get large, is an external style sheet that's a separately loaded file with a separate request response cycle. So we'll start with sort of the simplest but sort of least used of these things. And that is, like I said, you can put a style attribute on any tag. And you say any attribute, you say it's got a double quote and a bunch of stuff and another double quote. And in there is a series of CSS rules that are basically CSS setting like border style, colon, and then the border style setting that you want. And so in here I'm saying I would like a solid border, I would like it red, and I'd like it to be 5 pixels. And that effectively determines how that particular thing gets painted, right? In this particular one, I said font family monospace for that particular paragraph. So this paragraph is painted with a font family monospace. And so you can just put these things here. I put on the body tag, I want an Arial sans serif font. So the whole body is not Times New Roman, except for the fact that this particular one is monospace. And so these two tags are rendering opinions about what the font's supposed to be. But because this one is closer, the monospace wins here, but the Arial wins everywhere else because none of these other tags render an opinion. And so that's kind of the cascading bit, meaning the closer it is, the more priority that it has, unless of course they put important up here. And important is something we'll talk about later. You can make the farther away override the local, but it's not something you want to use too much. If you're using important, that's a trouble. But don't worry about important right now. Just imagine cascading means the closer, the higher priority. Closer to the tag the statement of CSS is, then the higher priority that it is. So another place that you can put the CSS is right there in the header, right? So instead of putting it on a tag, we can use a style tag in the header. And so here we have the header of the document, right? The head, the body starts down here. And up here, we're going to set a set of rules. And now we're using the thing where we have to say which tag it goes to. So now I can say the body tag, even though there's only one body tag. We want a font family Arial sans serif. And because they're all inheriting from the body tag, then all the paragraphs inherit from this, and the headers inherit, etc., etc. So it's like body on down in this particular case. The header 1, which is this, is blue. And paragraphs are supposed to have a solid border, red, 5 pixels. And so border style, border color, etc. And that means that each of the 2 paragraphs here are away you go. And I'm going to dig into the anchor tag, and here's my little anchor tag. And I'm telling the anchor tag that I would like to have a green font, and I would like no underline. The default is to underline them. If you look at links, they're always underlined. I'm overriding that. And then I want the background color of that text to be light gray. And so this is a set of rules. All that HTML is down here, lower down, and there are no style tags. There are no style attributes on the tags because we have basically said for all paragraph tags, for all anchor tags, for all H1 tags, and for all body tags, and we put it up here in the top of the document. Now the problem is most websites have multiple pages, and this gets really frustrating after a while. So you really want to pull some of those widely used or repeated things out into a file and include them. And all we do is take pretty much that same set of CSS rules and we put them into a file. And in this case, we'll put them in the same file, same directory, same folder as the HTML. Although you can pull these things off of a website if you want, so http:// or whatever. But you put a link in here and tell it's a CSS, and it's going to be a style sheet, and then you give it an href, which is then going to pull this file in and sort of expand it as if it were right there in the middle of a style tag. And so it knows it's a CSS, and it pulls it in. So that's how you change your HTML. So now if we take a look at the next example, we see that in this next example, we've got a link, right? And down here, we've got no style. Ignore this little thing. That's how we're putting this little, don't ignore that page. But in the real stuff here, we've got this. We've taken our, we got our pre-tag. We've moved it in. We've got some things here. We got all that stuff that we've done, right? And if you look, here is that rules.css file. Rules has all that same stuff. H1, border color, a tag, all that stuff that we put in the head now is sitting in this rules file, and we're just pulling it in right here in one fell swoop, and it accomplishes the exact same thing. Okay? And so this, including in a separate file, is by far a superior way to do it than putting it in the head tag. So, but sometimes you have to change 2 things and you put them in the head tag. And it's up, you use all 3 of these ultimately, but generally you tend to start with a large amount of CSS in a file, and then you tweak in the head, and you might tweak on a tag here and there. And that's kind of how these 3 things tend to work together. And the whole cascading thing works out well. You can put the link first and then style tag second, and then it kind of overrides some of the stuff that are in the linked, and then you can have something on a tag which overrides the stuff that's in the head. Unless, of course, it says important. So, as the world went from hacking look and feel in HTML to, finely tuning look and feel in CSS, all these tags, paragraph, H1, body, they all had default styles that had kind of evolved, and links and all that stuff that evolved, and a lot of pages depended on those default styles working. And so they couldn't say, welcome to CSS, and now all the styles, a paragraph that's unstyled will look terrible. Not that they look great. And so we couldn't take the paragraph tag. Everything had a style. That's the problem. All the existing tags had something on them. So they had to make new tags, and the new tags that they made are the span and the div tags. The key to the span and the div tags is span is an inline tag that has no styling associated with it, no default styling. It is defined as having no styling, and the div tag is a tag that has no styling associated with it, but it's a block tag. And so we sort of use these to sort of mark text, but don't inherit, without inheriting any styling from some long ago 1993-94 defaults. And so the span tag is span tag here. That's kind of broke over a line. The span tag has no styling except that styling which you add. In this case, I'm adding it with a style attribute. And the same thing is true for a div tag, right? The div tag, and also divs can be within divs. So this is a nested div, right? There's an outer div and an inner div. And basically you know that styling, the div has no style whatsoever, right? The span has no style whatsoever. So if you just put something in a span tag and you don't do any, you don't sort of render an opinion about what it looks like, the span doesn't change it. It just is, it inherits from whatever else is there. And so if we take a look at this, right? So here we have a P tag with a green border, 1 pixel border solid. Now, the interesting thing is you say, well, did the paragraph tag have styling? It turns out it does. It has some margin and padding to make it look better, right? And so the paragraph tag is not an unstyled tag. It is expected to create blank space around itself. And so, yeah, we got, so the paragraph tag has a default style. It's supposed to have a default style. But then if you look at the div tags that we've got here, like this div tag, this div tag, remember, goes all the way down to here. This div tag, I just put a blue around so you kind of know what's going on, right? So this blue goes from here to here. But you can see right away that the div tags have no padding or margin or side of little white space to make them look prettier. And that's okay, you've got to do that. You've got to add the padding and the white space. They just start with nothing. It's just a block, right? And the span tag, this one here, changed it green because we put a style color equals green right there. And okay, so we did that. And the div tag, and you'll notice, interestingly, these, because the divs I'm using end up with a 1 pixel border as their style, meaning they started with nothing. You can even see that if you look really close, it's impossible, but you can zoom in. This orange border, the blue border takes up space, and then the orange border's on inside of it, and that's 1 pixel wide. So I'm adding to these through the style attribute, I'm adding CSS to them, but they start with absolutely nothing, and they kind of look ugly when you just like put something in a div, it's like right next to each other, because they didn't want anything. And again, they're nested, and there's reasons, because we'll use divs to say, this is the main body, and then there's divs within the main body, and then this is the navigation, and this is the footer, etc., etc., etc. And so we have, divs are ways to describe blocks without adding CSS styling by default, and it's, as such, letting you define all the CSS for these things. So these are cool. They're like the non-tags, the untags, the tags that don't cause anything to happen but let you cause everything to happen. So they're really important. They're really important. So the next thing I want to talk about is making a sort of finer selection of which tags that you want to apply a rule to, right? A rule to. And so if we look at this tag right here, this is the body tag, and that basically says I want everything from body to /body, then everything inherits. So unless it's overridden, I want Arial sans serif to happen. Okay? And I can do that with a paragraph tag, but I want to show you this other thing. So there's a way to mark a tag. Let's find this one. Where's first? First right there. So there's this ID attribute. An ID attribute is an attribute that was added kind of specifically for CSS as well. And so you can only mark 1 tag per document with an ID. And then there's this class tag, and you can mark as many tags as you want in the document with a class tag. And the idea is like ID tags are for chunks, like main page, like left navigation, top navigation, or something that's only going to appear once on the page. And so if you want to sort, in effect, what #first means is look through the whole document, find a tag. Where's div ID equals first? Where's that stop? Div, right there, right there. Find the tag that's got an ID of first, and then paint it with those rules. The class can happen more than once, but more space, let's see, class is more space here, that's there, and so that basically says, let's change clear and change color here. More space says look through all the document and find all the class. There's that paragraph. Ooh, do I not close that paragraph? Oops, mistake on my HTML. Here, yeah, so that basically says change the margin left. That means shove this in, and change the margin right and shove it in. So we'll see all these things. And loud, and then you can also see a situation where when you put classes on, you can have more than one. And so this basically will respond both to the shout and to the loud class. Okay, so let's take a look at what this page looks like. So here we go. It's a little busy. So if we take a look at first, it grabs this tag here, the div tag is first, right? And then if we look at like more space, this more space is affecting this one, and it's shoving it in both on the left and the right, and that's because it's this paragraph more space. Okay, shout, let's find the shout ones. Well, we can see them right here. They're all the loud ones. So that is red. No, that's shout and loud. Oh, here's one that's shout. Oh, entire has been shouted, and all has been shouted. So you'll notice these guys are lowercase, but shout is a text transform to uppercase. So you can even change the case of things. And then in third, for example, where's third at? Third says within. So this says find the third div, which is right there, and find all the p tags within the third div. This p tag and this p tag, and then apply a background color yellow to all those, which leads to this right here. Okay? And so # means find ID and apply. Dot means find class and apply. You can have multiple classes, right? Pull in the definitions from two classes, shout space load, go find the whatever's in CSS. And then you can kind of have hierarchical things, and this is quite useful because you don't have to get special. It saves you putting classes on. It saves you from putting classes on all the paragraph tags here. You don't have to do anything, but you're not affecting the paragraph tags outside here. You're only affecting the paragraph. I think of this as go find third and the paragraph tags within third, and then do something to them. And that way, otherwise you'd be making more classes than you need to be. And so this is a very well-liked technique for really fine-tuning your selection, your selector for CSS to touch only the things that you want to touch. So up next, we'll talk about images and colors and fonts and a few other things. So welcome back. Now we're going to talk about making our stuff look a little prettier with images and how we can play with images, colors, and fonts. So CSS and images are a lot of fun. We can fool around with them. We can move them around. Actually, this for me years ago was the thing that in 1994 that made me fall in love with the World Wide Web. So what made me fall in love with the World Wide Web was the ability to take a picture of me, and I love pictures of me, and then float it to the right, and then I put a little border around here. And so that's what I've done with CSS. So let's take a look at how I've done that. So if you look in line here, the navigation, which I'll show you when I go through the code walkthrough how the navigation works. But at this point, at the end of the navigation is right here. And I put this image in. So if you were to watch this inline, the image is right there. But what I do is, when I say float, that actually, and there's other things that we'll see when we start looking at fixed and absolute positions, you can pull it out of the regular stream. And so this is like pulled out of here. It's as if it didn't exist. And it floats to the right, but then it's vertically aligned. So the next thing you see is this header 1. This header 1 CSS, oh, there's a typo there. I got to fix that. So I'll pretend that was an H1 there, but that's okay. So this header at Quarks mode, I should run this all through the validator to make sure I'm okay. But okay, so the top box of this CSS and images H1 is right here, and then this floats over, but then it top aligns. Now you can change this alignment if you like, but it top aligns here, and then it actually looks at the width, in this case the width of the picture, but you can also control the width up here in the CSS, and then it carves out this space, and then I do a margin of 1em. And so on M, you sort of sometimes wish they would put default formatting on, but then they kind of tend not to put default formatting on, because if they did, then you have to turn that off. And so I wanted some white space, and so I had to put some white space around it. And so I said I'd like a margin of 1em, and so that puts a little bit of space here and here and actually here as well. So you see that this lines up over there. And then that talks about what is a 1em. So 1em, I could have said 5 pixels, 5px, and that would have been fine. But 1em is basically the width of the letter M, roughly. It is a width that changes with the size and nature of the font. I think of it as the width of an M, and I think that might be a soft definition of it, but I don't think it's a precise definition of it. But that's what I did. So float right hoists it and sends it over here, and then shoves this over so that this text is now, it reserves this space so the text is wrapped basically, and then I held out some space just for prettiness, right? And so that's like CSS is making it look pretty. Now what happens here is sometimes you want to basically force, after this float has happened, something back to the left margin, and there's this clear equals all that says clear any floats is what it's really saying. And so it means that even though this, if it wasn't for clear equals all, this next paragraph would have been kind of up in here, and then maybe it would have wrapped if it was long enough. And when you play with this, you can resize it and see how the wrapping changes. But no matter what the size is, after the BR clear equals all, this is going to format back to the left nav, right? So that clears that hanging wrap, that sort of. But you don't have to. You could not do this, and then it would wrap and wrap and wrap, and then it would get longer and it would continue on. But if you want control over that, you can with the BR clear equals all. And of course, you can have images right in line, and this is just from the HTML bit here. There's nothing fancy CSS here. Images kind of are like big characters. I sized that one so it sort of fit nicely, and you could even make this a clickable link. But that's really just, this part here is just HTML, not CSS. But I could have, if I wanted to, change the width and the height of this. That'd be kind of fun. Make this guy be like the width of an M, and then you'd see it more like a character. So there's a bunch of colors, and the colors have to do with, there's the simple thing for us simple folks. You know, we just put in things like red and green and stuff like that, and especially if you're doing a developer and you're just trying to get basic stuff working, I often use colors in my testing. That, like, put the border red. I do that all the time to say, where was that div at anyway? So I'll throw a 1 pixel border around it, red border, like, oh, that's where it is. Although the Chris Pedrick plugin has a thing where it puts 1 pixel borders around everything for you automatically. But whatever. These are not necessarily most graphically beautiful colors, even though I like them because they're super primary in terms of primary colors and strong. You'll see that I kind of use those colors in my slides a lot because I'm not a graphic artist, of course. I just like, oh, the greenest I can be is good. So there's 16 official colors, and they're here. Once you get a little more sophisticated, you can use precise colors from I think this is a, I don't know, 32-bit. Yeah. So this precise colors are the ones that start with £. And so £, and these are hexadecimal numbers. These two numbers are effectively 0 through 255, but they're in hex. So hex is like A, B, C, D, E, F are actually numbers. 0 through 9, this is actually 10, 11, 12, 13, this is 15. And so E is bigger than 9, and F is bigger than E. But basically these are 0 through 256, that's a three tuple of 0 through 256 numbers. And so the more red you put in, the higher this is, the more green you put in, the higher that is, and the more blue you put in, the higher that is. So RGB, red, green, blue. And if you're playing with like a slider inside your UI, you might be changing this, but you're just changing these numbers ultimately. And so you can find these things. You know, so white is all Fs, and so if you turn it all on, it's white. If you turn it all off, it's black. The absence color is black. Red, green, so you turn, that's max, max, and max, and so you can make sort of a pure red, pure green, and pure blue. Picking these advanced colors is sort of way beyond my ability as a graphic artist, and people will pick colors. There are sites that help you pick palettes for your pages, etc., etc., etc. There is also a sometimes these colors can have a transparency, and there's a fourth set of two numbers that have to do with how transparent the color might be. So fonts are also important. The default font is a Times Roman because that's what computers had in 1994. And I think they're ugly, especially on screens. They're not so bad on print, but they're ugly on screens. And so I tend to want a sans serif font. It's too bad that and maybe they have changed on some browser default for sans serif. I just change it to sans serif all the time I want. Now if you look at fonts, the font family is kind of a special tag, in that you ask it a set of fonts, and what you're really doing is you're setting a priority. And the problem is depending on whether you're on Windows or Mac or which version of Windows or which browser or what fonts they've had installed, you can, fonts might not be there. And so what you basically do is you basically say, okay, I would like this. I think this is a Microsoft font. And if that font's not there, then I would like this font. And I think that might be also a Microsoft font. And if that font's not there, then there's Arial. See how much I know about graphic arts? I have no idea. I think this might be a Mac font. And if that font doesn't work, default into the fallback font sans serif. And there is always going to be a serif font, Times New Roman like, sans serif, Arial like, monospace, which is Courier like, cursive and fantasy, which are whatever. And so all browsers are supposed to have those fallback fonts. And so you tend to see them here at the very end. And so when you see me, I usually will say Arial sans serif or something like that just to get sans serif. Although it's quite common, the more sophisticated a page is, the more likely. And the other thing that's increasingly the case is people are downloading fonts and having special beautiful web fonts, and then they download them and then they put that font in here, but then they probably still have fallback fonts. So font family is kind of a weird and unique and glorious thing that leads to some really gorgeous web pages, because so much graphic and arts work is going into making web pages beautiful, and we're going way beyond the operating system installed fonts and having pages that download their own fonts. Things that you can do is set the things to bold, italic, text decoration. Remember, links have underlines and we can turn them on or off. Font sizes are kind of troublesome in that you can set them to pixels, but then you're in danger if you get to a certain kind of a screen size or people start zooming the screen and stuff. And so you can tend to use these relative ones, but they're not as guaranteed as you might like them to be. And so just these are a little bit tricky. Absolute font sizes are a little bit dangerous. I tend to just go like, here's my font. Here's the one that's a little larger. Here's a little smaller if I need that. So most of the time I'm tending to do things that are like smaller. If I'm putting like a copyright statement and I don't want to distract from the main page, I'll just make it a little small. I'll say, okay, make this small or extra small. And what if it doesn't turn out to be that much smaller? It doesn't matter. I'm just kind of trying to so I'm not an expert in how to use those. I tend to use them as simply as I possibly can because they're not as predictable as it would be nice if they were. So links were a big part of the early web, and it's called hypertext markup language, hypertext transport layer, hypertext. And so links got really special treatment. They used to be blue before you clicked on them and purple after you clicked on them. The blue was to jump out at you and say, please click me. And the purple was to say, I've been there, because a lot of what you did in the early web is you wandered from place to place to place to places like, oh, I found a new thing. Let me explore this. And so you're always like exploring by clicking links. Once we got to the point where people assumed the web, these links didn't need to be blue and garish colors to teach us these things because people just clicked on everything. And so it became more important to make things pretty. So we have a lot of control as to how we style links. We can say the A tag, we've already colored an A tag with just the A at the top. You can basically say an unvisited link is supposed to have the color black. After the visit, it's supposed to be gray. While you're hovering over top of it, it's supposed to have text decoration and down there and be black, white with a background of navy. And then active is not so heavily used. It's once you've clicked on the link while the page is loaded. So it's a way to kind of, maybe disable it or turn it a color so people think, oh, I better wait until this next page loads. And so when I do the recording, you'll see this. It's a lot easier to see this dynamically. And so there's a whole bunch more samples that I have, and I'll record some walkthroughs of every single one of the samples. And so you can take a look at that at Web Applications for Everybody or in the recordings. So this has been a zoom through CSS. CSS is quite the art and science, and it's evolutionary. I mean, people specialize in this. They're very good at it. It's a modern form of graphic arts. The basics are there, and I think every programmer who does anything on the web should know the basics of HTML. They keep moving things better with things like nav tags and Bootstrap, etc. And while there will always be like edgy new things in CSS, and so sometimes you'll see CSS with like these Moz fields, which are for Mozilla, for the Firefox. But people are always pushing that boundary. And before you couldn't put rounded corners on things, but then the browsers added extensions to put rounded corners on things. And then everybody kind of agreed on that. So CSS is kind of always going to get better and better and better, because for the mobile and desktop, they really want to create as beautiful experience as possible and use standards wherever possible. And so the basics are there. You can do so many wonderful things, especially if you pull in something like a bootstrap that just kind of cleans up the rough edges of HTML and makes it generally pretty and takes a lot of responsibility off of you. But you can certainly make a lifetime study of CSS if you like. So I hope you found this useful. I will see you on the net. Hello and welcome to Web Applications for Everybody. We are taking a look today at cascading style sheets. You can download the source code and unzip it on your computer if you like, or you can browse this code and just play with it in the browser, because it's all static content, so it's just as easy to play with it in the browser. And of course, we're going to want to take a look at this in the developer console. It just makes a lot more sense to get into this, and so here we go. We're taking a look at CSS. There's a couple of ways to do this. We can see here, we can see the style attribute. Style color equals blue, and there's all kinds of various CSS parameters. Color is the parameter and blue is one of the values, and you gotta look all these things up. One of the nice things that we can see is we can see over here, as we move between elements in the document object model, we can see what the CSS values are. And so Arial sans, like for example, this is cascading. The body on here is Arial or sans serif, and that means an Arial font if we can get it. Sans serif is a fallback font. And so that this H1, this little bit right here, this H1 is being colored. This is ours. Browsers have their own default, so display block, font size 2EM, which is twice as big as the rest of the font, etc., etc. And so this came from the browser, and then this came from the style sheet. So this is cascading, and the bottom ones here are this is the most important one, because this is the one we said that's closest, and that's how the cascading works. Yeah, we already saw that. We already saw that. And then the cascading is, again, we take a look at this little guy here, right here, and so the closest one is we want a monospace font family, but the body said the font family is Arial and sans serif, but this one has been overridden, and we can kind of see that, and that's why this particular text is monospace. Another thing we can do is we put border style. Now when I'm working with this stuff, I tend to remember border a lot, because it's a good way for you to mark something out and say, what am I doing here? And we'll see, like when we're moving text around, border, solid border, a red border, and a 5-pixel border. And so that's what we see. And you can also see that there's some extra padding around there as well, or some extra margin. And margin top, that's another one. I'll scroll this up a bit. Margin top throws 5 M's of space above the text, and so this is a normal paragraph. We got 5 extra M's. Now what's an M? M is the height of a character in the current font, and so M's is a really convenient measure. There's M's and pixels and percent. So margin before, that's 1 M over here. The paragraph already has an M. Margin before, and then, well, hang on, come down here. Down to here, we've added the margin top. So this margin top overrode the margin top that was part of the paragraph tag automatically. So that's these style rules. So let's keep on going. While this is technically possible, this would really be overwhelming to put a style on every tag. And so one of the things we tend to do is we want to put style rules that are generic. So we'll say we would like the body tag, and this is a style rule. This is the selector, body, and then font family. And again, font family works as please give me the Arial font, and if that's not available, give me sans serif font. Curly brace, H1 tags. When go through the whole document and paint H1 tags blue, go through the whole document. whole document, find every paragraph tag, set the border style to solid, border color to red, 5 pixels. So you see that every paragraph, and we're going to change our anchor tags to have green and have no text decoration because they're defaulted to have underscore, and we're going to make the background color light gray. Why? Just so we see it, so you can see that particular thing up there. And then if you look down into the text here, we have paragraph tags and an anchor tag, and no style equals down here. So what we've done, ignore that little part there, that's what puts this little thing in the corner, so that's not what we're talking about. We put no style tags whatsoever, and we put all the style tags up here. But now we've also done something that all the paragraphs have to have the same style, which sometimes is what you want, and sometimes it's not what you want. Now what happens again now, if you have multiple pages, as we have here, it gets a little tiresome to put this text in every page. And so what's really common instead, so now we have the same basic rough paragraph stuff here, nothing in here. We have a pre-tag, of course. We have a paragraph tag. There's no style equals on these things. But up in the head, we have one line right here that basically says, let's take a look at this style sheet. And if we were to look at the style sheet.css, it is in the same folder, rules.css. It's in the same folder as that HTML file, and it's exactly the stuff we had there. It's just a set of selectors and then a select of key values we want, color blue, border style, border color, etc., etc., etc. And so it really is the same as what we showed before, except now that we have to put this into every file, and you'll see we'll put this now from now on in every one that I'm looking at. And so, but now our problem is that we've done something with this to do all the headers, right? All H1s, all paragraphs, but we need better ways to mark text. And so, we have these tags, and these tags that we use just to put handles on. In the old days, like this paragraph tag has this border. See that has the margin up there. I mean, it has the border, but it has this 1em margin. That's that space that you're seeing that makes paragraphs look good. I mean, it's not a bad thing. And so if you look at that, we have all these colors. We've got the strong tag. By default, the thing uses a serif font. I don't like that. So let's get down to here, and this. Well, let's just look at it here. The span tag, inspect element, right there. Okay. So the first thing is the span tag is an inline tag that has no styling. The problem is before CSS, which is a long time ago, all these tags had default styling. But the span tag is an inline tag with absolutely no styling whatsoever. And then the div tag is a block tag that has no styling whatsoever, and it can be nested. So it's kind of like a paragraph tag, but it has no styling whatsoever. Now I've added a 1-pixel style, and you'll see that these div tags don't have any extra space, like the paragraph tags came with space. Now some people would go and turn off the space on a paragraph tag, and there's even CSS files that you can to take all the default styling off tags. But you'll notice these divs don't have any space. They're really kind of a block. When I put these pixel on, you see the border. If you look really close, you'll see that there's a 1-pixel blue line and a 1-pixel orange or sienna line right there. But the divs can be nested, and they don't themselves start. So you'll notice that here they don't start with any kind of formatting that comes from the browser, whereas if we look at paragraphs, there is formatting that comes from the browser. And so the div tag and span tag are just are ways to put handles around blocks of text or chunks of text and then style those. But then we still have to figure out how to grab our handles and make it so that our styling doesn't just touch one thing. And so here I've got a couple of things. I've got the body tag, and I'm setting font family. You'll see me do this all the time. And now I have a pound sign, and this says go find all the tags name body. This says go find all the tags with a attribute of first, ID equals first, ID equals second, and then class and shout. So if we take a look at the text, there is the notion of an ID tag. Okay, an ID tag that is unique within the document. So we're going to call this div first, we're going to call this div second and this div third, and they correspond to first, second, and third. Okay, and so first is first is monospace. What is it? First is monospace. Second is green. So everything that's in this block that's second has been green. And then, but you can only have one ID name first. But class you can have all over the place. So we can have, we can put the more space class on a couple of different tags. So this tag, more space, all more space does is shove it in from the left and the right, margin left and margin right. So it kind of pushes this in. And so you can put this on here, you can put it another place, and so the more space pulls in something here. So here's another paragraph that's got more space. That one has more space. This one has more space. See that one? And so you can put more space on as many times as you like, and then div third. Right. And so the hierarchical section means, in this case, this one's a little bit, and loud is red, so where's loud at? So let's inspect that one. Inspect element, yeah. So that's the loud is not only red, but it's also forced uppercase, text transformed to uppercase. Shouting and loud, and you can have more than one class on on a tag, and then you can be even more precise with your selection. This is basically, this says find a third ID and then only paragraphs within that tag third make their background color yellow. And so that means that background color yellow does not apply to this tag, it doesn't apply to this paragraph, doesn't apply to this paragraph, but when you see div ID third, we have selected this paragraph and this paragraph, and they have a background color of yellow. So continuing on, let's take a look at a simple navigation bar. Now, there's this nav tag that's an HTML5 thing, and if you look at most navigation on pages, let's go to the next one. They're pretty and they got colors and they move around and stuff. But what we want to be careful when we build our HTML for these kinds of things to make them very, very simple. And so what I've got is a navigation is usually, we describe it, we use a nav tag, which is a block tag that says, hey, this is our navigation, useful for screen readers, etc. And then we're going to say we're going to have a list of two links, and so that's what we're doing: unsigned list, unordered list, and a list element that's just no paragraph here, just an include, just a anchor tag, and we're going to put a class equals back and class equals forward, so we can style these two things differently in the future. And so this is what this looks like with no CSS whatsoever. And so this is a nice, elegant, clear HTML. And so if you were just looking at this HTML, like a screen reader might be looking at, you can see what this really intends to mean. Now, then what we do is we add a little bit of HTML to this. And so for now, we're just not going to bother, but in navbar.css is the HTML or the CSS that makes this pretty. And so there's a whole bunch of stuff, and we'll come back and take a look at that in a second. Okay, and so there's our styled nav bar. So I'll come back in another video and pick up right here. So welcome back. Now we're going to take a look at some more examples. We're not going to, the one thing we're not going to look at is exactly how this navigation bar works, at least until a little bit later. So the next thing we're going to take a look at is how fonts work. And there's a couple of ways that you can put fonts into a file. There are default fonts that every browser is required to produce, like serif, sans serif, monospace, cursive, and fantasy. And so you don't exactly know what's going on, but they're often used as fallback fonts. And so you can have those. There are any font that is on the system like Arial or Helvetica. And so if you're going to use Arial, not all systems have Arial, although most of them do these days. And you have to have more than one font. Now another thing that's really common these days is to include a font somehow. You find out about a font, and here's a Lotto font, and you go look it up on the web and you find, oh, include this. And so I included this link because I found this really cool font, Lotto. And this extends the browser. The browser then learns about this font, it downloads the font, caches them, and keeps them in the browser. And then I can make a font that's Lotto. But just in case I'm off the internet, and I can't download this thing, I have sans serif as a fallback for Lotto. So Lotto is a fancy font, etc., etc. So there's Arial and built-in fonts, etc., etc. And so that's how fonts work. Colors. There's a lot of cool stuff about colors. There's a couple different things. We'll ignore the nav for the moment. I'm just using span tags here. There's some default colors in the earliest of browsers. These days we have all these fancy ones, and you can go look these up and you just Google for HTML colors. And there's a bunch of names, and then they're consistent across browsers. But there's like 12 or so really solid names that are in all browsers since the beginning of time. But more modern browsers have a better palette of colors. Although really good graphic artists want to have much better control of colors. And so this is, the pound sign says that this is a hexadecimal number, and it's got 2 digits. Hex means they go all the way up to F. So F is A through F are numbers. 8B is the red level, 45 is the green level, and 13 is the blue level. And so this is a brownish color. And then there's what's called web safe colors, where you just have, this ends up being 88, 44, 11. But it sort of reduces the number of potential colors if you were mixing colors from various sources. And then in HTML5, you can see this color picker. When you have a form, which we'll talk about in a bit, it's a color form for modern browsers. And then you can pop up with this button, a color picker, and I've got a little thing to print out what the color would be. And so it just, when I pick the green, it basically puts 00FF, that's red, green, and blue. It puts that into this thing, which then the program could use. Could read this, or JavaScript could read it, or server code could read it. But right now we're just kind of playing with the picker, and we pick a different color. And so that magenta is all the red, none of the green, and all of the blue. And orange is all the red, some of the green, and none of the blue. So those are all just really strong colors. And so that's what's called an HTML color picker. Anchor tags. In the old days, anchor tags were kind of funky. They were blue if you hadn't yet visited them, and they were purple if you had visited them. And so this one I've obviously clicked on. And so we have a whole series of styling mechanisms that we can have. If we take a look at these, I have put these all inside of an ID tag of cool. So this is basically saying find the ID tag of cool and then style anchor tags to make them font weight bold. So let's take a look here. So I got one paragraph that has this one here, and then I have a paragraph with an ID tag of cool, and that's basically so I don't have to style. Usually you wouldn't say I'm only styling the anchor tags inside of, if I'm only styling the anchor tags inside a tag that has an ID of cool, but that way I can have the default on this one. That was my way of keeping the default. So normally you would just say A. So A links is red. If it's visited, it's orange, and so this one's been visited, so you don't see the red. It means it's unvisited. Hover, you can change it. So you notice when I hover in, the text decoration goes away, the underscore goes away, and I have a color of text font color of white and a background color of navy. And then there is one last moment. Can I click on this one? Oh, that will click. There's one last moment that's really hard to catch, and that is the moment of active. If the web was slow and you clicked on it, then it would tell the user. In the old days, this made more sense. that it would turn red and then blink away. I don't know if we'll even see it. It kind of saw it. You sort of saw it. And so there was a color while you click on it. Yeah, there it was. You might not see it in the screen, but that's what the the active means, is you've clicked on it, but it hasn't yet been retrieved. And then like a moment later, the whole page goes away. Another thing we can do is we can play with images. Okay, and so here is an image. One of the things that's really fun to do with images is float them to the right or float them to the left. And then what happens is that the image, the text is drawn around the image, so it wraps around the image. And you'll notice where I floated this left. Oh, I kind of got rid of everything. I floated it left before the H1, and so what happens is the H1, top of the H1 and the top of the image line up, and then all the text afterwards wraps around it. And so you'll notice that I've got the image first and then the H1 second, and but the float sort of disconnects the image from the normal line of flow, floats it over, and then takes this next thing and the next paragraph and saves the space for the image and shoves the margin over so that it comes over here. Now once you start floating images, you got to learn about this clear equals all, because if we want this next paragraph, like this one, we don't want this paragraph for whatever reason to be on the image. Now if it goes far enough, you see this paragraph here moves back to the left margin, and then this next one starts there. But if the browser is wider and the text is, there's not so much text, we don't want this to be up in here. And so you say BR clear equals all. So between this paragraph and this paragraph, we do BR clear equals all. And you can put images right in the middle of the text like a character. You don't have to have them by themselves. And you can even make an image that's a clickable link. And so you can click on that image. Now, C in CSS stands for cascading style sheets. And so the idea is that the tag that's closest has more precedence than a further away tag, unless you say important. Okay, so here we have some style. Here we have a body tag, border style of dotted, red, and red, a border color that's red and important, and border width that's 5 pixels, background color, which is kind of a grayish, that's that gray, and extra padding, so we've got put some extra padding all the way around it, and extra margin. And so if we take a look at this, we take a look at this paragraph right here, we see some things, and we take a look at what we've got. So we've inherited this, we got a border style of color, it wants to have a border color of green, but it doesn't because it says the border style is solid. So the border style of solid is down here in the second style tag. So the second style tag has precedence because it's closer to the paragraph. And so we tried to say border color green, but that one was overridden. So otherwise this would have a solid green border, except that this red important is up there, and so that the red important wins. And you can see it really easily here that this was overridden, and this is the one, this border color from the previous one is taking precedence. Okay, and so this is the second one, and it would normally take precedence over this one, except that this important is sort of like it is overriding the one that's closer. So another example of closer is the style tag. Okay, and so here we go. This is border. We're putting this. Style attribute. We're saying border style equals dash, border color equals blue, and so the border style equals dash holds on, but our attempt to make the border color blue is overridden again by the red important. Right, so important is up above that. Okay, and so this dashed is winning, and this blue is not winning because there is an overriding red above it. There's an overriding red important above it. And so if you want to override an important tag, yay, we override an important tag right here. We basically say I want a border style dashed,
come over here, border style dashed, and I want the border color to be blue, and this is important. So now this one's closer, and it says important. So among all the important ones, the closest important one wins. So now we see that the border color actually takes here, and we are overriding the far away. This one here from farther away got overridden because of this one. And so you can do that. Now, in general, while I've shown you how important works, you shouldn't do too much with important, because usually you're taking CSSs from other places and you're patching it, and you can end up with really inconsistent looks and feels with important. Usually when you see important, it means kind of something's wrong and you're fighting with a framework or something else. So let's take a look at some blocks. And so let's see, background color, my H1's color blue. And I'm going to put some padding and a margin. And so div P and H1 sort of live in a box. You have sort of like the actual, so let's take a look at, say, this paragraph right here. That's probably the thing to do. This is just a plain old paragraph. Nothing special, right? There we go. That's a paragraph right there. So let's talk about the padding and the margin, right? So working from the inside out, there is the actual text that is, and it's wrapped. And so if I change the width of this whole block changes, right? It gets taller and narrower. But at some point, the inner part, this inner part right here is, the inner part is however large it becomes. And that, in this case, it's 318 by 38 pixels, right? And then what happens is we sort of work from the inside out. So I'll go down here and see the box model. So the inside of this, the actual text is 619 pixels by 19 pixels. And then I've asked to add 10 pixels of padding, and that is between this sort of text and the border. And then the border itself has a width, and I specified that border width. Right, I said I want a 5 pixel border width, and so the border width takes up 5 pixels. And then there is, outside of that, there is margin. And so margin is space. Notice that the padding and the text itself has the background of the block, border has its own color, and then the margin has the background of the color of the background document. Okay, so this is the margin here, it's the color of the background document, right? So content, padding, border, margin, and then but the padding inherits from the text in the box, from a background, and the margin inherits from the background document. And you can have different background colors, etc., etc., etc. This is an, oh, by the way, this is an ordered list that we've got going on right here. Okay, so that's CSS boxes. We can change the size of these boxes. It's a little tricky. So and so here we have auto sizing div where we're not mentioning anything about the height. If we take a look at the box model here, we see that this one is simply, you know, the size of the text plus the padding plus the border plus the margin, and that's sort of how that box gets sized. You can say that you want to set the size of the box. Okay, so I'm going to set that to be 3 M's. 3 M's is 3 characters, but if you look, I have too much in here. And so you'll see that even though this box is 3 characters tall, it's 4 lines, and so the 3 would fit, but the 4th one doesn't. And so it just overflows. You can also, so 3 M's, it's good to set sizes in M's when you can, because then if someone makes the screen larger, oops, I didn't mean that. This one, if someone makes this larger or smaller. Now the problem is, well, I don't know about it, if we'd call it a problem, but in the old days, if you set a height in pixels and you zoom the screen, the box where you set height in M's would zoom, and the one that you set in pixels wouldn't. But they decided to make zooming work. Otherwise, so many people made boxes in pixels that they made it so that the zooming would pretend that pixels are really M's. So it kind of converts pixels to M's, but you're supposed to avoid using pixels when you really mean characters. If you want 3 lines, don't look at your font and say, I'll make this 40 pixels in order to do that. And again, in this box, we still have overflowing text. And so we have a couple things we can do when we want to change the overflow. We can tell a box that we would like the overflow to make a little scroll bar. And so here's that same stuff, and you can see we got a little tiny baby scroll bar, and it didn't sort of blop out of the box, right? And even if the scroll fits, you see you get little scroll bars, but you can't scroll it because there's only one line there and it fits in the box. And then another thing that you can do is you can just say chop it off, right? Chop it off. Now, one thing with some JavaScript, you can put a little more here and that expands the box or pops a bylog or whatever, but we're not going to worry about that for now. For now, we're just saying overflow hidden means lay this out as much as you need and then, you know, throw this text away. It's just not there anymore. Like, where did all this text go? But it doesn't show it because we told it to chop it off. Okay, so on to the next one. You can move these things around. This is a little messy. There we go. Let's make this a little different. Okay, so by default, I'll show you the HTML in a second for this, or maybe just do view source. Let's do view source. Okay, so if you just say div, they just follow after each other. And I've given them border because to make them a little picture, give them some border, some padding, and some margin just so they don't touch each other too much. So by default, blocks just, so I got a little border both on all sides and a little bit of space between them and a nice. So they, you know, however big they get, this one gets bigger. And I put a width on them just so that they wouldn't move around. And there's a width on it right there, 10 ems, 10 characters wide. So they just follow each other. And then you can say, okay, you know, this block right here, this number 3 would lay out right here, but I have told the number 3 block, that I want to move relative to where you would normally be 20 pixels to the left and 20 pixels down from the top. And so this block, it lays out exactly as if it belongs right here, and then we shoved it over and moved it down. And it came over top of the number 4 block. And so there you go. And so the text afterwards, this number 4 block, just comes next, and it's basically, it's as if this laid out without the position relative, and then this came afterwards, but then we sort of just shifted it, and that's why this overlaps, because this corner here is where 3 would have finished and with a normal layout. So you got to be careful with relative. I mean, you don't usually want to make it so that they sort of blop on top of each other. Okay, and so now we're in 4, and then we're going to look at 5 and 6. And so 5 is what's called fixed text. And you'll see the 5 comes right here, but because I've got this as position fixed, this is fixed relative to the window. So it's 20 pixels up from the bottom and 30% of the way from the left margin. So you can see that this is 30% of the way from the left margin, and it's the bottom of it is 20 pixels up from the bottom. And you'll see that that green box never moves, and that is because the fixed text is relative to the window. And that's how we actually get this little link that never goes away. And so there's a link that never goes away. Absolute text, I don't know why they call it fixed and absolute, but absolute text is a little bit different. It's relative to the parent element. And so in this div right here, the parent element is the body tag. And so when it's saying, I would like this to be 40 pixels from the top and 30 pixels from the 30% of the way from the left, that means it's relative to the body tag. And so the body tag starts up here. And so this has been sized 30% from there and whatever, 40 pixels down. And notice that that one goes with the scrolling, right? So that one goes with the scrolling. And you'll also notice that between 4, 5, and 6, there's like, it's as if there's nothing here. But if you look at the document, 5 and 6 are sitting there. And that's because they are plucked out of the normal rendering stream, and so they don't take up any space between 4 and 7. So they don't count in sort of the normal layout as the page is being laid out. And so here's number 7, for example. Actually, number 8. So here's number 8, and so this is positioned relative with a left of negative 1,000 pixels. And so in a sense, this stuff right here has been shoved off the screen to the left. And so that's how we often will put text on that nobody sees. Just move it to the left. But it takes up the vertical space anyways because it was just relative. It would have normally laid out here, but the left shoved it over there. And so that's basically some layout. And so now we're going to talk about z-index. Let's take a look at the source code here. And so z-index is the ability to what happens when things overlap, okay? And so this is a div. Number 1 has a z-index of 100. Number 2 has a z-index of negative 100. 0 is sort of the background document. And it works out pretty straightforward. And I'm just moving these so they have to lay on top of each other. You know, and so you see this one here is negative 100, so it's kind of behind everything. This one is positive 100, so it's in front of everything. And this number 3 is, yeah, it's in it. I just put that there to be in the original document with no z-index whatsoever. And so it's behind this thing that has a z-index of 100. Okay? And so that's z-index, like this little note way over here by the right margin says, z-index is kind of tricky. Everyone tries to be on top. And you'll put z-index of 100 and then you'll find that the navigation put itself as z-index of 1,000 or something like that, right? And so z-index is hard to debug and hard to fiddle with, but at least now you know that z-index is when things look weird and they're overlapping in weird ways, z-index is what you're taking advantage of. And so now we'll take a look at kind of how this navigation works, okay? And so here's a couple things that the navigation does. The body, of course, is font family Arial sans serif. The navigation bar itself, I guess I'll do a view source on this so we can look at the navigation bar. The navigation bar itself, this block, it's a block tag, right? That has a position of light gray, and I've given it a height of 3m, so it's like 3 lines. And if I zoom this page in and out, right, that gets bigger and smaller. I'll get back to 100%. It's 3 lines tall, and I guess I didn't need to say Arial sans serif. I did that in case someone else wanted to change the body tag, I guess. So then I have I want UL tags within the nav, and that's one of the nice things about this nav being its own tag. I can style just the ULs inside here. Okay, and so what I'm doing here is I'm saying I don't want any little circles, little dots, little bullets. I don't want any of those. I want to take away any padding that it has by default. This is one of those things that this UL inherits. Let's go down here and take a look at this, and you'll see that this UL right here. So what's happening is this is the things that I've said in my CSS, and I'm overriding some default things. It's normally would be display. It's a display block. That's okay. And so I overrode the list type style. And continuing on, the list item inside of nav, that's what it is, nav and list item. I wanted to make that, so let's inspect this guy right here. Inspect. So if we look here, and I've got a class of back, and so I have this positioned absolute, which is relative to the parent right here, and I have it 20 pixels to the left of that upper left-hand corner, and so that's how this comes over here. And then I have it colored dark blue because it's a nav, an anchor tag within an anchor tag within an li tag within a nav. That's what this is saying. Dark blue text decoration of none, and so that's where I get this color blue and no underlines. And then this is the dot back, and so I use a back class to position this right here, and then I use the forward class to position this relative on the right, 20 pixels from the right. And so that's how I make the navigation bar work. And CSS is really a lot of work. We learn a lot about CSS, and this is just a really short introduction to get you a sense of what the basic mechanics of CSS are. Thanks for watching.
Hello and welcome to our demonstration of how to move your code into GitHub. This is optional. You don't really have to do this unless you've been assigned to do it. And please don't put your stuff into a public repository because you really don't want to share all your solutions with every other student on the planet. But if you have a private repository capability on GitHub, perhaps you got it through GitHub for Education, then go ahead and this is how you do it. Okay? So, of course, GitHub is a great place to store everything. I store the website for this class even in there. So this is my GitHub. And so I'm going to create a new repository. I'm going to call it Django Projects. New repository. Django Projects. And my Mozilla Developer Network, Django Projects. So these if you've been doing this in order, you already have something in the folders. So you don't want to fill this with anything. So don't check this, don't check this, don't check this. Leave this all alone. You can add a git. We will actually add a git ignore manually in a second, and then we're going to create this repository. Now, when you create an empty repository and you haven't put anything in, it tells you how to fill it up, and that's what we're going to do. So I'm going to copy this. Well, I'll have this later. So remember this. Okay, so we've got that repository. Now we're going to go into Python Anywhere, and I assume that if you go into your console, and if you've got stuff in there just from before, you just type clear. I'll say CD to go into my home directory. Take a look, pwd, I'm in my home directory. Okay, so if you do an ls, you will see that there is Django.projects, which is something we created in the previous assignment. Okay, so first we're going to create a git ignore file. So I'll cd into Django Projects, and then I'm going to use nano to edit the file git ignore. Now the dot is a file that you're not going to see when you do ls. We'll show this to you in a second. Just put these 3 lines in. Zoop. Put those in, and then Control X, and then yes, and then save it. So if I do an ls, I don't see it. If I do an ls -a, I do see it. So -a shows you the files that start with dot, which are the hidden files. Okay, so I've created this file. I can type cat.gitignore. Cat shows you the contents of a file. So it has 3 lines. There are text lines. Okay. So now this is my site that I created. I'm in the Django projects, and now I'm going to follow the slightly altered versions of the instructions from GitHub. So these are the instructions, but I've got them kind of tweaked a little bit. We're going to set the push strategy. Git add star. So now we've created a local GitHub repository. We're going to add these files. It doesn't find the .ignore file, so you got to add that one explicitly. Git add ignore. Git status is always fun to type. It tells you what Git thinks is about to be done, where changes to be committed. They're not there yet. Now, in order for it to stop asking you so many things, we're going to tell it what our email address is. And what our name is. I like using my middle initial because as the internet goes, more and more people have the same first and last name. And then when we start pushing stuff up here, it's going to keep asking for our account and our password. And this cache idea here is going to make it so we don't get asked that quite so often. And this way, I think it's like 10 days or so. So that's credential helper. So I'm just going through all these things. So GitHub -m. So this is a message. Commit is preparing to actually send the data. It doesn't actually send the data. -m is a commit message, so it's our first commit. That's traditional. And if you type get status now, you will see that we're committed, but it's not yet pushed to master. Okay, it's not yet pushed. So now you have to say get remote add origin. You got to add this, but this really needs to be you, not me. CSEV. Now that turns out to be the exact URL that's right here. GitHub.com, Django projects get. I got that right. Django project. This is not actually sending it, but this is telling it where to send it. Okay, so now it knows where to send it, and we're just about ready to send it. Get push u origin master. Okay, so now it needs to know your GitHub account. So I got to go get my password off a different screen so you don't see it. So now I got my password right and it's all sent. And so at this point I can go back here and actually I can just hit refresh because I'm in that Django projects thing. So let's hit refresh. And son of a gun, here's all my GitHub stuff. And that's all good. I went and I checked, and so it's all there. And I can type get status, not that it's going to tell me anything particularly great, but we're on good shape. We got a remote. Another command you might type is get remote -v, remote -v, that tells you where you're going to be pushing and pulling. We're mostly going to do our editing here on Python Anywhere and then pushing, and we'll in future assignments I will tell you if you are choosing to store your stuff in Git, giving you some commands. So that basically gets your code into GitHub so that you can track the changes as you make changes as it continues. Hello and welcome to a supplementary video on installing Django. Now, normally in this class, all of the applications are going to be run on this MDN, on this Python Anywhere, but it turns out that maybe you don't want to get a Python Anywhere account and you want to just run this locally on your local computer, whether it's a Mac or a PC. I'm going to show you a Mac, but the PC is very similar. So the problem that you have is, so here I have a Django application sitting here in my test site, and then I can say Python 3 manage, and then run server, right? And so it starts up and it tells me, look at that, I can talk to HTTP 127.0, and so that works. So I'm talking to this application, and you can even see that it's talking. One of the nice things about running things locally is some of the logs that you have to go into Python Anywhere to look, you're just seeing them go by, including, like, you know, the errors, etc. And so some ways, and this is reasonable, but I prefer Python Anywhere because then folks can don't really need to install stuff, and people's install environments gets messed up. And so, but if you're skilled and you want to run this on your own server, I want to show you how to do this. So we did it. But the problem comes out when we use the autograder. And so we have this document about how to use the autograder with a thing called ngrok. And so let's take a look. It's easiest to just explain this. Oh, they don't have the picture on here anymore. So how it works. So the problem is that in effect, I am this autograder out here, and I need to talk to your computer, but your computer has a firewall built in, which means I can't make a direct connection. When you're talking to localhost, like this right here, that's 127.0.0.1 or localhost, you're talking, the browser's running on your computer and the server's running on your computer and it's working okay. What ngrok does is it effectively punches a hole, outbound temporary hole through the firewall, and then my autograder out here can connect to ngrok, and then the ngrok software forwards requests back and forth so that my software can grade your homework sitting on your computer. It's quite nice. And so you can download it and you can install it. And I got some instructions on how to do this. Okay.
So the simple thing here is this command right here. Now I've got ngrok installed in a way that it's just sitting there. And so if I say ngrok HTTP, that's the protocol we're doing, at 8000, what that says is connect locally to port 8000 on my computer and then export it up into the world of ngrok and give me a temporary domain. And so I'm going to grab this temporary domain. If you start it, this is going to change. This is what's going on locally, and this is what's going on sort of globally. Now on your computer, both the local and the global work, but it should be the same thing. So this is a URL, a real live URL, and it is basically a clone of this. And you can actually see the things that are happening here. And there's even a really cool, if I go like this, there's even a really cool thing that allows you to inspect this as it's going back and forth, right? So it's going back and forth. So it's really nice. And as developers, you probably want to learn how to use ngrok. And so I don't think it's a bad thing for you to use ngrok. It's just I think the average student, there's a lot more moving parts here. But we've got this document on how to run ngrok, and it talks about it. It's pretty simple. It just says, start it. It doesn't matter what folder you're in. And then you get this temporary page, and your local host and your ngrok should be the same, basically. Now, what's cool about this is now you can take this URL right here, and then you can give that to the autograder, right? So now, well, let's first go to this URL, localhost 8000. We'll see what this does. It'll probably blow my autograder up terribly. You think, oh, I got it running here, localhost 8000. So 127.0.0.1 is localhost. It's going to be like splat. So it can't, because this is running out in the real internet. It's, yeah, remember the picture somewhere, how it works, right? So this autograder's out here, and it can't connect to localhost. There's an infinite number of localhosts, so it can't connect to localhost. So it freaks out, okay? So that's not going to work. But if, on the other hand, I take this URL, which is exactly the same thing, except now it's a real URL, and I submit this to the autograder, see, that's HTTP, now it works. And the autograder can work, et cetera, et cetera, et cetera. And so it found it loaded the page, and install worked. Something went wrong with the static admin font CSS, so I don't have that quite right. But away you go. So this is not so much about getting this thing working. This is about using ngrok to get your application submitted to my autograder while your application is running. And like I said, you get to see lots of little log files, and you get this, and you can inspect this with ngrok. So there's a lot of really nice features to using ngrok. And again, it's optional, but you'll notice that all of the walkthroughs that I do, I'm using Python Anywhere, because I think that is, on average, much simpler for the average student, at least when you're getting started. Okay, cheers.
Hello, and welcome to our lecture on SQL. So this is a very, very short introduction to SQL. I love SQL. I was talking to a student the other day, and they were like, SQL is my favorite language. And I said, I have to agree that SQL is my favorite language too, because SQL is so beautiful. You don't even need to write loops in SQL. We write loops in languages like Python just because we have to. The problem is that SQL is perfect, but it's not the way we could write something as complex as Linux or Python. And so SQL is not really the way computers think. We have these things called database engines. And these database engines make things work really, really well. And so SQL is a great way to organize data, but a lot of work has gone into keeping that data organized and making it simple. So it's like there's this abstraction, and it's a lot of work to make that abstraction work. So I want to start out with a little bit of history, sort of before databases. And you might think, wow, before databases, how could that be? Well, yes, in the old days, and if you watch old computer movies featuring computers, you see pictures that have these tape machines in the background, and they're spinning, and the spinning of the tape machine is the sort of physical manifestation of computation. And it had to do with the fact that in the old days, computers did not have enough data to store all of their data in the memory or on a disk. We didn't even have disks in the early days. In the early days, tapes were what we had, and we used kind of a variation of audio tapes, and instead of on audio, they contained data, zeros and ones. And so the way things would work in the old days so that you could have a database, as it were, was the database was all of your data recorded onto a tape. And the key thing to a tape is that it was a physical thing, and so you had to rewind it and go forwards and backwards. And most of you probably never even seen a cassette tape or an 8-track tape or a reel-to-reel tape, but it's a physical, long, 1,000-foot piece of plastic, and to get the data at the end, you had to spin it until you got there. And so it wasn't what we call random access, which means that in a random access, whether it's memory or the disk drive, random access allows you to get to any place roughly in a fixed amount of time. Whereas if you're close to something on a tape, you can get to it very quickly. If you're far away, you got to go boo and then wait and then come back. So this led to a pattern where every night we would take the tape from yesterday's account balances. Let's just say we're a bank, and people coming up the window, putting in money, taking out money. And then what we would do is we would put all of the transactions, sometimes on physically punched cards, and then we would sort them, right? And let's just say we have 26 accounts, and person C shows up with a little, adds $10, and person F shows up and subtracts $10, and et cetera, et cetera. And then what we would have at night, we would get these all sorted, and there were physical machines that would actually sort these in the earliest of days. And then we would have the old balance, A, B, C, D, E, F, sitting on a tape in order, sorted in order. And we would start a process after the bank closed where we would read the first record off the tape, like A. We would read the first transaction off the cards, and we would compare them. And if the tape was earlier than the transaction or lower, we would just copy it. So we'd copy it. And then so the B would compare to the C, and B would get copied, and then C would come across. And then we'd realize that the C data, we would have to update the C data and add $10 to the balance. And then we'd write that. And you'll notice as we're writing this, we are sorting. It's in sorted order. Then we would copy D. We have nothing for D, and it would just get copied. We would copy E. We'd have nothing for E, and it would just get copied. And then we would have, oops, forgot to put F on this picture. We would have F, and we'd subtract 10, and we would copy it. And then we would be done. We would be done with the kind of stuff that we had to do that night. And then what we would do is we'd have this new updated data that was all sorted in account order. And then the next night we would move the tape, the new would be the old tape, and we would do it over and over and over again. And sometimes these processes would run for 4 or 5 hours because the tapes were long, or it got to be multiple tapes. And so a lot of computing was done sort of after the banks closed at 5 o'clock. Then a group of people would come in, we called them operators, and they would mount these tapes and run these jobs and just sit there and watch these tapes spin as the data was being copied from one to the other. And so, yeah, that's pretty cool. Thankfully, that's not how we do it anymore. The thing that made it so we don't have to do this is the invention of disk drives. And disk drives are a magnetic media, just like tape drives, but the difference was they were on these spinning platters. And so what you could do is the data was in series of concentric circles on these platters, and then you had a head that could move in and out rapidly. And so the speed at which you could access data was a combination with the speed at which the head could move to a certain cylinder, and you had to wait until the data came around. And so sometimes you would have a 5,400 revolution per minute, so that means that 5,000 times per minute, which is 100 times a second. Did I get there? Yeah, 100 times a second. Yeah, 100 times a second. 100 times a second, you'd wait 1/100th of a second for it. And so this is way better than waiting like a minute and a half, 2 minutes, even 10 minutes to spin up a tape. And so the problem is then we're like, okay, now that we have this wonderful technology, we can store all of our nightly data on a disk because it's enough space. how do we build technology to make really good use of this? And a lot of research, a lot of computer science, a lot of vendor research went into understanding how to best use this new disk thing. I remember talking to people because we used to use floppy disks, which they were much slower, so they didn't go 5400, so it might take a quarter of a second to move the head, and it might take almost a second to spin it around, which was still way faster than 10 minutes, right? So it's like about a second to get to anywhere on the floppy disk. And we would build approaches to storing data, and we would start with this physical thing, and you'd hear it grunting and moving and grunting and moving, and then you would come up with a better way to store the data, and then it'd grunt and move less, and your thing would go faster. So this was like a research thing. It was good old days when computers actually made noises, and it could change your code inside computers. And the first thing, of course, we did was just took those sequential master updates and put them on, but that turned out to not be the best. And that was sort of the research, is not just how can we do what we used to do on data that couldn't be randomly accessed, and instead say, let's take advantage of it. And so a lot of research, a lot of vendors, there was a lot of very expensive software that people bought to say, look, you're a bank and you really and truly want to, know how this works. And so what happened is in the 60s and 70s, the computer vendors were fighting, and they would come up with a technique which, compared to our current database technique, was just trivially simple, but it took a lot of work back then. And they would fight with all the other computer vendors, and they would say our index sequential mechanism is better, and vendor 2 would say our networked approach is better. And then they would sit and they would sort of struggle with each other, and then the poor customers would be like, I don't even know what you're talking about. And so then they would just buy the stuff from the vendor who took them out to golf or the best lunch, or took them on a trip to Florida. And then they would just, adapt to whatever that vendor did. And so it was really kind of scary, because we were moving into a place where you were locked into a vendor. And then once you're locked into a vendor, you're in bad shape. And so the U.S. government, in particular, had a ton of money, and we're buying tons of computers, both for normal data processing and for strategic things like military stuff. And so they were buying tons of computers, and they knew that these vendors, if they got to the point where they locked them into a single vendor, that the vendor would just be able to dictate the price. And so the federal government, through NIST, the National Institute of Standards and Technology, decided that databases needed a standard. They needed a way so that we could talk to any database from any vendor using the same technique, and not have to do one vendor, and then if you switched vendors, you had to completely rewrite your software. And so the NIST didn't specify how this abstraction, the standard, was going to work. They just brought the vendors in and said, we're going to stop using your software if you don't come up with a standard. And it was a perfect time, because even though the vendors thought they had everything was perfect and wonderful, there was a lot of upside. And in particular, there was this concept of relational databases, which back then was more of a mathematical theory of a better way to store and retrieve data than it was a practically implemented available technology. And so SQL, and this is Liz Fong, who I went and I did an interview at NIST. She talks about the early days. It's a great interview. The early days of how this SQL standard really made so much sense and really fixed the industry and got the industry working really nicely. And I recommend that you take a look at this video just so you can kind of see. Now, what SQL basically said is that let's not worry so much about where that data is actually on disk, because the earlier database approaches were, we programmers would know that there was cylinders and positions, and we would place things in certain ways, and we would make indexes, and we would look at the indexes ourselves, all kind of different things. Or we would read to one place on the disk, and that would have an address of the next place we're supposed to read on the disk. And they said, you know what, let's not worry so much about the physical storage structure on the disk, but instead, let's come up with a language by which we can express what we want to read, write, update, and delete on the disk, and a really simple language. And then we can build a piece of software that there's could be many disk formats underneath that, and then we could all sort of just use this language, and you could buy vendor A and use this language, and vendor B and use this language, and then you could even benchmark it and say, here's a bunch of stuff in this language, which vendor can run this faster? And so the NIST also had a series of benchmarks, TPC, or some of the benchmarks. And so what they did is they basically made it so that this was like a beautiful and simple language, and it's what we call SQL. I think at some point it was called the simple query language, and it is the language that we use to talk to databases. And the interesting thing is what SQL allowed us to do, really in the 60s and 70s when it first came out, was to talk to the old style databases like index sequential and network style databases. And as this new form called relational databases, which had like this awesome mathematical underpinning, but was implemented badly in the first time, we could just say, oh, we're kind of, this is old. When the performance of relational databases got to the point where it was as good as the other databases, then we could just switch and we could talk the same SQL. So it allowed an amazing innovation over a 10 or even 15-year period where the abstraction allowed us to improve databases in a wonderful way without really having to change how we as programmers used them. Pretty dang awesome, I'll be honest. And so I've been talking about this idea of relational databases. And relational databases, and I'll admit that when I first saw relational databases in the early 1980s, I'm like, this is crap! Because again, I could hear floppy disks, and I knew that we were moving a thing, and I had so much awareness of what was going on, and I loved that awareness. And the relational databases sort of like hid what was going on behind this layer, and it turned out that whenever I used it, it was slower because it wasn't yet clever. And so relational databases started out as a mathematical idea, as the theoretical best way to represent networks of data, with columns and rows and connections and joins, and we'll talk about all that eventually. And it was a beautiful idea, and the mathematics was right. It just took a long time to get to the point where it turned the superior mathematics of relational databases worked out better than the highly cleverly optimized previous generation database systems. So there's a lot of common database systems that you'll run across. Some of them are open source, some of them are commercial. Postgres and MySQL are open source. Postgres is probably the more intricate and complex and rich. Oracle is a intricate, complex, and rich database that's available for lots and lots of money. And Microsoft has a database called SQL Server. And all these databases that we're seeing evolved, in a sense, after the SQL spec existed. So they just kind of built SQL. There was legacy databases that kind of learned SQL. And there's lots of other databases. SQLite is what we're actually going to use with this course. And it's super cool, super fast, and on your cell phone you probably have 40 copies of SQLite, and in your car you probably have 40 copies of SQLite, because it's a real tiny embedded database. It's not really good for production scale when you got 100 users simultaneously hitting a website. Postgres, MySQL, or Oracle or SQL Server are really kind of online multiprocessing databases. But SQLite is great because it's really simple. It stores everything in one file. We can move the file around, etc. So I love SQLite, and in this class and in this thing, we're going to talk about SQLite, but everything we talk about applies to all of these different database systems. So the first thing that you got to do when you are going to work with a database is you got to come up with a contract between you and the database as to what the shape of the columns are, how wide the columns are, what kind of data you're going to store in this, and it then informs how the database software is going to structure that database, like on the disk. And part of what you're doing is you're allowing the database software, MySQL or Postgres or SQLite, to super optimize its storage. I mean, it's so much smarter than you. Something like Oracle or MySQL or Postgres probably represents $1 billion, if not more, of research and development about the best way to store and retrieve data. And you just don't even need to know any of that. You just say, look, I'm going to have these columns. It's going to have 100 characters of text, then I'm going to have an integer, and then a floating point number, then 3,000 characters of text, and you worry about all that detail. But the key is if you just say, I'll store anything I want, then it can't optimize. And so there's this thing where you have to make a contract at the beginning and say, this is exactly how I'm going to lay out the data as I talk to the database system, and then you can figure out how to lay out the data in the actual disk. And so that's called the schema or the database model. And building a database model is itself a cool thing. So if you're building a complex application, you have these models and they have connections, and we'll eventually talk about all that stuff. But it's a critical thing to say that that's a contract between you and the database software, so the database software can optimize the storage of the database. Now, once you have given the schema, then you can write queries that depend on that schema. So you might have a column called email and a column called name, and then you can insert data into the database using that schema. You can retrieve data using the schema. You can change data sort of somewhere deep inside the database, and then you can delete data. Hang on a sec. Whoa, hi there. What are you doing down there? Oh, dang it. Sorry. You are a bad creature. Look at that. I was wondering what that noise was. Come here. I gotta introduce you to all these folks. Come here. You are not behaving. So this is Shelby. Hi, Shelby. This is Shelby. This is my puppy. I'm trying to keep her out of the cage and let her sit and get by my feet. And she's got some chew toys. Hi, Shelby. This is Shelby, and she is interrupting. You're interrupting my lecture, but you're cute. So quit chewing on the pen. Chew on your chew toys that I gave you, okay? Let me get through this lecture. Okay, you can get down. Just quit chewing on a... Sorry about that. Dog interruption. I was just hearing chewing noises, and I thought I took everything, but then there was one pen on the floor, and so the pen, poor pen, meets Mr. Puppy. Oh well. Okay, where was I? SQL, CRUD, create, read, update, and delete data. And so our next step is to actually do some SQL and create a database. Okay, so now we're going to actually play with a little bit of structured query language, SQL. Now, you can grab, at this URL, you can grab the instructions that I'm using, so you can cut and paste it in. Now, the key thing that you've got to do is you've got to find your way to a shell. If you're using something like Python Anywhere, you go ahead and open a command line. Now, if we're using Python Anywhere, most of what we're doing is running Django applications, but you can really just use Python Anywhere as a Unix platform. And so get to a $ prompt. These commands can run on a Mac. They can, I don't know if you can get them working on Windows, but any Linux system, but you can also run them on Python Anywhere. So there's a command to Linux called SQLite3, and then you give it a file name. So SQLite, as I mentioned, is a very simple database because it does all of its work in one file. It's not a slouch as a database in terms of its performance and scalability. What it's not good at is handling hundreds of people hitting it at the same time and having the database software resolve all those simultaneous accesses. But if you type SQLite, you end up in a command line where you get this prompt, SQLite, arrow, and there's commands you can type, like .tables says, hey, in this database, which is in this case zip.sqlite3, in this database, what tables exist? And it says there are no tables. And then you create some tables. Now this is our first SQL statement. And so you'll learn something about SQL as it looks a little different than other programming languages. And so you say create table. That's one statement. You can create things other than tables, and then you have a table name. And then you have some parentheses, right? And then you have a series of statements about the table that you're working with. And so there's just this little language, and there's a name of a column. So these are 3 columns that we're putting in: ID, name, and email. And we have a type. This is an integer. Varchar means variable length string field. Not null means it's required. Primary key means that it's an auto increment, meaning it's going to be supplied by the database. It gives us like a handle for every row. And then varchar 128 says it's up to 128 characters. Now, a key to this is that we're making sort of a contract here. And so when we say you got to do this with 128 characters, you can't put 129 in. You can put up to 128. And if you put to 129, your database query blows up. And you're like, oh, that's not very nice. And the answer is, well, you told it 128, so it could optimize how it's going to store the data on disk. If you made it this 1,000, it might store it in a different way than if you store 128. And so the key is you can make any contract you want, but you got to live by the contract that you make. And so it's not the database hates you. It's you said, I'm going to do 128, and when you do 29, it says you're violating our contract. And so it's up to you. So this whole create table ending in a semicolon, that is a single SQL statement. And so we can type it in. We can type it in multiple lines, and you can kind of see how SQLite's using this ... thing to tell you that it's in a continuation. And then finally you finish it all and you put a semicolon at the end, and then it does it. And then we can ask using .tables, we can say, oh, is there a table? And yes, it says, yes, it's users. And then there's a command, an SQLite command called .schema. And that says, tell me the schema of users. Now that's in case you hadn't just typed in the create statement. It tells you what create statement it would be. And so part of what the database stores in this file SQLite is not only the data for this table called users that you just created, but it also stores the schema. And so you can say, hey, what schema is it? So if I sent you one of these files, like you might upload to my AutoGrader, for example, I can inquire into that file using SQLite, and I say, what schema, what tables are here? And then I can start looking at the tables. As a matter of fact, that's how I grade these assignments inside of the computer. And so this is just sort of going through some. There's a lot of SQL, but the basics is actually surprisingly easy to understand. And so insert into, one of the things that SQL does is it tends to use more than one word. And it wants to be something. I've met people who have used SQL in their jobs, and they just like type it, and they don't realize how amazing what they're doing is. They're like, well, I just insert, or I delete some stuff, or I select it to read it. So it was designed to be easy, because if you go back to the basics of SQL, it was like, look, there's a lot of complexity down there. We want to hide that complexity. We want to hand something easy to users. And I write a lot of very complex SQL, and it's a very sophisticated skill. But simple SQL is something I think literally everybody should know how to do. So insert into, then you have a table name, and then you have a parenthesis list of the columns. Now, these are the columns that you named in your create statement. And then values is a keyword, and then there's a one-to-one correspondence between the values that you're going to put in the columns. And these happen to be strings, so we have little quotes around them. They could be integers, they could be dates, they could be all kinds of things, floating point numbers, etc. And then this has to meet the schema. You can't go putting a number into a string field or a string into a number field. And again, so that would blow up. If you can make all kinds of errors. You can either have syntax errors, like you forget the word into or something, or you can have errors that are bad, that your data is bad, right? So that's the insert statement, and that adds a row to the end of a table. The delete statement says delete from, and then a table name, and then a where clause. We're going to see where clauses a lot in SQL. And the key thing is that every SQL, I sort of mentioned at the very beginning that there's kind of no loops in SQL, and that's one of the reasons that we sort of love SQL, is you don't have to write loops. And that's because there's kind of an implied loop at the beginning of these commands. So when you say delete from users, that means delete all rows from users, right? Delete all rows, delete everything from users. So if you don't put this where clause on, if you don't put that where clause on, it actually deletes everything in there, because it's like delete all the rows from users. That's the way you can kind of phrase it that way, delete all rows from users. Now the all rows part isn't really there, but that just means that it's really important to have a where clause so that you're not actually deleting all the rows. It's saying delete all the rows from users where the email is equal to ted@umich.edu. And so what that is there's an implied loop of all rows on this delete statement, and the where clause reduces that down to actually one or a couple of rows, depending on those rows where this is like an if statement. So this whole thing is like a loop with an if inside of it. That's how it works. And this is why a lot of people like it, is because you don't have to write loops, because these things sort of like are loops. They have loops built in. So But this would delete one or a couple of rows, depending on whether we had more than one row in this where the email was ted@umich.edu. Update is really kind of cool. You can really zero in. You can zero into rows and columns. And again, update users, which is the name of the table. Set is, and then name equals, which is the field name and new value. And so you can get any, you can do all the columns, you can do one of the columns, you can really zone in on this. And then there's a where clause, because if you don't put a where clause on the update, it implies that this is for all rows. And you don't really want to set the name to be Charles for all the rows. You just want to set the name to be Charles where this is true. Because again, this, you could think of this as like update all rows in users set where. And so you just always got to be thinking that so the reading is done with select. I wish that it would be create, read, update, delete. The create is insert, read is select, update is update, and delete is delete. Select is the way that we read stuff out. And so select basically takes a list of columns, like select name, comma, email, or select star. And then a table name. So this select star from users is almost always the first thing you type. Select star from users, select star from books, select star from whatever. You can also put a where clause on a select, because this again has this implied all rows kind of a thing going on. And so select all rows from users where email equals c7umich.edu. And that reads much better when you kind of add that all rows logic to it. Databases are good at searching. We can do things like add indexes to the databases that make searching and ordering even better. So we might say that email, please, while you're maintaining this data, in addition to maintaining the data, maintain an index that has a sense of the order of these records. So if I want to sort them ascending or descending, then I can get that, and I can get that to be efficient. And so the order by is just a thing you throw on the end. You can add a where clause here as well, and you can have ascending and descending sorts, and it worked great. So this is sort of the first 60% of any SQL is the basic insert, delete, update, and read. And so that is not hard. And the beauty is this essence of SQL, the middle part of SQL, is portable across all the databases that I just described, because every one of those databases that's a modern database was invented after the invention of SQL. And so life is pretty good. Now, there are differences, because when they first built SQL in I think 87, I don't know, forgot that time, but when they first built it, they did not realize how powerful they were going to be, and so there's a bunch of features that got added by the vendors that were extensions, and some of them were sort of standardized. There's another round of standardization, but then there's a whole bunch of features that are a little different, but they have, because of competition, they have conceptually the same ideas. Like there's like a limit clause that limits the number of rows or starts after a certain number of rows, and it's a little different from one database to the other. So, but this is just a summary. You should know this. You should just know this forever and ever and ever. And then as you run into a different database, then you'll learn different features for that. A tool that you might want to install on your laptop if you want to start playing with these SQLite files and not just using the command line is called SQLite Browser. You can download it. It runs on lots of different systems. You can then open these .SQLite3 files, and you can do stuff to it, including execute the SQL commands right in there. And so a lot of people find this a more interesting and easy way to interact with these files. And so that kind of sums up our really quick introduction to single table SQL. Up next we'll talk a little bit about multiple table SQL and relationships, and then we'll also talk about how we connect this all to Django through an object relational mapper. So see you soon.
Hello and welcome to another Django for Everybody walkthrough. Today we're going to take a look at some SQL. Walk through some SQL. So the handout for this is djfree.com/lecture/SQL01 basics.txt. And we are going to do this in a Linux bash shell sitting here in my Python Anywhere account. So I'm sitting here in my home directory And I've got my samples checked out, and then projects, we're a little ahead of that. For now, we're just going to work in this home directory. So SQLite is a very simple database, and it does all of its work in a single file. It's not the greatest multi-user database, but it's great for a class. So I'm going to run this command. SQLite is a Linux command, and then I'm going to give it a file name, zip. This is just a file I'm going to throw away, but with an SQLite 3 suffix. So now I'm in a command line. I can type help to see what things are available. And away we go. I've got some of these commands all put in. And so you can do things like ask what tables are in there, right? What are the tables? Well, there are no tables. So let's run a create statement. This is a create, this is SQL, create table users, with name and name and email, but then there's this special, and each database does this a little differently. This is the auto-generated ID field. That's going to be our primary key for each of those rows. So create table users. So just copy this over, and semicolon ends these, and so you can, this is a continuation prompt. So it's prompting until it sees a semicolon. But now if I say dot tables, by the way, you can see me cursoring up to get to this. So I have a users table. Yay, we're good. So then I can say schema users, say what is in that table. So it looks like a create table statement, but basically this is, you can come back later and say, hey, what's in this table? And it teaches you this or gives this to you in the form of a create statement. So the first thing that you tend to do for anything is you run the select statement, the R of CRUD, create, read, update, and delete. And there's nothing in there. So let's put some stuff in. Let's insert, right? Do an insert statement. So of course we've got the table name, we've got the 2 columns. We do not have to specify the ID column because that's auto-generated by the database. And then the values keyword followed by 2 values, which is 1-to-1 correspondence in the same order as the columns. And so that happens. Now I can do a select star from users, and you see that I got a record that has Kristen and kf@umich.edu and a primary key of 1. And so that's pretty nice. Now we can say, I would like to see this not with those vertical bars. The vertical bars are kind of nice and condensed, but if I say mode column, I can say select star from users, and it gives me a little bit more white space, okay? And so that mode column is just an SQLite commands to make it a little easier for me. Now I can just put in all these other records, copy them all, and SQLite happily runs them in order and finishes them with a semicolon statement. So now I can say select star from users, and there they are. So I'm sticking them in the database. What's amazing to me is that it's so beautiful. I mean, I just think SQL is just so beautiful. I mean, people avoid it. There's a delete statement, right? Delete from users where email equals ted@umich.edu. Goodbye, Ted. Now I can do a select, and you can see that now I have record 4 is now gone. I could have said delete from users where ID equals 4. That would work too. I'm going to change my name in the Chuck record from Chuck to Charles. So update users set new key equals value where email equals, and the where clause is really, really important because otherwise it would have updated all the records maybe right before I delete all the data. You can see that the Chuck now has become Charles when I do a select star from users. So far, so good. You can use a where clause on a select statement, select star from users where email equals csev@umich.edu, and at that point we only see record 2, which is me. We can order by select star from users, order by email, which now we see the emails in ascending order, a csev, cvl, kf, nicely in ascending order. We can do DESC. We can say select star from users, order by name DESC to make it be descending. So now you see Sally, Kristen, Colleen, and Charles in descending name order. And away you go. And so we could drop the table users, but let's play with this data a little bit, right? So let's just say I did an update update users, set user's name equals Charles with no where clause. Watch what happens. This tells you something about SQL. Now if I do a select star from users, let's just do a select star from users. Select star from users, everybody's named Charles because the update applies to all rows until you tell it not to with a where clause. So we always type the where clause without even thinking, but you do not have to type the where clause. And the same is true if I say delete from users with no where clause. Watch what happens. Normally we put a where clause on delete. And then we go select star from users. Away you go. Okay? Now I could also say drop table users, and then it will all go away. Oops, users. Okay? And so that's it. .quit. I will log out. I hope that you have found this particular walkthrough for Django for Everybody useful. Cheers.
Hello and welcome to our lecture on simple Django models. Now, as you've seen in previous lectures, we talked about SQL, structured query language, and that's how we talk to databases, and it's beautiful because it allows portability up to a point across databases. And we talked about all the create table stuff, and so this is just a bit of review where we can type these commands to SQLite. We run SQLite, we run a create table statement, and we do it to say .tables, that we go, we can ask kind of schema users. We did all this in a previous lecture, and so that's basically how SQL works. And here's a series of SQL commands from a previous lecture, just kind of as review. It's pretty simple, CRUD. Now, one of the problems is as I mentioned, is that different databases like Postgres and MySQL do all this stuff identical, but then some more subtle things like how foreign keys work, which we'll learn in a bit, or how they do limits, like pulling like 25, next 25, next 25. That's a little bit different. And so if you want to build an application that talks across more than one database, you got to think a little bit. And one solution to this, also to kind of limit the fancy SQL you have to learn, I like to say that you can learn the first 60% of SQL in about 3 hours, and the last 40% is literally a lifetime. And so advanced SQL is difficult to do. It's really hard to teach a class in advanced SQL. I can teach you advanced features, but then there are so many features that you just can't learn in a class because which database you're using, and they're different for every database. So one thing that's happened in the past decade or so is the emergence of what's called object relational mappers. And that is you have the physical database layer, and then you have SQL, which is an abstraction. It's an imperfect abstraction. And then Django builds another abstraction on top of that called object relational mappers. So we just create a Python object and we ask that to be placed in the table. Now the object may have a name and an email address and a birthday or something in it. It can have all kinds of data in that object, and then that maps into a name and an email address, and we have to tell it, like, do we want this to be indexed, and all these other kinds of things. We communicate through the ORM. So we leave the ORM alone. Now in Django, as we get more advanced, you can also sort of bypass the ORM because the way the objects are mapped into the tables is predictable. The names of the columns is predictable. And so it's kind of like it's a shortcut for, I like to think it's like the 80% of the most common things you do with a database are easily done with an object relational model, but object ORM. But ultimately, once you get to the more advanced things, you tend to not be able to do that with an ORM. You get to the point where writing the SQL is easier than using the ORM. But for about 80%, writing ORM code is way easier than writing the SQL. The other thing that ORM does is it allows you to have multiple databases, because the ORM code inside of Django knows the difference between SQLite, Postgres, and MySQL. And so you could actually start an application that uses SQLite during all your development, and then when you deploy it to production, you just go like, you know what, let's just use MySQL or Postgres instead. And that's quite cool. I find them limiting, and so just I want you to know both how to use objects and how to use SQL, but understand that most of what you're going to do is to use the object relational mapping, and we get a lot of power with this. So if we look at sort of the way we communicate to the database, or the way we define the database, in SQL we create a table, and that right there is portable, but once you start doing things like adding auto increment columns and things like that, it stops being portable. And so that's the way we do it. But in Django, the way we do this is we have a file called models.py, and it's in the application folder. And then we are going to use object orientation. So we're going to, from Django.db, that's a package, we're going to import models. And models is now a class. And we're going to create a class called user. This is going to be equivalent to the name of the table. And we're going to, in the definition, we're going to extend models.model. And so there's a lot of, this is called extending, it's called inheritance. We're going to get a lot of features and functionality, excuse me. We're going to get a lot of features and functionality from this code. So there's probably 20,000 lines of fancy code that we didn't write that we're using. By extending models.model, we're getting all that. And then within here we create a couple of attributes that basically says give me a character field. Models is a class, char field is a method within that class, max length equals 128, and that gives us the name. These two things are equivalent, and what happens is when we build this and we do what's called run a migration, then Django will make this table for us, but then we have this abstraction that we can use to talk to it. So this is called a migration, and so you have to be in the projects folder. And so once you create a migration inside of your Django application, then you go up into the Django project and you say Python 3 manage.py. Now manage.py is kind of like the thing that starts everything. So make migrations is actually creating files, because the idea with migrations is that you would debug your migrations like on your development environment, and then once you know, you would move them to production. So you'd make the migrations in development environment, you'd get them right, and then you'd like check them into GitHub perhaps. And then in production, you would pull your migrations out of GitHub, and then the migrate. So the make migrations bit, that is creating a set of migration scripts. And you can see that it's making these files, and they're actual files, and you can go find those files like 001 initial py. And then the migrate is reading the migrations and then actually changing the database. So that's the one where you might be able to make a migration, and it doesn't matter what database you're going to use. Could be your development in SQLite and production in MySQL. You would do migrate in both of those, and in your development it would make an SQLite database, and in your production it would make a MySQL database. Put the tables in, and the SQL might even be quite subtle, and it will be subtly different between them, but you don't care. So migrate is the act of creating the database. Now in our development environments, we're going to be creating a file called db.sqlite3. And so if you get all messed up, you don't have to remake your migrations. They're just sitting there kind of as part of your source code. And you can like get rid of the db.sqlite3 file and then run the migrations again if you get kind of messed up. So the make migrations reads this and creates these other little files. You can take a look at them. They're kind of like Django's internal files. They're Python. It's just you're not going to write them by yourself. But then the migrate reads the 001 initial.py and then actually creates SQL commands and runs those SQL commands for us. And so if we jump, after we've done this, we see this file db.sqlite3, and we can jump in and take a look. Again, you have to be in the right folder, so you'd be in the Django_projects and then the folder of the project, but there'd be a file called db.sqlite3, go into a Linux command line, type sqlite3, db.sqlite3, and you will find a whole bunch of things. And when you go into SQLite and you type .tables, you will see that Django has a bunch of migrations that are all there from the sessions and stuff we're going to learn how to use later, authorization, etc., etc. But then the particular data model that you created, which is a user data model, there's a table in there for that. And if we use the schema command, of SQLite 3, and we say, hey, what is in that user model underscore user table? And you see a create statement, right? And so this is the actual create statement that the Django sent to SQLite to create the table. And I was talking about some of these things are quite predictable. The name of the column is quite predictable, ID, name, email, etc. It adds the ID field for you automatically. And most of it's portable, like this part here is quite portable, but this ID statement here, primary key auto increment, turns out that if you're in MySQL or Oracle or Postgres or SQLite, that's a little different, but literally the migrate takes care of all that because the migrate knows that thing, and as MySQL changes, that particular syntax doesn't change very much, but as MySQL changes, then the Django stuff changes and it all kind of works out. And so you can sort of run these commands and then sneak back into the database and you can see what they've done, but it's all very predictable. Don't want to spill my coffee on my computer. So you can also you're talking at the low level when you run the SQLite command, but you can also be in that folder, same folder that has db.sqlite and manage.py, and then you can start what's called the shell. So this is different than the Linux shell, and you see the prompt change from $sign to three chevrons. And it's not the same as the Python shell, although it is the same as the Python shell with a whole bunch of Django libraries that are pre-mounted, okay? And so if you just say Python 3, you'll get this, but this next command that is from user model, models import user, that will fail unless you let manage.py start your shell, because again, it loads a bunch of objects and classes into your space, and then all of a sudden user model.models works, users there, etc. Okay, so this is pulling from your models.py file that you built, and so user model is the application name and models is the models.py file. We import the user model, which is in this case a class. User is a class, and we're going to do a constructor call. And so we're going to say, let's make a new user, set the name to Kristen and the email to that email. And this actually has not done anything in the database. This creates, in effect, just a Python variable. And then to force it to be written to the database, we call u.save. And so save is a method on this new user object. Capital user is a class. We're using a constructor to construct from the class an actual instance, an object, and then we get that into u, the instance object, and then that object sits in our memory until we say save, and then it also pushes it back to the database. Now, one of the things that the save does, it assigns, in effect, a serial number or a row ID. If you look at these, they start pretty predictably at 1, 2, 3, 4, 5. But if you're getting a bunch of things coming in from a bunch of places, then the database just assigns each object, each row, and that's part of that whole auto increment thing. Come on, go back up. This whole auto increment thing that says, hey database, I'm going to put your records in, I'm going to give you the name and the email, and you come up with a number, but then when you're done, I want you to tell me what the number is. And this is how you get that number, by saying, oh, print u.id. Now if you printed u.id before you did the save, it wouldn't exist. And then print u.email, you can see this email is just the data we put in, but now this is not only in your u variable, but it's also in the database as well, okay? Now, we can dig a little bit into how this object relational mapping is working. And so if you're in the middle, you're doing things like that last statement, you can, from Django DB import connection and then ask connection.queries. And then what it does is it just shows you a little bit of debug data and what it did, how it started, the fact that it ran an insert statement. And again, this looks kind of familiar. This is it's making up SQL for you for that insert, the save statement, right? That save statement there. It's making that insert for you, and then you can actually see what it's doing, right? And so this save, set up a thing and save it. You don't need to know insert into or whatever, because the object relational model does it for you, right? And this is kind of what we did before, insert into capital users by hand. And so again, you'll find this ORM is going to save you a whole bunch of time for 80% of the things that you do with the database. And so you can do basic CRUD operations with this object relational mapper. The save is the insert. You can select is basically user object values. That's like select star, so give me all of the objects. A where clause is user objects filter, and there's your where clause. This is email is a column name, and c7@umich.edu is a value in that column. Values is actually go get them, so you can create kind of a query. So if you don't put values on, you get sort of a query that's not yet executed, and then values says go do it now. So you can do a different, you can delete something where you say, and so this is a little different syntax. This is kind of a selector that says these are the variables to select, and dot delete says, the rows to select, and then delete those rows. So value says retrieve the rows, delete says get rid of the rows. And then you can, again, the same kind of thing. This is kind of like a where clause, user objects filter email equals c7@umich.edu dot update, and then change this column in a way. And you can, go retrieve all the values. And there are things that correspond to lots of the SQL, like give me all these values, order by email, etc., etc., etc. So it's kind of a one-to-one mapping, and you will, you're going to do a lot of programming using this ORM in Django, and every once in a while you'll sneak down to SQL. And that's why I sort of teach you the SQL first. And there's lots and lots of fields that might not actually be represented exactly the same way in the database. So for example, an email field. Databases commonly don't have email fields. There might be some databases that have emails and others that don't. But because the object relational mapper is a layer between you and the database, and you say, I'd like this to be an email field, then it can add rules and stuff like validity checking, etc., to say, you know what, that doesn't look like an email address. And so there's all of these things, and these are very useful. And later we'll talk about connecting tables, and we'll use things like foreign keys and many-to-many fields and one-to-one fields, and those are less about the data and more about the connections between tables, which we'll talk in coming up soon. And so just to give you a sort of a bit of a sense of where you're at, this is our application, right? And so we have a browser on the left-hand side with a user doing some clicking. By now you may have created a urls.py file, and that takes the syntax of the GET request / this / that / whatever, and routes it to a particular view coming from the views.py file. You may or may not have made one of those. Templates and forms help produce output. But the models are our interaction between us and the database. And so the actual code we write in Django can talk through the models to the database, which you may not have done yet, but this shell is talking through the Django models to the database as well. And if you're starting to use the admin user interface, the admin user interface talks to the database through the models, and it's informed by the kind of things that you add to admin.py. If you want to use the Django admin interface and have your model shown a particular way, it's got a bunch of defaults, but often you want to override those defaults, and so that's what you put in. And the model.py file informs this connection between the database, and it also sort of informs the kind of code you write here in a view code in Python or in the Python shell. That's kind of the Django shell, which is a Python shell with all that stuff added to it. Okay, so this model.py is critical to defining our relationship between all of our Python code and the admin user interface and the actual database. And so you'll see a recorded demo where I go through a bunch of those things, which I kind of just showed you. It's just actually doing it in a demo form, but it's all mostly in this lecture. And so the Django model is Django's version of an object relational mapper. You can write Python code after a while, especially if you have an IDE that can show you what objects have and stuff. It's a lot easier to write, whereas SQL, you have to know it and write it. You gain database portability. You can create these migrations to both build your initial schema in your database and then evolve that schema as your application evolves. That's one of the more valuable things. If you're building straight up SQL, going from like version 1 of your database to version 2 of your database is kind of frustrating and difficult. Sometimes migrating and evolving a database is harder than actually writing the SQL code in the first place.
And Django gives you right out of the box this really cool administrator interface. The models and models.py and admin.py informs that. And later we're going to have all this automatic form generation. And so what we're doing here is it seems like we put like 3 lines of code into some file and then a whole bunch of magic happens. And that's really how Django works. And the idea is that way you as the developer can focus on the columns of your database and the forms that you want to put up and spend less and less time sort of manually building HTML that's very sort of brittle and SQL that's less brittle but still brittle. And so that's the idea. And so it's a little hard when you're getting started because you like the amount of code you write is so small and the amount of what that accomplishes is so great. But after a while, when you get all these little tiny pieces figured out, then all of a sudden you're like, okay, now I want to solve that end user's problem, and you can spend all your time solving that problem rather than just making databases and those kinds of things. So, see you in the next lecture. Cheers.
So it's pretty easy to get confused when you're first looking at data models, migrations, and the database itself. And so I want to go through this in a little bit more detail. So the make migrations is what reads the models.py files, and then it creates what are called migrations. And the key thing is this is guided by the list of applications in settings.py. So if you make a new thing and make a new application, and you edit the models.file and you try to run and make migrations and it doesn't see anything, you're like, what did it just do? Well, did you edit your settings.py? Because there is a thing called installed apps in your settings.py. Now, migrations are portable across databases. This means that the migration is a logical description of what the tables should look like. And they're an evolution. What they mean is like the first version of this table from the first models.py when migrations was first run is 001. And then if you change models.py and you run a migration again, it looks at the changes from the migration 001 to models.py and then 002. And then 002 is not like wipe it all out and start over. It's like, oh wait, you just added one column, I'll go ahead and add that column. But it's not done it in a way that's actual SQL. So migrations are themselves kind of Python-like. And they're portable across databases, which means that you might, on your computer, use SQLite, and in production you might use MySQL. And the migrations are the same for both of them, because they're just saying, here's the columns, here's the types, here's what they're supposed to be. Now, contrast that with a migrate command. The migrate command reads all the migrations, and then knows what database it's talking to, and runs the SQL commands to create the necessary tables and or evolve the necessary tables. So it looks and says, oh, here's the first migration, here's the second migration, here's the third migration. I'll make the table, I'll change the table, I'll change the table, I'll change the table. And at the end of all the migration, the migrate then goes through all the migrations and then has a database table that reflects the sum total of the migrations, which also reflects the latest models.py file. So it's a little complex. It has to do with database portability and the fact that we want to separate out the portable parts of this from the non-portable parts to this. So if you look at the make migrations, and here's in DJ free samples, my little sample stuff, there's lots of models in there. And if you take a look at all the models.py, you see that for every application in the DJ free samples project, you see a models.py file. And that's a Python code, that's class, book, blah, blah, blah. That's very portable, and that's how we, in our Python code, in our Django code, see the database model. And when you run the make migration, that produces these migrations files. And they're just in like autos migrations, 001 initial.py, etc. And so you see some of the ones I have here, there's actually 2 of them. So it sort of made the first one, and then I must have changed the models file, and then I ran make migrations again, and it showed, it recorded how that model changed from the first version of the models file to the second version. If you can look at these, don't edit them, you can check them into GitHub, but don't edit these. But take a look. They're a very portable representation. They kind of look like the models.py file. You're not supposed to change them. You're supposed to generate them with make migrations. And again, those can go into GitHub. Now, The migrate basically reads all those migration files. And not just one, but if there's a sequence of migration files, it applies them all in order as needed. And if the database has the first and second migration applied, but not the third one, it knows that and says, you know what, I'm going to just tweak this database that already exists, that's already running, and then add a column or change the width of a column or whatever it is that you've asked to be done by editing your models.py. So when the migrate is done, you then end up with a whole bunch of tables in your database. And they're all based on the name of the application and the name of the model within the application. And so somewhere in here is book one book, book one instance, and book one lang. They're all sitting there. And so those are all the tables. And we took a look at those tables before, but that's the migrate. That goes from all the little migrations spread across all of the applications in this project, and then puts a database together that has all those things. And I keep saying that the migrations are all about evolution, right? Because if you take a look here, you see one little table called Django migrations, and what Django's doing in that Django migrations table is remembering which of those migrations have already been applied to this database. So as it's going through the migrations, it says, oh, here's one that's not yet done in this database, so I got to tweak the database just a little bit. So it remembers the migrations that have been done. It's pretty fascinating, and in these little tiny applications, we don't always need to be so clever about that. So sometimes what you want to do is just like, I'm confused. I'm going to rerun the make migrate. Because you're not really running production, you're just really doing it over and over again. So you can rerun the make migrate. And the way you do this is you basically simply delete the file. You can delete these files. I would delete all the ones that start with 0, right? If you're going to rerun make migrate, just rerun make migrations. Delete all the ones that start with 0. And this is in application migrations, and then get rid of all these. And then you can rerun the make migrations, and it will read your models.py file, and then it will do all of the necessary things to recreate the migration file. Right now, that's not the database. That is the instructions on how to create the database. Okay, so that's how you rerun make migrate. You can run migrate from scratch. This is actually easier. So you can kind of wipe out the migrations for one application, and I did that. Just wiped out the book one here. That's what I did and started over. But you can wipe out all the migrations and all the database and everything by just removing the file. In this case, because we're running SQLite, just wipe out the file rmdb.sqlite, because after migrate, that's where everything ends up, is in that file. So then you wipe that out. It's gone. Now you might have created an administrator account or something, and you're going to wipe that out too. You're going to wipe the data out. You're going to wipe the tables out. It's all gone. That's one thing I like about SQLite. You remove this one file, and it's literally all gone. And then you rerun Python manage3 migrate, and it reads all the migrations and makes you a nice, clean, perfect, empty database. So if you're kind of stuck and you're not afraid of losing your data, which in most of the beginning programmers, it's okay to wipe out your SQLite thing and run migrate again. Just go ahead and try it. Like I said, if you made an admin account, well, you got to make it again. But that's the worst that you can do. So at least in these beginning applications. So now that we've talked about how to come up with a data model, how to encode it in Django model.py, how to do migrations, and how to migrate stuff, and how to make a database out of it, now we're going to talk about the kind of Python code that you can run to update these models in the database.
Hello and welcome to another walkthrough for Django for Everybody. Right now we're thinking about data models, and I'm going to show you how you can walk through and run this particular little example in the Django shell. So let's go ahead. We're going to Python Anywhere. I've already got a bash console. I love the idea of this bash console. This is Linux. I think that everybody should be learning Linux. So if I start my home directory, cd ... means go up a folder, ls -l. I got some folders here. I got DJ free samples, which I try to convince you to check out so that you can edit your file, edit my files, look at my files, use that as sample code for your own work. There is instructions on how to clone that, but we're gonna assume it's already there, and follow the instructions. So we're going to go into that folder CD, and then we're going to type a git pull. And the way this works is this is in GitHub, and that way if I've made any changes or fixed any bugs in my sample code, you've always got the latest code. And I've already done this, but there is a bunch of, oh, by the way, I got to switch into my Django 3. I got to switch into my virtual environment. You'll notice I didn't have virtual environment, now I do. And that's because this next command, this pip command, not Django 3. This pip command is going to change the Python configuration, and it's literally best if you do this in a virtual environment, so you're not like messing up your overall Python install on your system, whether it's your desktop or Python Anywhere, with my particular requirements. This is installing a bunch of utility code, etc., etc., etc. And is there some new? It looks like I got some new version here. And most of it's already there from a previous time that I installed all this stuff, but it's good that I ran this to make sure that I have all of the Python requirements needed for this. So now it's done, and it's installed all of my requirements. I'm going to type the clear command to kind of clear up my screen. Okay, so there we go. So then the next thing you run is this command that we're going to run a lot, especially in Python Anywhere, is this python3 manage.py check. And what this does is it reads through the urls.py and the applications and a whole bunch of other things, and it blows up. And so if you get no issues, that's good. The point is you do not want to continue down this other path unless check passes, because make migrations starts to make changes. So make migrations is Django reading through all of the models.py files and creating migrations. Now migrations are not SQL, they're actually Python code, and because this was checked out from GitHub, all of the migrations are actually sitting there, right? There's a way if you want to remove the migrations and remake them from scratch. So the migrations reads models.py files like vi users models.py and reads these and then creates migrations. And then the next thing that happens is we're going to actually, I'm going to get rid of my database.sqlite3. You can, that throws away your database. It actually tells you to do that right here. And then migrate reads the migrations. Migrate doesn't read the models.py files, it reads the migrations. And then it creates the database. And so it's going to create a database, and it is going to create a bunch of tables in that database. And so you see for each of the applications that I have in this Django project, it's creating a bunch of tables. And so here, for example, is users one initial. That is the table that I'm going to mess with up to that point. So now I've done all this stuff, and it's time to actually run Python manage py shell. So what this is it's like starting Django and loading all the Django libraries and reading all the Django configuration files. So there could be a bunch of errors that happen at this point. And if they are, go back and fix those errors, okay? You can't just like, oh, I think I'll ignore those. This is what the manage py check did. It sort of did that. But now it's like you're in a views.py file, which we'll see in a bit. You can type Python commands that inside Django. It's not just Python, but Python with Django and all of your Django application preloaded. So that's why it takes a bit of time to get to this point. And now it's pretty easy. So now we're going to type Python, right? Now we're going to import the user model, and that worked. And now we are going to create a new user object. So these next two commands are really important. So what that user says, name equals Kristen, email equals, that is going to create a new user model object in Django's Python's memory and give it back to me in the variable u. At this point, it's not stored in the database. So if I say, where did this store in the database? Oops, u.id. There is no ID currently because if it was given an ID in the row, it gets a serial number basically of the user after it gets saved. And u.save says, see this u variable that I've got in memory full of data? Well, store it in the database. And now I can say u.id, and I can see that it was stored in the database at position 1, which is exactly what you would expect. These numbers are pretty simple. They start at 1 and they go up, and we'll see as we do a few more folks. Let's put a few more folks in. We'll reuse the variable u. I'm just going to copy and paste all these at the same time. And now I can say u.id for who we're set. u.name is Sally. That's the last one I did. And then u.id is 5. It's the 5th one. So now I have 5 models that have been persisted, stored in my database. Now if I want to retrieve those, user objects. So user is the name of a model. That's actually a class. Objects is a attribute in there which has a method of values. So I can get back all the values, and you see what I get is what's called a query set, but in all intents and purposes it functions like a list, and then in that list there is a series of objects, and it looks exactly like the data that I put in, but it pulled that from the database. And the thing that's in there now is the ID is now in there. So this data has a primary key for every one of the rows that I put in there, and so I can say that. So I can add a filter, and so you'll see this pattern where user objects, and then I sort of throw these things in, and then the dot values comes at the end. And that's because filter is a method that returns a thing that has a method. So this is the values method that the filter returns, and you can just keep putting these together. So I can say this is like a where clause in SQL. So this basically says give me only, and it's a query set, so it's a list, but there's only one object. Now there could have been more than one because we don't have any uniqueness constraints on email. There could be more than one record that matched email csev@umich.edu. You can delete. So this is basically, let's go grab that record, but then run the delete method on that model object, model instance. So this will get rid of the TED record. We can go retrieve all of the objects, and we can see, oh, there they are, but there's no TED. There was a TED before, and now there is no TED. We can update. So let's check this one again. Let's grab that and pull out. So we're going to change this name here. This is in the database, and so we're doing CRUD here. And so we're going to update, create, read, update, and delete. And update's the last one we got to do. We deleted. And so again, we're going to grab all the objects. We're going to filter them down with a where clause to the ones where email c7@umich.edu. And then we're going to set new values. And so if I now say, what is this? Well, the name has become Charles. So it switched from Chuck to Charles. And it's in the database, right? This is not just in memory. This is Django writing all this stuff to the database. Now, just a little bit more, and you can go read up on this, and we'll have lecture after lecture and all kinds of example codes, but you can sort of sort this stuff by email ascending. So A, C, Colleen, CVL, and then K comes later, or we can descend. We can see them descending. So did I get that wrong? Oh, that's in descending order by name. So S, K, C, CO, CH, so they're descending by name. So that gives you just some of the kinds of things that you can do in the Python shell. Let's say quit parenthesis here. Yeah, there we go. Okay, so I hope that you found this this Django for Everybody walkthrough useful. Cheers. Hello and welcome to another walkthrough for Django for Everybody. This is kind of a supplement to tutorial 2. In tutorial 2 you're playing with models.py, and if you go through the tutorial they'll have you do a thing and then they'll do another thing, and they're kind of showing you migrations and how the migrations happen. And if you get them to have a mistake, you know, if you make a mistake, then you can get to the point where you need help or whatever, and sometimes it's easier to just like wipe out your database. But if you've added a question or added some choices or built models, you got to do all that stuff. But it's sometimes just easier to redo some of those things. So I'm going to show you what to do if your model/database gets messed up, and like your manage.py make migrations and migrate are not doing what you think, or they're giving you weird errors. Now if they're getting a syntax error, make sure you do a Python manage py check right before you declare that your database is messed up. So let me go into my go into my site. So here I am. Here's all my files. So just so you so here I should do it before I declare that the database is a problem. Manage.py check. And oops. Oh, I messed that up. I'm in my virtual environment, of course. Okay, so we got no issues now, so that's good. So I got a couple commands here. Let me explain this. Before I'm going to actually delete these, I want to show you where the migration. I probably showed you this. So I have a thing called polls2, and I got all the polls running. So this is like in tutorial 2. The migrations are in files with a number, and they're Python files. So if you recall, migrations are portable representations of what happens in the database. And then the migrate creates the file db.sqlite. So you need, if you want to really start over, you got to get rid of both the migrations and the db.sqlite file, and then you can start completely fresh. I mean, you could sort of do parts of them, but I'm like, if you're messed up here at tutorial 2, it's probably easier to just get rid of them both. So at this point, my application is going to stop working. So I get rid of the migrations, and then I get rid of my database. And so at this point, the only thing I got that has to do with anything to do with my database is a few models.py files. And this is where we are editing our code. And so this polls2 models.py, in my particular example, is the code that's going to be effective, because I got all the versions running at the same time. That's why you're seeing this. So the next thing to do is Python 3 or Python manage.py make migrations. So what make migrations is doing is it's reading all these models.py files, and it's writing this file. So I got rid of that file, but now if I do an ls, you'll see that it's come back. And sometimes you might see an 002, etc., and then you throw it away and you make it fresh, and you should only see an 001, and then you can say Python manage py migrate. And then that, well, if you do an ls, let me control C there. If I do an ls, you'll see that there, oh, wait a second, how come that, oh, the db.sqlite 3 is 0 size. So I'm going to do Python 3, or Python manage, sorry, my Mac, migrate. So that's reading these files, plus a whole bunch of other ones, and actually creating databases. And so now if I say ls-l, my db.sqlite 3 is back, and I might have to create a super user. If I created a super user account, then I'm going to have to create one again. right? And so I'm going to do that. DJ4E, check. Sev at umesh.edu. I should make my passwords easier to type. Now at this point, things should start working. But again, if I created any data, like a question or something, it was gone. It was gone at that moment. When I got rid of that database, DB-SQLite3, it is literally gone. So it's gone now, and away we go. And so and again, this is just if you can't seem to make these migrations or migrates work, back up, start over, and then redo some of the work. And that probably will be a good way to get things done. Cheers.
Hello and welcome to another Django for Everybody walkthrough. This walkthrough is the 04 Model 1. This is a walkthrough where we're going to talk about one-to-many models. And this is a situation where you have two tables and there is a one-to-many or many-to-one relationship between them. And this is all in my Django for Everybody DJ4E samples. You can it's public, you can check it out. And it's in the tracks project. So I'm going to go into DJ4E samples, CD tracks. So here's so I've got tracks, I got the tracks model, cat tracks model, models.py. So this is a model. We went through this in the lecture where we built this model. There's an artist, an album, a genre, and most of these are kind of simple. These are kind of, this artist is no different than a single table, but this album is related to, and this is where this foreign key comes in that says there's an artist field inside the album table that points to a particular artist in the artist model. Okay, so it's the artist that belongs to this album. On delete, set null. That basically means if an artist gets deleted, will the album get deleted? And null equals true means that we allow this to be empty. We allow there to be an album without an artist. That's what null equals true here. On delete means if we delete an artist, do we delete all their corresponding albums or leave them? And this says if an artist gets deleted, we're going to sort of clear out the artist in the album table. The genre table, again, just has a single field. And the track table has two foreign keys, the album foreign key. And what we're going to do here is if we delete, on delete cascade means if album gets deleted, we are going to delete all the tracks. And on delete equals set null for genre means if like a genre like rock and roll gets deleted, we're not necessarily going to delete the track. We'll just have a sort of an empty genre here. So that's what this on delete. It's the on delete of an album entry or a genre entry and how it affects the track entry that we've got. Okay? So we've got this put together here, and we're sitting in here, and we've got our model. We could say Python 3 manage.py make migrations, but since I checked this out of GitHub, the migrations are already in there. And then if I say Python 3 manage py migrate, it'll actually do a bunch of work and make us a database, including all of the tables that are part of the tracks model. So now if I have a DB-SQLite3, and if we were to take a quick look at that, like SQLite3 db.sqlite, and we say what tables, we'd see there are all these tables, tracks model, album, genre, and track. And if I say like schema, tracks model.track, you'll see that it's got some indexes, it's got these things, it's created a bunch of SQL that represents that model. So we'll get out of that for a bit because we're not really here to do SQL. We're here to do the object relational mapping. So
So we're going to start the Django shell. And again, some of these Django shells have different user interfaces. Some of them have arrows. This one here has this little prompt. And so we're running Python basically. So we have to import our models. This tracks model.models, that is sort of in our Python, and the manage.py knows how to set the paths up. So we're in the tracks project, and we're getting to the tracks model application.models, and we're importing 4 models. Now these are classes that we're now going to start making some objects. And we start by working from the farthest out leaves of the tree and working inward. And we're going to store all these things in, I'll just grab all 3 of these. I think it'll paste pretty nice. Yeah. So this creates a new artist in memory with the name of Led Zeppelin. And then I'm going to have this in the variable Zep. And then I can send it to the database, save it, and say get the ID, which was the primary key that was assigned to this, as 1. Now, later I'm going to use this variable because I'm connecting models to each other. So the next thing we're going to do is, and the names of these variables are just variables. Sometimes I use mnemonic ones, sometimes I use silly ones. I made an artist called ABC for AC/DC, but the variable's ABC. Be careful, this is just a variable in Python that we're using. This AC/DC is data we put into the, if we do abc.id, oops, we get a 2. Okay, so if we say, well, how many artists, what's in the artist table? This at this point is just a single table thing, and we can sort of see what the primary keys, those ID fields are the primary keys that were assigned. And so the next thing we're going to do, this one here is the tricky one. So we're going to create an album. Now albums has a title, which is just a string, but it has an artist field, which is an artist. And so this is who made who, and the artist is ABC, which is this variable, right? This title could be a variable too. This variable is an artist object, right? And so we're saying connect this album to AC/DC. Right? That's what we're saying. When we made AC/DC, we retained that object and its ID in particular, and we're going to make an album and connect it. Then we have to save it, or it doesn't go in the database. And then we're going to make a Led Zeppelin 4 album, and we're going to give it a title and use this variable Zep, which we created up in here, and then we save that. So we've got, if we take a look now, we say what is in our album table? Album.objects.values. What's in our album table? So we type that, and we see that we've got 3 albums, and you see this field here, artist_ID. That is a convention that says that's the ID key in the artist table. That's a foreign key. It's in the album table, but it points to a key in the artist table, so they name it artist_ID. It's a common pattern in object relational mappers, and as a matter of fact, it's a common pattern for people who use SQL to use this pattern. So it just signals right away, I can look at this and know on hundreds of database tables what that means. That is, oh, that's a foreign key into the artist table just by the name of it. It's a convention that the Django object relational mapping enforces, but a lot of people follow the convention even if they're not using the Django object relational mapper. But we now have 2 objects, and they have connections into the artist table. So this is the important part. It's the part you should understand, where you're creating a foreign key, but when you're doing this new album, you got to have this variable present. It's got to be there. Okay? So let's make a new genre. Let's make 2 genres. And again, these are just variable names. So I've saved those. I could do genre objects dot
values. And we can see what we put in genre, but that doesn't surprise us, right? Okay, so now we get to the big deal right here. So we are going to create the track, and the track, if you recall, the track has two foreign keys, both a genre and an album. So when we create our first track, the album is the variable ZEP4, which we made right here, and the genre is rock, which is the variable we made right here. Okay, and so that's how we indicate that the genre is rock. And we do that. The title, rating, length, and count, they're just standard fields in this. And then we say x.save. Boom. And then we got these other ones. But the pattern is the same. They're just, when we have foreign keys, we're referencing variables that are themselves the right kind of object. Album equals ZEP4. That's an album object. Made is an album object. Made is an album object. Met is an album object. A genre object. And rock is a genre object. So I got these, constructed correctly. That's why I gave them to you and didn't make you type them. And now we can take a look at all the tracks we've got. And so it's a little hard to see, but we've got a query set, which is a list. The first object is ID 1, Black Dog, rating 5, count, album ID, first foreign key, genre ID equals 1. So those are the pointers into the primary keys of the album table and the genre table, respectively. And if you go through this carefully, you see the second one, ID 2, Stairway to Heaven, ID 3, About to Rock, ID 4, Who Made Who, rating, with an album ID of 1 and a genre ID of 2. And if you carefully get it right back, you know that the AC/DC things were metal and the genre is rock. Okay? So now we have set things up, but now we can also look things up. So let's just say we're going to grab that one with a primary key of 1. That's going to be Black Dog here. Track objects get primary key of 1. So that's the variable first. And I can say first. And that tells us it's a track. If I say print first, it uses the stir method, and then it gets to the Black Dog. Okay. Now the stir method is __ stir method is what decides which of these fields shows up when we print that out. That's why the stir method is important when we're defining models. Now we can say print first dot ID. We can say print first dot length GHT. Got that right? Oh, then GTH. Okay. But we can also print first dot genre, which is rock. We could be even more clear to say first genre name. So first genre is a genre object, and name is an attribute of the genre object. We can say print first dot album dot artist dot name. So that says first is this object that we've got, which is this object of the track Black Dog, and then album is the album associated with that track, and then artist is the artist associated with the album, and name is the attribute of the column in the artist table. Okay, and so this is an object, first is an object, album is an object within first, and artist is an object within album, and then name is a column within artist. Okay, so I hope that was interesting to you, so that you could see how a one-to-many data model could be worked with and used in Django. Cheers. Now I want to talk a little bit about a concept, model view controller. It's not super essential to understanding how everything works in web servers, but it's a great set of terminology that we use among web developers. And I think as you move into your role as a web developer, you ought to understand this. So this is a picture of the request response cycle. At the bottom we have the browser, and at the top we have a web server talking on port 80. The user clicks on a page, clicks on a link, the browser intercepts that link, opens a connection up to the web server, sends a GET request, the web server does its work, and returns a web page. And so that's sort of the basic request response cycle. And now we're going to, as in much of this class, really expand what we're going to do when we're in that web server. So that's where we're going to take a look at this. So basically, model view controller is really a set of terms that allow us to say this aspect, this part of the work that's going to be done in the web server, it's either the model, it's the view, or the controller. And so it's the most value that it has is to say, oh, that part right there, that's controller. So model view controller is independent of the programming language that you use, independent of the operating system that you use. It's pretty universal across as a concept, as an architecture, as a way of talking about web servers. So the three parts of it, it'd be probably better to call it controller view model, or model controller view model, or something like that. But model view controller rolls off our tongue better. So the definition in my mind of these terms is the controller is this sort of abstract idea of what happens next, what is the sequence of events that happen, and then where do we start from, what do we do when we get a request, and then afterwards, where do we go at the end of that. The view is all the stuff we see. It usually is at the end of the request response cycle, we produce a view and we return the view back. And one of the things that the request response cycle often does is either interacts by storing data in a database, like an insert, or it edits something and puts it in a database, or it just reads stuff from the database and shows it to us in the view. And so that's called the model. The database itself and sort of the notion that we have persistent storage inside the application, that's what we call the model. The view is what we see, and the controller is kind of the glue that puts it all together. So the controller orchestrates all this stuff. And so sometimes you don't say that's the controller, but the controller is like several places and the actual shape of your application. So when we receive a request, we have a number of tasks that we often have to do for each request. Sometimes if it's like a form that's been sent to us, we have some data that we have to receive, validate, and then process, and then store it in a database maybe. And so that's often thought of as the model work. Then once we've done that, we make a decision, like I stored this, where do we want to send the user? What do we want to show next? What page to show next? Maybe we show them, a thank you page, or maybe we send them back to the top page of the application. And so once we know what page we're going to send back to them, then that page has some data that we might have to pull from the database. And so we retrieve that using the model, and then we produce, perhaps using a template, some HTML response, and then put it back. So these are the four typical steps that we break down to say, in comes an HTTP request. First thing we do is, if it has data that we're supposed to do something with, we handle it, maybe store that data in a database, then we talk to the database and retrieve more data to produce the next output that we're going to make, and then we produce the HTML or the other form of output and we send it back to the browser. And so if we take a look at this in our Django application, the Django application is pretty much a model view controller application, in that the routing is very much the controller. It is that which it's like, here comes a URL, it's a request for something, where do we go? And so when you write urls.py, you're informing the controller. So the urls.py, I would say, is part of the controller action, the controller activity. The views is named the view. So the view is a little bit controller in that sometimes the view is storing some data in the database. Sometimes that's the job of the view. Here comes some data before the view produces the next output. It actually has to store what came in on this request. And then the view will do some controller activity, like it might decide, you know, I don't want you, this is the wrong page now that we've processed your data. I'm just going to send you over to some other page. That's kind of a controller activity. So it might say, I'll store the data. It might, let's see here, yeah. So it might say, you know, here I go, I'm going to store some data, and then I'm actually just going to send you to a different place. I'm not even going to give you any HTML. And we'll talk about that redirect. That's called a redirect in a bit. Sometimes there is no data, and so sometimes you get some data, you route it to the right view, and maybe some data has to be retrieved from the database, merged together, and result is processed. So when we think of views.py, that is to me both the controller and the view production. So sometimes it's making decisions about where to go next. Sometimes it's just handling incoming data or sending data out. And similarly, the models is taken from model view controller, because the models.py is where we basically do all the work to talk to the database, whether it is storing stuff in the database or retrieving stuff in the database. We use the Django model capability to implement the concept in model view controller of models. So just a quick summary. I like to think of urls.py and some of the views.py as the controller. The models, of course, is all the things that talk to the database. And then the views are like the second half of views.py. So produce using templates and forms.py and et cetera, to produce the output and send it out. And so that's how I map the model view controller onto the Django architecture. And again, Django architecture was probably inspired by the model view controller, and that's why it takes some of its names of some of its capabilities from the model view controller concept. So now we're going to start producing the actual output of our application in the views and using templates. And there's a lot to cover here. So up till now, we've been starting to talk about URLs, which are simple. It says when you get the request with a URL of this format, choose a view and send it to that view. We're going to talk a lot about views.py and templates. In an upcoming lecture, we'll talk about forms. And we spent a bunch of time talking about models.py and how the models can talk to Python code, talk to the shell, how the models can inform how we write to the database and how we read from the database. So we're starting to fill parts in. As we put the views together, we're really starting to create our entire application. And I know it's taken a while to get to the point where we can update get to the point where we see the whole thing. So I just want to say that from time to time, wherever you have DJ free samples, whether it's on your laptop or whether it's on Python Anywhere, you should do a git pull from time to time, because I'm always working on these samples and I want you to make sure you have the latest copies of these samples. Sometimes I add little bits I don't change the samples, but I add bits of documentation as I'm like, ooh, I should have added that. So views are like the core of the application. I mean, the URLs find their way to views. Models tend to serve the needs of views, act as this layer to allow views to write and read the database. And so the views.py has a model aspect in that it handles incoming data. When we get to forms and post data, then we copy that into the database. The views.py decides sometimes whether or not to send the user to a different screen, or if it's going to produce the actual screen, the HTML, it produces that HTML, often using a template, and then sends it back. So the views are where the work really gets done. And what you see is you write a lot of code in the views. You write one line in the URL, few lines in the models file, and then lots of stuff in the views. And I consider the templates kind of part of the views as well. So the first thing that Django does when it receives an incoming document, a request for a document, it basically parses that URL. And the first thing after the domain name is generally the application. So remember that Django has a project, and then underneath that there's one or more applications. In each of the DJ free samples, you see lots of applications, each application kind of to show a little bit of sample code for a topic. And so that second part of the URL, that is the application name, and for all intents and purposes it's also the folder name within the Django project. Now within that, usually the next chunk is the view. And so that view within application, the view within application is defined in urls.py. And then after that, there are two kinds of parameters. One is like a key value parameter that comes after a question mark. It also uses ampersands for that. And then sometimes we just put after slashes. This is more of a REST style URL that's very pretty, and you put the parameters right on the URL rather than the question mark, which is sort of the old school for doing all this stuff. So there is this thing in Django called the URL dispatcher. I sort of call it router on my picture. It's basically to get you to be able to define the URLs and how those URLs are to be parsed and handled, and how those URLs to be routed to the various bits of view code. And so we do this in urls.py. There are three basic patterns. First, you might route a particular URL pattern to a predefined class, and you'll see the example of that coming up. Or there's sort of functions, really old school function that take this request, which is an object that captures all of the data, the parameters, the URL, whether it was a secure request or not, what host it came from, what's the IP address it came from. All that stuff is wrapped up into this request object, which we'll talk about in a second. And that view function looks at that request object, decides what to do, talks to the database, maybe, and then sends back a response, whether it's a redirect or some HTML. And the function is kind of the low-level thing, but you can also then define a class. And defining classes, as we'll see, is really quite nice. The classes have methods like for get and for post, depending on the kind of incoming HTTP request that we're handling. And it also, in those methods, the request and any other URL parameters can also be sent in. So let's take a look at a sample urls.py from views. And we see examples of all three kinds of these routes. URL patterns is a global variable. It's just a list, but it has very special meaning. This list has very special meaning to Django. And you see these path commands, and there's other ways to describe these things. And then you have the path, and the blank path means sort of just slash right after the application name. And then we have which view to send it to. And so this template view as view, this is basically to save you from writing code if all you want to do is take a template out of the templates folder and return it. So you don't have to write your own code in views.py. And so it's already there, and that's why we go into Django Views generic import template view, and we're going to say, you know what, I'm going to route, I wrote that template, but I just don't want to write the code to go send that, just read that template and send it back. And so this is a predefined bit of Django that does this for us. Sort of the more old school thing is this syntax right here. And basically from .import views pulls in views/views.py. And then this, you will see our functions inside there. And then these are classes also from our views.py for this particular application. And the syntax is a little weird. This is the module we imported. This is the class from that. And then asView is a static method that returns a function that then can respond to the incoming requests. And we'll see these as we kind of go through these. So up next, we're going to actually look at the views.py and take a look at the views. So now we're going to take a look at the code that actually writes the views, the code effectively in views.py. Now the first view that we're going to take a look at is one where we're not even writing any code at all, and this is that predefined view, that template view. And again, template view is code that a class that's given to us from Django, template view. and you pass it a parameter. So we're actually kind of calling a function here and passing a template name to it, and that is a file, views main.html. So this is the application views, there's a subfolder called templates, and then I'll talk about this in a bit. We repeat the application name twice, so that's a little bit weird, but it has to do with the fact that these names are global across all of the applications, and so you want there to be possibly more than one main.html, and so that's why you have this extra folder name, and you put this there, even though that feels a little bit redundant, but it's okay. And so this is just a static HTML file. I'm not going to read any data from a database. I'm not going to write any data to the database. I'm just going to read this file and send it back to the browser. And that's a common thing where we just have a file that we want to send back to the browser. And so we just don't even have to write any Python code other than add this entry into the URL patterns in urls.py. So that's a view where you wrote no Python code. Now, for the parts where you're going to write Python code for a view, you're going to be passed in variables. The variables are all about the request object. The request object is all the data coming in, and the response object is something you produce in the view and you send it all back. So the request object is an object instance of class HTTP request. This is a predefined Django, and there's just a whole bunch of things. The scheme. Now, what is the scheme? Whether or not it's secure or insecure HTTPS. The body, it's the string. So there's like about 20 or 30 attributes. We're going to use some of them, but you don't have to use all of them. But you can go look up the documentation, and the more sophisticated your application becomes, the more likely you're going to have to go digging in to find some little bit of the incoming request. You could think of this request data as all that data you see in your browser debugger about what data was sent to the server. That all ends up somewhere in this object. Now, when we return from a view, we have to send a response back. And so the response is something that we create inside of our view. It might be simply text that's HTML, or it might be a redirect object, redirect response that says, hey, go to a different page. And so we make that the main job at the end of the view is to produce a response and then return it back to Django. And so here is a very simple view. So here we're saying, we're in the views application. We're going to go to the view funky, right? And so in the URLs PY, we say map/funky to this function named funky. It's a funky function. That's why I call it funky. And so when it sees this, all the data coming into the request shows up in this variable that is the first parameter sent to that function. So that's what this is saying in urls.py. Take everything that goes to views/funky, gather up all the request data from the browser, put it in an object, and then pass that request object in. Now in this, I'm not really going to do anything with that request object because I'm always returning the exact same thing. And so I just have a nice triple quoted string of some HTML with less thans and greater thans, and I'm going to basically return, it is my job in the view to give back a response. There's two main types of them. One is an HTTP response, which is just like a body of text, and that's what I'm sending here. I'm sending an HTTP response. That's a constructor. We're constructing a HTTP response object and taking that string that I put in there, and away we go. Okay? And so that basically, if you hit this path, you're going to get this page back, and it sort of looks like that when it's all said and done. Okay, so now we want to talk about how we can get at parameters. So I mentioned that this request object that comes in to your view function has all the data from the request. Well, if we send to a view with this question mark, key value pairs, that's guess equals 42 on there, and we're going to route danger to views.danger and urls.py, and so all this data is wrapped up in this variable called request, passed into the function named danger. And so inside of request is some data. request.get is a dictionary of the key value pairs that are on that URL. So to pull the 42 out, we can say request.get bracket quote guess quote, and that pulls that out. And so that's all we've got here is a really simple HTML page, and we are replacing that little chunk with 42. And so whatever this number is comes back out in the output. So your guess was 42. So that's how we pass get data into a view. Now, up next, I'm going to explain to you exactly why it is I called that function danger. So it's important from time to time to talk about ways that you as a web application developer have a responsibility to create secure web applications. And so I want to call your attention to places where you write code that seems like on the surface that it's what could go wrong, and then you realize, oh, wait a sec, that could go wrong. So it turns out that you take data from the user in the request object, whether it's from a form or from the URL, and, like guess equals 42 seems innocuous enough. And then what I did is I just concatenated that into HTML and I sent that back. And so the problem is what if somebody with ill intent tries to produce data that actually does something? And the problem is if I take data straight from the user and put it back in the HTML response, well, HTML and JavaScript are programming language. Your browser is being programmed, and that means that a user typing data into your system can program the browser. And what's even worse is that, having them program their own browser, not such a big deal. But in a way, what they do is they put some data in your system that turns into code, and then they kidnap someone else's browser when they take a look at data that came in. This is called cross-site scripting, where in a sense what it's doing is it's trying to run code so that it can read stuff from your site and then hand it to a rogue site. And so we have to protect against this, and it's a very simple thing. So if we take a look at the code that was bad, basically we have this parameter guess, and in the last time I showed you that was 42. And we just took this request get guess, which is this stuff, and we simply concatenated it into some HTML. Well, if I carefully construct my guess with %C3, blah, 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 all the blah, 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 all that stuff, well, that turns into, this is a URL encoding of less than, B, bold, greater than, bold, slash, so that turns into HTML. So I passed into this application some HTML, and I as the developer took that and I concatenated it together, so the response source has HTML. It's HTML that mostly comes from the application, but this little bit of HTML came from the person who put it in. And like I said, it's not such a critical problem if I in my browser put stuff to take over your browser, but it is if someone, you can move that into someone else's browser. So what happens is the browser sees this bold text in HTML, and instead of showing us the less than and the greater than, it actually shows it to us as bold. Now this seems innocuous enough until you do something much more clever, and that is I am going to carefully construct some code, JavaScript. And so what happens is this here is encoding of that line right there, the script alert owned / script. And so what happens is that came in and it was concatenated straight out. And if you run this page, you won't see the data, but actually JavaScript will run and it's going to show up an alert box that says owned and OK. Now, you can go ahead and look at the Wikipedia entries on cross-site scripting. Generally, the idea is once you're in JavaScript, you don't just say alert that I've owned your browser. What you do is you do something like grab a cookie and send it to a third party,
or you call, say, a web service on the system with a cookie and do bad things. Like you can convince a teacher to log in and change someone else's grade or delete all the grades in a class. Once you're into a person's browser in JavaScript, you can do a lot. So that's really quite scary, and there's all kinds of scenarios where you're taking data from the user, and you got to be careful because, yes, I said the guess is supposed to be a number, but if it's not a number, if I concatenate it without escaping it, it's a problem. So here is a safer version of that. So I've got another view function called game, and it takes that same request, and it still pulls that get data off, which is this bit right here, but then it calls a function, and that's Django utils HTML escape, right? So what that does is that concatenates that into the HTML, but escape processes any dangerous characters and turns them into what are called HTML entities. So less than becomes ampersand LT, greater than becomes ampersand GT. Right? These four things with ampersands are a safer version of it. And so that means that even though I put in the data for bold, it comes out with the less thans and greater than showing, and it's not actually interpreted, right? So this whole notion of escaping, or HTML entities, converting data, running the data from a user through an HTML entity's automatic filter, ensures that the user cannot provide you data that turns into code in their or someone else's browser eventually. So that's the kind of thing you have to think of as you're concatenating stuff together. And the key thing is the request get guess, that came from the user. And so we think the user's going to be nice, but a user with bad intent can send data that they carefully construct to cause the maximum trouble. But if you just escape your data before you concatenate it, there's nothing they can do about it. So another of the views is where we're going to parse the parameter off of the URL itself. These URLs are a little prettier sometimes than the question mark keyword equals value. And so, so let's take a look at this. The way you do this is in your URL patterns, you have a path, and instead of just having the path name, the view function name, you actually have this bracket, int colon bracket, guess bracket. And what that is, and you can go look this up in the Django documentation, there's a whole series of these things, that says the parameter after the word rest is an integer, and please pass it in as the parameter guess. So I've chosen the name to pass it in as a parameter, and then once Django sees this, it pulls that 41 off and hands it to us. So we don't have to tear the URL apart. Actually, in this request object, we do get the URL. We could do a bunch of splits and fool around, but nah, doesn't matter. Let's let Django do all that work. Let's just tell it we want that parameter after the word rest. It's supposed to be an integer, and pass it to me in the variable guess. And then that same 41 comes in. I am cleverly escaping it before I concatenate it, and then I return a text-based HTML response with some HTML back to the browser. So this escape is there just because of cross-site scripting. I'm still taking this value, still coming from the user. So if any value comes from the user, you have to properly escape it before you show it to them. Now, those are all function-based, which are sort of a lower level. We haven't got to the point where we're talking about forms, but eventually in those lower level functions, you have to check whether you got a get request or a post request. Post request often comes from forms. And so this class-based view allows us to give a method for get and a method for post and let Django pick whether it's a get or a post. And this is an object, and if you're a little rusty on objects, I've got a URL there on pythonforeverybody.com to review just like what a self is. I'm not going to cover all that. In the path command, you just have a string that comes after the application, routing to this. The main view, as view, is something you got to add to it because main view is a class
not a function, but asView is a function. And then we have to create a method get. Self, of course, is just part of Python's object-oriented work. Request is that first parameter, right? And so this one here is just a stock response, and I, just like the other ones, I return an HTTP response. Now it's like, why this looks a little more complex than the other one. Did the same thing, but it turns out there is tons of things that we can do. And inheritance, the fact it's a class, there are so many things about object-oriented programming that over the next few lectures we're going to really take advantage of this, and we ultimately will rarely write the old school function-based view. We'll do class-based views. And so we can also pass parameters to class-based views just like we can pass them to function-based views. You say, okay, with a prefix of remain, slug is a kind of string, and then guess is the parameter, so that says pull the string after the word remain off, right? Views is the name of the view, remain is the view within the application, and then this third parameter is the guess, and it's automatically parsed and handed to us in guess, and then we're going to respond to a get request. Self, of course, is the object-oriented thing. Here's the whole request, and guess is that little piece that comes off of the end of the URL. We're going to create a response by escaping the user-provided guess bit, so that if the user puts something nasty in for cross-site scripting, we stop them from doing that. And so that produces the same kind of output. Your guess was ABC 123 42 XY ZZY. So, talking about return values, everything we've shown you up till now is your basic 200 OK, which means you asked for a page, I gave you a page. You're probably familiar with 404 not found, which means you ask for a page, that page doesn't exist. There is another kind of response that's not actually a page, which is a response header that says, you know what, it's not like you made a mistake, but you're at the wrong place. And we call it a redirect, and 302 means I know where you're supposed to be and it isn't here. And it was originally used for sites that would move. And it's all handled by the location header on the HTTP response. And so we send a redirect response, which is a 302 with the location header being sent, and it uses our URL. And when the browser gets that the 302 and a location header, it doesn't show you what it just got, but it immediately re-gets that URL and then shows you that URL. And the original idea was that if you renamed a domain or something, you wanted to have the old domain redirect web browsers and search engines, you use these 302s. There's also a 301 header that can be used to redirect all this stuff, but now we use it for all kinds of things, and it's very much a controller function. If you go to Model View Controller, controller says, okay, we're done with that, but I want your browser to go over there. So that routing, that sort of routing the browser, changing the browser, putting the browser where you want it to be, that's part of the application's controller phase. So we can send a redirect from a Django view. And so here we go. If you go to this bounce, it's going to actually not end up at this, it's going to bounce it to somewhere else. And in the path, we just say if we go to the bounce view, run to this function. This is not a class-based function. This is an old school function. And so the request data is passed in. And instead of now returning an HTTP response, which we would put in here HTML, we are doing an HTTP response redirect, and now we put a URL. And what we're saying with this whole thing is, you're at the wrong place, please browser, when you get this response back, go here. So it's like it bounces to the browser and then bounces back and then reads that URL. So, and you can have some output, but folks generally don't need output when you're doing a redirect. So if you take a look at that bounce, watching it in your network console in a JavaScript debugger, what you see is you see a set of 3 requests, actually just 2. You'll see the first request is going to bounce, and if we take a look at this request, we see that it's a 302, it's kind of small. You see we got a 302, which tells the browser something's wrong, I'm not at the right place, and then also the server sends the location header that says this is where you're supposed to be, and the browser immediately turns around and does a get to that URL, simple.htm, and then that's what we see. And then this 404, interestingly, the three statuses I talked to you about, is because at this new location, djfree.com/simple.htm, there's no favicon. Remember, the favicon is the thing that shows up like right there in the top tab bar is the favicon, and I don't have a favicon, at least not now for DJ Free. I should put a favicon there, but we get to see a 404, and all that means is the browser looked for a favicon and didn't find it. So we see a 302, which is moved with a location header, and then we see a get, which returns then a 200, which is a success, and we see the document, and then we see a 404 because it tries to grab the favicon. And so the HTML you get back from djfree.com simple.htm, that's this simple page with a simple link. Okay, so that's how the redirect works. So that's a series of views, both the input, class-based, function-based, and to both the HTTP response and the HTTP redirect response. So up next, we're going to talk about how building templates makes us do a lot less concatenation. Hello, now we're going to talk about the other half of the views, the templates. And the templates are our way of creating HTML. And again, just to ground everything that we've got here, we're in the views, and the views are really sort of the code, the Python code that we drive. We're going to get to forms in a bit, but views kind of merge stuff from the templates, merge stuff from the models, send stuff in and make pages, right? So this is going to look a lot like HTML. It doesn't have to be HTML. It can be things, but other than HTML. But templates in our class will mostly be HTML. And so they're kind of the last little piece of the puzzle to start building user interfaces. And from this point on, we're going to be making user interfaces rather than introducing the parts of a Django application that have the user interface. So this is the text from the Django website. It's about convenient ways to generate HTML dynamically, and there's a couple of different templating engines. We're using the default one, and there is some data that we pass into the template. There's a process that's called rendering, and then we get the HTML back, and we return to the browser with that HTTP response, which we've already been doing. It's not the request response cycle is the same. The difference is, instead of writing Python code to concatenate a bunch of things together, we are going to use a template engine. So this is the kind of stuff that we've been doing all along. We have a class in a view class, REST main view that extends this view. In comes perhaps the request object, and then maybe even another parameter. That's not changing. What we're doing here is we're using concatenation. Concatenation, these little plus signs. Escaping, we're doing all the escaping and concatenating, and then we are sending back a response. So what goes back as a response, what comes in as a request, what goes back as a response. We're still going to do that. We're just going to get rid of that middle bit and make it a little prettier and make it a little more sense. If you look at that, if you look at it, you got to get it syntactically right. You got indentation problems. That's 3 lines of Python. I'm using triple quotes. I'm using plus. I got to get all that matching together. And then, eventually, I'm going to be in the HTML is going back. I'll be using single quotes and double quotes and all those kinds of things. And JavaScript's going to look really ugly here. Indenting of the HTML kind of will fight with the indenting of the Python. So this is just general. I mean, I've only done short ones because I only wanted to show you a little bit before we showed you templates. So the basic process is a bit of software, a template software that Django provides us. We're using the built-in Django one. And basically, template is some HTML with some hotspots in it that says, put data here. And then the rest of it is just HTML. And then we pass the data in some kind of an object, dictionary, etc. And then a bit of code pulls all that stuff together and then produces the HTML with all of the data placed in it. Often the render data that we're passing in is coming from a model, for example. We might talk to a database, load up a bunch of rows, and then put it in. But In the simplest form, what we've got is we've got like a little dictionary. Call this the context. You could call it the rendered data, and then you have the render template. So the render template is really HTML, and that's what makes it a lot easier to look at because you're not putting double quotes around anything. There's no concatenation, but there are special characters. And what the double curly brace surrounding it says is, instead of that, take this bit out and replace it with whatever's in the variable dat from the render data. And so that's how, when it's all said and done, this is replaced in the fun stuff, replaces curly brace dat in the final output. And if you thought about it for a while, you could probably write a render engine. They're not that hard. Now you'll see they have some sophisticated features eventually, so you probably don't want to write your own render engine. But you could imagine a Python assignment where I say, write me a function that takes a dictionary that looks like that, and then with key value dat fun stuff, and then take some text file that has curly brace dat curly brace, and then find that and then replace it with that string. You could write that code. You don't want to write that code. Django has already written that code for you. So here's the code in action. And so this is we're going to call this. We're in the application named TMPL temple. And so we have the application temple, we have the view game, and then we have a number 200, and that's what we put in our urls.py to route the game view and take one parameter. Remember that slugs are a special version of strings that are letters, numbers, and dashes, I believe. And so the entire request coming in from the browser is coming into the variable request. This number 200 is coming in the variable from the URL is coming in the variable guess. And so instead of us concatenating together, we are going to create a context. What I call a context, which just is a dictionary of key value pairs. And the key for guess is GUESS. It's a string. That guess will matter inside the template. And then we pull this number 200 and we convert it to an integer, and then we pass it in. And this render, we pass it the request object, we pass it the name of a template, and then we pass the context, the key value pairs, to be substituted in that. So let's take a look. So if we look at this template, it has a series of curly brace, like hotspots, places where you would replace stuff. And so the double curly brace just says retrieve the string that is under guess and put it in. And so that's how we get your guess was 200 in the ultimate output. And then we have curly brace percent all the way to percent curly brace. And this is a series of if then else's. So you can put logic in here too. You don't have to just take this string and put it in. So what we're doing is we're basically saying if the guess is less than 42, we print out too low. If it's above 42, we print too high. And of course, if it is 42, we print out just right. And since our guess was 200, it prints out too high. And so basically, this makes this view code a lot simpler and doesn't put a less thans and greater thans and concatenations. It's all substituted by this render routine. Now, the render routine returns an HTTP response request. So when we get that back, we just return it. So we hand back to Django the HTTP response request, and then the page is displayed in our browser. Remember that we have a Django project, and this is the Django project. In my case, the Django project is DJ for eSamples, and I have a bunch of little applications. All these things, as a matter of fact, Temple is the one we're working at right now. Those are just the different pieces of sample source code that I've built for this class to talk about. And so those are applications. So it's just that Django terminology. Project made up of one or more applications and folders. Okay? And so the problem is these templates, when Django starts up, based on the settings.py, it loads all these files up. Loads them all up. And so it loads them all up, and the templates are actually global, and we'll see this in a bit. They're global across all of the applications. And so the problem is that if you have a template name like detail.html and you have a whole bunch of applications like I do, all of which want to have a template named detail.html, it doesn't work because which detail.html, it'd be template/detail in two folders. It's not clear which one you're talking about. So we've adopted a convention that we take the application name, and we make a subfolder inside of templates that's the application name, and then we use this favs/detail.html or pics/detail.html as the name of the template. So in a sense, we're introducing a subfolder. It's a little jarring at first because you see there it's the same. It's a good convention. I mean, it's unfortunate we have to have the convention, but because these names end up being global across your entire Django project in each application, and to get them a name, to get them properly named, it's necessary to introduce this extra level of redirection. And when we get to logins, there's templates that are stored outside in other applications. So sometimes you want to get a template in some other application. So there's all kind of reasons. This is a great idea. It just isn't the prettiest thing in the world. So just when you see it, don't freak out. I try to call it out in the slides. And so we put these paths that includes the application name twice. It's weird, but it is necessary to do this because of the notion that all these template names are global across the entire application. But if then we call this the template name with the name of the application prefixed, away it goes. Django could have made that a little easier for us, but they basically didn't, and so we have to do this. But everybody does it the same way. So now what I want to talk about is the actual templating language itself. I showed you a couple examples, the double curly braces, but it turns out there are lots of things that you can do with double curly braces in the template language. So now we're going to talk about the actual template language. As I mentioned before, there's more than one templating language. We're using the default one, and I think it's actually one of the better ones. This whole notion of double curly braces. There's all kind of templating engines, and a lot of them use these double curly braces. Sometimes there's a one called mustache because the curly braces look like a mustache. So this double curly braces, you learn it in Django, and you'll find it all kinds of other places. I've used it in front-end processing. This is back-end processing because we're doing all the substitution in the back-end. So there's basically a couple things you can do. The double curly braces do substitution, and one thing that's cool about this, if you recall, I talked about how you have to escape data that came from the user. Anything in the double curly braces is automatically escaped. As a matter of fact, you have to do something to not escape it, because it turns out that 98% of the time you want to escape data that you're printing out, because it doesn't change what it looks like, but it does make sure that it's safe. If you add this vertical bar safe afterwards, that's like a modifier. I think it's called a filter in Django that says, look, don't run this, don't run that filter on it to do the HTML entities. Just do it as is. I know there may be HTML in that, but I've taken care of that because I am the application developer. You can call functions, like with the code is the percent, curly brace percent, and in there you tend to call a code. This is like code. This is like calling a method or a utility code. And so the first part of this is what you're calling, and then later you can have some parameters. So this URL says, I want to find a URL for the view cat detail, and I'm going to take the number that is the current cat primary key for the cat record and put that on as the URL as well. The author in this case is and we'll see this later, is a model item, and get absolute URL is a method inside that model item. You can have sort of ifs and if then else's. It's kind of Python-like, which is nice in that you don't really have to learn new things. There is looping code that's in there, like a for loop that we'll talk about in a bit. And then there is blocks that can be replaced. So you can have a template that sort of pulls in another template and then substitutes in part of it. So you can have whole blocks of substitution, not just little strings of substitution. And so we'll talk about each of these in turn. So here we go. We'll start with a real simple one. And you'll notice that in this particular simple one, we have no parameters on the command on the URL. So we don't have any parameters here. I'm going back to a non-class style, just a simple function, and I'm not sending a context. The context would be the third parameter on the render call, and so I'm just saying, hey, and this is what you do when you just have some static HTML that you don't really need to change anything, and so that's what's sitting in here. It's just a simple page. There's this thing called a built-in template view class that sort of does exactly this thing, that just grabs a template, turns it into an HTTP, grabs a file, turns it into an HTTP response, and sends it back to Django. So that's just a super simple template. Now here's one where we're going to take a parameter to the context, and I'm not taking it from the command line quite yet. I'm just going to make the parameter always be 42, and the key is, this is a key and this is a value. So zap in this case is the key and 42 is the value. I often call this variable context, but the fact that's just a mnemonic memory thing for me, context or CTX is what I tend to call it. And now I'm passing in the template, this template here, the guest.html template, and it has one little curly brace substitution, and remember that does escaping for us automatically, so there's no need to use escape the way there was when we were doing this via concatenation. That alone is a good reason to use templates. And so this ends up sending out your guess is 42. So this is just really focusing on what's in that context and how the things come out of the context. This name here, zap, in the context means pull the thing out of the context under the string name zap, and then it substitutes the results, like the 42. So instead of it saying guess was zap, it's your guess is 42. So that's really focusing on the substitution. So this is showing us how we do the safe stuff in case you actually want to pass some HTML into a template and actually want it to render as HTML, not as HTML entities or HTML entity style. So we're sending in a thing that's bold with a B and a less than B. That's HTML. It's got less thans and greater thans in it. And then we got zap. And so you can see that the zap comes out as 42. It's HTML entities, but it has no special characters. But if we escape text, text is the one with the HTML entity characters, that automatically escapes it so that you see the less thans and greater thans in the browser output. Escaped, less than B, bold, greater than B, right? And if you say text and then add the safe filter to the end of it, that says don't escape it. And so then this bold goes right into the HTML document, and instead of you seeing the less thans and greater thans, you're actually seeing the text turn to bold. Now, usually the bad folks that are trying to get into your computer are not just turning your text to bold, they're trying to run JavaScript. And all we're showing here is that whatever less thans and greater thans would be in that context value txt, they're going to end up literally in the document, and the browser is going to interpret them as HTML. I mean, there's just no way that somehow your browser knows the HTML that came from your program versus the HTML that came from a context variable, because by the time it gets to the browser, it's all one thing. And so it doesn't know, oh wow, that's dangerous, that came from a variable. No, by the time the response goes back to the browser, it's just a blob of text. Now we can talk about some loops here. I am passing in two arrays, apple, orange, banana, and lychee. And then I'm passing another array called n with peanut and cashew. And then I'm going to create a context. And in that context, I'm going to have fruits point at the list F, nuts point at the list N, and then zap is just the string 42. And do I even use zap in this one? No, I think there's another place that it. No, oh yeah, it's. I just don't have it in the. So here's the template, a part of the template. It's not looking at zap, and so here's the key. So we got this for loop, for x in fruits. Well, fruits is looking up something in the context under the key fruits. They're string. They don't look like strings in. They don't look like strings in the template, but it looks up there and it finds a list. So that little list F is what really is going on here, and F is a list of apple, orange, banana, lychee. And then X becomes the iteration variable. That's only within the template. And then I'm going to print it out, and then I'm going to end it. So that's like the start and end of a for loop. Apple, orange, banana, lychee. Now, you'll notice that I have an li tag, which is the list item tag, and it just generates all that HTML. And again, the double curly braces are doing HTML entity escaping automatically. So, so we take a look at nuts. So we ask, is nuts present? Because that's a way to tell if if variable's present or absent. If it's absent, I'm going to ask another filter on the end saying how long was it? Okay, and so this is the n, nuts is the n list, and it has a length of 2, which means it has 2 elements in it, and so we see the number 2. And so you can do various things. So this is an if then else, the syntax of an if then else, with curly brace percent. Now we can pass objects within objects, and so it's a little tricky. We have a context in this x variable, and the sort of the outer key is pointing, the key is outer is pointing to another dictionary, and in that dictionary there is a key of inner with a value of 42, and then we render the nested.html, and you see the outer, but then outer dot inner, so outer is that object, and then object dot inner, then this thing becomes 42. Okay, so you can kind of walk through objects if you have hierarchical objects that contain objects, or lists that contain objects, or any number of hierarchical structure of lists and objects. You can walk through them. So here's just another simple example. This one has data coming in instead of hard-coded. So we again have game 200, and we're running into game view. It's a class view, and the 200 comes in as the parameter because we said it's the parameter that comes after the word game, and so guess comes in as 200. It's a string at this point. It hasn't been converted to an integer. So when Django pulls these off, well, it does some validation based on the types, but it doesn't actually necessarily convert them. And so we're going to create a context, x equals a key of guess, and convert it to an integer to pass it in. And then we're going to pass the context in and the template in. And so the word guess is going to come out, and we sort of saw this. The guess is 200. And then depending on the if then else logic, it's going to say, in this case, too high because your guess was 200. And of course the right answer is always 42. So now we're going to talk a little bit about how you manage a common text going from one template to another through template inheritance. So now we're going to talk about a technique called template inheritance. And this and other times, it's a great time to review object-oriented programming, because I'm just going to use object-oriented programming definitions and words and not completely explain them. So you got to know what a class is, you know what self is, those kinds of things. And I've got a great online lesson that you can go read and listen to and understand objects, and I'll explain it to you in 30 or 40 minutes. So inheritance, actually from that lecture, is the notion in object-oriented programming to not repeat yourself. You have some kind of a shape, and then you make a bunch of objects that mirror that shape. But you can also, with inheritance, you can have a shape that makes another shape, like a shape in general that's a triangle. And so you can inherit that all triangles have everything shapes have, and all squares have everything shapes have, and all circles. And it's just a way of capturing information once, writing code once, and then not repeating yourself. Functions are a form of DRY, don't repeat yourself. Modules are, but inheritance is the key. And inheritance kind of can get in our way as programmers because it leads to smaller and smaller code. If we're going to make 5 things, each of these 5 things is really small because we make a big thing over here and we inherit all 5 of those things from it. But then you look at it and like, oh, I don't understand that, right? I don't understand these only one-line functions. What are they doing? Well, the answer is there's 50 lines out here that we're inheriting from. So we'll see some of that. I'll try to kind of allude to that part where, look, there's magic over there. And a lot of what you do in Django is use classes and objects that you didn't even create, meaning that they've got data in them like .scheme or request.scheme. And so this is just also a way of trying to simplify the way you handle sort of things, objects that are handed to you, and then you hand objects to other parts of Django. So template rendering basically says, okay, here's some render data and here's a template. What happens now is there's this thing called a base template, and the base template and the template combine together to be sort of like the ultimate template, and then you pass in the render data and produce the rendered output. So let's just say that we had a bunch of pages and we were doing the same thing over and over again. Now we will soon do this with navigation, because you want to put a menu at the top of every page, and literally that menu could be 40 or 50 lines of HTML, and you do not want to repeat that menu every time at the top of the page. So you want to put that one place, and then you want to make many pages that have the same top navigation, so that your pages, as you go between them, look like the navigation is the same. So we're going to do this in a very, very simple way. So we have one template, this cond.html that we've been playing with. You'll notice it has some HTML and a title and a body tag and some of this, and then it's got this stuff. Well, let's say we wanted a bunch of pages that had that everything but the body. So what we basically then do is we take parts of this, like the repeated parts, and we put it into a template. And then we take the part that we're going to change every time and we put it into a template that then extends. So see, this one here has one line that says extends temple-base.html. So this one uses everything in here but then adds some stuff. Okay, so the basic idea is we split this one big template into reusable parts and non-reusable parts. And then we have a bunch of templates that come off a base. We call it base commonly in object-oriented world because it's like the thing that we're basing it on. So, you know, this is the base, and then we're going to build on it. Base, build something else on top of it. So how this works in practice, we have a view here. We're going to call this view game2, right? So we're going to use the URL game2. We have a class-based view. We have a get method in there. The request data comes in as request. We told it to parse the slug off the end and pass it to us in the variable guess. We make a template, which is exactly what we did before, where we have a key of guess and the value is the actual guess itself. And then we pass that template in the variable x into render, and we tell it to go read temple con2, which is the condition, the second conditional one. And the thing is there's nothing in the Python code, in the views.py, that knows about the base. What happens is the only place that the base is the only place that the base is noted is in the con2 template itself. It says, hey, go grab this one and extend it. Now the way it works is it starts out a little counterintuitive. It says it really says start with this template here and then push this content into the base template. And this block content and end block, it basically, that tells what I want to replace. You're replacing blocks in the base template. So all the stuff in the con2.html that is between the block and the end block is what is then pushed into the base template. And then in a sense, the base template with those blocks replaced is what is returned as a result of the render and then returned to Django as the HTTP response. We're going to use these a lot. When we start doing navigation, we're going to go crazy with these things. So up next, we want to talk about URL mapping and reversing, where we have to actually make a link in one page to a different page. So now we're going to take a quick look at URL mapping and URL reversing. This has to do with basically routing, and it really allows us to generate links from one page to another. So we're in the middle of a page and we want to make a link to a different page. We've got to figure out what the string of that is. So again, we're sitting here in the middle of our code. We're in the views, and this URL mapping is basically a set of functions that allow us to read the urls.py. In a way, if all these functions didn't exist that allowed us to read urls.py, we would write a bunch of functions to do that. And so these are just now part of Django. And so often these are used in the view. Sometimes they're actually used right inside urls.py to come up. So it's like, if you know the name of a view, what would be the URL to get to that view? And sometimes views have just a URL, and sometimes they're a URL plus a parameter, and that's all set up here. And so it's like, give me a link to a view, please. And then Django looks in the urls.py, potentially across applications and gives you that string. And it's just to avoid hard coding the strings. That's really the idea. And so this is just a common problem. This is the documentation right from the Django website. You don't want to hard code these things. You actually can, but then if you rename an application, the whole idea is you could make a Django project that had 4 or 5 applications, and then you could reuse some of those in a different Django project and add some more applications. So, you know, you don't want these applications to have too many hard-coded decisions. And it might be easier to hard-code some of these things, but it is actually in the long run much easier from a maintenance perspective. And so it's better maintenance. It's another don't repeat yourself, or doing a table lookup rather than hard coding strings. It also lets you hunt around in your code to see where it is that you're talking to that other application, because we're going to do login eventually, and login is another place. It's not in our application, but our application is going to have to generate login URLs by asking the login application, hey, what's the URL to log in? What's the URL to log out? And that's where we'll mostly start doing this. So I want to talk about it now, so when we get to log in and log out, you'll have that will make more sense to you. And it also is some of the stuff that you're doing from the tutorials. You're putting these reverse lookup things in, and you may or may not know what they are. And my goal here is to give you a little sense of what really they're there for. So let's take a look at an example. So here we have our urls.py, and most of it, I mean, this is the application route. So if you're looking in the samples, it's in the route application. The main thing that we've added is some names. Names are here to look up these paths. We don't really want to look it up by this path mapping, because that could actually change. So we're basically saying this view in your views.py, second view, is going to be referenceable by this second dash view. I named them differently very much on purpose. So here's what happens if you just go to the route/route, the name of my application. It pulls up this main/HTML. And so the first thing I want to show you is what a hard-coded URL looks like. Now we know that blah 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 samples/route/second is going to go to that second view, because the application's name is route and the view name is second, and that's good. That will work. It's not going to break, but this is where you lose flexibility as you try to recombine applications from one into the other. And so in a sense, what we're asking to do here is we're going to instead use this URL utility. And so in our template, we use curly brace %, and then we're running a utility that's been plugged into the template system that is like when we're running the URL function, as it were, and we're going to pass a string to it, and that is within the route application, the view that is named second view. So that goes into this file, the route urls.py, reads down the views until it finds second view, and then it reverse generates the path that works for that. Now in this case, these two strings are going to be the same, and yes, that looks a little uglier, but the key is that we can make changes here, and this will not, the top one, route/second, will not reflect the changes, but if we're looking it up by name, we can do all kinds of crazy things and remap stuff quite naturally. And so again, it's just this URL command, the name of the view, the application, the view. So this is what it looks like when it's all said and done. There's no parameters to this. So if you take a look at this route second view ends up under this hard-coded, the route/second view, the hard-coded ones ends up under the string in the URL output, the page output. We just see it's /route/first is the thing that comes out from running the code URL and passing route:first view in, so that's what it looks up. And we can make a link. This is now an href, and the actual path is sitting there in the href. So now we're going to see how we do this when we're going from one application to another. So an application we're going to look at in just a bit is this thing called the generic views. It's an application called gview. And we want to make a link to that application, and we know that there are two views. There's a list view and a detail view. And all we have to do is go take a look at the urls.py, and we know that it's an application gview, and this view has a name and that view has a name. The view that is all the cats is got a name of cats, and the view for a single cat is cat. But the cat one takes a parameter. It's an integer number, which is cat number 42 or whatever. And so we're sitting here in the route application, main.html, and we can now go create a URL that actually is pointing to another application and a view within that other application. So this is a URL for gviewcats, and that'll just look it up. So now we don't even have to know what the URL patterns are inside of gview/cats. Now, we can look at gviewcat, which is this URL, but you'll notice that this has a parameter, and so we actually have to add a second parameter, which is that 42 number. And so this will generate the URL straight to the detail page for a single cat. Now, there's a lot of nice stuff about this. So for example, if you omit this, it's going to look this gviewcat up and find it and say, you know what, I'm supposed to have an integer, and it'll blow up on you, right, if you get that wrong. Or if you put a 42 on this one, on the gviewcats, you're not supposed to have a number on that. But gviewcat, you are supposed to have a number. So this is one of the nice things about this reverse URL lookup, in that we can, there's some error checking that goes on, because if it could just blow up silently, and in many ways when code blows up silently, it's worse than blowing up in a spectacular fashion, because if it blows up in a spectacular fashion, you can fix it. And so this is what it looks like. So this gviewcats URL and gviewcat42, this one that actually is the detail page that demands a parameter, it constructs that just fine. Okay? So that's going from the route application to the gview application. Now, you can also, this is kind of subtle, and we will need it when we start doing social login using GitHub. So I'll just mention it because we're deep in it right now. And so basically this is actually the overall DJ free samples urls.py, and that's the one that's pulling all the URLs together kind of in the same folder as settings.py. And so you're pulling in a bunch of URLs, and these live in an application of their own name, but we can actually give them a name of our own to reference them. So you can actually name them, you can reference them with the name they were already given by the application that we're talking to, or we can say, you know what, I'm going to call these social : or nsroute : So if we take this route application and include all those URLs, and we're going to use a namespace of nsroute, you still can say route : or you can also say nsroute. And so you can see that in this example, right? We can go to the second view of route, or we can go to the second view of ns. And so there's route. Route is one way in, but nsroute is our own way in case we somewhere have an application named route or something like that. And so this allows for a second way to access these URLs using a namespace. And it's not in the urls.py in each application. It is in the urls.py for the Django project. So I just finished showing you all that in the templates, but we can also do this in Python, and we'll find that sometimes in like models.py or views.py, or even sometimes in admin.py, we'll need to sort of be able to find a view in the same or another application and automatically construct it. Sometimes in forms.py, we're going to do it as well. And so this, you tend to call this reverse or reverse lazy to look these things up. And the URL feature inside of the template is pretty much just calling this reverse lazy automatically, because the parameters are kind of the same. So I just want to show you how to do some of those things that I just showed you in templates, how you can do them in Python as well. So here's the one in templates. We just have this little plugin to a template called the URL plugin. It takes one parameter and looks up in the urls.py of the first application, the URL named first view. Maybe there's parameters, in this case there's not, and then it generates a path to that, /route/first, right? And so that's how you do it. It's really under the covers calling this reverse lazy. And so these reverse and reverse lazy are from the Django.urls library. And so in this view, there's nothing tricky about this view. It's just a class-based view. We have a get method. We pass in all the request stuff. But basically, we can call reverse lazy and pass it the exact same string, which is go into the gview application, work your way down until you find the cats, or go into the gview application, go in and find the one for dogs, or in this case, this is the dog detail, and it requires a number, and so this gview dog, go find that one, and then the second parameter is 42, so make me one for that. And in Python, U2, and U3 are all just strings, which I'm passing in through some context under the variables x1, x2, and x3. They're really lousy choices of variable names, but I do that sometimes to point out that they're arbitrary and capricious and all they have to do is match. And so then like the x1 matches in this substitution, now we're just doing string substitutions, which is different than calling the URL, but it's still just a bunch of strings. You called reverse lazy in your Python code, and now you're just pulling that string into with double curly braces. And so this is how it ultimately works. We can, we get these, we're just showing how this output turns out, where we go reverse lazy for gview cats, gview dogs, or gview dog with an argument of 42. We pass it in, we replace it, and so this is how it prints out, gview cats / gview dog / gview dog 42. And so that's how that reversing works in Python. And you'll see that certain situations, whether you're like in a model, sometimes you're in a model, it's very common in a model to want to put something about the reverse in it. And the reverse lazy says delay until later to look it up. So up next, we're going to put this all together and ultimately start writing using the generic views, because we're going to look at list pages and detail pages, and in time we're going to look about delete pages and update pages. And Django has these wonderful features that make it work really simply with very little code. Well, we want to talk about it because sometimes the less code you write, the harder it is to understand. We're on to our last mini lecture about views, and it's a big one. It's about generic views. It's a really big lecture so that we end up with little tiny views with one line of code. So I've been building up views, and we've talked about inheritance with the templates, and now we're going to talk about inheritance and views. And we've been inheriting all along with views. So here we are in the views.py. This whole thing, these particular kinds of views, we define them in views.py, but they're very informed by the content of model.py, which means that views are constructed automatically just looking at the data in the models.py. So it's again sort of the logic of don't repeat yourself. If you have a thing in models.py, you've defined exactly what the fields are, and things like, what the help text is for this field and what the description for the field is, that has nothing to do with the database, but it can inform the views. And so it's just a way for, you'll see how it all fits together nicely, but sometimes when we use these super awesome techniques, we end up with a little tiny bit of code, and it's really important to deeply understand that tiny bit of code, because you can sort of just fade away and not realize what's going on, because this code is so cleverly reusing a ton of other code and pulling stuff in from other places. So if you go all the way back to, we talked about SQL, the four basic operations are put data in a database, get data out of a database, delete that data, or update that data. CRUD, create, read, update, and delete. And we're going to build a bunch of things, whether they're add things or auto things, where we got to insert an auto, update an auto, delete an auto, list all the autos, insert a cat, delete a cat, list all the cats, update a cat, right? And so we have a bunch of user interfaces that we're going to build over and over and over again. And as you build your own projects, you'll probably have 4 or 5 tables and then little CRUD user interfaces for each of the tables. And sometimes you make them a little different and there's pretty stuff on them and they're customized. But surprisingly often, these things just look the same and we end up repeating ourselves, which is something we don't want to do as software developers. So here is a simple CRUD application. It's the cur, create and read. Or no, actually, it's this one here is only read and detail. So we have a list of cats, and then you click on the cat list, and then you see the data for a particular cat, and then a link back to the list. So this is like a detail page. But we're going to do a lot more than that. But this, I just want to show you how these generic views work by keeping things very, very simple. So we're going to talk about a generic view in the list and the detail, which are 2 of several generic views. So this is our GView application, and here's the urls.py. In this GView, it has a list of cats, an individual cat, a list of dogs, an individual dog. And so you see this sort of repetition. And I'm putting so many of these in here because I'm going to show you sort of different approaches to implement them using less and more detail and less and more inheritance. So they're all kind of the same. I give them a name. You know, some have integer primary keys, and away you go. And so here is the cat list. I'm going to start with a template. So we're going to expect in the cat list template that there is a context variable called cat_list, and that is a list of cat objects. And then we are going to iterate through the cat list, however many cats there are, with inside of a list, and generate an li tag, and then create a link URL, and then pull out the name of the cat. So the cat has a name, and the cat has a primary key, and so we are going to generate a link to the cat Sophie, and underneath that link is the link to /cat/12, whatever that number is. And if the cat list is empty, we're going to say there are no cats in the database. Now we've actually got a script that you use to preload all of this data. So there's instructions in the sample code as to how to preload that data. Take a look at the README for it. And so if we're in the detail page, we're going to pass a cat object in, and that has a name, and then we want a link to go back to the cat list. And so again, we're using something from the immediately previous lecture where we're using the URL macro, passing in the name of a view within an application. So this is the GView applications, the cat view, and then that makes for an href, that makes a valid link with the string go back to list to be the thing that does. So we're going to build all this stuff, and that's the basic idea, that template and the HTML, that's how we're going to do it. But we're going to look at how the views work. And again, this is a reminder of the dry principle, the don't repeat yourself principle. Again, sometimes this dry principle gets us in trouble because the idea is that some bit of logic is placed one place and reused as many places as possible, because don't repeat yourself would probably be as well described by calling reuse, 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 reuse. Do it once and then reuse it as many times as possible, so that if you have to fix it and you got a bug in it, you don't have to find the 49 places that you put all this code. And because we do the same thing over and over and over again, cats, dogs, horses, we do it over and over and over again, cars, the idea that you have a list view, a detail view, an edit view, etc., it's a common thing. And really, if you're going to do this stuff, why not make it look consistent and function consistently? If you have one developer build the cat's editing interface and another person develop the dog's editing interface, and they like go off the same, go off in their own way, and they got some groovy design, but it's different, who cares, right? It's inconsistent. So consistent, you still want a beautiful design, but you want the cat's data and the dog's data to make sense with that consistent design. So both of them can have a nice design. So we got templates. The templates expect variables, like the list expects a thing called cat_list or dog_list or whatever, and then the cat detail just has a cat variable in it, and then we call it. So if we just forgot about all the stuff that we're about to learn and we just wrote a view, it would look like this first one, this cat list view here. And so we would inherit from view. We're going to go to the database. We've imported the cat model, cat.objects. This is the way to query all the cat objects and get a list of cat objects and put it in the variable stuff. That's what cat.objects.all does. Now we've done this before like in the shell, but now we're doing it in actual Python code in the views. Like I said, views are where all the stuff happens. So that says make a database call, load all the cat records, turn them into objects, and give me a list of those objects. And then I'm going to pass in the context into the template, the gview/catlist.html, I'm going to pass an entire list. And if you go back and look, there was a little loop in the template that printed out, Sophie, Frankie, and made links underneath them into the detail page. Okay? So this is how we would do it if we were going to not repeat ourselves. Okay? Now, this next way of doing it for the dogs, we're going to do it another way. And so what we're going to do is, it looks like it's more work, but it's more reusable. So the stuff that we're doing here. So what we're doing is, now we have a dog list view, which is just a class, and we're going to create an attribute variable in this object called model. And we're just going to say that this model for this particular one is dog. So the idea now is, in this get method, we take this code right here, and we said cat, make that be generic and have it be driven by this one variable. Okay? Now the tricky part that makes this a little tricky is, sometimes we're just using the model, and then other times we are going to actually turn it into a text string. So if we take a look at this, boop, boop, we have this variable model, and in the get request, self.model is the way refer to the particular instance that we're in, that model variable. And this little meta verbose underscore name title to lowercase. You can figure that out by yourself by going to Stack Overflow eventually. That's how I figured it out. I wanted to get a lowercase version of the model name. So the model's name is a string DOG, which is not the same as the dog model. Okay? And so that just is a way, model name is going to be lowercase dog. But if model is cat, then model name will be lowercase cat in this bit. So I'm trying to make reusable code. So yes, the reusable code looks a little more complex because it's generic. But you'll notice that I'm creating a variable called model name underscore list, because I'm just concatenating it together. So it's model name and is going to be dog underscore list. So that's what's going to happen. I am going to talk to the model and retrieve all the objects. That's okay. I don't have to change it to a string. Self.model is dog.objects.all. So then I'm going to get a list of all the objects and stuff, and I'll put that in the context. And then I'm going to go get myself a template out of the GView folder with the model name underscore list, so that what used to be cat list in here is now dog underscore list. I'm concatenating it together, and I passed the context in. And so then when that happens, then you get a dog list and some list of dogs, and away you go. So what I did is I generalized this code and put it in here, and then I passed in a sense, to the object that was made from the dog list view class, the actual model that I wanted it to operate on. Okay? So I do this to give you a sense of how this works. You can do the exact same thing for horses by doing this. And that is, you import the generic, Django views generic, right here, and you say, I'm going to make a class called horse list views. I'm going to extend not just view, but generic list view. So this is a generic class. You can go look at the Django documentation for this. It's a generic class that does a list view in general. And the rule for the class is you have to add one line here to say which model it functions on. And that's it. And that's because the get code is already in this model. We're extending that model. We're inheriting all this code, not from dog list view, but instead from generic list view. So we took something that was 5 lines, a little more generalized, it's like 8 lines, and now it's 1 line. And so that's how the extension works. But you have to trust, and you have to go read the documentation for list view to know how it is that you inform it as to what model you're supposed to use. So I want to show you a little bit of how this is happening by making one of these list views that's mine. It's not as cool as the real Django list view, just to give you a sense of what's going on behind the scenes in the Django list view. So if you say, so I'm going to make a new class, DJ4E list view, and then I'm going to extend view, and then I'm going to have a get method, and it's going to be all this code. It's looking for a variable called model, and you'll notice that it's not defining model up here because it's intended that this is a class that's going to be reused. So I'm going to say, oh, well, whatever the model is that's been set up here by the class that's being created while we're extending it, go grab that, convert it to a text, get the title of it, and then convert it to lowercase, make that model name. Whatever the model is, retrieve all of its objects and put it into stuff. and then put model name underscore list, you know, in this case car underscore list, and then pass that list into the template, and then render, you know, gview car underscore list context. Okay, so this is not doing anything per se. DJ4E list view is creating a class that I'm going to extend later, and I'm going to extend that 2 lines later. I'm making a car list view that extends DJ4E list view, and the only thing I need to do to get all of this code in here is extend it, and then I do need to add model equals car. So you'll notice that car list view has the exact same syntax as horse list view, right? Horse list view, you basically tell it, the generic list view, tell what model to work on, and then generic list view does it all. And if you look at car list view, it says use this generic list view that I just invented to show you the source code of what it is. That's the source code behind the scenes. Like I said, it's way more complex and sophisticated than what I did. This is the crudest, simplest version of an extendable generic list view. But when it's all said and done, you don't write any of those versions. You literally make a list view and tell it what model it is. You make a cat view and tell it what model it is. And you just reuse the list view over and over and over again. So the fact that I give you 4 different ways to do this, yeah, I think 4 different ways, maybe 5, 4 or 5 different ways to doing this. The real way to do it is one way, but when you look at code like that, you're like, horse list view is an extending generic list view and the model is horse. I'm trusting a lot. And the answer is, yeah, you get used to it. And now the code you have to write is only 2 lines of code. And you have to write the template still, because it's going to call your templates, but it knows the name of the template by looking at that horse, right? It knows, oh, horse, oh yeah, horse underscore detail, right? Or horse underscore list. And so this is the actual detail page that shows you the horse and goes back to the list, etc., etc., etc. And so using these generic views, you can make things really short and really succinct and really simple. So generic views are excellent. They allow us to produce lots of similar pages without repeating ourselves. They keep your code consistent. The repeating yourself, doing the same thing over and over, even if it seems quick to cut, paste, change, cut, paste, change, cut, paste, change. If you really want to build reliable code and code that's thousands and thousands of lines with hundreds of features, you don't want to be able to you don't want to be pasting the same thing over and over. And so less lines of code means fewer mistakes. So this is kind of the end of our talk about views. It's really where we're going to start doing most of the work. The URLs, the models, they sort of don't get the kind of activity. Although we are going to talk upcoming about forms, which touch on views, and they touch on models, and they touch on templates. So forms are one of the things that lets take our user experience and really up it. So we'll see you soon. Hello and welcome to our lecture on forms. There's actually quite a few lectures here because we're going to talk about how forms work in HTML and HTTP, and then we're going to talk about how they work in Django. So forms are the way that we put HTML in browsers that have fill-in-the-blank areas. And so the idea is that you draw some fields and some places for the user to type, and then you have some way of sending the data up to the server. And so we'll take a look at a number of different ways to gather this stuff up and send it to a server. There are 2 basic ways to talk to the server with form data. Everything we've been doing when you do an anchor tag is a GET request, which means you're going to get a document and show it. And you can put parameters on the end of those, like the question mark guess equals 42. You can put that on the end of a URL. But then what we're going to really introduce and talk more about is the notion of posting data. So in forms, you can actually do getting or posting. And so let's take a look at some code here. So this is a little bit of utility code that I'm going to use over and over and over again because the get data and the post data and even the cookie data and stuff come in as dictionaries. They look like dictionaries, key value pairs. And so I just wanted a way to dump the data. I want a little label, I should call that guy label, and then a dictionary. And so I'm just going to retrieve, go through all the items and call HTML escape, so that we just don't end up with HTML cross-site scripting injection. Just print the keys and values out and put some paragraph tags and stuff like that. So it's just a way to dump this out so I can show it to you and not put this code on every one of my slides. So just remember that that's what dump data does. And here is a little form that prints out a form and then retrieves the form. So you'll note the dump data. If there is no data in request.get, it doesn't print anything out. But this ends up producing a form, right? And there's a form tag, there's an input tag. Input is the painting. You know, just put some text out, and then this label, this box here is the input type equals text, name equals guess, size equals 40, and then we put a submit button out. And we can type some stuff in, and we can hit the submit button, type 42 in, and hit submit button. And you will notice that once this submit button is hit, it adds automatically onto the end of the URL that it came from, question mark guess equals 42. And then it sends that back and does another GET request, but this time it does a GET request with question mark equals 42. In comes this. This guess equals 42 is put onto the request.get, and then we dump it out so we get to see the key value pair of guess equals 42. And again, Django's taking care of all that parsing and everything before we get to it. Now, this is pretty much the exact same thing. Later we're going to talk about this CSRF exempt. This is to keep it as simple as possible for now. And all we have to do is tell that we would like to communicate this same form of data, one input field and a submit button. We're going to communicate this from the browser to the server using the post method. And so this is a communication to the browser when the server says, I would like to send this data using the technique of post, not the technique of get. And so, you know, it prints out, we put in the number, we submit it, and so the first thing that you'll notice is there's no key value pairs, and that's because the post actually transports the data to the server in a different way. And it appears in a different key value pair. We can tell whether it's a post or a get, and if it's a get, we get our get parameters in request.get, and if it's a post, we get our post parameters in request.post. And so we still get the same guess keyword equals the number 42, okay? And so that's simply the two ways of transporting it. And this is talking about those two ways, right? The browser has a form, you know, blah, 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 input type equals guess. And the name field, name equals guess, is the field that is going to tell what the key value pair is. So if you're going to put a post, you're going to hit the submit button on a get form, it does a get to wherever it came from, right? And then appends the key value pair to the end. And again, that goes into Django, which parses it and puts it in request.get, etc., etc., etc. And if all you do is you tell it with a method equals post, then it chooses a different way. So the post is going to the same URL, but there are no parameters here. And so there's a series of headers like, you know, what is my preferred language, etc., etc., what I'm using for my browser, the content type is this application URL form encoded, and that's talking about this. Now remember, this is going into the server, so the content type coming out tells if it's an HTML page or a JPEG, but the content type going in tells the browser, tells the server how to parse this. So it leaves a blank line, it's very symmetric with how the server sends us pages back, and then guess equals 42. Now, there's some complexity here, and there's some complexity in that post data, and there is some complexity in the get parameters where if you're sending special characters, there's ways they have to be encoded, but we're going to ignore that for now. Just understand that the reason you don't see the parameters on the post request is the data has been transported as part of the HTTP connection, and it's later on in the connection after all the headers have been sent. So you might say it doesn't matter. Well, it does matter. So there's a couple of simple rules. The post needs to be used when data is going to be created or modified, and we'll see situations where we force this, where you don't want to delete something on a GET request. If you're reading or searching, GET is great. It should never be used to insert, modify, or delete data, anything that's going to change the state of the system. And part of the problem is that web spiders will find GET requests. So you might, if you build a bad application, like a catalog of bearings, for example, and you have a delete that happens to be a GET request, and a web spider grabs your grabs your page and hits all those URLs, you might find that the web spider just wiped out your database. So web spiders do not follow posts because they assume that by following posts they might be changing your data, but by following gets, they're just reading your data, and that's all a web spider really wants to do. Unless, of course, it's doing some kind of automation. So get URLs are supposed to be idempotent. So the idea is if you say blah, 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 guess equals 42, it's supposed to kind of give you back the same page. Now, that's like saying, you know, blah, 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 current calendar. Well, what is the current calendar? It might be, it's not identical, but it is sort of semantically the same thing. So you're supposed to be able to go bookmark a get. You know, you can bookmark a get URL, but not, like you might say, where's my inbox? You know, here's a URL to my inbox in some kind of a system to read my data. And so you can bookmark that and go back to your inbox. It should be a GET request. You shouldn't be bookmarking posters. The other thing is that depending on your browser, your web server software, etc., you may have an upper limit on the GET. Let's just think 2,000 characters. Doesn't mean you should worry about it too much, but just large things, especially when we start uploading files like pictures, then all of a sudden the GET is impossible and you have to use POST. And it also has the advantage that POST doesn't mess up keeps your URLs looking prettier. So next we're just going to do a quick review of the kinds of things that you can do in forms and HTML and different kind of input tags we can show in our HTML. So now we're going to do a real simple run through of the kinds of things that you can do in HTML and forms. This is only the beginning, and there's so many great online resources for how to do forms in HTML. So I've already showed you the basic text field. We'll talk about the password field, radio button, checkbox, select and drop down. And I just got kind of this one HTML page that you can view the source of and borrow. I kind of write this stuff up for me for a quick reference. So we've already talked about the text field, right? So input type equals text, and then the name is the value. The ID, don't get too stuck on the ID. The ID has to do with how you associate the label tag with the field, and so that knows that somehow account and this text box are connected. So the ID is more of a browser thing, and the name equals is the thing that it's going to be sent to the browser. So the browser is always going to get key value pairs. And so, you know, when we type Beth and we hit submit, then we're going to get the incoming post data is going to have the value account equals Beth. Now, if you look at password, that's a type. Password, for all intents and purposes, is a text type. And it shows it so people can't shoulder surf and see what it is. Of course, they can watch you type your password, but it shows asterisks in the box while you're typing. But then it's important to realize that once the data is submitted, the data is submitted in plain text. And so here's another one, another nickname. So nick equals NICK. So that's basically the variance of the input types of text. Hidden, type equals hidden is another one where you just don't see it in the user interface. We're going to use one of those input type equals hidden in a bit. A radio button is designed for situations where you can only pick one of two things. So when you hit AM, the PM goes off. When you hit PM, the AM goes off. And you can actually have a whole bunch of them, and you can click them. Now they're drawn together because they're type equals radio, and then the name is identical. And interestingly, you can scatter these literally all over the page. It doesn't lead to very good user interface, but away you go. And so what happens is again, no matter how many of these you put with a name equals when, no matter where you put them on the page, if you click one, all the others are going to turn off. And so the one that's clicked, they all have different values. And so what will happen is whatever one is clicked at the moment that you actually send it, that will be the key value pair, where when equals PM, because only one can be selected, and it's up to you to make these things unique. Or maybe you don't want them unique. You do whatever you want. And so in this case, the PM one is selected, so we see when equals PM in the incoming post data. So that's a radio button. So this is a checkbox. This is probably more useful in many ways. Checkboxes, you can have as many that you want, and each of them are individual and distinct. So if you take a look, for example, you see that you have different names, class 1, class 2, and class 3. right? So that each checkbox has its own name, but the checkboxes are actually just little checkboxes. The text here is just text. The text is not really a critical part of it. The value is what will get sent if that checkbox is checked. And so in this example, we've checked Pi free and SI 539, and you'll notice that two of them have values and one of them doesn't. Now the key is often you're just checking to see if the data is there. In this case, class 3 is not in the post data, and class 1 is on. That's the default. If you don't say value equals, it's like value equals on, or whatever the value is that you put in that checkbox. And so you get to decide these. You might easily think that you don't need any values whatsoever because you're really looking for the name of the field, and you want the name of the field to be distinct. And so again, you can check as many of the checkboxes as you want. You can uncheck them, you can check none of them, and you can check all of them. So those are checkboxes. So to describe a drop-down is a multiple choice option basically for a single value that's going to be sent back to you. And so we have a select, which is the whole thing, and that gives the name, the keyword that it's going to be sent back to. And then we have a series of options, and you'll notice there's no value on the select, but each option has its own value, right? So I happen to be going 0, 1, 2, and these are strings, not numbers. They often are just numbers to make our lives simple. And then you have some text, etc., etc., etc. And so you pick one. In this case, I leave it default, and I hit the submit. So soda is going to be equal to 0. So this happened to be the one that's selected when we hit submit. Okay? So that's what a select looks like. You can also make a select that has some defaulted one, and so you just put selected on one of them. So that means it's the drop down. They're all there, right? They're all there. If you click on this thing, you'll see, if you click on which snack, you're going to see all the different snacks. Peanuts is pre-selected. And if I don't change it and hit submit, then we're going to see snack equals the value, which is peanuts. So that's an example that you don't have to make numbers, although it's really common to be using numbers. So that's a drop down with a default other than the first item. The default is it's the first item unless you do it otherwise. When you're typing in comments or a blog post, a big long blob of text, you use a text area tag. The text area tag is a little bit different in that it doesn't have a value equals. It does have a name equals. It has rows and columns to tell how tall it is and how wide it is. There are clever styling libraries that make these a little prettier. But basically what it is, it's a series of text, including paragraphs, including new lines, etc. And you're just allowed to type with new lines and edit and cursor around in here and build all kind of stuff. And then you send it in, and you can put default text in here. You can edit the text, you can change it, and it comes in as a key value pair with new lines and everything and any weird spacing that you might put in. But it's basically a block of text like a comment or like a comment or a blog post or something like that. So the last thing on this page here is the submit button. And so you can make a type equals submit, and you can give it a name, and again that's a key value pair and a value. Now the submit is a little bit weird in that the value actually appears on the submit. What we tend to do is this submit, and if you're in a multi-language environment, you're going to want that to be whatever language of the user. So usually what we do is I carefully name the variables, or the name of the form, and then I check for this to exist. And if I have a bunch of buttons, I name them differently and don't really actually look at this text because that text might want to be translated at some point in time. So that's an input type. Input type equals button. This is a little pattern where I'm going to do like an escape or a back or something like that. And then sometimes it's easier just to do a little JavaScript. And what this little JavaScript chunk is, location.href equals quote www.djfree.com return false. What this says is it actually sort of, when you press this escape button, it goes up in the browser and in effect pastes this little URL into the URL bar and then hits enter, and return false keeps the form from being submitted. And so this is a way that I often will put a simple cancel or escape or something else in a form. Just if I know the URL I want to go back to or go to, then you can put it in here and on-click location.href. So those are the input types that have been around for probably 20 years. Yeah, at least 20, 25 years. HTML5 is a more recent phenomenon, although by now it's pretty well supported in most browsers. Defined a whole new set of input types. And what's nice about this is we were slowly but surely building complex libraries to solve all these problems. But now we can use these input types, and now each browser can support them to their own way. And they all fall back to type equals text. And so if you have a really old browser, these don't cause trouble. So here's just some samples of some things. So type equals color is a color picker, and that's going to pop up a color picker, let you cruise around. That color picker is defined by the browser and usually the operating system, and so you'll pick a color, and then that color is going to go in hex format, and that's the red, the green, and the blue, and so that's what colors look like. You can have type equals date, and so here's a date, and they pop in here. You're going to pop up a date picker for the birthday. You'll pop up a date picker, and you'll be able to kind of move around and pick a date, and then that'll put that date in as a string. They're all going to turn into strings when they're being sent in. A couple of the other ones, like email, name equals email, that basically does validation that says it's got to have an @ sign. There's some rules about what is and isn't a valid email, and so this will refuse to submit this form unless there's a valid email in there. The same is true for number. If you put something that's like 25 and it's not between 1 and 5 with min and max here, we're going to refuse to submit the form. The same is true for a type equals URL. It's really a validation on the form to say, look, you can't put something in here that's not a valid URL. And just to prove that it doesn't matter, if you make any type, which flying doesn't exist, you can type something in and it just functions as a text field. And so in a way, all these fall back to text fields. Now the key thing is when you hit the submit button, normally that gathers up the form and sends it to the server. But when you use this HTML5 validation like date, number, email, URL, it actually will, before you hit the submit button, before it actually sends it, it's going to do a quick validation on these things. And it will actually stop and say, you know what, you didn't get that one right. And it just refuses to submit. So you can't override that in your application. What happens is the data doesn't get submitted at all so the browser blocks the submission of the data. Now, if it's not an HTML5 browser, it's going to get submitted with no validation whatsoever. So we still have to kind of check this data for sanity, which we'll talk about soon about how to do that in the server. But this is quite nice because it gives your user some immediate feedback, kind of customized to the browser, so the browser takes some responsibility for helping get the user to type the right stuff in. And so that is a romp through HTML forms. You will learn so much more. I just wanted to kind of cover some of them in case you hadn't seen it in a while. Now that we've talked about forms a bit, I want to talk a little bit about security in forms. I want to talk about a security issue called cross-site request forgery, or CSRF. So the idea of a CSRF attack is that a rogue site, it has to do with cookies and how cookies get sent to sites. So let's say you're logged into my site, and a rogue site generates a page that's going to post. And on every form you can post to a site other than the one it came from. And so if I can get data that I want to send to the legitimate server, the rogue site can set up a post, and then if I can convince you to hit the button, then it will grab the cookie and send it to the legitimate server that you're already logged into and perhaps do something dangerous. And so the rogue server doesn't need to know the cookie. The rogue server just needs to convince you to click on a rogue form to send to the request server. So the defense for CSRF is don't be confused with session. It is going to use session. We're going to grab another large random number, and we're going to call it the CSRF token, and we're going to stick that in the session. And then what we do is every time we send a form out that's coming from our server, we add a little input hidden tag that has this CSRF token. And then when the post comes in, we check the CSRF token that's coming in the post data, and then we check it against the one that's in the session, and then rejects it if it doesn't match. So here's a picture of how this works, right? So we'll have a legitimate server, right? We're going to produce a page by the legitimate server, and it's going to post back to this same server. The action is the URL to send the post data to, and we got some key value pairs and a submit button, right? So you hit the submit button and it's going to come back to the server. Now, one of the things that the browser is supposed to do is pull the cookies for that server and send it. So it sends it both a post and the data, but it also sends the session ID cookie. And then what happens is that the Django gets its hands on it. It looks up the session ID, pulls it in, and notices that it's C7 and I've been logged as an instructor, and then I can actually change this grade and set the grade, and it works. Okay? Now, here is what happens when you get to a CSRF attack. So somehow a page gets sent to the server, right? Sent from a rogue server, and it just has this form. Method equals post, action equals DJ. It's not the action, it's going to a different place. And it puts sort of a new grade and then a submit. So what happens is this submit comes in, and the browser dutifully appends the cookie to it, and it sends it. Now, you had to be tricked into getting to this page and sometimes tricked into submitting the page. But once the post comes in, it has legit cookie in it. The cookie is used to look up the session and reassociate it, and we can check in the session that the user is indeed logged in, and we'll let the thing set the grade to 1.0. So this would be a way, if you could convince a logged in instructor to run a post form that you created, you could basically change your grades. So that's how it works. That's how a CSRF attack. You have to be tricked twice first, but there's ways in JavaScript to make it so it's hardly noticeable that you get tricked. So if you do this with CSRF, the legit server basically adds another value, not the session ID, but another value in the session, which is a large randomly chosen number. And then when a page comes out, it's a legit page, and it uses a type hidden variable and puts the CSRF value in. Now you hit the submit button, and the CSRF is coming in as post data. Your regular data, the grade data is coming in, and the browser dutifully appends the session. And so then using the session cookie, it reassociates the session, says, yep, you're C7, you're the instructor, and the CSRF works, CSRF matches, so let's go ahead and let you set the grade. So we let them in. With the attack blocked, because the rogue server can generate a page, but it doesn't know what the CSRF is. So it could, who knows what the CSRF is, so it generates it. Maybe it can put a CSRF, but it doesn't know it. So then the post happens and all the data gets gathered up, and so it sends the CSRF, but it's not the right CSRF. The session ID is sent in, and so the session is pulled in. We know it's user C7, we know it's instructor, but we're going to check to see if the CSRF matches, and then it blows up. And so then you just refuse the post, probably log the user out, and then log some kind of a security error. So the idea is by having this little CSRF number in the session, we can then take care of that. So like most things, Django comes out of the box with CSRF protection built in. Just like the session, we've got CSRF middleware just dropped in, and actually it works automatically. You don't even have to ask for it to work. Once you have a session, it starts putting out CSRF things. So up next, we'll talk about, now that we know the concept of CSRF, we'll talk about how we're going to use CSRF inside of forms to implement sort of CSRF protection.
So now that we've introduced CSRF conceptually, let's talk about how we actually implement it running in Django. So if you remember, I didn't really point this out too much when we went through it. This was my first form where I showed you how data could be transported to the server using a post request. If you look at the top, I have this little annotation.
at CSRF_exempt, and there's a little import above it in the views file. And what I was basically telling Django is don't blow this up because I'm not handling CSRF properly. So what we're going to do is we're going to do the exact same view, except we're just not going to have that little thing. And so we'll call this one fail form. And we're going to throw out a form. We're going to press submit. Everything looks fine. The only difference is I did not turn off CSRF processing. So on a post request, CSRF processing is on by default, which means that we have to do something explicitly when we're making post forms. But I didn't do it yet. So this is what happens if you don't do it. So you get a form and you press type some stuff in and you hit submit query, and boom, you get this forbidden message. That's a 403. So among all the HTTP responses, we've got 200, which is okay. We've got 302, which is moved, and we got 404, which is not found. 403 is you're not getting this page, but not because I don't have it, but because you're not authorized to do it. So this is it aborting and stopping the post. So it comes in, it looked up the session, and everything looked good except the CSRF did not match. Now, we are a legit server, so what we've got to do is we've got to actually add the CSRF to the post on the way out. Okay, so this is the exact same post, and I'm doing this kind of at a low level, and we'll show you a much easier way to do it in a minute. So we have an input hidden. I just happen to know that CSRF middleware token is the proper name for it, and I'm just going to have a placeholder which is __ token. And so then what I'm going to do is I'm going to talk to that middleware CSRF get token. Now that token is probably just a number sitting in the session, but I don't need to know that. I just say, hey, give me the token for the current request. The request is, of course, all that data that's coming in. It's got the sessions, got everything else in it. So, hey, give me that token. This is a big, long string, which is really just a big, long random number, a big, long random string. And then what I'm going to do is take whatever that big, long random number is, and I'm going to replace this little bit with a stir, a simple replace, and then I'm going to send that out. So this time, when we go to that page, you'll see that now we have an input type equals hidden, name equals CSRF middleware token, and then the big long middleware token, whatever that is. And then now when we submit it, it bundles up both the guess and the middleware token, and it actually bundles up the submit as well if it's got a name, and sends that in as post data. So now when it dumps out, you see, oh, well, you got guess equals 42 and CSRF middleware. Now, by the time it's got to this point, we're not really doing the checking here. The checking was done before the view started. And so if we go back to the view here, the checking is done before it gets to here. When you're dispatching from a urls.py to this, and it says, you didn't tell me not to do CSRF, and it's not done properly, so I'm going to blow you up. So if it's going to work, it's already worked. The fact that we've come in here and we're dumping this stuff out of the post, that's just sort of like we see it, but it would have blown up before it would have even got to our code at that point. But we do get it and see it as post data. We don't need to, because if by the very fact that our view is running means that the CSRF processing has been successful. Okay? And again, the rogue system has to somehow get its hands on this, the actual number of the CSRF, and that changes every time you log in, and literally it could change every hour or so or whatever. And so it's a hard number to guess, and it's a hard number to get your hands on. Now, that manual thing is not the easiest way to put this in. There's an easy way in CSRF. You simply say, so here's our form, here's our / form. I do all the stuff I want to do that I want to do, and then I use the code. This is called a template tag. When you have CSRF enabled in your Python, you have a template tag of CSRF _token. And that emits the input, the type equals hidden, the right name, and all that stuff. So you, as the developer using templates, you don't have to know anything about that. Okay? And so that's how we do CSRF. And the only other thing we got is guessing game, and then we're going to pass a message into that, and we're going to do that in a bit. We're going to use this for a whole bunch of little examples. So kind of remember this particular guess.html template. But the key right now that we're talking about is the fact that we've got this CSRF token in. Now, I'm going to write a bunch of guessing games, and these guessing games I'm actually going to start checking the guesses. So I'm going to have a function in this view that's called check guess, and it's pretty simple. It returns a string or false, If the guess is an actual non-false thing, we check to see if it's too low, too high, or right on time. Or if it doesn't compute, if it doesn't convert, if this int guess throws a trace back, well, then we'll say bad format equals guess, and then just because it probably came from the user, we're going to escape it and then send that back. So whatever it does, we're going to send back a nice little message going back. And so here is a simple guessing game that we're going to do. And so if you, and so we're using a view-based view, a class-based view this time. Of course, we extend the class view. And remember how it works is it's not just a function. We actually have two methods. One is a get request, and the get is called when we're receiving a get request, and the post is called when we're receiving a post request. This alone is one of the nice reasons to do this. You don't actually have to say, if it's a get do one thing, if it's a post do another thing. We just have two methods, and Django properly routes the requests in. Okay, and so this is going to be a form post. So on a get, we just render with no messages. We render with no messages. And we have a CSRF token that goes out, so we just render it. Then we'll click the button so that this render right here will produce this page. Then we type in the guess of 42 and we hit submit query, and then that bundles it all up, including CSRF, and goes to the post. Now the CSRF, as long as we put it in that template, we don't care, because before that post method gets activated, CSRF has been processed, and we get a 403 if the CSRF isn't right. So if we go back up here, and you don't put this in, and you run this code, this CSRF token, you don't put it in, then when you hit it's never going to make it to the post. I mean, it blows up en route to the post if the CSRF doesn't happen. But we've got CSRF, and it's all automatic. We just throw that one line inside of our form, and that's all we've got to do. So we put 42 in, we hit submit query, passes CSRF, it comes in. So we grab the post data, the guess from the post data. We call my little check message, check guess. That's going to give me that little message, whether it's too low, too high, or some kind of other mistake. And then I'm going to pass in a context. The string message has that string. And if then we go, do I have it down here? No, I have it up here. So then the message comes out. So this, you'll notice I've surrounded this by an if, so that if message is false or not present, then it doesn't put anything out. But if it is, it actually puts the message out. And so out comes the guess. And so this is what it looks like when we do a get request, right? We see this. Then we're going to see all this, stuff. We're going to type our number in. We're going to hit submit query, and then it's going to fire up a post request. And so then it's going to come back into the post request. It's going to get the guess from the post data. It's going to check it, and then it's going to pass the message in. And so the message is going to come out here, and then we're going to return that page. And so you're going to see something like, congratulations, 42. So that was part of the post. And so we now have made a successful guessing game. So next we're going to talk about, just when we get something working, there's always something that we have to say, oh, but there's a little detail that we forgot about. So up next, we'll talk about post and refresh, which is a little problem that we're just going to have to fix. So these forms are kind of complicated. There's a lot of little details. Once we get them, then we'll be able to knock out forms and just do form after form after form. So I call this little section post refresh oops. So remember this little page not so long ago where I'm like, look, it's great. We did CSRF and we checked it and it worked great and we put the CSRF token in and it's all good. Well, it turns out from the heights of success is the depths of failure. But it's not too bad, not too hard to fix it. So we just got to fix it. So the problem is if the browser sends a post request and it gets back a 200 in a page of HTML, which is exactly what we just did, and then you hit the refresh button on your browser, the browser is going to resend the post request. And if you go back, I said post requests are things that change. So for example, if you are transferring money from your account to someone else's and you hit the transfer button, it's a post. And money gets transferred, and then transfer successful. And then if you hit refresh, you're going to post it again. And so the refresh basically reruns the entire previous transaction. It doesn't just grab the page, it sends the post data again. So if you transferred $100 in one post and you hit refresh, you're going to transfer $100 again. So what happens is that because the browsers know that posts are potentially dangerous to the server, the user will get a pop-up, not from you, but from the browser to say, hey, this person who built this server application left you sitting on a post and you hit refresh and I'm going to about post it again. So are you sure you really want to do that? And the problem is the user doesn't even know what a post is, barely knows what's a refresh, and it looks like a mess. So the way to do this is you go to the page, you type in 42, you hit submit query and it'll say congratulations. And you look at it and then you press the refresh button, the refresh button, the reload button. And you press the reload button and it says, to display this page, Firefox must send information that will repeat an action such as a search order confirmation that was performed earlier or a money transfer. That is not a message from your application. That is literally because your application was a little sloppy and Firefox is like, I'm really not sure if we should do this, so I'm going to ask the user. But it doesn't exactly know what to ask the user. It doesn't know what you just did. And so it's a yucky message. And what we want to do as programmers is avoid this. We want all the message, all the user experience coming from us, not having the browsers take over some of these things. And so it's just bad practice in general to send a 200 post, to take a post request and then send a 200 with an HTML page back. Okay? And so it's just ugly. The browser asks, it's out of your control, it's ugly, it's bad usability. So we can do a little bit of work to make this never happen. And so that's what we want to do here. So the way we do this is through what we call post, redirect, refresh. So up next, we're going to show how we're going to fix all this using a post, redirect, get, refresh. These titles keep getting longer and longer. Hello and welcome to my lecture on cookies and sessions. So taking a look at sort of how all this stuff works out, we're again in our application. And so there's two distinct topics that we're going to cover, and it's really important to keep them clear. So there's cookies, which are a browser concept, and then there are sessions, which are a server concept. When we write Python code in like our views.py, we talk to the session. Cookies are essential to sessions. Cookies are used to look up which among the sessions that we're going to use. So what we're going to do is I'm going to first talk about really just the cookies, how cookies talk, how the servers talk to the cookies, and then separately we'll talk about sessions. So keep the two concepts the same. A lot of people tend to confuse the concept of sessions and cookies because one of the most common use of cookies is to establish and maintain sessions. So the first thing about the web in general is that you have a web server, and when you're just developing, you think there's only one person, which is you talking to the web server. But in reality, when a web server is in production connected to the internet, there could be 1,000 connections to 1,000 different browsers. And it's essential that the server can figure out at any moment which browser it is talking to. We don't maintain a permanent connection to these browsers. That's one of the reasons that the internet scales as high as it does, right? So we still have to have some way of distinguishing when a request comes in from this server versus when it comes in from that server. And so what we want to do is we want a way to basically put a little mark on each browser and say, oh, that's this browser. And so when you log in from this browser, I can know that it's you. So marking the browser is different from saying I have browser 41, 42, 43, 44, and each browser ends up with a mark. In the early days, the web was pretty much a read-only medium. We didn't do a lot of logging in. We didn't do a lot of uploading. There were password mechanisms, but they were very, very clunky. And so all the browsers were pretty much reading the same information, and as long as you're not logging in and modifying stuff, it just doesn't matter. So quickly, in the early days of the web, the idea of a cookie was created, and that was a way for the server to store a little bit of data on each of the browsers. And they're just little pieces of data written by the servers, read by the server, sent by the browsers, and read by the servers. Now, it has nothing to do with logging in. It has to do with writing a little mark on every browser and then getting that browser mark back every time we ask it. So often when a server gets a first request from a web page that doesn't have its little mark on it, it makes up a number and sends that cookie back. So it sets the cookie that there may be many interactions between the time you're starting to talk to a server and when you log in. But often the cookie is set immediately. But the key is that once I set that cookie, it's like storage for my server on your browser, and each of the servers and that can be sort of temporary or permanent storage. So they're marked in the browser by the web addresses they came from. It's a security thing. You're not allowed to read cookies from a page. If your page comes from a particular server, it can only read the cookies associated with that server, and vice versa. So they're like a little stovepiped. Cookies have an expiration date. There is two kinds of expiration dates. There's sort of by a certain time or a number of seconds, or there is stay logged in or keep this cookie until the browser is shut down. We call those session cookies, which is kind of weird because we often use them. We often use session cookies for sessions, but we still got to keep them session cookies. So here's a bit of sample code. So one of the things you can do is you can go into your browser console and you find something like storage, and you can see for the website of the current page, the current website that you're on, that website's cookies are stored here. And so I'm looking at the cookies here, and I see there's only one cookie, this CFDUID. This server is using a proxy to help speed itself up, and so that cookie's not really part of our application. And so what happens is there is no cookie, it's not set, and so we go in and click on this if you give a browser a cookie. And it's going to route to this particular view, and so in this we're going to do a print of request.cookies. So what happens is I mentioned that every time a web request comes in, all the cookies get sent in with that web request that are associated with that server. So we're going to print them out, and they come in just like request.get, request.post, and request.cookies is Django's way of handing us all that information. And so in this case, I'm not actually going to send the response back in the return value. I'm actually going to create the response. That's RESP HTTP response with a string. And then I'm going to set some cookies. So cookies are part of the response. They're actually part of the headers of the response. And I'm going to just set one cookie. They're my names. I set them. This application, cookie named Zap to 42, and then a cookie named Sakai Car with a value of 42, and I give it 1,000 seconds. So that's one is a session cookie, and the other is a cookie with a fixed expiration date. Now this 1,000 seconds, you can go much longer than 1,000 seconds. If you start looking at the cookies that you're talking to on the various things, these are year-long, multi-year cookies, et cetera, et cetera, et cetera. And so if you were to see the printout that is coming from that request.cookies, you would see that it's basically a dictionary of key value pairs. Now that's after the second response. So if we go and we click on the cookie and we start with no cookies whatsoever, we're going to send this code out, and it's going to send two cookies back. And so what you can see here is, you can see if you look closely, on the response headers, two set cookie responses. So the response headers are like the content type, et cetera, et cetera, et cetera. They're not the actual page. The actual page is C is for cookie, and it's good enough for me. But basically, when this response came back, the server said, hey, set this key value pair and this key value pair, and have this second one expire, which is exactly what I did inside that code. And so now if we take a quick look, and we take a look in our storage, what we're going to see is that we now have two values. Sakai Car is 42, Zap is also 42. Sakai Car is going to expire a certain amount of time in the future, and Zap is a session cookie because we gave it with no expiration, which means once I want to close all the tabs in my browser and close the browser, then the browser will throw this away. The Sakai Car will be persisted to disk or some other place, so that if I close all my browsers and open browsers up and go back to this website, samplesdj4e.com, it'll start sending that cookie. So that's a permanent cookie with an expiration date on it. Now that's pretty short expiration. 1,000 seconds is like, what, 20 minutes, I think, and so that's going to go away. But a lot of these cookies last much longer. So that's after the set cookie comes back from the server. Then we can take a look and we can see as we make another request, we're going to see that the browser is going to look up the cookies, and we have this one here that's part of the hosting environment, but zap equals 42 Sakai car. So now in goes a GET request, and as part of the request headers, it's telling us all the cookie values for samples.dj for e.com. And then when I look in my code and I say request.cookies, request.cookies contains the parsed versions of zap42 and Sakai car 42. So I'm going to end up with a dictionary with two values in it, and zap and Sakai car. And so the way to think about this is when the browser first comes into the server, it looks for the cookie. It might say, do I have this cookie already set? Now my application that I wrote is real simple. And then you are going to send the cookie back, and then the browser stores the cookie inside the browser. And then from that point forward, every time it makes a request, that comes in, and we can see this in the variable request.cookies inside it. So we really only have to set it once, although the code I wrote sets it every time, but it doesn't matter. Until it expires or until the browser closes, the job of the browser is to send that cookie back. Okay? So remember what I said? I said we're going to mark each browser with a different number so we can know which browser is which. That's exactly what it is. Now it doesn't always set it to 42. Usually it chooses a large random number, but we'll get to that in a second. So up next, we're going to make some sense of this by adding the back end part of this, which is the sessions, which stores all the data from request to request. So now we talked about cookies and how the server can set cookies in the browser and how the browser has to give it back. Now we're going to actually do something useful with it, and that is we're going to build sessions. And sessions is a place on the server where we record things like this user, such and so of user has logged in. So let's take a look at this. So inside the server, there is some code that we've enabled in Django called session middleware. And what it basically does is it kind of grabs every incoming request right before it comes in to urls.py, and it sort of injects itself before urls.py runs. And what it does is it uses the particular cookie value, maybe 3e, comes in as a cookie, and then it actually grabs the particular session and associates it with our request. And so by the time you're coming into one of your urls.py, one of your views from urls.py, what you find is the cookies have all been set, the session has been set up, it's made a session if necessary, it's looked up an old session if necessary, and so there's a whole bunch of sessions, and these sessions are stored in the database or on files or other kind of places, and there is pretty much one session object for each distinct browser that's out there, and we look them up by knowing what the cookie value was that we set it. And so one of the things the session middleware does is if it doesn't see a cookie coming in, it actually oh, well, I'll pick a large random number and then I'll send the cookie back. I will create a new session and I'll send the cookie back, and then I'll be able to look that session up on all of the future requests. So usually we just go ahead and start sessions when we meet a new browser. It's simpler. I mean, you can sort of sometimes delay it to save a little bit of resources, but often for most applications, right away you start using sessions, and then later you've logged a person in. You are going to mark each browser with some unique random number, and then when that cookie's sent back to us, then we can reassociate the session with the incoming request. So Django middleware handles the creation, deletion, the inserting of data, the deleting of data, and the updating of data in these sessions. The session identifier is a large random number that we put in a browser cookie first time we meet a browser, and then we store using that same number a bit of data on the server, and then later when that cookie comes back in on an upcoming request, we basically look up the session data and then reassociate it with the request before we go through urls.py and into our views. So we have to enable this, and if you used manage or Django admin to create your project, this is already there. You can go ahead and look in your settings.py and you'll see that it's there. And you'll also notice that by now you've probably done a bunch of make migrations and migrates, and you see it making a session table. So there's all kind of defaults that are set up so that most of your first Django applications are set up to A, support sessions, and B, store sessions in the database, which is a fine way to go for small to medium-sized sites. So like I said, they're going to be stored in the database. You do this migration and you see that it's creating a sessions table for you in your SQLite db.sqlite 3 database. So here we go. We have, as I said, out there, we've met these browsers. We've made a session object in our database, and we've put a cookie in each one. So there's some kind of a cookie that they're all named the same. So we'll name these cookies sesh ID or something. And so, but we've picked random numbers and we've marked them. And so what happens is that a browser comes in, a browser sends a request in, and they send their cookie along with it. The Django middleware looks among all the sessions and then connects it up, and then it does the request. So there's many browsers, each with a different number, and then there's many sessions, each with a different number. And part of connecting is creating it. Now, if we look at this from the point of view of one browser and one session object, one session storage area, at some point we come in and it reassociates the session, and we're doing some work and we're writing some stuff into the session, and then we respond. We go to another request. We can read what we wrote. So we write stuff into the session, we can read it from another one. And then here we can read that same information. And then here we get a post, we read a bunch of information, but we write some more information. And so you can kind of think ultimately, just sort of at some level, relax about all the detail and realize that this session is a variable that lasts across many request response cycles. The cookie variable sort of also lasts across many request response cycles. The get and the post data, they vanish. So the get data for each one, you use it and you consume it or you store in a database, but the get data from one request is not available on the next request. So we have to use things like sessions sometimes to store little bits of information so that in a later request we can get it back. So the request object has this little attribute called request session, which is basically a dictionary. We can put keys in it, we can delete those keys, we can update those keys, we can call .get and retrieve a key to see if it's there, etc., etc. And so in a sense, we just take request.session and treat it as a magical dictionary. Now, we have to remember that each browser has its own dictionary, but when we're in a view function, we're only dealing with one browser, and so that session is the one associated with that browser. So it's this persistent interface, persistent data that lasts across all these things. So here's a real tiny view function, and you can see in this view function what we're going to do is request.session. This is where request.session is where you see the session data. It's basically a dictionary, so we can say .get. Then we have a key, and we have 0 as the default, num visits is the key, 0 is the default value, and then we're going to get that and add 1 to it, and then store that. And this is kind of like how we do counting. If we get it, if it was 4 before, we're going to go to +1 and get to 5. If it's not there, we just set it to 0, so we set it to 1. So somehow num visits is either 1 or 1 more than what was previously there. And so then what we see is we see the line that actually just stores it back into the session. That's it. It's a dictionary. It's a magic dictionary. It existed before it came in, and we're just going to leave it there, and somehow magic things take care of updating all this stuff. And so the other thing that we're going to do is we're going to have this go up by 1, and if it gets over, we're going over 4, then we're going to wipe it out. So this will count 1, 2, 3, 4, 1, 2, 3, 4. And well, actually, yeah, 1, 2, 3, 4, 1, 2, 3, 4. And so this del is just the standard Python syntax to remove a entry from a dictionary, and then we just kind of print out the number of visits in our little string and our response. And so if we go, we start, we have no cookie. That means that we also then have no session. And then we go into the session code, and you see that it has set a session cookie. right? So we see a session cookie called sesh ID. It's got an expiration date, which is it's not a expire when the browser goes away session, and it's got some big long random number, and so that is basically the session ID until we get a new session. And as a side effect of that, we've also stored the value 1 inside the session in the server and printed it out. So we came in, we established a session. We didn't do any of that, right? If we look at our view here, we didn't establish the session. All we did is grab something out of it, and that's because the establishment of the session happens in the middleware that's kind of outside of us. And so the middleware happens before our code starts and after our code is done. And so the session stuff is just taken care of when we do that. So view count is 1. And then what happens is when we just hit refresh, it's going to send the cookie in for that session ID. It's going to load up the session that's GJ2233, and then our code is going to add 1 to that number and store it back into the session, and then it's going to be 2. And if we kept refresh, it would say 3, 4, then it would do a reset and be 1. And so in this code, we just kind of say request.session and put stuff in it and read stuff out of it. And the cookie is the thing that looks that up. Now, if we wanted to take a look at what's in the session table, it's really just a session, and you can see that it gets created by your migrate and your make migrations. So we can go right into the database. We can ask for the tables. We can see the Django underscore session, and then we can say select star from Django underscore session. And so that will show us the data that's there. And so what we're going to see is the key, which is that session key, and then a time, and that's used to expire the session because these sessions don't last forever. The Django middleware kind of cleans these up after a while. Otherwise, you'd have sessions that just lasted forever and ever and ever. And then the actual data is this big long string. So what this is this is actually an encoded string. And if you really want to look at it, it's encoded using a technique called base64. And there's a base64 parsing library. Base64 is a way of taking arbitrary data and encoding it in basically letters and numbers, upper and lower case. It's a little less dense. I mean, it kind of expands. It's not like a compression. It's the opposite of compression. It expands it, but it expands the data when it's encoded into base64, but it also means that then you can store it. You don't have to worry about any special characters, because sometimes when you're going like pasting, single quotes and double quotes mess up, all that kind of stuff. By saying, here's this string, I'm going to encode it in base64, I basically am guaranteed that there will be no weird characters that will cause some kind of problem farther on down the line. So if we take a look at our thing and we grab the little thing that's the base64 encoded variable, if you decode this, we're going to base64 decode it, you see that ultimately it's just kind of like a little key value pair that looks pretty much like a dictionary. It's a serialized version of a dictionary. It's a dictionary that has been put into a serialized form. And it's in also JSON format, and so we can actually sort of tear this apart and use the JSON library to load it up and see what we've got. So that's there. You don't have to worry too much about that. It's just somehow this big long thing is being read and written and read and written on every request response cycle. That is certainly read on every request response cycle, and it's written when you modify the data in the session. So this has been a quick set of lectures. We talked about cookies, a way of marking each browser with a big random number, and then sessions, which are a bit of data that's stored in a database indexed by that large random number. And then each request comes in, we get the cookie back, and then we look up the session. The data, session data, key value pairs, basically a dictionary, is all stored in there. And so we talked a little bit about how we do request.session in Django to implement, to access session capabilities in our Django applications. Hello and welcome to our lecture on data modeling. We're going to have a couple lectures on data modeling. This first one is sort of the one-to-many, which is the easiest to understand, and then we'll have another lecture on many-to-many, just to give you sort of we're still sort of building a Django application one piece at a time, and we haven't built a whole Django application. But basically, we're really focused on model.py and a little bit more on admin to inform. So model.py is where we define the structure of our database, and we see this database through data models, data model objects, and we can register our data models in admin.py. There's not too much in this admin.py. But we really, and so we're going to be talking to things like the shell, or you can even run scripts in here. So the whole thing in this lecture, we're not talking much about the routing or the views or forms or templates. So we're really focused down in this area of our Django application. And it's okay, we'll get to the rest of them. And we're just kind of talking about the data modeling now. So I came to databases late in life. I saw them a little bit in grad school, which is a very long time ago, and I didn't like relational databases much. And I went to a job, and I had to learn relational databases for the job. And luckily, I actually was pretty advanced programmer at that point in time. And so they taught me how to do data model design, and I picked it up really fast, and I totally fell in love with databases. And so model design is a interesting problem to solve. The basic idea really comes down to efficiency of storing and retrieving data. And it just comes down to, like, if you build an online application like Facebook, and if you're not clever about how to store your data, and somehow every time you logged into Facebook you had to read all of Facebook's data to find you log in, it would really literally take you 2,000 to 3,000 hours to log into Facebook if it had to read all of its data. Now obviously millions of people log in per second in Facebook, and so obviously they're a little faster than that. So somewhere between, days and days and days to read the data, and can read the data a million times a second, in there is where databases win. And so at times it seems like when we're building a data model, you're like, oh, this is so difficult, why are we working so hard? And the answer is you just can't scale. I mean, you can read through your data for simple data mining things, but databases are really important. And especially when you're building interactive online applications, speed's important. So it turns out that, like most things in database, you can learn the basics pretty quick, and the rest of it is sort of an art form that you learn as you go. And so the goal is to figure out the data that you want to store in your application, and then draw a picture spreading that data across multiple tables and then creating links between those tables. So you kind of start with a sample data set. Now this is where we're going to end up, and this is the model for the data for this local library application that we're building, and this is the thing we're going to keep coming back to over and over. So this is the destination, but we're not going to hit this destination. We're going to start more with the data. Now different applications, when you work at different organizations, you're going to find that the data model is very important. So this is the data model of my auto grader, which is based on a framework I built called Sugi. And so if you were to learn this thing, early on I say, oh, and here's our data model, and here's how we store stuff, and here's this, that, and the other thing. And this data model took a lot of time to get right, and it's a real important part of the application. And another project I work on is called Sakai. It's a learning management system that's open source. And this is a tiny fraction of the data model, but if you want to work in this application, you want to improve something or add a feature, you got to figure out this data model, because where the data goes, it shows up kind of flat in the user interface, but eventually it's stored in very specific locations and linked. And that's why you see all these little boxes, but then lines. The lines are also the links between the various tables. So there's a whole bunch of theory about database normalization, and it's important. It really is. And if you take some time, go ahead and read about it. First normal form, second normal form, third normal form, version A and stuff. I'm not really into the math. I don't really want to explain the math to you. The key thing about database normalization, ultimately, that it can be sort of distilled down to: don't replicate string data. And what I mean by string data is like names and URLs and things like that. So in a system, ultimately, if my email address is stored in text in that system, it literally should be stored once. There should be no email address, email address, email address. What you need is to have the email address one place, and then kind of give that email address a number, and all the places you want to indicate about that email address, you use the number. And so these integer numbers are the key. So we create keys, which are the lookup handles, and then we point to those keys. And we use integers to make links between the tables, because integers are fast. They're the thing that computers understand better. They understand, computers understand and move integers around. They use less data, they calculate, they compare really fast. And so integers are very important. So up next, we're going to take a look at some example data, and then we're going to design a data model for that data. So now let's design a data model. Usually you start out with a user interface that if we're going to build an application, you're going to end up with a user interface. In this, I'm not going to really start with a user interface. I'm going to start with like a spreadsheet view. And if you've ever done something like tried to organize your music collection with a spreadsheet, or a video collection with a spreadsheet, or you find that spreadsheets are super convenient because you can scroll around and do stuff, and you've learned SQL, you can go into various cells with SQL, rows and columns, and update and do all this stuff. But you find that after a while, you start repeating yourself in spreadsheets, and you find it's really difficult because it's really easy when you're putting data in to copy, paste, 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 and put the same stuff in. But then what if you want to change it? And this is where this vertical replication, or the replication of data in multiple places, is very bad. So here's kind of an exploded table view of that same data. And it's okay, this is the data that we've got to do. And so if we look at the use cases of our application, what we see is there's a series of books. Like in this course, Wisdom of Crowds is a book, Introduction to Networking. These are all books coming down here, Unlocking the Clubhouse. So the first column is titles of books. The second column is the ISBN. And then we are sort of keeping track, because we're a library, and so we might have more than one book, and we're going to call those the book instance. So instance 1, instance 2, instance 3. Each book, each physical actual book, you might have no physical books actually, or you might have one physical book or 5 physical books, and each physical book might be checked out and have a due date. And so we have a status. And then we have something like, say, the language of the book, or the genre of the book, or who wrote the book, right? And so that's kind of the data we're going to represent in this application. Now, when you're looking at this, the first thing you do is you go like, anything where you've got vertical replication is a problem. And so you've got to be careful. So you look for vertical replication. And the places that are problematic in this table view of all of our data, like the status, the language, the genre, you see the word think, 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 think. Those are strings, right? They're not numbers. Okay, Wisdom of Crowds, Wisdom of Crowds, Wisdom of Crowds. And the problem here with Wisdom of Crowds is that there are 3 instances of the book, but then because we've got this all in one row, one table with just a bunch of columns and not multiple tables, well, we have to replicate the name Wisdom of Crowds 3 times so that we can represent the 3 instances. The same is true about the English language and the genre and the author name, right? These are the same authors. Okay, so this vertical replication is your first clue that says that you've got to come up with a smarter data model than just this. And so the idea is you're not allowed to put something like the string EN, English, in more than once in your whole database. So what you have to do is you have to split this all out. Somehow you have to remove duplication by making a language table, a book table, and an instance table. And so in the book table you only put Wisdom of Crowds once, and you only put the English language in once, and Spanish in once. But then the problem is, okay, somehow we've taken this data, moved it from one big long bunch of columns to 3 tables with sets of columns. But we still have to represent all the original data that we were working with before. We have to represent all that stuff. And so this is where we have to be able to make connections. And this is the essence of relational databases, and that is they don't replicate data, but they make connections from one data item to another data item. And so what we're going to do here is, in the case of the Wisdom of Crowds, we are going to have 3 book instances, but somehow they all point to one book in the book table, right? And so we have 2 books that point to the English language, and one points to the Spanish language. Now this seems like, wow, that wasn't such a big deal. But when you do millions of records, it actually matters. It's the string data that gets you in trouble and requires far more scanning and far more storage. And another thing that happens is when you follow this rule of only one copy, well, what if we wanted to turn this to uppercase EN or something? That means as long as the data is linked rather than replicated, that means you're only changing one copy. Okay? So the replication has a performance advantage, has a storage advantage, and it has a modifiability advantage when there's only one place. If we mistakenly misspelled the title of Wisdom of Crowds, it's easy, we fix it. It's not in these other tables. Whereas if we misspelled the Wisdom of Crowds here, we have to go find on the top one where it's just all one big long spreadsheet. We got to go and like do a search and replace. But what if that's in a different column? And so the idea of getting to the point where we have unique rows and we connect those rows. Now, I haven't told you much about how this magically works. I just said we can draw some arrows. And so by drawing those arrows, we got to show you how those arrows get drawn because that's really important. So this is how you start drawing the picture of your database. And so the kind of relationship we're going to have between tables is like a many to one. So when we say many to one, what we're saying is that there is one English language entry and then there are many books that go to it. So that's a many to one relationship. So it could be just one, but it's many. And if we look at the data model that we see from the Django example from the Mozilla Developer Network, we can look at this and we can see here, right? This connection between the book table and the language table has two ends to it, and it has a direction to it. And one end says 0 ... and the other end says 1. So this is many. 0 ... means a number between 0 and infinity, including 0, which means it's possible for a book not to have a language. We call that null in database concept. So there's a book with no language, or many books can have one language. So there's one language, English, and there is as many books as we want, including potentially 0 books, right? So we might have a language that has no books in our library with that language, and that's okay. So in this one, between book and language, it's okay to have 0. So 0 through infinity on the book side of the relationship and 1 on the language side of the relationship. If then we look at the relationship between the book and the book instance, now remember what the book instance purpose is to record the fact that we have multiple the actual physical copies of the books that we have. And so we might have multiple copies. And so if you look at this, it's pretty much the same in that there is any number of book instances from 0 until infinity. And you could have a book in your book table for which you didn't actually own a physical copy, and that'd be okay. We would know things like what its author was, what its genre was, etc. And then we would buy a copy of said book, and we'd add a copy to the instance table, and then we'd link that into that book. So again, you can have 0 book instances, 0 through infinity book instances mapped to a single book entry. Okay, and so this little legend, 0 to infinity to 1, is how we read this table. And you will see database tables that have different syntaxes, but they all are capturing the same thing, and that's the cardinality, or the number of things at each end of the arrow. So up next, we're going to show you how to actually physically store this information in the database. So far, I've been just sort of saying, and there's an arrow, but we have to have a way to actually store it in the database. So now what we're going to do is we're going to talk about how we can represent links in a database. And so up till now I've just been drawing arrows and just assuming that you know how to do them. And so here's some arrows, right? We got some book instance rows that can somehow magically connect to some book rows, and some book rows that can magically connect to a language row. And so there's a way that we do this, and we put what we call a key column in every one of our tables. Key column. We call this the primary key, and we often call the name of the column the ID. There's a way in the database to make it what's called auto increment and primary key and index it so it's really fast. And so that then becomes the handle. The primary keys are like the destination endpoint of the arrows, right? So that's how we say English becomes language number 1, and Wisdom of Crowds is book number 1, and Introduction to Networking is book number 2. And so the ID is something that we then can use throughout the rest of the system. Integer replication is not a problem, okay? And so then what we do is we put columns in that we call foreign keys, right? And so those foreign keys are the starting point of the arrows, right? So book underscore ID. Now by convention, we name these by the name of the table followed by an underscore followed by the word ID. These are called foreign keys. Foreign keys. And so by having a foreign key everywhere we need to start an arrow and a primary key everywhere we need to end an arrow, now really we pretty much put primary keys on every table so that every row of every table has a primary key. Now in this example, I've just got one foreign key per table, but you can have more than one foreign key per table. There could be another column here that points off to another table. But that's it. That's how we do it. We just simply add these integer numbers and then we kind of maintain them and put them all together. So like I said, the primary key is that column that we add, and that is our handle for the rows. And then the foreign key is the column that we add to a table so that we can point to something. So basically, once we create these foreign key columns and the primary key columns, we start being able to build, using these links, we can build the links that replicate the data model that ends up being our picture, okay? And so that's how they work. Up next, we're going to talk about how we represent these links in Django. So we've talked about how we reduce replication by moving data from sort of one table with too many columns into multiple tables, and then make links with primary keys and foreign keys. But we're really not going to operate at that level because this is a Django class and we're going to do this in Django. And so we use data models in models.py to do this. And so a lot of the model field types are characters or numbers or dates or long text fields, etc. But some of them are special and used in this one-to-many, foreign key, many-to-many fields. These are the fields that we'll use to do the linking in our Django data model. And so we'll take a look at how these all work. So if we have our book instance that links to our book table and then our book table that links to the language table, we end up with special little lines in our models. So most of this is pretty familiar. We got a language, it's got a name. Now one thing about Django is it automatically adds the ID field, and that's kind of nice. So you just assume that everything inside of a data model, every one of these three tables are going to have ID fields. And we don't even talk about the name of the foreign keys, even though Django names them the way I just showed you with the lang underscore ID. We have just a regular old thing, so lang is suitable as a destination for a link because it has an ID column automatically added by Django every time. The book table has an ID column, so it's suitable for the destination of a link, but then title and ISBN are there. And then there's this language, and that's the first one. And so this is where we're actually modeling the need to have links between the book table and the language table. So we're starting at the from, or the start of the arrow, and we're saying we need to have a language. But the language is not a string, it's not a number, it is a foreign key. And it's a foreign key into the table called lang, and this table called lang matches that table. And then we have a couple things. I'll talk about on delete in a second, and then null equals true is whether or not it's required. And so what it's saying when null is true is we're allowing emptiness. So that means it's possible to have a record in the book table that doesn't have a language. And so that's what we're saying when we're saying null equals true. The instance table points to a book. It's a foreign key to the book model, and it has a do back. Now the status was in there, and so I sort of shortened it a little bit, but we have a foreign key that points into it. And so again, we're defining where we have the beginnings of the arrows because the ends of the arrows is kind of implicit. Django gives us sort of the primary keys for each row in these models automatically without us having to say it. But you can put it in a Django model if you want to override the name of it, but if you just want a column called ID, which everybody pretty much does, you just leave it out and Django puts it in for you automatically. Okay? And so again, you see this from the point of view of the data model, where we have the arrow between book and language, that's a many to one, and then a book instance to the book is a many to one as well. And so those foreign key links represent the arrows in this data model. Now, just to sort of review, you might have done already some of these migrations. So once you edit these data models and you get them right, you have to do a two-step process to get them so that your database reflects these models. The first one is you have to make migrations. And so the way the make migrations works is it looks through all of the applications that are registered in your settings.py, and for every one, it checks to see if the data model has changed since the last run of make migrations. So make migrations actually creates files in your application based on the models.py. And it's a series of files. Like 001 here, that's the first one. There might, if we changed it and then run make migrations again, there'd be an 002. And what it would do is the 002 is evolution up beyond the 001. Now the migrations are portable, okay, in that they're not specific to the MySQL database, the SQLite database, etc. Now the migrate reads those migrations and then updates the actual tables in the database. And so the migrate is mapping the portable representation of what's supposed to be in the database into the actual physical representation in the database. Now you'll notice if you run these both twice, once they work, they'll say no changes detected, because in the case of the make migrations, it looks at your models and then looks at what's in the migrations already and says it's a perfect match. And then in the migrate, it looks at what's in the migrations and what's in the database table, and it says everything's there, everything's been done. So this can be confusing, because in my documentation I'll say run a make migrations and you say no changes detected. Now there's another reason why you might get no changes detected, and that is that you have to add it to the settings.py file before you can, it's going to be detected. So you might have edited a model.py file and changed it, but if it's not, the application is not in the settings.py, then it won't be detected. So the make migrations is reading through all the applications listed in the settings.py, checking for differences, deviations between models.py and the migrations. It might be a little easier just to show you these things. That's coming up. I'll show you those in a second. If we look at what the migrate does, the migrate creates the SQLite file. And so we can take a look at this file. You don't have to, but you can take a look at this file after you've run the migrate. And you see, so I have a tables book 1%. That's actually a wildcard, because the like statement, that's like the like statement in SQL. So that says, show me all the tables that start with book 1. And you see that there's 3 of them, book 1 underscore book, book 1 underscore instance, and book 1 underscore lang. Book 1 is the application, because Django has project and then applications within project, and book 1 is the application that we're doing. And then instance, book, and lang are the 3 models that we've specified in our database, in our models.py. So if we take a look using the schema command of book 1, we can see how the migrate statement produced the table. And so we created a book 1 underscore book. It has ID, auto increment, all that stuff from the SQL stuff. It's got a title, it's got ISBN, and then it's got this lang ID. That's the foreign key. So it's actually building the foreign key the right way. Now in SQLite, there's one way of building foreign keys. In MySQL, there's a different way of building foreign keys. And so that's all something that the migrate operation understands how to build. And if you look at the language, you just see that there's an ID column that's automatically produced, and then a name. And then if you look at the instance, you see an ID and a dude back, which is date. And then, and then you see the book ID, which is the foreign key into the book table. And so you can kind of see how these tables implement the links as described in the picture. Now, I was telling you that about this on delete. So the problem is what happens when you have a row in one table, like in the book table, that's pointing to a row in a language table, and you got records that are pointing there. So you've got 2 books that are pointing to English in this situation, and then you delete the English row. What happens to the rows? And there's a couple of different things that you can do, but the 2 common things is cascade, and what cascade says is that you're going to delete all the rows. If you delete those rows, you're going to delete all the rows that have the matching language ID. And set null basically instead says, oh, that's okay, we're just going to wipe out these and make them null. And in this in this language, if we delete a language from the language table, we probably just want to set it to be null. Okay, and so if you look, you'll see that the relationship between the book and the language, which is right here, if we delete one of these things, we set it to null. We set the corresponding language to null. We just throw away these links in a sense, and that's okay, because books are allowed to not have languages. Okay, and so languages are allowed to be null. Null equals true. Languages are allowed to be null. But if, on the other hand, we get rid of a book from our books table, then we probably want to wipe out all of the instances that are related to that book. And so that's why we in here say on delete cascade in the book foreign key entry. And we don't say null equals true. And so set null requires you to be able to say null equals true. So you have to say, I am willing to allow nulls in this column. Oh, and by the way, if the thing that this column points to is deleted, then set it to null, which means don't delete the row. Cascade means if the thing we're pointing to is deleted, then delete this row, because we don't want inconsistent data. We don't want those little things pointing off to absolutely nowhere and making absolutely no sense. So up next, I want to go into a little more detail on models, migrations, and databases and how they work at a bit of a low level. So now we're going to take a look at the kind of Python code we can write to manipulate these data models. So to do this, we're going to use what I call the Django shell. Now the Django shell looks a lot like the Python shell, except that there's a whole bunch of stuff preloaded. You can't just run Python 3 in interactive mode. You see the chevron prompt. On Linux you see a bracket prompt. It's the same shell, but in the Django shell, what happens is actually reads the settings.py and goes and finds all the applications in settings.py and preloads the applications and then gives you a shell. So it's like there's a bunch of things that happen that's not just a shell that are done before you're in the shell. And this statement of from book 1 models import book lang instance, that wouldn't work if you just ran the Python shell by itself. That's because the book 1 application was loaded by Python 3 manage.py shell. After that, you've got all these things preloaded, but then you can pretty much run any Python that you want that messes with all of your Django classes and objects, etc., etc. So let's take a look at the kinds of things that we can do. So if you remember, our data model was named lang for language. And so we can create a new object in memory with lang parenthesis name equals quote en quote. And that basically says give me a new language object and set the parameter, the attribute name to be en. And give that to me back in a variable. That's an object-oriented constructor. We're constructing an object. Now that doesn't store it in the database. That simply creates it in memory and gives it back. So it's a Python object with an attribute. It knows it's a language. Now the save method, z.save, that is the thing that says, you know what, I've got this thing in memory, please persist it to the database. Write it, transmit it to the database, and come back. Now what's cool about that is this ID column, that's been set at that moment. So we can say, what ID did we get? So remember how every row that we put in a model gets an ID value, and we're going to use that ID value as the handle to point to. So this is the primary key, which is the way we point to a row in a table. So then what we can do is we can make a book, right? So we made a language, and we know what its ID is. Now we're going to make a book, and it's got like a title and an ISBN. And what we do is we say, and the language is Z. Now Z there is that variable. Now we don't use the ID. Django knows all about how IDs work, and so it knows when you're saying lang equals Z that it's going to make a lang ID and put the ID of the language row in, foreign key, all that stuff's just done. You just have to have a variable that has an ID value and pass that in. So what that's doing is that is making a book and then connecting it to a lang, right? Now that's also not saved until you save the book. The book is now transmitted to the database. It has a foreign key in it. It gets its own primary key, so it's primary. It's the first book that we've inserted, so its primary key x.id is 1. And then we can make an instance, and the instance needs a due back, which is a date, and then it needs which book it is, and we use that variable x to indicate which book that we're talking about. So that's just creating a link from the book instance in memory that we get back in the variable a. It's a book instance that points to the book it's in the variable x, which is py for e, ISBN 42. And then we save that, and that has an ID. So now we have created a language record, then we created a book record that linked to the language record, and then we created a book instance record that linked to the book record. Okay, and so that is, you know, this whole linking thing, right? So these are the pointers, and what Django's doing in this situation is Django's trying to hide from us the whole idea of the foreign keys and the primary keys. Other than me asking what the ID is, it's not really something you have to do. So all those asking for the IDs aren't necessary. You just say, look, I have a book and its language is this thing. I don't know what its ID is. You should please make me a column and do all this magic stuff. So much of the bookkeeping of these one-to-many relationships or foreign key relationships in general in Django is just done automatically. Now, we can retrieve these and we can sort of walk down these things, walk through these things. So here we are again in samples, and we run the shell and we import our models, and we can say book.objects, and book is a class from our models. It's book1.models.book, and then a lot of the methods that we talk to inside of these classes are under the attribute.objects, which is, you could think of it as all of the rows in a sense, or all the objects in this model, all the rows in the table that lives there. Book objects, and then get is like, which one do you want? Get pk equals 1. Pk means primary key. I don't know, I think it would make more sense if we called this ID, but ID is the name of the column of the primary key is really just kind of a convention that's done 98% of the time. It's not required, it's not the truth, but it's so common that it might as well be. But pk really means primary key, which 9 out of 10 times is the column ID. So we're loading from the books table, we're pulling that in, and we're getting the row number 1 from the books table. So if you say what the title is, well, the title of that is py for e. Now, there's a title, but then there's lang. Lang is that foreign key that points to the language. And so we can say x.lang, that is the entire language row, but x.lang.name is within that row, it's the name column. So we sort of walk down the little arrow and grab one of the elements out of that. So it's like walking from a book to the corresponding language row and then pulling the name out of that corresponding language row. So I think that's a really pretty syntax, and it starts to make sense after a while. You walk through the little arrows. And this is why the picture of the data model is so absolutely important. Oops. And then, and so now we're going to go grab the book instance number 1, the first row of the book instance table. So instance.objects get pk equals 1. That says give me that first row, give it back to me in the variable y. What is the do back of this one? And then you can sort of walk it. You can say I'm at a book instance and I want to follow the foreign key to the book table to get me a book, and then give me the title of that book, right? So from a book instance, you can walk to the book table and then get the title of the book, and then we get py for e. So you see this sort of starting from one row, walking to the corresponding row that's pointed to by this relationship, and that's the essence of this. We're going to do this a whole bunch. By the time we come back to this will all seem pretty straightforward. So we've been working with the Django shell and typing commands in to insert records and populate fields and create the both sides of many-to-many and then link them together. And so some applications that we're going to build, you're going to put up your super social ride-sharing thing that you just built, and people are going to start filling it with data. But other times, you're actually building a website for which the data is already known. You might actually be reading a bunch of data and putting it into a database from some source. Maybe it's an API, maybe you're scraping or whatever. And so you have some source of data and you want to put it into the database. And you don't want to put it in by hand. And so we're going to talk a little bit how you can write a script to load data into your Django database, into your Django models, after you've defined those Django models. And so we're going to actually take some CSV data, we're going to read it from a file, and it's just comma-separated values, and we're going to use the course person membership model from before, and we're going to say basically, here's a person with their email address, their role, which is instructor or learner, and then the course that they're in. And what we're going to do is we're going to write a script to read through all those things and then insert and populate. Because you gotta, when you're making a many-to-many, you gotta like put both sides in and then connect it together. And so the code will be in DJ Free Samples scripts manyload.py. That's the code to load it, to read this file, and then create it, put it into DB-SQLite, informed by the data model in the many-to-many example that I gave you with the course stuff. Okay, so that's what this is. Now, running scripts is part of a feature of Django called the Django extensions. Now, if you've already done this through when you installed DJ Free Samples and you're in pip3-r requirements.txt, you already put this in, but it doesn't hurt to go into your virtual environment and type pip3 install Django extensions and make sure it's already there, because if it's not already there, then it will get installed. Otherwise, this whole script thing won't work, right? After you install it, you do have to put a little link into your settings.py. That's Django under store extensions in your installed apps. And there's documentation on how all to do this. So that's the first thing you've got to do. Once you've installed it with pip, you have to pull it into your Django application. So when Django first loads up, which is python3 manage.py, at that point that says pull this in, pull all these other things in. All your apps, your extensions, the Django features you need, etc., etc., etc. And that's in the project settings.py file. So Django extensions won't work if you don't put it in this file. Now, if you're running on Python Anywhere, of course, after you edit this file, you gotta reset your web, but I think you probably figured that out by now. We wouldn't have got this far if you weren't resetting your web server on Python Anywhere. The next thing you do is within your Django project file, you make a scripts folder. And you put this file, empty file, touch is the Unix command to create an empty file, scripts / _init__.py. This is just kind of a thing you do, and what it is an indication as Python is reading through these folders to say this folder contains modules that are suitable for importing, and that's just a signal. And I think later versions of Python make this less important, but we've always put this in. So if you're going to put like classes that are intended to be imported into some other application, we always put this empty file _init init_.py. So touch says make an empty file of this name.
So let's take a look at our files inside of the DJ Free Samples folder. So I am currently in the DJ Free Samples folder, and it's the main folder. The settings are in DJ Free Samples. We're also in the same folder as the manage.py because we're going to be running commands, the manage.py commands. We're all playing with the folders cats and in the scripts. So the cats is where we have the models. Cats models.py. So we have two models. We have a cat model that has two normal fields. One's a nickname field that's up to 200 characters. The weight field is a floating point number. And then the breed is a foreign key into the breed model. And the breed model, other than its indexes, and I mean its primary key, has one field called its name. And of course, you want to have run your migrations. You probably already did this. No more migrations to run. If you run a migrate, it'll say I'm all taken care of, because these were here when you first checked this out. So the migrations, yeah, so we're good now. So the data is in a file called cats/meow.csv. And comma separation, it's got a heading at the top, name, breed, weight. We're going to skip that in a second. And then you've got the cat's name, the breed, and the weight. Now the key problem here is from data modeling. We've got some vertical replication. Manx, Manx, Tabby, Tabby, Sphinx, Sphinx. So we can't create a whole bunch of breeds. We can't just put these in as strings. So we're going to create a many-to-one relationship, and the breed is going to be in a table. Yeah, cats. Back to the model. All right, we're going to put each breed is going to go in uniquely, and then we're going to get a primary key for that breed. And then when we insert each cat, we're going to reference or point to using a foreign key. Point to that breed. So let's take a look at the scripts. Now, just the way this works is you've got to put these scripts in a separate folder. And the reason is so that this import statement works. So that has to. So there's a whole bunch of stuff to load Python up, but then load your Django application up as well. And once your Django application is loaded, then this cats models exists, and we can import the breed. And if we look through the code, we're going to open the file cat/meow.csv that we just looked at. We're going to use a CSV reader. Now you could do this with a split and commas if you really wanted to, but we are going to skip past that header. Remember the header, this was the first line. I'm going to skip past that. And so we can run this over and over again. We're going to just call cat objects all delete, and same for breed, to get rid of any data we put in, because it lets us run this over and over and over again. And so now we've read the first line, so we're going to start the second line, and then we can just iterate through the remainder of the CSV reader. I'll print the row out. And this line here that says B created equals breed objects getter create name equals row 1. So the first thing is this row 1 is going to be, in this case, Sphinx for the first one, and then Burmese for the second one, and Manx, Manx. So this is a pretty cool, this getter create method is a pretty cool thing. It's saying if there is a breed with a name of Sphinx, get it for me. If it is not, make it for me, and then get it for me. And that whether it's created or retrieved, it comes in this variable B. And created is just if you want, it returns a true or a false as to whether it was newly created. Sometimes your code is more sophisticated and wants to know if it's the first one. So then we have to create a cat object. And let's just take a look via cat/models.py to recall that the breed has a single variable, a single field, name, and cat has nickname, breed, and weight. But breed is a foreign key. It's this special kind of thing. And so what we're going to do is we've got a breed object, in that was created with, in this first line, Sphinx. And then we're going to make a cat object. And the row sub0, which is, in this case, Abby, is the nickname. The breed is a reference to the breed object, which is in this variable B. So breed is the field inside of the model, inside of the cat model, and then B is the actual row that it's pointing to. So that's a real live saved row in the variable B. And then weight is the third column, which is in this case 6.4. And you know that just by calling the cat constructor, we do not actually store it, but you have to call c.save. And then this loop goes round and round through all the readers, and eventually it creates all these things. So let's go ahead and run this. Python 3 managed py run script. cats load, I think. Hopefully I got it right. Oh, yeah, maybe I should put a T in there. There we go. And so it's successfully loaded. This is just printing as the rows are read, but it's all loaded in. Now, we can verify this by saying SQLite 3 db.sqlite. That's a database. Now, I got to be in the right folder for this to work. And I can say .tables to see what the tables are. So kind of going down into SQL, and you can see the cat's breed and the cat's cat. So I'll say select star from cats underscore breed. And these are the breeds. And they're the primary keys. So Sphinx is 26, Burmese, Manx, and you'll see we've only put them in once. And then I'm going to say select star from the cat's cat, limit 10. And so we've got Abby with a weight of 6.4 and a breed of 26. So Abby is a Sphinx, right? And then Annie with a weight of 7.6 has a breed key of 27. And so there you go. And so now you see that you've built those. If we say select count star from cat's breed, there was only 6, and if we do that same thing for cat's cat, we have 104. And so there you go. This is a simple way of running a script and reading some stuff, and this get or create is a wonderful way to allow yourself to do many-to-one relationships and make sure that you're not doing vertical replication in a column. So the get or create is kind of really doing almost all the work for us with the vertical replication.
Our next topic is to talk about log in and log out. Now, just in general, I have this GitHub repository called DJ Free Samples, and every once in a while you ought to see if I've found some bugs and fixed them. So go over to your samples and do a git pull. So every once in a while, just do that. So Django, like in lots of situations, comes with a built-in log-in, log-out system. There's lots of ways to do it. You can read up on it. It has a way to create users, has this nice admin interface. And so one of the things we like about Django is that we don't have to build some of these basic maintenance things. It has permissions and groups. We use this in the local library application, but we're not going to use that so much in our applications. And passwords, etc. And it has a way to store these things in various techniques. And so the first thing that you'll probably encounter when you're doing this is to create a super user. And so you have to log into your system, you create a super user, give it a name, an email address. The email address is for password recovery. Even though you can log in and you can change your super user password anywhere, and then you do it. Now there's a great XKCD cartoon for so many things. This is one guy says make me a sandwich, and the other one says what, make it yourself, and then says sudo make me a sandwich, and the other person says okay. So what sudo means is it's a Linux command to switch to the super user and do a command. So if you don't have permissions to do a command, you can say sudo a command, and so that's what this XKCD. So that's what we call a super user. That's the user that has all permissions, doesn't need to get any special permissions. This might be a good time to review what you're going to do when you wipe out your database. When you create that super user, it just adds a row into to a table in your DB SQLite, and you can wipe this out anytime. That's why I like using SQLite for development in Django. If you remove it, you've removed all the tables, all of the tables created by migrations. The migrate command is what creates tables. The make migration actually creates migrations with your Python code. So if you're going to start fresh, you got to remove the DB SQLite file. That's got rid of all your users, all your super users, any data you've put in, it's gone. And then you have to wake it back up with a bunch of empty tables with a manage.py migrate, and you'll see all those things. Lots of lines come out at that point. I didn't include them. And then you're going to have to create your super users again. So just if you wipe your database, you got to recreate your super users. Once you have a super user, The rest of the users are put in using the admin interface. You just go in and among all the other models that you might have in your application, the groups and the users are just models. They're models that happen to be built into Django, and you don't have any responsibility for building them. And so, like I said, the groups and permissions is useful, and you can read up on that, and maybe your application needs to use those. But for me, I pretty much just make users and call it good. Later, we're going to learn how to use like social login. So we'll use GitHub to log people in, so you don't have to create any users other than your admin user. But in the short term, we're just going to use what are called local users, which are stuck in the database, kept in the database, and easy to create, easy to maintain, but you tend to have to manually maintain them a little bit. So next we're going to look at, now that you've got a user, how do we in our application code log in and log out users. So now we're going to take a look at what we do with Django to handle logging users into and out of our application. So we talked about sessions recently, and making a session is not the same as being logged in. Logging in actually changes data in the session. Logging in general, the most basic way of logging in depends on the existence of a session, and logging in is putting data into the session about the current user and their name and their email, and then logging out is removing it. In the session, you could have multiple users, log in with one user, log out, log in with a different user, log out. If you're just in the same browser, you're going to end up with the same session, just associated with different users. So remember, sessions and login are not the same thing. Just like cookies and sessions are not the same thing, sessions and login are not the same thing. But they all build on each other. Sessions build on cookies, and login builds on sessions. So to make this all work, you have to add to your installed apps all the Django support for all this login and logout stuff. Now, if you automatically built your project and you got a settings.py, that they're going to just put this in automatically. So this is just so you know when you're looking at it where it is that all this magic functionality comes from. It comes from this installed apps. Also, for the login and logout, you're going to have to add a path to your project-wide. So DJ for eSamples, DJ for eSamples, urls.py. This is not in any of your applications. This is in your Django project, and you add a path, and there's a bunch of URLs, and that gets all registered, and a whole bunch of wonderful magic happens at that point. And so that's how these URLs are activated in your Django project, so the applications. So the way we get the URLs to the login and logout features is we use the reverse. We've been using reverse all along. Reverse is the way we look up for a particular view. And in some urls.py, matter of fact, in that Django contrib auth URLs, in that there is a name equals. And so there's a view in there that they've got that we didn't write, and it has a name equals, and has name equals login and a name equals logout. And so we can do a reverse lookup like we would of any of our views that we might have. Say, give me the URL in this Django project for the view named login or the view named logout. And it's pretty simple. You could even probably hard code these, but maybe the route isn't exactly account slash, right? And so maybe you called them something else. And so that's why we use the reverse to look these things up. And so that's just a convenient way of doing it. Now, one of the things about logging in is sometimes you have an application and there's like a login button, but sometimes you just have pages that are protected by login. And then when you go to a page, it says, oh wait, you got to log in first. And then after you log in, you'll notice it typically just takes you right back to the page that you wanted to see. So you might bookmark a page when you're logged in, and then you log out, and then you click on that bookmark page, but that requires that you be logged in. So you're going to go to the page, and then when you're done logging in, you want to come right back to that page. And so that's using redirecting, but it's redirecting after login is successful or after logout is successful. Logouts are almost always successful. And so there's a parameter that we can add, a get parameter that we can add, and it's the next equals, and what we do is we give it a path. And so here's a little bit of code that we're going to play with in my sample codes under the authz project, under the authz application. And so I got a bunch of views, and I'm going to give them some names so that we can play with them. So these are just the urls.py. So if you take a look in this main.html template, you see a whole bunch of things. You see this next feature in action. So here's a couple things we can do. So there is this user object that in a sense is passed in. You don't have to do anything to pass it in. There's this user object that sits there in your template context that's automatically. We'll talk later about how you can sort of inject into every template certain little things that you got to inject. But the system injects this user. There is an attribute called isAuthenticated, which is true or false, to say whether you're not logged in or are logged in. And so if we see it, we say, oh, what's their person's full name, user.email, user.id. This is, user ID is the primary key. We might actually have later we'll have a foreign key that goes into the user table, and we need to know what the primary key of the current user is so we can populate our foreign key. So when we have a row and it's owned by such and so, we're going to actually put a foreign key into a table that we didn't even create. But the thing I'm talking about now is you can get a URL, that URL tag that's looking up a name of a view. Log out is the name of a view. Log in as the name of a view. And then we have this question mark next equals. That's the parameter to say when you're all done with that login or log out, go back to this particular URL. Okay, and so that says go to the URL that's in the Auth application, the view named open. And so that's one way of doing it. Another way, let's say in login, we're going to get the login URL and send ourselves back to the request path. The request is another one of these things that's dropped in automatically for us. That is the current URL of the view we're at. So in a sense, this is a contraction that says go ahead and go to login, and when you're back, come right back here. So login will log in and then redirect back to this page that we're on, whatever the page is, because this is going to be, this little main.html is used in a couple of my different views. So request.path is like come back here. So that's a good pattern to know, to just say log in and come back to this current path when you're all done. And so here's just a bunch of connections to this thing, and we have here's just all my links, and I have a couple of things. I have some no login required pages just to play around, and then I have one that's protected by hand in Python, and then one's required by a login mixin, and then I sort of dump all that data, and I think I showed you that one already. So here is one of them, right? I showed that. That's what this all looks like. You can see that these links have the next in there. This is how it turns out to be. You get accounts login. Oops, come back. You go to accounts login, next equals auth open, and that's basically, I'm in this file right now. I'm in that URL, and that says go ahead and log me in, and then come back to this URL, to the auth open. Here's an example of the logout URL with a next setup in it. And so up next, we're going to talk about not just how to get the users to go to the login page, but how to configure the login page. So now we've kind of understood a little bit about the user object and how we do things in templates, and how we get at the URLs for login and log out, and then how we redirect back to ourselves. Let's talk a little bit about the login page itself. And so the login page is something that's provided by Django, but it needs a template. And so what happens is we get to control the template. And we're going to go to this URL, the code behind the views, the code that looks up the password, the code that gives you errors. That's all taken care of. All the views are taken care of. And what we get to do is we get to describe a template that controls our look and feel. And so we can have a simple login thing or a pretty login thing, and we can have links to the rest of our application. And so we want control over our login page so it looks like it comes from our application rather than having it look like it came from Django. So I'm not going to go through in much detail about how this works. You have to create a template that can be accessed as registration/login.html. And remember that no matter which application in a Django project you're working in, those names are global. So for example, this name right here, registration/login.html, the fact that it's in my home application doesn't matter. And that's why we have this extra slash in here. So just because it's in the home application doesn't mean it has to be, the home and the registration don't have to be the same in this particular case. And so this is a template that if they just do a render, so in their view, in the login view that's somewhere deep in Django, they're just going to do a render to registration/login.html. You have this somewhere in some application because the templates are global. It's going to find your template and put that in. So within this template, there's a few rules that you've got to follow. They're going to send they're going to send some errors, and there's errors. If the form has errors, you have to have some output that deals with that. If next, that's actually that next equals parameter. Okay, and so if the next is there, and you come into this log, and this one's a little bit weird. If you have a going forward page, that means you came from a page and you're going to go back to a page. If the authentication happens, that means you've been logged in, you went to the page kicked you back because it's protected by more than just logged in user. Okay, so this little bit right here, this is a little bit subtle. If you're not logged in, that's kind of the normal case. Please log in to see the site. And then we basically create a simple form. We're going to post to the login URL. That just looks up the login URL. And we've got this context variable called form, and we can print that out. That form has the key, that form has all of the input stuff in it. We're going to talk about forms coming up soon. And so that's what generates, this form here generates all this stuff right here. And so there could be a bunch of things in there, but the form is a variable created by the view that has all the input names and areas, etc., that it wants. So we didn't have to actually construct the form. We do have to submit, put the login button, we could put a cancel button, and we do have to pass the next back as a hidden field. Now a hidden form field is just like a text field, except that it doesn't show up here. And so that's in there, and if you were to view source, you would see that. And so that's after you submit this form, it needs to know where we're going to go next. So then if you're successfully logged in, it's going to log you in, say yay, and then it's going to redirect to whatever that next value is. And that's our way of, it's going to give us the next value inside this template, but we have to give it back to the view when we post back into the view. So like I mentioned, there's a whole bunch of data that we can get. There is this user variable, and that user variable has their full name, their email, and very importantly, the primary key of the logged in user. But these things are only defined if user is authenticated is true. You can access this user data in Python. It's in a little different spot. It's in the request. So I just changed the name of request to REQ. That's just a variable name you pick. I will generally always write it as request or REQ. And so the user information, that is pretty much the same as what's in the template tag, template context user. User is authenticated, their username, their email. I could have had rec.user.id if I wanted here, and otherwise it's not logged in, and then I just throw this back as a simple HTTP response. This isn't all that useful. It's just showing you how to get your hands on those values if you're in Python. So sometimes you're in Python, sometimes you're in templates. Quite commonly you're in templates. So I've been talking about a view that requires a logged in user. And so again, imagine something where you're sort of reading your messages on an online system, and you bookmark the message reading URL, and then you shut your browser down, which logs you out of the system, and then you click on that bookmark straight to the messages, my inbox or whatever, and then inbox looks at you and says, you're not logged in. So I got to send you to log in, you finish logging in, and then you come back. That's what the next equals does. Now there's a couple of ways in views to write that kind of feature that basically says, this view is fine, but only fine for logged in users. So let's take a look. So one of them is checking to see if user is authenticated. So I have two views in here. One is, I'm going to protect it manually, and that's so you can see how it works, but it's really not the right way to do it. I mean, you can do it this way, but it's like, there's always a better way in Django, always a better way in Django. So here we have a class-based view, and we ask, is the user authenticated? If the user is authenticated, we just do whatever. Now, there might be a whole bunch of stuff in here. There might be a whole bunch of, but I'm just going to render the thing so that's a view. So I'm protecting this particular manual protect view. But if you're authenticated, you can see it, right? It doesn't do anything in particular other than dump a bunch of data out. If you're not authenticated, then I'm going to construct a login URL by calling reverse, say look up the URL for login, add a question mark, and then add the request path, which means wherever we're at, come back to it. So that's the next, and that's going to put next equals, blah, 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 blah. And then instead of returning a render, we return a redirect and say, okay, go to the login URL. So the way this is going to work is it's going to come in once, right? You're not logged in, so it's redirecting. It's going to go out, but then it's going to come in back again, and this time the user is redirected in, so it's going to show you the page. So you end up going through this twice. Now, that's the bad way to do it, or the wordy way to do it. I mean, it's only 5 lines of code, but I don't like 5 lines of code. So there's this thing called a mixin, and a mixin is a class. The idea of a mixin is that, you know, we have kind of an inherited class. We inherit things that are like just a feature almost. So what we're doing is we're going to take our protect view. It really extends a view, but it's going to also add the capabilities of login required mixin. So login required mixin basically says to Django, if this is here, hey, I want to do this. Don't let the user into this particular view. Protect the view. So this is another protected view, but by simply including this little signal that says login required mixin, I've mixed this into my view, then it does all this work for us. So what'll happen is it won't even come in, right? It won't even come in if the user's not logged in. It will redirect and then come back and then let this code in the get run only when the user's logged in. And so this is by far the most common way to do it, is just called login required mixin, saving you from writing all these lines of code, right? So all these extra things, because do I remember how to do this? What if I write that 5,000 times in an application? It's really kind of silly when we've got login required mixin that takes care of all this stuff. And just to review, this is what that view looks like. It just sort of dumps all that stuff out. I use the same I use the same template for all of these views. So login, like many things in Django, is simple. It's easy. You add the things to installed apps and URL patterns. You make yourself a template. I didn't go into great detail. Django has great documentation if you want to get really sophisticated. What I tend to do is I get 1 or 2 templates working for login. I'm like, I want to use this one today or that one. So this is where like the sample code has 2 different logins that we're going to use. One is a simple local login, and the other one actually is a login when we're going to use GitHub to do our logins. You can get yourself you get your URLs for login with reverse lazy, or the URL template tag. And then if we want to come back, we add an X parameter to those URLs. And then when we have a view and we say, look, this view is going to depend on request.user or the user in the user template tag, just add login required mixin, and then Django takes care of making sure that you can't get to the view unless you're logged in. And if you try to get to the view, it tries to let you log in. And if you are login successful, you come back to the view, and it's all transparent to you. And it's literally just one little comma thing in the create. So it's pretty simple. It's pretty awesome. I just want you to understand what's going on, because again, sometimes the fewer the lines of code to write, the harder it is to understand. Cheers. So up to now, we've mostly just talked about how forms work. We've been talking about how forms work across whatever programming language you're using or framework you're using. We've mostly talked about how the browsers treat forms, how we generate HTML to make forms, how posts work, how refresh works, how post redirect works, how CSRF works. That's, other than subtle details, those are topics that are true no matter what you do, no matter what language you're writing in or what framework that you're using. Now we're going to pivot a little bit and talk about how Django helps you do all those things that we just got done talking about doing. So if you look at this picture, you see that like forms are kind of in the middle of this picture. That's the final piece we're filling in. And forms are connected a lot of ways. Forms can be connected to models. They're used in the view and they're used in templates. And so they're a very powerful part. And all the things that we've been doing as abstractions, where we write a little bit of code and find lots of ways to reuse that code. Or we write some code that extends an object and then we add a little bit to it, and then we've got some very powerful object when we're all said and done. And so that's what we're doing here in forms. And forms can be used in views, they can be used in templates, and they can interact even with models. And so we're going to talk a lot about forms. There's a lot of like just menial labor that just working in forms, and if you really had to build all the HTML from scratch like I did in some of those earlier examples, it's just really painful. And there's other problems too, and that is that, you know, there's just a lot of repeating yourself. We kind of want to use like object-oriented techniques and other techniques to not repeat ourselves. And it's really easy to put the HTML up for a crappy form, but why wouldn't you want a beautiful form? And so if you write the HTML and you write some CSS and you do a kind of crappy version of it, then you have to fix it or hand it to a designer, and then they have to go fix 100 pages. There are things in Django, Crispy Forms is something we'll talk about later, that just like says, hey, I'm using forms in Django. Wait a sec, I want them to be pretty now. And then you just make them pretty. And if you want to change how they're pretty, you can change how that works. And then you change them all at the same time. And so not repeating yourself, being able to like lean on utility code. Seems like, why would we do this? But in complex applications, you just fall in love with this idea that you don't have to repeat yourself. And even though I've showed you some of the things like post, redirect, refresh, CSRF, all that stuff, it's even more complex than that, especially when you start talking about pulling data from the database and putting it in an edit form and then checking to see if the data is valid. If the data is not valid, send back an error form and give them a chance to resubmit it. If they're successful, you do post redirect and then you send a message in the session. We've done all that in really simple, but if you really look at everything that you need to look at, it's pretty complex. And so we're not going to do all this in this first lecture, but this gives you a sense of the kinds of things that a create form, where you're going to go like, you know, new cat, and then you got some forms to fill out, fields to fill out about the cat, and then you hit the save. And so if we just go through this, these are the steps you need to do to insert a cat in your cat database, right? So your browser initially goes and gets a GET request, and then you fill out the empty form with a bunch of fill-in-the-blank fields. The user can always cancel out of that and get out. The user might enter some data and hit post. Now the problem is, what if you have some rules about the data, such as this is required, that has to be at least 5 characters, etc. You have to then send a form back with that data to let them fix it and resubmit it again. Or if it's good, you go ahead and store the data in the database, but then we have to put some kind of a success message, like in a session or something, and then send a redirect out, and then the browser immediately comes back and gets the redirect URL, which pulls the message out, sends the page, and sends the success. And so we've done parts of this already, right? We've done parts of this already. The big part we haven't done is kind of like this middle part here, where we're like validating the data and have this error retry loop that we put the user back in the loop and give them another chance. Now that's the create form. The edit process, where you're pulling in an existing cat and you're going to edit their fields, is even more complex. You know, you go load up a cat, but you might have an error page because they're looking for a cat that didn't exist in our database. You send out the form with the old data, they might leave, they might edit it, they might come back, they might validate the data and get an error, then they have to fix the data. They got to go around here until, okay, we got some valid data, and then you store the data in the database, put a message in a session, send out a redirect to a success URL, and that success URL, you put out the message and say yay. So that's complex too, and we're going to figure that out. Delete is not as simple as you might seem. The problem with deleting things is that you can't delete with a GET request. So usually you have to go navigate, like you see a little delete button, you click on it and you go to a delete page. It's going to load the data that you want to delete, so you can build a confirmation page. Confirmation pages turn out to be really important because they're also our tricky way to convert a GET to a post. But if they're asking for the wrong data, we have to send an error message. Otherwise, we send a confirmation form that says, are you sure you want to delete this? That's both nice for the user to give a confirmation, but it also then turns this into a form. And of course, they can leave with a cancel, but if they click on yes, that turns into a post. and it has the key. So the first thing it does is it has to load the data again from the model. And then if that data is not there, they got the wrong key, then you send an error page out. And if you got the right key and the user has permission to delete the data, then you go talk to the model and you delete the thing, right? Then you put a congratulations on your deletion in a session or something. Then go with a redirect, because you can't respond with a 200. You got to respond with a 302. And then the browser immediately does a get a success URL, pulls the message out of session, makes a success page with the message. Now we're going to cover this a bunch of times, so you don't have to get this the first time. But I just am telling you that forms are complex. And what's cool is Django form objects that we're going to create act like glue. They can generate the HTML, they allow for a consistent look and feel, and they allow for you to change the look and feel. When the post data comes back from the browser in a form that it created, then it puts it all in the right spot. It validates the data based on a set of rules that you say, like this has to be this kind of a thing and that kind of a thing, or a date or a character or an integer or a floating point. Whatever it is the rules are, that's all done for you in Django. And if something goes wrong, then it hands you an error form that you can send right back to the user. It really greatly, and then of course, once it's validated, it moves it into a model, and then actually can even do the database store automatically. So the form is like this glue thing that sort of talks to templates, it talks to browsers, it reads data from browsers, it plugs stuff in. And so in a way, the form is like the controller, it's like the view, it just makes your views really succinct, and you're gonna love it once you understand it. So here is a simple form, and so forms live in a file called forms.py, not surprisingly. And basically, just like them, it looks a lot like the models file. And so you're going to see the one thing that forms do differently is they can have these things called validators. Models have rules about max length, etc. But there are even more complex validators, and you can even write code that you have your own functions that when the form is coming in, you're going to look at this one field and you're going to say like, oh, I wanted 2 uppercase characters followed by 3 lowercase characters. Sorry, you didn't do what I said. That's what's called a validator. And that's when that error page goes back and it says, hey, you're missing this stuff. And we'll show you how the validator stuff works. But basically, you put in little lines just like you did for the model. And you're effectively defining a user interface plus a bunch of logic behind it. Now, the one thing I'm not doing in this particular section, we'll do soon, is connecting this to a model. So you could say, wait a sec, I'd like to make a form and I really mostly want to inherit from a model. You can do that, but that's not this one. That's coming up in the whole next section, but it won't be long. So the form object, right? So here's this form we just made. It's got 3 fields in it. And this is a real simple view. It's not useful. It just kind of shows you one of the things you can do. So make a basic form. When the basic form is defined as having these 3 fields, and then you say form and then call the method as table. And so what this produces, it's just a dump. There's nothing, the UI of this looks really ugly, but basically it generates all this HTML for you, all this HTML, input tags, and we told it to do it as table. That's not necessarily the prettiest way to do it, but all that HTML is generated from the form utility. So it can send it out as a list, you can send it out as paragraphs, etc., etc., etc. And so this is just to show you kind of the dump. If you go to this URL, do a view source on it so you see this stuff in here. So that you define a form object, and one of the things you can do is make me HTML. And this is not a good example. We'll come up in a bit with a better example. The better example, of course, is to use it in a template. And so here is a template with a simple form in it. We got a form, it's a post. We got some submit stuff. We got ourselves a cancel, button that we put in. And we got a CSRF token. And we're going to use that form as table. And we're going to surround it by a table tag so that it looks a lot prettier. And so this is a far more typical way of doing it. That first one was just to dump it. And so when you do this and you give it, you sort of make the form in a get request. You make the form and you pass it into the context. If you remember, form.asTable. That's a very, come back. Too far. Form.asTable came from the context, came from the passed in variable, and that is right here and right here. And so we make the form object, which has all the fields in it, and then we pass it into our view, our template, and it renders that. And so then this is what it looks like, much prettier. And if you do a view source of that, if you go to this form create and you do a view source on that, you'll see it's all that same table stuff. You know, it's the same table stuff that we had before. It's just now wrapped in some stuff to make it look a little prettier. We put a submit button, it's got a form tag, and then you can actually hit the submit button and something actually happens. So this is by far the more typical way of using a form in a template. So I talked about the create form, the update form, and the delete form. This is kind of an example of how forms can be used. Now, I'm not actually talking to the model yet. We'll do that in a bit. So I'm just going to pretend that we have some old data. And so this normally would come from the model. This old data, title, mileage, purchase date, that would come from the model normally. But for now, we're just going to like make it up. And so then you basically start a form and you pass this old data in as the constructor. That's a constructor for a basic form. From the basic form class, pass in old data and give me back the form. Give me back an object of type basic form, and I'm going to have it in the variable form, and then I'm going to pass it into context. Now you'll notice I'm using the exact same template, the one I showed you before, because that form as table understands that sometimes there's data in these fields, and it properly puts the data in. It properly escapes the data. It understands that this is a number. It understands that this is a date. It's got all that stuff all figured out, right? And so this is how it works, is you just somehow get your hands on key value pairs of the old data, you pass it into the constructor, and now you render the form, and the forms library takes care of putting in all that old data. Believe you me, you're probably glad I'm not showing you how to do, HTML and code and all these things, and when you do encode, but this is a little different because it's inside of an attribute. You don't want to know that because you just are going to use form as table, and it's got all the rules figured out. This is hundreds of lines of code that you're not writing. So up next, we're going to talk about the validation part. So that's actually what happens when we receive data back from the browser.
Hello and welcome to another Django for Everybody walkthrough. So you are probably at this point working on your autos assignment. This is our first real create, read, update, and delete assignment. And we're going to, a lot of what this assignment is to look at the code I've given you in DJ Free Samples and pull it in. Do not clone the repository for this assignment. The DJ Free Samples is a monster. It's got all kinds of stuff in it that's way too complex. And you do not want, you want to start with a nice clean application. Your previous assignment was to make a really tiny application. Now we're going to extend that application, and that's why you've already have this DJ for E projects in your wherever it is, okay? And so what this is this assignment is to evolve that using the sample code. But what I'm really going to do is I'm going to walk through the sample code because there's new concepts in this sample code. So this is more of a lecture about the sample code than exactly how to do the assignment. But importantly, you need to understand every single line, because literally every program that we're going to write for the next N weeks is a variation on this CRUD, right? And so these views, these default views, the get or 404, all that stuff are really foundational things. And what we're going to find is the right way to write this code, like everything in Django, is really small and succinct. Okay? So let's take a look at the code. Let's go ahead and run the code. Go to autos, and you got to log in. And so the idea of this is there are two tables. There is a table of makes. So I'm going to add a make, and then I'm going to add an auto. And the cool thing about this is neon 1, mileage 1, 2, 3, 4, Sakai car. And then I have this cool drop down. And so this is there's a whole bunch of forms going on here. There's drop downs. There's a many-to-one relationship going on. Then I have this list, and I can update it and delete it. So that's where our full CRUD is. And so we can add makes, view makes, add autos, etc. And so that's all the sample. So it's very close to what it is that you have to write. It's just don't go grabbing all that stuff. So let's start by taking a look. So I'm here sitting in my DJ free samples. And if you look, you see all of my various applications under a project. And so we've got the autos, but I really want to start with the authentication code. The code that, if I go here, back to samples, let me log out, the code that allows me to log in. So if I go straight to autos, see if I've logged out. Right, so you'll notice that what it does when I go straight to autos is it routes me to login and then with the next to go back to autos. So this view in autos, the /autos, has protected itself with login mixin. And later we'll do login. Your login won't quite look like this, but this is the one I have on samples where you don't have to make it pretty yet. An upcoming assignment is going to make everything pretty. So now we're at autos and we're logged in. Okay, and your application has to have some more things here, but I'm more interested in showing you really the essence of the views in this autos, right? So if we let's just review just briefly. Let's just review briefly about how the auto login works, right? So if I look at DJ free samples /settings.py, you need to have this auth plugged in, right? So that basically that's a bunch of code, some views, etc. that comes from Django, and that's been there all along when you did your start project. Of course, then somewhere in here we've got to have the autos, wherever autos is. Yeah, autos app config. You get to pull the autos app in. And if I take a look at DJ free samples /urls.py, then I can find autos here. And there needs to be some kind of a link that basically says at the top level, everything below autos is delegated to the URLs file in autos.py. But also then there is the accounts, right? And so if you recall, this is a bunch of views that comes from Django for us. It's pre-installed for us. And the thing that we've got to do is we've got to build we've got to provide this a template with the name registration.html. So I think I've got this in home/templates registration. Yes, I do. So I've got actually two logins. I've got a really simple one is login.html, and this is the one I recommend that you start with. Later we'll use the social login. And this is very simple. It's a login page. It uses the Django Forms capability. If form.errors, that means that there was a validation error and it came back and redisplayed this page and showed you an error. And then we make a simple post form with a URL that is a reverse lookup to a view with the name of login. Then we put the CSRF token in, and then we take the form, and I'm just making this with paragraph tags. And so that's a simple login. That's not the actual one that we're showing. And then the next is a hidden value that you've got to pass in so that when you actually successfully log in, it knows to come back to autos when it's all done. It come back here after the login has been done. And so that registration/login, you can put this in any of your applications, but you want to name it registration/login.html. So if I take a look real quick and I go into home templates, these are all the templates. When I do an ls, you'll see that I have a home templates home and a home templates registration. You can have more than one folder here. And if I do look at what's in registration, you see that I've got this simple login and then later the more complex login that will give us the GitHub login capabilities. So we can log in using, what that means is log in use social. The point is underneath this templates, you don't have to just have one subfolder. You can have more than one subfolders. And so that is the necessary configuration to make it so that when we tell our views to add the login mixin, which we'll see in just a second, when we tell our views in the login to use the login mixin, then it knows where to get the template from. So that's just part of it. And your instructions tell you how to do that. So any application that you're going to build or any project you're going to build, you have to put those in settings.py, urls.py, and then make the template. And then you have to start using login mixin, and then everything just magically starts coming together. So let's take a look at the actual autos application. We'll look at a couple of different things here. Autos. URLs. And I'm going to do a I'm going to tab so I can switch back between files really fast. You probably have a better text editor than me. So I've got URLs. I'm going to take a look at the views. Nope. Autos. Views.py. Then I'm going to look at autos model.py. Models.py. And then I'm going to look at autos forms.py. And so let's sort of work through these 4 files: URLs, views, models, forms. Probably let's do models first. So this is pretty straightforward. We're going to make a make object class. It's going to have 1 character field with some validators in it. We kind of played with that with forms. You can put validators in models. We've previously seen validators in form, but there's a validator that basically says we're not going to accept data coming into this database table unless there's at least 2 characters. These underscore str, you've been doing this for a while. That basically is if you take a model object, an actual make, and you print it, it says which of the fields, in this case there's only 1 field, and so that just says when we're converting a model to a string, a model object to a string, we get to decide how that looks. Okay, and then we have an automobile, and it's got a nickname with a min-length validator, max length of 200, a mileage, which is an integer field, a comments, which is a 300-character field, and then a foreign key into, this is a one-to-many or many-to-one relationship, not a many-to-many, just a foreign key into make, and then we're going to do on-delete cascade, which really means if you delete a make, then the corresponding auto entries will automatically be deleted. And so this is a pretty straightforward model, actually very, very simple. And once again, we're always defining this stir __ self so that we know that we're just, if you're just showing it like in the admin interface, or if you're just printing it, or just converting the model itself to a string, the field among these fields that is supposed to be used is the nickname field, just to show to end users. So that's the models file. Let's look at the forms file next. So the forms file is interesting because we've seen forms that are just forms by themselves, but this is a special kind of form in that it's a model form, in that we normally in the other models we had all these fields, right, and we put them in, and it looked a lot like a model file where we'd have a character field, a positive integer field. But what we're basically saying is, you know what, we're going to make a form here, and really all we want to do is take all the fields from the make model and make them form fields. So a form and a model are 2 different things. A form is something that goes between sort of the view and the template, and as you'll see, it also goes down into the models automatically. But you gotta, so this is just like make all the fields, right? Let's make a form, because form objects don't have to be associated with models, but in this case we are going to sort of derive a form object from a model. And so instead of extending form, we're extending model form. So that's a model form must have, and this is just some data that says the model that we're going to pull all our fields from is the make model. And it only has one thing, which is a name. That's it. Okay, so this is auto-generating a form that if we changed it and added another field here, then this make form would automatically have a field. You can give it a list of fields, __ all __ is like a signal to say, just give me all of them. Now there might be some internal things like created at or updated at or something that you don't want to use. So that's a form. Remember how forms work. Covered that before. Let's take a look at our URLs. Now a lot of this looks pretty similar to things that we've done, right? We basically have a main table, which is our autos table, and our lookup table, which is our makes table. And we have sort of 3 things. There is the main list view, which is list all the autos. There is the main the make list view, which is list all the makes. And then we can make a new one, which doesn't have a primary key, because part of the idea is the create is making a new thing, which is going to generate a primary key. And then we're going to have a update and a delete. And so we have a read
create, update, delete. So it's not exactly CRUD, but you see all 4 of these things. And so we've got views, and we name these views so that we can reference them in our views themselves and in our templates, so we can make links in between them. Okay. Okay. So these are pretty straightforward and not all that different. So the fun starts to happen when we're in the views.py. So login mixin, if you remember from the auth-z walkthrough, you just add this to a view, and it just basically says you cannot get to this view unless you're logged in, and if you aren't logged in, it will bounce to the login.html file and then bounce back after you're done. And so login required mixin is all we need to do. If you go with the auth-z sample, you'll see like I did that by hand, but you don't want to do it by hand. You just call login mixin. Now, so this main view is a list view, and so let's go take a look at what this is going to look like. This is the list view. So we're going to take however many autos we have, we're going to loop through that list, we're going to retrieve all the autos from the database, then we're going to have an add the auto link, then a view the makes link with a count of how many makes there are, and add a make. So let me also then go into autos templates, autos again, yeah, I'm sorry about that, and auto list. So this is the template that makes that. And so there's a few things that we get. We get an auto list. Now the names of these are not forced upon you, but there's conventions that turn out in a moment. They're going to look really useful, okay? So we're going to get an auto list, and if we go back into our views, we see that we say get all of the objects from the auto table, all the auto class objects, retrieve them all, pass them in to the context as auto_list. Now we also want to be able to show that little count, this number 2. So we're going to ask, go ahead to the make objects all, but don't give me a list of them, count them and give me a number. So make count is stuck in there, and you'll see if make count is greater than 0, we can show the add an auto button, and it also somewhere, yeah, shows the make count, view all the makes, add a make, and the make count comes out here. So that's another thing we put in. The auto list we're going to go through, and that iteration variable of auto is going to go through each of the separate things, and nickname, make, etc. That's right straight out of the models.py file. There's the 4 things that every auto has, and we're just printing all this stuff out. You also get the primary key, and so we're going to make a update URL, and that URL is to autos auto update. So if we look in urls.py, we see this auto update looks up this, gives us a path to the view, but that particular path needs one parameter, which is a primary key, and so that means that this URL template tag autos has to have the auto ID. But because we're looping through the models, you got one, right? So, and you do an auto create, that's pretty straightforward. But one of the rules is you have to have at least one make before you can do an auto, because if you recall, add an auto has to have this drop-down list populatable, and that's being pulled from the make table, okay? And so that's basically the way around this. That's the main view. Now, just like I showed you before, it turns out that there are here we go. Auto create update. Yeah, that's the autos view. So, and then if we do the make view, we're doing the same kind of thing. If we go and look at the make list, we're doing the same basic kind of thing. View all the makes. This is and now we got update and delete. This way you don't need a count. We just want to grab all of the objects. We want to put it in a context under make list, and then we do make list under HTML, and this is even simpler.
is just going through the make list. It comes in through the context. If there's none, we don't print this out, and then we put out the name of it, and then we have an update and a delete button that goes to the update and delete. And of course those, if you look in urls.py, those also, the update and delete, have primary key requirements. And so you have a primary key that you got to pass in here to make that URL the proper kind of URL. And then just some links to go back to the various things so that we can, get back to autos, view makes, add a new make, cancel, all that stuff. Okay? So that is the views.py for listing the autos and the makes. Okay? Now, we want to make the make create view. Okay? So if we take a look at the make create view, that is add a make. That's going to create this form. I can make this bigger here. Create this form where you're going to put in a thing called Chevy. BY. So we need a way to make this form, right? And so we're going to make it a login required. We're not going to let folks do this. We're going to have some variables that are class wide, like what template we want to use. And success URL is after we have done this right. Now, if you just submit it and it complains, it doesn't do it. But once you've done it right, where do you want to go afterwards? So Chevy. Where do you want to go afterwards? This is a controller function. Boom. I want to go back to the auto list. And so the success URL is go to autos:all, which in urls.py is this main view. That's the name of the main view. Okay? And so if we go here, which template to use and which success URL. If we do a get request, we're going to build a form for the make. That comes from make form, but really it comes from the make model, which is just one string field. It's simple as that, right? We're reusing this. We're just saying let's make a form that pulls from here. We have to pass a form in because models can't be used to create this kind of a screen. That screen comes from a form, okay? And so if we take a look at the template, oops. If we look at the make create template, make form. So that is, that's the template we're going to use to make form. We're going to need form as table, right? So that's from how we did forms. Put the CSRF token, you make a table, that could be as paragraphs or as tables, but whatever, you need this form object. So you need to pass the form object in. And so here we are. We're going to make a form, and then we're going to pass the form object in, and then we're going to render it self.template, autos.makeForm, HTML. And then we're going to return that for the get. And then when we hit the button, the submit button, add a make, we hit the submit button, it's going to do, it's coming into the post because we made a form post, comes in, we're going to take the, oop, don't do that, oh, that's terrible. I hate it when VI does that. But here we go, we're back. Yeah. So, post comes in, request.post has all the key value pairs, which are these key value pairs as defined by the form. So we say, let's make a make form with the initial data coming in from request post. And given that the form generated it, it knows what the names of these fields are, and this is something that hides behind how forms work. But it also checks to see if the form data is valid. And that means, were all these validator rules followed? If the validator rules are not followed, if not form is valid, we're just going to send it back. And so so this code here, this if form is not valid code, if I put in a single letter, A, and hit submit, it's going to come back and re-render the form, and all that error stuff, all that stuff is all handled by this form code. This Django form code figures out what is wrong, right? this over just a little bit so I can get back to it faster. There we go. It figures out what's wrong with it, makes an error message. The error message came from models.py right here. Oh no, right here. And then went through forms.py because it is a form ultimately that we inherited from model form. Get it? And so that's cool. So that's the error condition. And otherwise we do form.save. Now the thing here is that's really super cool is because this form is a model form. It knows this, and the field names are the same as the field names in the model. And so it actually does a save on the model itself. So in a way, the form contains the model data that came from the post request, and then it saves it. Okay? That saves the form. It puts it in. And then we just redirect back to the request URL. So this is pretty succinct, right? We pull in the post data. We check to see if it's bad. If it's bad, we send it back, send the form back to the exact same template we did, and then we save it if it's good, and then we pop to the success URL. That is a beautiful thing. But just like in Django all the time, this is a far wordier thing to do, even though this is super succinct. And if you did this in almost any other language, you'd be like, 75 lines of code. And here we have like 15 lines of code. But it turns out in Django, there's almost always a more succinct way to do it. We have a generic create view. You can take a look at the documentation for this generic create view. Django views generic edit. Let's just go and Google this stuff. I always just put a dot here, and this usually gets me right to, because that's the actual package and the class inside the package. Oh no, sorry. It thought that was a domain name, so the search didn't work. But now I'll just say, Django something. Look like, so at least it's going to do the search for me. Generic editing views jump to the create view. So you can read through all this stuff, right? Generic create view. Actually, let's make do I have a reference to this? So there you go. Take a look at that. Now, this, just like some of the other views that we've inherited, have a ton of functionality in them. So if I want to do an auto create, this is all it takes. Now, auto create and make create, for all intents and purposes, do the exact same thing. So what happens in auto create, because we're extending create view, we have 3 bits of metadata. We tell it which model we want to use, which fields from that model we want, and where the success URL to go is. And then this generates all this code. We inherited all that code. You'll notice that there's nothing hard-coded in here except the make form. Now, we don't even have to make a form for the auto, because this code right here builds the form. And not only that, but it uses this name auto to pick the template. So if I do auto underscore form, I have to use this, right? I use this. That's my base bootstrap. Don't worry too much about that. And so it knows the name of the template that it's going to use. I don't even have to tell it which template to use in here, because it derives the template. Auto underscore form.html is the template. Pretty cool, huh? Pretty awesome and cool. So it automatically finds that and the success URL. And so this is all that's needed. As a matter of fact, I could, in this make create, I could have deleted all this code from here to here, but instead just do a create view by extending create view. So I'm just showing you this because I want you to see what's really going on. But this is not how you write your code. This is how you write your code. Okay, so now I want to show you the hard way of doing an update. So what's an update? Let's take a look at the code. So let's take a look at view makes. Update is the thing that happens when we go here, and that's going to go to make update. So here's make update. Here's urls.py. It's this one. Lookup primary key update, which then if you look under here, it's going to be autos lookup one update, right? So I'm going to update the Chevy one. It has to read the old data, has to show it to you, and then let us update it, and then submit it, checking, of course, for any validation errors, and then redirecting us back to a success URL. So if we look at the views, we're going to, again, foreshadowing, there's a much easier way to do this. So we set these variables, where the success URL, which template we want, and the model, okay? And then we have a GET request, and because in the urls.py, there's this int pk, we're passed in this pk value. Now, this get object or 404 is really cool, okay? So self.model, this get object 404, self.model pk equals pk. That's this parameter, but we're passing pk equals, and it's common that they're the same name, but this is a parameter to get object or 404. The second one is the parameter that was called to our get. Self.model, of course, is make, right? And get object or 404 basically checks to see if, so I'll do this update. Let's go to makes. Let's do an update. And what it's doing is it's taking this number, this 3 here, autos lookup 3 update, and it's retrieving the old data. Now, what happens if I inadvertently have a number that doesn't exist in the database, like 9,999, and I do a GET request to that one, I get page not found 404, right? And so what's happening here is somehow you say, hey, load this object and give it to me in the variable make, or just blow up and send out a 404 error, right? And so this is telling you what's going on, which view you just know make matches the given query. Now, generally, you're not supposed to hand type these. 3 works, and so it doesn't blow up. So get object or 404 is a way of loading the old data and then protecting, and using that data, or just blowing up. So don't go any farther at that point. Now, then we're going to make a form, and we're going to fill it with the old data. So the instance is make. So that's the object. Make a make form. Here's a make form. All the fields from the model inherit from the model make. And then pass it into the template make form.html, which we just looked at. This form comes in. That's all we need. This is very generic looking. It really doesn't care too much. It's all pretty much encoded in this form, which is derived from the model. Then, of course, we type a bunch of stuff in, blah, 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 and we hit submit, and it does exactly the same thing as the create, in that it does, well, first it has to do a get or 404, because we post to the thing with the primary key. We load it up to make sure we have an object to update. Then we create a new make form from that database and then change it. So this is the starting data, but then it alters it to the data. So in this particular case, Chevrolet is the old value in the database, and if I say bow tie, request post will have bow tie. This will start as Chevrolet, but in this form object, then it will be bow tie. Of course, if it's not valid, we're going to return an error message right back here. And if it is valid, we're going to save it, and so this new bow tie is going to be saved in there. And so if we view our makes, we see that it's now bow tie, right? And we're going to redirect to success URL. Now, at this point, I would hope you could predict about what's going to happen next. Auto update extends update view, the generic editing view. It says which model it is, which fields you want, and where to go when it's successful. Okay? And then it does everything that's in here, right? It does everything that's in here. And literally I could go and say the exact same words for make delete, which is what happens when you go in here and you delete, and then you have a cancel. There is a confirm delete, and the name of this template is not randomly chosen. It's got to be called the confirm delete, the model confirm delete, right? And there you go. You got a CSRF token. You're handed the make as an object in this, so that produces this output. There's no form in this one. There's just the make that gets loaded by object or 404, and then it passes make in and renders it, and then when the post happens, it retrieves it. If it's there, with a 404, again checking for bad data and deleting it, and then hopping off to the success URL. And it doesn't take much to guess what I'm going to do next, and that is, if you extend delete view, you get all that code for free. You just tell which model, fields, and where to go for success. And so the key thing is as you're doing your homework, I'm sure some of you are just going to like copy and paste all this stuff. That's wrong. This make create, the make update, and the make delete should be as short as auto create, auto update, and auto delete, because you're going to do this a lot, right? You're going to do these generic editing views a lot, and we're going to do CRUD over and over and over again, and you really do not want to write 15 lines of code. That's unnecessary repetition, unnecessary cutting and pasting and changing code, if you can keep it really simple. So I can basically build a full set of CRUD forms and CRUD functionality with validation for a model with this kind of code. And then I don't even have to have a forms.py, I just have a models.py. So if you're doing your autos, you kind of would think, I made a mistake if I'm making a forms.py. Because if I just use this views.py this way, instead of making all of them look like make update, then you're going to save yourself a lot of time and energy. And when you have to modify these things, it's a lot easier to find all the changes and then modify them. So that is a walkthrough of the sample code for autos. And you're going to do an assignment on this, but don't just copy everything. I set this up so that the time you spend understanding what's going on, particularly in the views, right? URLs you'll probably just copy. Models you just copy. The URLs you'll just copy. But the views, don't just copy it. Figure out what's really going on and come up with the easier and more succinct way to do all this stuff, okay? Because Django is starting to look really beautiful at this point. So I hope you found this helpful. Cheers.
So now we're going to talk about data validation. Data validation is what happens when you hit the submit button and then that data is sent to the server. And what the server does is it checks that post data that it's getting to see if it's proper according to its rules. So if you go back to this picture I showed you in the create form, the part we're talking about now is really this part right here, where the user has entered their data, they've hit the submit button, and we in the server are going to look at that data. And then we are going to decide if it's an error, send back a form, or store the data, and we're actually sort of just have a comment say store the data, and then go to the success. So we're really looking at this part right here of receiving and validating the data and then taking all those actions, okay? So the idea of data errors is, you're typing in a form and you forget your zip code, and you hit the button and a little red box pops up and says, zip code is required. Now you can also tell the fields in the browser that they're required so that the browser won't even send the data. That's different, and not all browsers do that. So you still have to check if you really want the zip code. You got to check to make sure the zip code is there. Now in this one I made it just to generate errors. I made a validator on that form, if you recall, that said that all the titles have to be at least 2 characters. And here's a little message: please enter 2 or more characters if that's not true. Because otherwise, you know, the fact that it's not a string or a number or whatever, because the browser is a little too smart for us. So I had to come up with a validator that would fail in the server and not fail in the browser. You still need to validate data in the server. So you type some stuff in, you make a mistake, like in this case, the title was only 1 letter. I hit the submit button, and now what I want to see is a thing that tells me what the errors are and gives me a chance to fix it, including putting the old data that I just posted, right? So it gives me my post data back. And then I get a chance to resubmit. So again, here's the data form, and the validator there it's a min-length validator. If you go look at the documentation, there's a jillion validators. This was really simple and it fits on a slide. So basically, in addition to whatever the fact that it's got to be a character field, I want it to be at least 2 characters. And that's not a crazy validator to have, because you know, you might have a post that says, look, you're not going to have a title of 1 character when you're doing a blog post or something like that, right? You might say, look, at least 5 characters. So now we're going to walk through that process. And so if you take a look at this code from the form, in comes a GET request, and that GET request is going to show up with some old data. It's going to create the form with the initial settings. It's going to build a context that it's going to pass into the render. Same render form that just makes the thing with the table tags and CSRF and form post. And so at this point, we are a GET request. We're returning a 200, which is returning the HTML for that page, right? So that's the first part of it. And that is in the edit process, get the old data, show it to the user, and give the user an opportunity to change the data. So now we change the data, right? And let's just, you know, say we didn't make any mistakes. You changed a few numbers, you hit the post, which gathers up all this stuff and sends it as a post request to the server. So then what happens is it comes into the post method. See how these class-based views are so dang pretty, right? So pretty. And it comes, and so request post, right? All that data coming from the form comes into request post, and you just construct the basic form and say, hey, basic form, your old data is from the post, and all the fields are named the right way, and the key value pairs. I mean, this is basically a dictionary, but the form made the key value pairs. It knew what names to name all the forms, so it named them, and so it's not surprising it knows exactly what to expect in there, right? And so it takes a look at the post data, and then it constructs us a form object, right? It constructs us a form object and basically says, if there was a validation failure, if not form is valid, then we're going to do one thing. But in this case, I didn't make any changes, so form is valid, so it drops down. This is where we would normally store the data off to the model, but I'm keeping this really simple. And then I'm going to redirect with a 302 to form success. The other thing I might do is put a message in the session so that the message makes it into here, but I'm keeping it simple. And the browser immediately comes back and does a get to /form/success, and then I return thank you very much. I might have pulled a message out, as we've seen in an example where I have, from the post method to the next get, I drop a flash message into something. But there's better ways to do that, and I'll show you that in an upcoming lecture series. And so that's the success flow, and it works great. Now, let's take a look at what goes wrong. So in this case, I got my form, I put in the wrong kind of title, it's too short, I send a post, it gathers up all this data, sends it along with the post, that comes in request.post. And so now, the form comes back, and now, form is valid as false because I violated a rule. Now the interesting thing is in this form object is not only the old data but also all the error messages, because at this moment it has constructed a form object and part of the form object is error messages. Okay? So if it's not valid, let's make a little context. Okay? Let's make a little context and pass that in, and then out it comes, and and at that point, that form as table is going to print out all of this stuff. All those error messages come back. So I render it back. Now, I render it back, and then of course you can submit it and maybe get to a success. Now there is one sort of interesting question about this page, which I have asked a Stack Overflow question about, and I'm not sure I'm ecstatically happy about it. And that is, this pattern is exactly how Django wants you to write it. It wants you to write this. And if you'll notice, I'm doing something I told you not to do. Django is telling me to do something that I don't want to do, and that is return a 200 at the result of a post. So I got a post. Now the key thing is, the thing that everyone will agree on is once you store data, you have to return a redirect. And so the Django people who've done this for years, they consider it okay to return the 200 and a page after a post if no data was changed. Now the problem is, if you hit refresh on this, you're going to get the weird funky message. But this is how Django works. And so I don't know what to tell you. I can write my forms differently. It's a few more lines of code in here, and I've written that, and I've made it so that I pass the error message and I serialize the form and put it in the session and do something. But I'm not going to fight City Hall on that one. I'm just going to say, if Django thinks it's fine, the thing we do agree on is if you're going to return a 200, don't return a 200 after you've saved data, because then you'll double save the data. Like you'll double commit a transaction, you'll double do a transfer, you'll double order, you'll do whatever. But in this case, all we did is looked at the data, came back, and then sent back an error message. So you can look at the Stack Overflow where I sort of argue for a little bit. So this has been a long lecture series. We talked about HTML, we talked about HTTP, how get and post are different ways of doing it. We've talked about the idea of how to fix the refresh. We talked about cross-site request forgery, CSRF, and how Django handles CSRF. And then toward the end here, we've talked about how to define forms in Django to sort of outsource all that HTML generation and how we do validation. Now, there's much more to learn on this, and we're going to learn more of the features of form objects as we go forward and build increasingly complex applications.
Hello and welcome to our tutorial on the Hello World application for Django for Everybody. So I am going to go in excruciating detail how I have this Hello World, how this comes out at drchuck.pythonanywhere.com. And now if you go to this website, you never know what you're going to see, because I have lots of Django projects that I can mount up on this URL, and I'll show you how that's all done. So, so let's go ahead and get started. I'm going to wake up my Python, just my Python for Everywhere, Python Anywhere dashboard, and walk through a couple of things. So I want to call your attention here to my left-hand side here. So you see that I've got a bash console and a bash console in the virtual environment Django 2. It's probably a good time to review what a virtual environment is. If you go back to your old installing Django on Python Anywhere, I have this assignment, and if you go back to this assignment, that's paw_install_md under the ASSN folder, you had this thing make virtual environment, pip3 install Django, and then work on Django, and then we would do Python 3 -m Django -- version. And at some point it showed you the Django version. And if you recall, this took some bit of a long time. And virtual environments are a way in Python for you to change the overall Python configuration and install things that the owner of this computer has not installed themselves. So, so Python Anywhere, they installed a version of Python, they may have installed Django, they may or may not have installed Django extensions, etc. And so you want to have more control over what bits of software are actually running in your environment. So instead of using a system-wide Python, you're going to use your own environment, and that's what a virtual environment is. And so this is creating files in your home directory, and if you go in under Files, so I'll go in under the Files tab of Python Anywhere. If you see it in your home directory, you see .virtualenv, and if you go in, you see one folder called Django 2. And that actually has lots of stuff. You don't want to include, you don't want to mess with this. That virtual env Django 2, .virtualenvs Django 2, that was created by you when you ran make virtual environment, and it downloaded a bunch of stuff. And then in that you could run the pip3 command, which is installing extensions to Python. Now on your laptop, you might be able to just run pip3 normally, and just install more stuff once you have it configured properly. But now we're on a shared system at Python Anywhere, so we have to do virtual environments. You can do virtual environments in your laptop as well. It's nice if you do it, but it's not essential. Sometimes you can just run pip yourself and have the system-wide Python get all your stuff. But sometimes your laptop can get messed up because systems like Anaconda or Miniconda really confuse your Python, and that's unfortunately because there are so many ways to install and reconfigure Python on your laptop that can get you in trouble. But in this Linux arrangement that we have with Python Anywhere, it's actually pretty easy. You make a virtual environment, it works pretty good. Now, every time you leave and make a new shell, you have to say work on Django 2, otherwise you've inherited the standard things. And so if I take a look at my dashboard, and you see I've got a bash console, and then I've got a bash console in the virtual environment named Django 2. And so if I click on the bash console alone, you see I don't have the work on the Django 2 prompt. Should be a sign that something's not going to work for you. And what you can do is you can always just say work on Django 2. And that says for the rest of this session, until that bash console goes away, I want to be using the Python that is part of my virtual environment. Now there's a command in Linux called which. So I'm going to say which Python. Well, now it might actually, this one might python3. So you'll see which tells me if I type the command python3, which python3 says, if I type the command python3, where's it going to load that code from? And you see that which python3 is going from the virtual environment, meaning I have installed a copy of Python3 in my home directory, and that's the one I'm using when I type Python3. And that's the essence of how this virtual environment works. So I'm going to log out of this shell. Okay, exit. We'll just exit. Okay, so now if I go back to the dashboard, I should only, so I have this one here. I'm not going to click on the bash console and virtual env yet. I'm just going to start a new console, and that'll start one up, and I won't be in the virtual environment. So that's the key. Every time you start a new one, you see I'm not in the virtual environment because it doesn't say Django. If I type which python3, that is my own local copy of Python3, and I don't quite know how that works, but it's not the system one, but I'm going to guess that is not one that's in my virtual environment. But there's other parts that of the virtual environment that are important. So that just shows you that. I'm going to exit out of here using Control-D, and that's going to close this. Now I can go back to my dashboard. Now, there's a really cool thing that you can do to make sure you're always in a virtual environment. And I do this all the time, almost without thinking. So I'm going to go under my Web tab in Python Anywhere. And if you scroll down, one of the things you were supposed to set up is this virtual env area. And I've got that path, the exact home drchuck.virtualenvs Django 2. That's got to be in there, or my online web application is not going to run and start. Okay? But I can also then start a console in that virtual environment. And that's how I created that console. And if I click on this, start a console in the virtual environment, it actually starts it and then does the work on for me automatically. And you see that I've got Django 2 here automatically. And so that means that sort of all my Python Anywhere stuff works. You'll notice I'm actually properly in the folder for my Django project, and that Django project is the one that's currently mounted into my, I'm going to exit out of here, and so close this, go back to the Web tab. And so back to the Web tab, there are these variables, source code, working directory, WSGI configuration file. Those are telling the Python Anywhere, which of the Django projects am I really mounting at this point? And we'll talk about these later. These 3 files allow me to have in my home directory on Python Anywhere a whole bunch of different projects and let me switch between them. The local library project, the Hello project, the DJ Free project, the my setup. And so this is how you switch it. Of course, whenever you switch these things, you've got to do the reload, right? So that's sort of my summary of virtual environments. And so I would say, ultimately, don't try to reinstall your virtual environments, right? I would install it once, and chances are good, if you did it right, your virtual environment is not broken. What is most likely broken is the fact that you're not using the virtual environment. So a lot of people are like, oh, I'm going to blast this virtual environment, trash it, and try to go all the way back to the install. Sometimes you might have to do that, right? But it kind of confuses your system if you are like running in the virtual environment and you wipe out the virtual environment, you try to remake the virtual environment, and it doesn't work so well. So just in general, once you get the virtual environment set up, leave it alone. Don't try to fix it. It's probably okay. Start a shell, say work on Django 2, and if it doesn't blow up, you're probably okay. Okay, so that's a quick review of what we have with virtual environments. And remember, this is PAW_install MD is the place where we set that up. But at this point, it's some time ago. Okay? So now that we've done all this, I'm going to go into my web tab, and from previous times I've got this virtual environment. When you switch applications or switch Django projects, you don't switch the virtual environment. That stays the same. That's just giving you Django and Python and all the Python extensions, the Django extensions that we've added. So I'm going to go ahead and start a console. Hopefully I'm not running out of them. I keep exiting them so I don't run out of them. So I'm happy at the point where I've got a bash console and it's in the right folder and it's working in the Django 2 virtual environment. So you see that. I'm working in the Django 2 virtual environment. I'm in /Django_project/first. Now, I'm going to say cd ... to go up a folder. And so this folder is Django projects. If you're using GitHub, this is what you check into GitHub. And so this has all the work I've done so far in this course. I've got my test site, which was the very first assignment, then local library, which was all those whole series of assignments where we're making books and authors and all that stuff, and that code's all sitting here in local library. My folder's called Django projects because each one of these is a different Django project. Checklist is something we're going to build later. DJ Free is what you're building, hopefully, about right now. But I didn't name it because I had this thing called First, which is, I should probably call this the beginning. But First is this application that you're building from scratch at this point in this kind of DIY hello world. So First, I made First by using a Django admin start app, and let's go to that, the Hello World page. Hello World. So, right, Django admin start projects DJ for E. That's going to make a subfolder within Django projects. You got to say work on Django 2 if you need it. But if Django 2 is already showing in your prompt, and you don't have to keep saying that over and over again. And then you're going to start an application within that. So I've gone down one folder into Django projects DJ for E. I ran Python 3 manage.py start app home. And so if I take a look at the folders, I've got database. I've got first folder, which is the name for the Django project. That's where settings.py and urls.py for the entire project. And then I have one application called home. And we'll talk about that in a second. And that is the sort of first application. And home is actually where the template that renders hello world is going to be shown. And so that's all good. And so I'm in project First, and I've done this other than I didn't name it DJ Free. I named it project First. Okay. Now, I say how to start Django new project if you're on a local computer. You're not on a local computer. You are in Python Anywhere. So let's take a look at some of the files and the important things. And again, the instructions tell you how to edit these files. Or let's just file the outline of the homework assignment. So let's go into, I'm going to open this in a new window, the web tab. Now, the web tab is really cool. There's a reload, although you'll see that there's reloads, little reload buttons all over the place. If there's a little reload, there's not one here. I wish there was in the console, but there isn't. But reloading it is when you make changes, okay? So the key thing here is this code section. And there's source code, working directory, WSGI configuration file. Again, I said don't change virtual envs. And then there's this error log down here under log files, Dr. Chuck Python Anywhere com error log. If you get the dreaded something went wrong with a smiley face, then you have to go look in this error log and scroll all the way to the bottom. But back to code and source code. So the working directory and source code are two of the three things you have to switch when you're going from one project to the other. And that is just the full path of the source code directory and the working directory. Working directory tells it how to find the db.sqlite file, right? So that is the file. And there's going to be many db.sqlite files under Django projects, one for each of the Django projects that I build. And that's where migrations, and so in every folder under Django projects, there is, here, let me go, cd ... I'm going to say ls-l star, that means in all folders, / db.sqlite3. And you see that there are a number of db.sqlite3s. And so it's important in the web app setup, I'll go back into first, cd first. It's important in the web app setup that you tell it where to go to get the db.sqlite3 file. You just edit this and you change it. Now, pretty much all this is the same, except the last part where it says first, and then you're going to change that. Now, you'll notice the path to the WSGI configuration file is not in your home folder at all. And so you just have to edit this. This is kind of in the system far, far outside your control, but it is the way that you tell the Django starter upper code that's part of Python Anywhere how to start your code up. And so here you generally have to get this path right, the OS path expand user tilde, which is my home directory, / Django project / first. That basically is the path to the Django project. And then you have to say first.settings. That has to do with the fact that this is the first module gets imported, and that's a object within the first module rather than a file path. So that's not really a file path, that is a module. Whereas that is a file path. And so you can switch back and forth, right? You can switch back and forth between many projects by changing those. There's two things you got to change here. You don't have to retype all this. You just change those two things. The word first, maybe it's local library, maybe it's my test app, who knows, but it's a way you change it. And then you go back to web tab, you change that file, the WSGI configuration file, and then you change the source code and you change the working directory, leave virtual environments alone, and then reload your application, and then you should see your application. Finish reloading, and here we are, drchuckpythonanywhere.com, hello world. So I've showed you how Python Anywhere and virtual environments work, which is sort of like the outer wrapping of your application. And now I'll just sort of show your application. Now, this all is described in the section under djfree_hello.md. Change the source code, change the, your virtual environment should already be pointing, right? And then you gotta, I tell you to change these things, your name is not first, right? So your everything, or I'm using first, you're using DJ free. And then I tell you to make some folders. So home is the first application. Underneath it, you're gonna put more in here. So you got to make the folder for templates, and folder for templates and templates home. The command to do that. So I'm in first, make dir home / templates. This is going to fail because it's already there. Yay! And then you got to add it again. Home templates home. Got to make that folder. So that you've got to do. I'll change that to put those instructions in. And then you got to create the file. Come back. Home / templates / home So I got to put some HTML in. I'm going to put it in hello.html, and I say hello world. That's it. So I've got it. Okay, so I'm in hello world. Now you may have to put some more stuff in here, but that is the text that is this. Now, let's talk about how it all gets to work. Now you've got to change the settings file, and in yours will be DJ free. Mine is first settings.py. I'm going to edit that. So there's a few things to look at here in this file. Oops. So some mistakes I've seen students do is this debug, you want it true. They're telling you to turn it to false if you're in production, but you're not really in production. You're writing your code. When you're developing, you want debug turned on, and that has to do with the fact that it gives you more detail when you make errors. Otherwise, it's very cryptic about your detail. So a lot of students will come in, I can't figure out what's wrong with my thing because it just says error. Well, that's because you have debug to false. Now, reading this comment, it's really quite reasonable, so I just remind you over and over, do not set it to false. Otherwise, you will have great difficulty dealing with your application. You have allowed hosts, which basically says who can hit this application, and you want basically anybody. That's anybody on the internet to hit it. Okay, so we have the apps here that we want. And so those are the things that you've got to do. Get debug right, get allowed host right, and get the apps right. Okay? So that's that file. Then you've got to edit the file first, or DJ free in your case, urls.py. And this, you'll put the admin and the home URLs so that you can eventually do the admin. The admin is less important in this particular first application, but you're going to need it soon enough, so we might as well just put it in. And then include the URLs from the home application within the first project. Okay? And then if we take a look in the home folder, pi home/urls.py, so here I just am going to import a template view, and then I'm going to basically route /. So it's basically routing. The global URL routes the no path into, come back. Global URL routes no path. There's like nothing here, right? There's nothing blah, blah, blah. There's nothing after it, right? / this. So it's like there's nothing on the URL. That gets routed into home.urls, and then I'm routing nothing within home.urls into just the template home/hello.html, and I'm giving it a name for no particular reason. Okay? And so those files, the first settings.py, the first urls.py, home urls.py, and the home templates home hello.html, those are the files that you've got to create. And then you go to your web tab and you make sure that your code section has pointing to the right folder, both source code and working directory. Your WSGI configuration has been edited to point to the right folder, and then load up the project-wide settings. And then I think I can hit back here. Yeah. And then make sure your virtual environment is right. Don't keep changing this. Okay. And at that point, you should be able to reload your application. Visit your URL, and it should talk. And if it fails, if you don't get that and it sends the little funky message, well, let's just do this. Let's just cause the message. So I'm going to come in here in this WSGI configuration file, and I'm going to mess it up. Okay, and I'm going to save this, and then I'm going to go back to the web tab, and then I'm going to reload it. And if this goes well, something went wrong. Now everyone looks at this and they go like, oh, let's run and get help. It's telling you what to do. You look here in this error log first. I'm going to open it in a new window. drchuckpythonanywhere.com error log, and then scroll all the way to the bottom. Now the weird thing here is all of your errors that you've done, right, are in here. So you got to get all the way down, right, and you got to look at the bottom, and you can even look at the times of these things. And it's a traceback, so just like in any Python, there's a lot of stuff that has nothing to do with you. But look at this one. Module not found error. No module named XYZZY. Error running WSGI application, right? And, you know, I just forced an error, right? And sometimes you can look in the server log to see it. If there's nothing that seems like it might be a suspect, you can check the server log. But the error log is mostly where you do this. So let me go fix that now. I made a mistake here, and I've got to change this to be first, XYZZY to first in the WSGI configuration, and then first again in the WSGI configuration, and then I save the file. Then I reload the application. This is up here in the file editing. I reload the application, and if all goes well, I should be able to reload it. So I hope this was helpful. It's a bit long. I wanted to just remind you of a whole bunch of things that can cause your application to go wrong. Part of the reason we're doing all this is so that your application can go right, but you've been working on the same application, and I want to get you focused on what it takes to build a new application and get that application running. Cheers. Welcome to another Django for Everybody code walkthrough. In this, I'm going to walk through the Hello World application that you've got to do. This is the DIY part of the course where we've been developing an application for a while, and you've been modifying an existing application, local library, and its catalog, local library project catalog application. And it's time for you to start fresh, and I want you to really understand what's going on. So I'm going to go through in some great detail. So this tells you how to get started, and we're going to assume that you're running on your local computer. If you're still running Python Anywhere, that's okay. I've got another video for that. So somewhere you've got a folder called Django Projects, and so I've got my folder in, this is a Macintosh, and I've done all of the installation. I sort of followed this installation. Now the weird thing is there's so many different ways that you can install Python 3 and Django on your computer. You might use Anaconda or Miniconda or pip or whatever. And so I haven't given you like every single possible version of how you might do that. You have to kind of figure a bit of that out on your own. I've been giving you some online resources. But hopefully, when it's all said and done, whether you've done a virtual environment or not, you have things like Python 3 running, and you have Django, -m Django, Python 3 -m Django version, and you can look at what is your current pip. In mine, all my extensions. You might not even be using pip for your extensions, but if I say pip freeze, I use pip 3 to install them. Yeah, I see all the versions of all my extensions, and if I look through here, for example, I can find Django extensions, and that means that I have Django extensions. And some of the problems that people have are like when they don't have the right extensions installed. So here I am in Django projects, and if I do an ls, you see all the projects that I've got. I've got the local library and my test site. Those are from before. This is, DJ Free is the one you're going to work on, but you're going to work on that and add stuff to it, and so that's a later version of it. I made another one that's just this first Hello World, so I can take a look at it, and I named it first. And so you would do a Django admin start project DJ Free, but I did a Django admin start project first, and that's just the name of it. And then I went into that folder, and so I'm going into the first folder, first, and then I did a Python 3 manage py start app home. And so this shows that I've got a home folder, then this first folder, which is the project-wide settings.py and project-wide urls.py, and of course the db.sqli3. Now, at this point, when you're in this folder and you've got these things set up, it might not hurt to do a Python 3 manage.py shell, because if this doesn't work, then you've got some configuration wrong. So the fact that this worked and didn't blow up with a big traceback, that suggests that I've got all the right stuff installed, and it's good. So I just have to Control D to get out of here. So there we go. That's a funny looking shell prompt, but that's how it is on my Macintosh. So that's weird. Your Linux boxes and maybe your Windows boxes look a lot prettier than that. But the point is, if you can't run Python 3 manage Pi shell, make migrations isn't going to work, etc., because this manage.py loads up everything. It loads up all of your applications and all the urls.py and all the views.py. And so you think, oh, just start a shell. Well, no, this is completely construct the Django application and then start a shell in that Django application. So if there's anything wrong with any of your files, well, you go, no, ignore this little part right here. The .quit didn't work. Okay, so let's take a look at some of the files that matter. So the first thing is that the folder that is the same name as the project folder, and my project folder is first. There is first/settings.py. And if you take a look, it tells you what to do here. A couple things I'll call your attention to. So leave debug true. Do not set debug to be false. Even though the comment right above it will encourage you to do it, what it really is doing is telling it whether or not to give verbose error messages. When debug is true, the error messages are verbose. When debug is false, the error messages are cryptic. Well, you're writing software. You need all the help you can get when you make a mistake. You want verbose error messages. So debug equals true means verbose equals yes. Allowed host, this is one we've had to do every time we make one, where we basically, that is the addresses from the internet that are allowed to access this application. And then start project sets this up, and then you have to add a home config, your home apps home config. And so that is the setup to get your home application loaded. And if you take a look at first/urls.py, and by now, if you've done stuff in local library, your URLs are pretty complex. We've got pretty simple stuff. We're just going to include at the base URL all the home URLs, and then we're going to bring the admin in because we're going to need that later. So that is the urls.py. So that is the first things, and there needs to be a, in your home folder, urls.py, you have to create this file, but I give you the exact text of this file. And we're going to use a template view, and we're just going to have a template name. Remember that templates are global, and so we kind of re-add the, I just dragged that, I undid it. We add the home/hello.html in a way to kind of create a global namespace of templates. And so that's your urls.py, and I completely give that to you. And then the last thing that you're going to edit is the home/templates home. Again, you have to do this twice. Hello.html, and against this last part, home/hello.html matches the templates in the urls.py, and you just put HTML in here. And I just happen to put an H1 hello world. Now, if we are sitting here and we've got these things all correct, we just say python 3 manage.py, run server. Now, this is going to connect to my local host 8000, 127.0.0.1/:8000. That's port 8000. And if you've got one of these running in a different window, it will say the port is already busy, but you're jacking into the port. If you go all the way back, we talked about the request response cycle and servers. You should remember about ports and how servers grab onto ports so they can listen for phone calls. So we are going to go into localhost 8000. Actually, just go on 27, doesn't matter. And so that retrieves our page. Now this shows a couple of cool things, because it showed the get. And so one of the nice things is you can watch things as they go on, and you see traceback errors and everything. And so I really like developing locally whenever I can, because I can really quickly switch from one application to another. So let me show you how I will switch from one application to the other. I'm going to hit Control-C to blow this up. So now there is no server. And if I go to this, it's going to say, sorry, I can't get that. And now I'm going to say cd ... I'm in my Django projects, and I've got a whole bunch of things let's go up one even more, and I've got DJ for each samples. So I've got this checked out, and there's a manage.py here, and I can say Python 3 manage py run server from this folder, which then runs that application. And now I can go to that exact same address, and I have a completely different application running on it. So this, and I can see the errors and favicons. This one actually has a favicon, I think. I don't know why the favicon didn't. Oh, maybe it doesn't do it for localhost. And so this ability to move around really quickly and start and stop servers in your Django application, and the ability to watch this stuff as it's running, is a real important part of why you'd run a local server if possible. And of course, I gave you a installing Django locally that does its best, because each thing is going to be a little bit different, and away you go. Okay, so in general, this is how my Hello World application is structured. There's really only 4 files that you need to edit and get right, and then you have to mostly the hard part for local running is getting your installation all done. So I hope this helps. Cheers.
So now I want to talk about a concept called virtual hosting. Like I said, this doesn't really affect you directly, but I want to sort of show you a little bit about how an organization like Python Anywhere can have a very small amount of resources and support a very large number of hosts. And this is the idea that they have one piece of hardware or very few pieces of hardware and many different domains running on that system. And this also kind of helps you understand why you have to configure Python Anywhere the way you do to help them route the request not just to the server but to your application within the server where your application is running. So if you recall, with the request response cycle, HTTP, it makes a connection to a domain, and then it sends a GET request with the domain in the GET request. And so here we have a little sample. We say telnetdata.pr4e.org, that's the host, and port 80, which is to say let's talk to the web server. And then we connect, and then we send the GET request. And the GET request has a couple of pieces, right? The GET request has, you know, the name of the document, including the server that it's going to, and then the protocol, and then a blank line. The key thing is you don't just say, get me any document. You actually tell it the host that you're looking for. And by looking at this, that's how the virtual hosting works. And so it says, oh, I'm one host really, but I can pretend to be many hosts and know which host I'm being asked for with that information. And so that's how the virtual hosting works. So when a GET request comes into a server, it can say, I have many virtual hosts inside myself, and I'll pick the right one. And so if we look at the browser's debugger console, we can see that it's asking and doing a GET request to a particular Python Anywhere URL, and with a particular domain name, and the domain name is part of the request, which is what makes their virtual hosting happen. And so this is where in the web tab of Python Anywhere, you've got to give this thing about where are you at. And you have to say, within this server, I'm running at this home folder, and so that's your home directory, you know, Django projects, local library, your working directory, where it's supposed to go when it receives a request for you. And then it has this one configuration file, and you'll notice that that file doesn't belong, that www.mdntutorial_pythonanywhere.com_WGSI, the WGSI configuration file is not in your data space. So that's actually in the system, and that's the place where the system can look up where you're going, and then that file, and again, if you read that file, you'll see it's telling where it's supposed to go in the overall system to start in a directory and load the configuration for a particular application, and up you go. And so this is kind of the picture of how it all works. You know, you got a browser out here, and that the browser is making many requests to this server, which is one piece of physical hardware, and then there's a little piece of software. Often it's a open source software called Nginx, and it has a whole bunch of configuration files that you put in their user interface, and it has little instances of Django, one for each of the domains in those systems. And so you're isolated from all the other ones, whether it's mdntutorial pythonanywhere.com, dj4e pythonanywhere.com, or just some other kind of thing. It doesn't even have to be Django, it can be just about anything. And so there are these configuration files that allow, and all this really accomplishes is reusing some of the server hardware so that you don't have to have a dedicated piece of hardware for every single piece of software. And then within that is what I showed you before, and that is how the request works in your settings file. But the goal of Nginx is getting it to your front door so that your application gets the requests that are destined for it. So this is both how these applications are combined into one server using virtual hosting, but also how applications work internally. And so I just wanted to give you a really short overview of how this all works so that you can build the picture a little bit at a time over the next few weeks as you learn this material. Hello and welcome to our lecture on owned rows in Django. So what do I mean by an owned row? Well, up to now, every CRUD application that you've written, you got a table or a model or two. Maybe they're connected, but basically if you log in, you can edit every row. And so if you do a list, you see an update and delete button on every row. Real applications don't work that way. If you're building a classified ad system, some ads belong to you and some ads belong to other people. You can see them all, but you can't edit them all. So you have to decide when to put the edit and delete buttons up and only do those for the owner. And we got to make it so you can't like sneak in and edit and delete other people's stuff. And so we have to protect these rows from being edited or deleted by anybody but the owner, but anybody can see them. And so that's why I call them owned rows. If there's a row that you own, you will see an edit or delete button. If there's a row you don't own, you'll see the row and the data and you'll be able to read it and view it, and that's it. And so if we go back to how we were working in our CRUD application, we were making heavy uses of these generic views, the generic list view. And so when we're all said and done, after a whole bunch of machinations, you ended up with a very, very simple view. You ended up with a horse list view that extended generic list view. Generic list view is provided to us by Django. And the only thing we had to do was take this code, which is several thousand lines of code, and inform it as to which model we want it to be, and then we make another view, right? So we make the horse list view by extending generic list view and informing that list view that we want to do this in the model with horses. And from that point on, all kinds of convention happens. And so we know things like the variable will be named horse list. It'll be a list of objects that are retrieved from the list of model objects that are retrieved from the database. And so we kind of know how that works. And it makes things really simple, not a lot of repetition. Every view kind of looks the same. You probably have done cats, dogs, autos, a couple of different things. And they all look very much the same. And if you get good at it, you should be able to make these changes very rapidly. So if we look at how this is working kind of from an object-oriented perspective, we are making a new class called gview.views.horselistView, and we are extending, our parent class is the generic list view, and we're sort of adding our own little special sauce by saying one class variable model equals horse. Okay, and so that's kind of what's going on here. Now, in this owner view, we're going to do something quite similar, and that is when we're going to have an article, and this is all from the DJ Free Samples My Arts example, we're going to extend owner list view. Now, soon we will look inside owner list view, and we'll see that owner list view is extending generic list view, and this model equals article is informing owner list view. The difference is this is our code that belongs to us. And in the last part, we will show you everything that you have to do to build one of these things. And so we're taking the list view, which has almost everything we want, and we're going to add one feature to it, and then we're going to extend the list view and create a new view called owner list view, or you might call it list view for owned rows. And at that point, you just you're good. And this has this class, owner list view, which we'll see in a second, has everything you need to deal with rows that are owned. And for example, we're going to have a owner column. So every article is going to have an owner, and if that's equal to the current logged in user, then we are going to show these little edit and delete buttons. But if the article owner, the owner value inside the article object, or the model, if that owner is not equal to the current user, we don't show it. Now, not showing a link does not mean you've protected it from editing. We'll show you later how that protection from editing happens. But this is such a common problem that we want to just be able to, in a sense, say, look, here's a list view. Here's a list view with this special owner column in it, and we want to maintain the owner column. We don't want to have to write hundreds of lines of code in every view that we want to have this owner column. So we just use object-oriented techniques to accomplish this. And so we're going to use inheritance, and we talked about it and we'll talk about it again. Inheritance is the idea that you have a class, you're going to make another class that inherits all that parent class and then extends it, adds a little bit of stuff to it. And it's another form of don't repeat yourself. Do something once in a parent class. You make the parent class sometimes quite generic, then you make a child class that extends the parent class, and then we use the child class. Or we could call them subclasses or child classes. There's a whole bunch of different terminology, and it's all pretty much equivalent. Subclasses are more specialized versions of a class. They inherit attributes and methods from their parent classes and can introduce their own. Again, basic object-oriented programming. So up next, we're going to talk a little bit about how it is that we can peek into one of these generic views and add our own special sauce for it. So now we're going to take a look inside of a generic edit view, and we want to look at how it functions internally so that we can override and extend some of those functions, so we can take the generic edit view and turn it into a edit view that supports an owned row. So this is a review. We've gone back a couple of lectures. This is the edit form flow, right? And I went through this in great and gory detail, so I'll just review it really quickly, right? So you've hit the edit button, right? So you do a get request to like /1 or /15. You're going to grab that data. Oops. You're going to go in. You're going to load the primary key 1 or 2 or 15. If you didn't find it, you're going to send in 404 error, and then you're going to fill the form with old data. The user's going to edit that data. They're going to post the good data. Then the form is going to be validated, of course, according to the form rules. Remember, the model kind of deals with the back end, and the form kind of deals with the front end. So the validation is a form aspect, and then if there's an error, it goes back and allows you to redo it. And then if there's no error in the submitted data, then we load a new model up. We reload the model, check to see if that model is accessible, and accessible is going to matter a lot to us in a second. If it's there and you can read it, and you're legally allowed to read it, great. Otherwise, we're going to give you a 404 as you're submitting the data, and that has to do with if they messed with the form or something, or they're submitting it to the wrong URL. But if we can get the data, we change the data, and we store the updated data, and then we do the success URL, right? And so that's the basic form flow. We did that before. We did that with every one of our CRUDs. And we also looked at this documentation in the generic list view. It could be in some of the edit views. At some point you will see in the Django documentation, it's telling you how this class is functioning internally, how it's working its own magic inside itself. And this is method flowchart. First it's going to call setup, then it's called dispatch. Check to see if the method's allowed. Get its template name, get a query set, load the data from the database, get the context object name, get the context data, and then render to response. And so you might say, why are they showing us all this? And the answer is because we can get our hands in and mess with these things. And these are like our access points into this generic list view class that allow us to dig in and make changes. And so if we were to look at that same picture and think of it from the point of view of which methods are being called at the moment where this generic edit, in this case it's going to be an edit view, this generic edit view is happening. So here we go. So the GET request comes in, it's got some primary key, so it does a GET query set, and it reads this thing, and then it reads it using GET query set. It's still reading it, but it happens to be doing it in a method called GET query set. And if GET query set works or doesn't, then it keeps on going. Then as it's rendering the template, it's going to get the context data by calling a method called getContextData. That's another place that we're going to play with, and we're going to inject ourselves into getContextData. Then we'll do the edit, the post will come in, and then it's going to do validation, but it does it in a method called formValid. So the first thing that happens upon the receipt of post is it checks to see if the form is valid. We're going to add our own little code into formValid as well. If it goes back, it does a render, so it's going to use getContextData. If it is good, there's no error, then it's going to actually call getQuerySet again to get the data, and then it's going to modify the data, and then it's going to store the data. There's some name for this, but I didn't put it in. The point is, each of these moments where there's something critical going on, formValid getQuerySet, that's a place where we can extend the behavior of this built-in class without knowing too much about the class. And I showed you at the end of a few lectures ago this crazy override. I did this crazy override where I made this weird equine view, and I have a model of car and a template name, and then I'm overriding getQuerySet. So this is extending generic list view, but instead of using the getQuerySet that's in generic list view, we're going to call our own getQuerySet. So instead of reading car objects, we're going to read horse objects. And then we're going to return a list of them, and that's what the getQuerySet has to do. The rule of getQuerySet is you get called, you have to return a list. If we didn't write this code, it would do this except with car. But we did write this code. Why? Because we wanted to override it. Was there any logic to it? No, just because I wanted to show you crazy things, right? And so because I've overridden in the generic list view, it's not calling the generic list view's query set at all, which would look at the model car, but instead it's calling mine that's in wacky equine view. And so when it prints out, you see a list of horses, not a list of cars, because I overrode what behavior was inside the list view class, which normally would be informed by that, but my code in here ignored it. Again, I have no purpose for this other than showing you that I can change the behavior of the parent class while creating a derived class. Now sometimes, in this case, I'm just completely overriding it, and it's like, I don't care what you were going to do before, I'm going to do something completely different. And you have to know what the rules are. I had to know what the return. It took me a while to write this, and I might have even looked at some Django source code to figure this out. But eventually, through Stack Overflow, I figured this out. So this is not trivial to write, and I'm not expecting you to write this. I just want to show you the technique. Like this keyword args, that's something. I'm sure at some point I knew what it was, but I just stole that off of Stack Overflow like everybody does. So, in this def get query set, you'll see that I have just overridden and ignored the def query set from generic list view. Okay? That's one way of overriding a method. Another way of overriding a method is this getContextData. So what is getContextData going to do? Well, at some level, getContextData is what puts in this list ends up going into horse list. Right? So that's somehow this variable that I return here in query set ends up being put into my context as horse list, so then I can write this loop that prints that stuff out. And that's by convention, right? It actually looks at the type of this thing and says, oh, that's a list of horses, so it makes up the variable and puts it in the context. Now where that's being done in generic list view is in a method called getContextData. And so I actually don't want to completely replace getContextData, although I probably could if I want, because this is so simple. What I actually want to do is I want to augment the context, and I want to throw something else in it. So what I want to do is I want to run the code from generic list view first. I want to get the context back from that, and then I want to add something to it, and then return sort of like this composite context. Okay? And it's not, the syntax is a little scary, but it's okay. So let's take a look at get context data. Just like anything, self is the instance. Self is always the instance. KW_args is just a way of taking all the parameters so I can pass them in. So what I'm going to say is I'm going to say, hey, super. Super is like calling get context data in generic list view. So go into my super class. Wacky Equines view is a subclass. List view is my superclass. Super, get context data, and pass whatever arguments were going in there. We're all good. So just call that. Do it. And pass in all the arguments. And do whatever. And that's what ends up putting in horse list. And so at that point, context is going to be a dictionary that has horse list in it. But then I want to put some more stuff in. So then that goes into generic list view and then comes back out of generic list view and gives me, and if all I did is return to context, then I really wouldn't have changed anything. But what I'm going to do is I'm going to throw in this little extra key called crazy thing and put the string crazy thing in it. And then I return all that, and then eventually it goes into the template, and this context finds its way into the template. And again, that's all inside of generic list view, and eventually horse list is there because of the call to the super, and crazy thing is there just because I explicitly put it in. And so I have augmented without replacing. The first one I completely replaced get query set. In the second one I called the parent and then I augmented the return value and then returned kind of the combination of what the list view did and what I want to add to the list view. So we're going to use both of these techniques coming up when we start talking about the owner list, the owner.py code, and how we can then jack in to this generic code and implement our owner field. So that's the next thing that we're going to do. So hello. With all that as lead up, we are going to finally start taking a look at how we actually build this owner list view. So let's take a look. So the basic idea is we're going to make a new class called owner list view, owner update view, owner create view, a whole series of classes that sort of mirror the generic ones, and we're going to add our own little sauce. And we are going to basically make our owner list view, which is going to extend generic list view, and we're going to extend owner list view to create article list view. So the thing we ultimately end up with as our view is sort of 3 layers deep, where we have our view that extends another one of our views that extends a view that came from Django. And so there we go. And so things like article list, HTML as the template, and all that convention, and the name of the variable article list, that's all convention. And we've been doing that quite a bit. So let's start with the models changes. Now in this model, everything except one line should be familiar to you and pretty comfortable. The only line that's a little bit different is this owner line. So it's just another field. It turns out to be an integer. It's a foreign key, like all foreign keys are integers. And on delete models cascade, you have seen that before. That simply means if we have a bunch of articles that are linked to a user and we delete that user, it deletes the 4 articles that were associated with the user in order to keep the internal pointers consistent. So that part is all the same, quite comfortable, and you've been doing that for a while. Now, settings, auth user model. We're importing settings from Django, and we are making a foreign key to a model that is not ours. It is something that Django maintains. Django always has a user model somewhere. It may be named one thing or a different thing. We just don't know. We don't know what the name of the user model is, and so we have to ask Django for it, and Django conveniently always leaves it in this location, settings.auth user model. And it turns out if you want to change it, you got to change that variable. But for us, we're not going to change where it's at. Django's going to set it for us, and we're just going to use it. So there's 2 tables. There's this article table and some user table somewhere, and there's a foreign key relationship between them in a database level. And once you make this database, you could go see what the name of that table is, because it will show you the create statement that it actually used. Not that that matters. And so it's pretty much a normal old thing like we've been making, except it's got this extra owner column. And that's what that's the thing we're focusing on right now. Okay, so the views are going to be pretty straightforward. The thing you're going to see about the views is we're not going to use the generic list view, the generic detail, the generic blah, blah, blah. We're going to make our own. These are made by us, myarts.owner. So we'll see owner.py in a second. And so article list view, which is we got a urls.py that routes here, is going to extend owner list view and say, do this model. Things like the template name and everything, that's all done by convention, right? So we're going to have a detail view, a create view. Now the one thing that's different about the create and update is there are two things. There's a form, which tells what shows up on the screen, and then there is the model back here that shows up what ends up in the database, right? So the model, article model, is what's in the database. The form is what we show on the screen. So the model is which model is in the database, and fields are which model fields are to be put on the screen. We're not going to show all of the fields on the screen. In particular, we are not putting the owner field in, because we're not letting the user say this is owned by number 12. If it's owner 12, great. That number 12 is the current logged in user. It's not something we let the user see. So we don't put owner in here. We put the title in the text. We don't put updated at or created at, all the things from the model. We have to tell that we want this to put in the form and that to put in the form. This is going to be handled internally, and all these three are going to be handled internally. Owner, created at, and updated at are handled internally. Text and title are to be shown to the user. And so here we are in article create view, and we're saying this is the model, and make a form based on that model, but only for two of the fields. Ignore the other fields. The same for an update, and then the delete, it doesn't use an actual form, so you just tell it which model it's going to use. So again, this is a triumph of don't repeat yourself. All the brains of this operation are really add an owner column, add an owner column, and then extend these classes that we are about to make. Extend the classes that we're about to make. Now I want to show you how to make the classes. So I show you the easy stuff. Now we talk about the hard stuff. Okay. So this is the owner update view. And so let's take a quick review of the owner update view. And when we first do a GET request, if we go look at the documentation, it says, oh, I want to show you the old data in a form, and I'm going to call a function called getQuerySet in generic update view. Okay? And if I can't get anything, if I don't get anything, I'll give you an error. So this is like to a URL like /edit/2. And if the 2 is not in the database, then you're going to get a 404. So we call getQuerySet. Okay? And so let's just take a look at getQuerySet. So the way we're going to do this is, because we're in the middle of an update, the user is intending to modify it, which means we're not going to let them modify it unless they're the actual owner. So what we're going to do is we are going to override the query set. And I just put a print statement in for yucks. And so the first thing we're going to do is get the default query set. This is going to pick the model that we're going to query, and it's probably going to say something like, the primary key is whatever that number was, 2 or 14. And so we're going to actually get a query set back. And so that says, super, go into owner update view, no, not owner update view, go into update view and go run its query set, and then give me back that query set. And then what I'm going to do after I got that query set is add a AND clause to filter it that says, okay, whatever that primary key was, fine. And the owner column of this model must match the current logged in user. And so it's like I'm adding a where clause and an and to the where clause. The other thing that you'll notice here is login required mixin. I could have put login required mixin on all those in the views.py, but I need to have this variable self-request user properly defined, which means any owner update view, you really can't use it unless you're logged in. So it's like, I'm going to put the login required mix in here. That's like a marker interface that says, look, If you're not logged in, send them to log in and then come back here. And if they can't log in, I'm never going to let them run this code. Because if you let a non-logged in user run this code, it would blow up right there. So in a sense, this is like a guardian pattern to say, don't even bother coming in here if you're not properly logged in and you don't have a user object properly passed in as request.user. And so that's why I put login required mix in there. So the key here is we're going to do a where clause, that is where ID equals 7 and owner equals 14, whatever the current logged in user is. And so that means that when you come in here, if you're trying to edit a thing, you're going to get a 404, right? If it doesn't exist, you're going to get a 404, or if you don't own it, you're going to get a 404. 404 is not found, and it's legit to say it might be there, but you didn't find it because you were trying to read it for updating. So by changing the get query set, in a sense, to return 0 records when you don't own the record, because this is an update view. If you look at the list view, it doesn't do any tricky stuff because you can list them all, right? And so a list view is no big deal, a detail view is no big deal, but an update or a delete view, yeah, detail view and list view are good, but an update and a delete, you have an intention of modifying it, so we're not even going to let you retrieve the record if you don't own it. So we do that by overriding the query set, calling super, and then augmenting the query set when we get it back so that it accomplishes what we want to achieve. So the next thing we're going to look at is how we actually store the data. And the storing of the data is in form valid. We're going to override form valid. And what form, remember when the post data comes in, we're going to, it first calls form valid. That checks to see if the things are the right length, if it's a date, it's the right format. Who knows what it does, but we're also going to override it and stick our own code in form valid. So yes, it's going to do all those checks, but also we're going to do a little sneaky thing to make what we want to do that's going to solve the create and update situation, but it's mostly for the create. And so in the create view, it sends out a blank form, and then in comes the data, but we never showed owner. Let's go back a little bit, right? So if we're going create view, the form that we're going to send out is title and text. There is no owner field. Now this owner is required, and so we have to get the owner in. So what we do here, it's really quite simple. We're going to, so there's a form object, which is kind of like the UI side of things, and then there's a model object. And so form.save commit equals false says just copy the data into an object as if we were going to store it, but don't actually store it. Commit equals false is make it, but don't store it. And then we're going to add the owner field, which is there, to be self-request user. Now self-request user, remember, is like 16. It's some number. It's the primary key of the user. And so that's going to copy 16 in here. And then we're going to save it. But then we're also going to do the validation and call the super to do form validation for us. And so we're calling the create view form validation as well to make sure everything else is done properly. Okay? Okay, so when it's all said and done, all we have to do to make an owner work in this situation is we add an owner column, foreign key to the right place, we import owner delete view, and then we just extend owner delete view to make article delete view, and then tell it which model to work in, and then the magic all happens. So I'm not going to show you owner delete view, just you know that it's going to force login, and it's going to only let you delete rows that you own in the system. And so this is really a neat example of how you can use the object-oriented pattern to extend these existing things and give features that you want to add to them. I'm going to guess the first 10 of these are going to be just add an owner field, because it's such a common thing to have a database rows that have an owner field in them. But you know, we can do other things beyond just an owner field. And it again is a nice review of object orientation. I'm just going to hit object orientation over and over and over and over again because it's hard to get it, and I want to tell it to you as many times as I can. And again, we don't like putting, don't repeat yourself, lots of boilerplate to do this owner. You could do it all in a view, you really could, but you really don't want to. You want to basically make an object yourself. We've been using other people's objects. Now we're extending object classes to make our own classes and then using those classes. So it's a good example of how we can save a lot of time and energy with object orientation and inheritance.
Hello and welcome to another walkthrough for Django for everybody. In this walkthrough we are going to play with crispy forms. Crispy forms are a good example of how Django just has something and you plug it in and things just get better and it doesn't take much work on your part. So the simple thing is let's take a look at a boring form. This is the kind of form we've been doing in our CRUD. And I'm using a form to do it, and all I have to say is let's just make that a crispy form. And now things are pretty. They got all these colors. They got the highlight. There's a bunch of CSS. Forms are actually, the markup of forms is actually surprisingly complex. If we take a look at the markup in this crispy form, it's got some CSS in there, and it's just, there's a lot to it. So if we look, we got all these classes and fancy stuff, and so crispy takes care of that for us. And the key, I'll show you in a second, the key difference is just not that big of a deal. So let me walk through the code. So here is my crispy URLs. So what we're going to do is use the same view and just switch between two templates, one called boring and one called awesome. Crispy is Urban Dictionary for awesome or cool or whatever. I'm not sure how cool of a word cool it is, but it doesn't matter. This is a riff on some of the forms code. This is a real basic form. I don't have any models in this one, and so I'm just using forms and putting them on the screen. And so I just got a simple form with a string, mileage, and purchase date. That validator so I can make some mistake. And this is just a view, just similar to other things we've done in forms. I'm making a class that extends view, and I've got to set this template name to none because really what I want to do is I want to pick the template name here in urls.py. Something about how Django works, you've got to put this in so that then you can override it here. And I like putting templates in here and success URLs in here when I possibly can. It just seems like the routing is going on here in urls.py, and so I like doing that. So you'll note there's only one view, but we're doing two things, and that's because we're just taking self template name and doing the exact same thing. And so the boring form, it basically is loading some old data, making a form, pulling in the initial data for that, and then passing it into the template and then rendering the template. The post, if I submit the post, this would be saving the data. You read the post data, check to see if the form is valid. If it's not, send an error message, and then if we'll see a flash message. I'll show you that in a bit, and then we just redirect to a reverse. So let's just see, for example, what happens if we violate a rule. We get this, please enter 2 or more characters. And that's something we've been doing before, and that's just kind of the get post of an edit form. So let's take a look at the template that creates this, right? We're going to do base bootstrap, put a title in, override a welcome. So if you take a look at base bootstrap, I should add a link here to show you base bootstrap. cd.vi home templates base bootstrap. So base bootstrap has a number of different blocks that we can override. The title block, the head block, which is some material to put before the /head, a navigation bar if we want it, a welcome message, and then we'll talk about these little flash messages in a second, like alert messages, and then the content, and then some footer. Maybe we want to put some JavaScript in at the bottom of a page. And so we've got these hot spots in Bootstrap, base Bootstrap HTML. So we're going to extend it. We're going to set the title. I'm going to put an H1, which is like a welcome. It's the beginning of the body, and then there's going to be some messages that come in here in a second. And then here's our normal block. So we got a form. We have to put the CSRF token in. That just puts out that input hidden tag so that we avoid cross-site request forgery, CSRF. And we're going to use form as table. Form is the context variable. As table basically renders it as a series of table rows. And then slash table. And so if we do an inspect element here, and let's do page source because my screen's too small so that you can see it on a sweet little mobile. So it's got the table, and then it's using TRs and THs and slash THs and just kind of putting it out. Not a lot of CSS. It's using the table so that these things can be lined up. That's what it tried to do. It has some aesthetic, and away it goes. Okay, and so the form as table, like if you make a mistake, this ends up view page source. Close that one. You see that this is just another somewhere here. Where's the error message? Yeah, it's just another table row, and it uses the table, and the table helps it do all this alignment, but it's not very pretty. Okay, and so then we have the table, we have our submit buttons and our cancel buttons, and we end our form. And so we've been doing this now for a while, just making boring forms. So let's start by, so if I go to awesome, so I go to cancel here and I go to the awesome form, then I am going to render, right, crispy awesome HTML instead. And so let's go there. So it looks almost the same. So here's boring, and here is awesome. So most of it is identical. It's extending base Bootstrap. It's setting up a title. It's putting up a welcome chunk. But then we have this. So this is, you know, when you're using a curly brace % load crispy form tags, that's like running code basically, like the URL, this curly brace URL crispy main.py. That's running code. It's like the reverse. It's calling reverse to compute a URL given a string as a parameter. So this is sort of like making sure crispy is loaded for this page. If you do not do that, then this curly brace form vertical bar crispy will not work. Then the rest of this form is identical, except we just don't tell the form to render itself as a table. We use vertical bar crispy here, form vertical bar crispy, and this is called a filter. And we'll see another filter in an upcoming video where we'll make actually one of these filters ourselves. So we're taking the form object and piping it through a bit of code from the crispy library. And so that renders, it's not in a table, that renders all of the HTML for title, purchase date, and all that stuff. And it has all the CSS and makes it all gorgeous, right? So that's what it does. So form crispy does all that, and that's the main difference. Other than loading crispy form tags, that's the key thing. Everything else is the same. We had a table, form as table and slash table, and then we load crispy form tags, and then we just pipe form vertical bar crispy, and everything else is the same. And then we get this beautiful crispy form. And it makes things consistent. So you just use crispy forms. I'm not saying you can't build your own form system, but for me as a software developer, I like starting out with something that looks half pretty, and then away it goes. So that's crispy forms. That's how you use crispy forms. But let me show you a little bit more about how that works. Let me close a couple of my windows. So one of the things that happens is you've got to load in your settings.py, you've got to add crispy forms to your installed app. So that's when you're, so if you do like Python 3 manage py check, you've been doing this a lot, it loads up all these things. And so it's checking and loading, and it's reading through the settings.py, it's loading all of these things. Like this humanize is a thing that we'll talk about that later. Django extensions, we'll talk about that later. All these things we'll talk about later, but crispy forms is a code library that you're at that point pulling in. So if you don't put that in, then crispy forms is going to blow up. It's going to blow up right here because it can't load the crispy form tags. Okay, so that's the first thing. But then you have to install this, and you probably don't recall in the very beginning I had you check out, let me go to that, www.dj, I got it right here, djfree.com, lessons, installing Django on Python Anywhere. So if I look at the assignment specification you did a very long time ago, you make a virtual environment, you go into your virtual environment, and then I told you to go grab DJ Free samples. This is in the very beginning of the class, and I told you to pip install -r requirements.txt. And requirements.txt is a file that looks like this. And what it does is pip reads this file and downloads a bunch of extensions. Django Crispy Forms, Django Filter, Django REST Framework. And so literally now for weeks, you have had these all, it's installing it into your virtual environment. And that's why sometimes if you run Python check and you're not in your virtual environment, it'll blow up. But then I say, oh, well, go into your virtual environment and it starts working, right? I need to run server because I'm running this locally. Okay, so because you installed these things into, you installed the requirements into your Django 3 virtual environment. And so that's why when it reads the settings.py and sees crispy forms in the installed apps, then it's like, oh, crap, you know, I don't have it, but that's because you're running the loading of this file not in your virtual environment that has all that stuff installed. And if you're doing this outside the class, you will want to make a virtual environment and then do the pip install for requirements.txt. So that's two prerequisites. Edit settings.py, make sure you have crispy forms in your requirements, and then pip install from the requirements. And then it's pretty simple. You just load the crispy form tags and then pipe the form object in a template through the crispy filter, and then you will get gorgeous forms without hardly even trying, and you just keep using it. So that's our summary of crispy forms. I hope you find it useful. We'll pretty much use crispy forms from this point forward in the course. Cheers. Hello and welcome to a walkthrough for Django for Everybody. So the walkthrough that we're going to be doing is the walkthrough for the My Articles, which is really focusing on the notion of owning rows in a model. And what I've got going here is I'm logged in twice. I'm logged in one with a user ID of 1 and the other is a user ID of 2. So let's just do a quick demonstration of what really owning rows in a model is. So here I'm logged in as my first user, and now I'm logged in. I'm using a separate browser because this is Safari and this is Firefox. You can't just do this with tabs because the cookies are shared between tabs, and so you can log in and log out. I want to just be logged in simultaneously. Okay, and so I've got two of these tabs. Refresh. So you'll notice that the edit and delete buttons show up differently for different users, and that's because this row in the table lawnmower belongs to this user, user number 2, and this row, these two rows belong to this user. So if I take a look at administration and I go down into groups, not groups, users, now I can kind of hover, figure out that CSEV is 2, you can kind of see at the bottom there. And DJ Free is user 1 and CSEV is user number 2. So those are the primary keys in Django's user table. And now if I go and I take a look at these articles, you will see, and this looks a lot like if you were looking at, say, your autos. Here's the rows or the models in articles. And if I look at lawnmower, you see that there is a title, some text, and the owner is a drop-down. And that's because this is a one-to-many field. This is a one-to-many field between the articles and the users. And then if I switch to a different, so that's CSEV. So CSEV owns the lawn. Yeah, CSEV owns the lawnmower. I'm logged in as DJ Free here. Oh, no, here. That's my name. I'm DJ Free. And if I switch to the trombone, we'll see that that one belongs to DJ Free. Now I can sit and edit this in admin, right? But that's not the point. The point is to build software. If you'll notice, when I create a new article, it doesn't ask me what user it was, right? So this is where you would say Dodge or whatever when you were doing cars. So this is like a race car, slightly used, neon. So now I have another one, right? And so the key thing is it looks like a create from things we've done before. And if I look at my articles, here's this, but somehow magically this owner field is populated. And that's the essence of owned rows, is we've got a row, a column, and these are marked, and we know in all our code, we know the difference, for example, between things we own and things we don't know, things we own and we don't own. So if I hit refresh over here, there's a slightly used race car, but slightly used race car, but I can't edit it, right? So that's the ownership. Now, I don't know where to start. There's a lot to cover here. Let me show you. I don't know. Okay, I'll just start with where we always start. Let's start with, I'm running this locally. I don't know what that bug is there. That's not a bug. So this just looks kind of like your autos. If you look at it, it looks pretty much like the autos. I might add a mileage or price in there or something. The only thing that's really different at all is this. There's a foreign key. Now in your autos, you had a foreign key to makes. And the key difference here, the only thing that's new is this idea of where the foreign key is pointing at. Now the problem is in Django, there is actually a table that all these users live in. And I can probably come over here and type tables. And I can see it. I think it's probably here. So let's just try saying select star from auth user. So we should see a bunch of rows. And so there are my users. CSEV, it's all jammed together in DJ Free. So this is row 1 for DJ Free and CSEV. So there is a table and a model. The difference is we're not allowed to know that this is the user model in the auth application. And so what happens is we have to let Django tell us what the name of that model is. And so we go into settings, which is settings.py actually. And we're going to pull in the settings.py, and the default is auth user model, and that's the name of the model. And so this is a foreign key to a place that we don't exactly know, but Django will tell us and put in a string here. If we were to print this out, we would see what that is. That's just a string, but it's not a string we mess with. On delete cascade, that's just normal. The kind of parent row, the one row is in users, and if you delete a user, that means that all of the rows that belong to that user will get deleted because on delete cascade. I'm choosing that as the model. And so you see created at, if we go into that back into you see all of these things. Now created at admin doesn't show. It's pretty smart knowing about created at and update, so it doesn't bother doing that. And it actually updates them automatically. So it knows something about created at and updated at in admin. Okay. So that is our model. If we were to take a look at my arts article, we will see that there is a foreign key right there. There's a foreign key. And if we say select star from my arts article, we will see that there is a foreign key in there. So this row belongs to user 1, this row belongs to user 1, that row belongs to user 2, and that row belongs to user 1, which is perfectly reflected here. So now I am user 1, so I can edit 3 of them, And now I am here with user 2 and I can edit one of them. So I'm editing the ones where I own it. So ultimately we're going to write a bunch of code so that these numbers are properly updated. So when you add the article, it works the way you want it to work. Okay, so let's just take a look at urls.py. It's pretty boring. This looks just like autos. I probably hoisted up success URL here, put that in the as view as a parameter, and so that makes my views even simpler. My arts : all points to that view. I think it actually is kind of prettier to put it in here because this is sort of a URL place, and so it's not in my views. So that makes my views really succinct. And so it's like what you did once you got your autos down to like just using the generics. And so I have a list, a detail, a create, an update, and a delete. And I have a model called article, which I just showed you. And I am going to reuse some general purpose views for owner kinds of rows. Now, these are not from Django. These are from me. I made them. And now I'm using them. So article list view extends owner list view. And then I can put all my things in there. The success URL, actually, I don't need that here, but for create view, I do need a success URL, but for create view, that success URL comes right from here. So I could have put it either here or I could have put it here. For me, it just kind of, after a while, I think this is prettier because now I can look all, the names of my arts, etc. So that's kind of nice. Okay, so here's views. We're going to come back to this. All the brains of this operation are in owner list view, owner detail view, create view, update view, and we'll look at that last. So that's where the hardest part is. But let's first look at the template. And so here's the template. This looks a lot like your autos. The only real difference here is that this edit and delete button is inside of an if statement. So it's, article update, article ID, article delete, article ID. That's the same. You've done that, right? But if all it says is if article.owner is equal to the current logged in user, article.owner is one of the article lists, and that's just one of the fields in the model, which happens to be a number, but we're given this user for free, right? It just hands us user, and so we can compare it. So if this is one that we own, we show this link, and if it's not one we own, we don't show the link, right? So we don't show the link for the ones that we own. Now, I hope by now you realize that we have to also protect, right? So if this is number 4, right, and if I click edit number 5, but what if I just change this to 4? We still, just not putting up the link does not mean that we can't have someone go to that link. So I'm cheating by putting in this link, but this is going to blow up, right? And so we'll show you how just because you don't put the link up doesn't mean that people can't go to the link. They can guess what the link is. I just did that. I went to an article I could update. I noticed the primary key of one I could not update to be 4, and then I went to 5, and then I just edited it, changed it to 4, and I attempted to update 4. So it's not good enough just to not show the link. That's actually not security. That just is prettiness, usability. Don't show a link that is going to blow up if you click on it. So that's not really protecting us. This if statement is not really protecting us from clicking on or attempting to go edit or delete. It's just not showing it if it's not going to work. Okay. And again, article.owner is just a column in this model, and user is the current logged in user. Okay? Okay. So what we'd seen before is I would create a view and then use it in my urls.py, and it would extend another view. So now it's time to take a look at where this view is being defined. And so here's our view, generic view, the generic list view, delete view. These are the generic ones, and all I'm really doing here is I'm creating a class called owner list view that extends list view. Now, it pulls in everything that list view is, and you'll notice I've added nothing to it. And I really could, because the list view doesn't really care. It's not really doing anything other than the fact that that value is in the models, so it's going to come in, right? So I could have made this be list view, but I just want it to be pretty. I want to make it so that I could just say owner list view, owner detail view, and so you'll notice that I'm not making any changes at the moment of inheritance. I'm not changing owner. So owner list view is exactly the same as list view, and owner detail is exactly the same as detail. I just did it to make it pretty in case later maybe I want to add some. But now we get to owner create view. Owner create view is something that matters a lot. So there's two things we've got to do for owner create view. So let's go ahead and start to add an article. So the first thing is there is no field here for which user it is. It would be kind of silly, and I can actually mess this up. So if I go to create view here and I add user, then if I hit refresh on the create view, come on, wait, back up. Oh, it's not user. Owner. So if I add it to that list, and part of this, what's going on here, is there is both a model and a form. This fields equals is informing the form, and the form is the user interface. So look at this. I'm allowing the user to specify it, and now they can set the owner. Pretty convenient. Well, that's not what we want. So that's why in this create view, you say, don't let them set the owner. I don't want them to see the owner, because it takes a little while for this thing to restart. Okay, now it's restarted, and I can hit refresh. So when it was blowing up, it was just because I was coming here too fast. What is that? I don't know what that is. So go back to the views. Maybe I have some tiny little bug. I'll dig through that bug later. It's working. It's probably passing the auto grader, so I'm pretty happy. So remember that there are two sides to this. One is the database side, and that's what the model deals with. And then there is a form. So these views, this list view, if you recall, once we tell it the model, it actually makes a form. So in this create view, it's making a form from article, copying all the fields in article or the fields according to this little list. And so that's why we're doing it. So the key there is we're explicitly not putting owner in there, and we're not putting created at or updated at. If I wanted to put created at in here, I'd say, hey, let's show them created at. Okay, let's refresh. Okay. Oh, okay. So again, it's trying to take a model, it's trying to go from the article model to make a form, and it's not an editable field, so it's mad at me. So I'll go back and fix it. I'm sorry. Okay, you get the idea. It uses this list of fields to make a form. The same for article and for update. In fact, the update and the create are so equivalent that the template for them is shared. It's basically, we'll talk about crispy tags separately in a different little video. The form is the same. The difference is when the update comes, there is already data in it. That's the only difference between a create and an update. It looks exactly the same, but update has data in it. A create has no data in it. So the code between create and update is super equivalent. Very, very similar, and the template is similar as well. Okay, so there we go. So we got create view, delete view, etc. Now, I'm going to focus on create view. And the key to create view is now in owner.py. Here's our form. That's pretty straightforward. In owner.py, this create view now has a little bit more to it. The list view and the detail view just inherited. So the first thing is that create view has a login required mixin. And that's because if you're going to create it, you need to be a logged in user. But to view it, you don't actually have to be a logged in user. Or if I was to, okay, let me log out here. So now I'm logged in as anybody, and so I can see all these. I can't edit any of them. I could log in if I want, and a detail view also works. So I'm completely logged out here, but add article, yeah. So add article is protected by login. So owner create view, login required mixin. And I do this because I don't want to trust the user who's writing this view to put the login required mixin here, because I am writing code right here that depends on the fact that this person is logged in. So this is like a guardian pattern. If I'm putting this in here so I don't end up with tracebacks inside my code. I don't want, if I didn't put this in if I didn't put login required mixin in owner create view, then they forgot to put owner in the views.py, they forgot to put it in an article create view, then this code would blow up. It would trace back at when I tried to set object owner to self request user. It would just blow up. Okay, so I'm extending create view, which is inheriting all the functionality, and I'm only going to override one method. This is object orientation. And you got to go read all the documentation. This documentation right here. Show you that documentation. Doop, doop, doop. So, this documentation is hard to find, and I'm sure I helped myself by doing some Stack Overflows. So that's why I put little notes at the bottom of the file, the things that took me a long time to find. So this form model mixin, and that is what they're really doing is they're giving us for these editing fields, like the update, they're saying these are the functions that are in this, and I can override them. So the one that I'm overriding is the form valid, and what that does is it basically says, here's your form, save it to the database, and set the current object for view, and then redirect to get success URL. Okay, that's its job, except that right before it's going to save the form instance, I want to do something myself. Okay, so what I'm doing here is I'm saying, and the form is what's being called as the parameter, which is the form that has been pulled in from the post data and handed to me. And so what I'm going to do is I'm going to say save it, but don't save it to the disk. That's what commit equals false means. Don't save it to the database. Just save it into this variable object. And then I'm going to set the object owner. I'm simply going to copy the current logged in user into owner. And then I'm going to set it to the database. And then what I'm going to do is I'm going to call the original form valid, passing form in as a parameter that's in this class. And that's really not going to do much, right? Because it knows that it's already been saved, so it's not going to save it again. And then what it's going to do is it's just going to do the redirect to the success URL. So this is rather late in the process of create view. It's been validated, it's checked for bad data, etc., etc., etc. And so this is like right before the redirect happens. Okay? And so at a high level, my whole goal was to pause the saving of this data to the database and sneak the current logged in user into the owner column and then be done with it. And so that's the basic overriding. I'm really extending form valid to cause my code to be called right before the default code is called. Okay? Okay, so that's owner create view, and that's how once I add an article and put some stuff in and I submit, right as I submit it, right before it's saved, there is a little field called owner that's going to be updated, boop, and it's there. And so the owner field came from this code. Now I don't have to, I could have put this in this view.py, but no, I got this really awesome creatable thing. I can write really cool code. I'm going to make hundreds of views and we will through the rest of the semester do this over and over and over again. We're never going to change this file again. Okay? So now let's talk about edit. Okay, so there's two things. So here we're going to load Article 6, and then we're going to put out a form that has all this stuff. So the first thing that's got to happen in owner update view is we got to check to see if this belongs to the current logged in user. Remember when I tried to go to whatever it was, 4 here, and it blew up? This is the moment where I'm going to protect it. So if we take a look at the moment where it's loading the model, do I have a link to that? Django populate. Let's go to Stack Overflow here. This one I got from Stack Overflow. Been there 10 years, probably a good one. Right. I don't like that one. Using middleware. Somewhere in here, I should make that link be a better link. Yeah. Oh, I like this one. I'm going to put a link in just to this one here. Link straight to that one. It's telling us what to do. You see, I just borrowed this right there. Form valid. Over. Oh wait, no, that was the create. Sorry. Yeah. Okay. Can't find quickly where I can do this, but query set. So query set is called when it's loading ID number 4. Okay, so it's going to do a load. So query set is not the actual load, but it is the query to the database that we're going to do. So what I'm going to do is I'm going to tweak the query set, and this query set is probably going to say, show me where ID equals 4, right? So I'm going to say, it's going to say something like select from articles where ID equals 4. And if I just did the normal query set, it would work. But I'm going to change the query set. I'm going to change the query set. So what I'm going to do is I'm going to call the default get query set in the superclass, which is the delete view class. And that's going to say query where the primary key equals 4 in this particular case. But then what I'm going to do is I'm going to add another filter. This is like and owner equals the current logged in user. So so number 4 is owned by user 2, but a logged in user is 1. So this is going to be and logged in as user 1. So when it does the query, it says give me the thing that's ID equals 4 and user ID equals 1. It's going to get no records. And so as the delete code or the update, am I looking at delete? Update and delete are the same here. Oop. Before it does an update, it has to load the old data. And I have made it so that if you're not loading data on something that you own, then it's going to give you a 404. So it's like that wasn't found. Now 4 does exist, it just doesn't exist for the current logged in user. But 5 does, and it does belong to me, right? Now the other thing is when it's going to call get query set again, new stuff, XYZ 1 2 3. So when you submit it, it actually is going to call get query set one more time before it actually stores the data. And so let me show you. This will be kind of tricky. So I'm going to try to mess with it on 4. I'm going to try to change 4. So I'm going to go into edit screen and I'm going to inspect element. Boop. And I am going to somewhere in here find where's that hidden? Where's the hidden? Oh, input type hidden. Right. So that is the input type equals hidden. No, that's the middleware token. That's not the one I want to change.
Oh, this is gonna, where's the, I would think that. Oh, it's because it's in this URL. I don't think if I change this to 4, it's actually going to work. But let's try it. It's probably not going to work. Yeah, that won't work. Okay, but the idea is eventually someone could mess with that post. So you still got to protect it. Right when that data is being modified, it actually does, it runs this code again, and it reads the thing, and if it can't read it, then it won't let you update it. And so that protects you from people breaking in and attacking there. And the owner delete view is the same thing. So if you go into delete, it does a get query set, and I add this filter to say, and it has to belong to the right person. So if I try to delete article 4, boom, it says I can't load article 4. But if I come over here, well, I got to log back in. So this one I think was CSEF. I think. Yeah. So now I can't delete number. But I can delete number 4 here because it kind of hides it, which is crappy, but there it is. It's deleting number 4, and away I go. So, okay, a lot of stuff. Okay, so here's the thing. We're going to use owner.py over and over and over again. We're going to write simple and elegant views, and all we have to do, ultimately, any model that we want to have this owner feature with, we add an owner column to it, then we have the views extend an owner view, and then everything's taken care of after that point. So it's really, we're not going to change a line of this. It's really cool. We're going to use it in project after project, on table after table after table, right? Because this can apply to different models. It's just this one happens to be applying to an article model. So I've built a super generic owner capability that I can use over and over. And just take your time, watch this more than once, review object orientation, figure this out. It's hard for me when I'm teaching to explain why object orientation is cool. Object orientation is cool because it can let you write these super elegant and very reliable. The fewer lines of code you write, the more reliable it is. But the harder it is to understand, because the magic is here in this object-oriented pattern. And again, it took me a long time to write this stuff, but now it's really gorgeous and really reusable. So keep thinking about object orientation. We're going to be doing a lot going forward in terms of object orientation. Okay? So I hope this helps. Cheers. Hello, and welcome to another screen recording for Django for Everybody. In this one, we're going to play with the Bootstrap menu. So what's a Bootstrap menu? A Bootstrap menu is a common bit that's going to be on a whole different set of pages. And so in this particular menu, we're going to have like a page 1, a page 2, a page 3 inside of a drop-down. And then we have kind of like a login drop-down. I'm already logged in, I'll log out. And then it switches when I'm logged in. When I'm logged in, it shows my gravatar. When I want to log in, I'll log in as CSEV DJ42 exclamation. Ooh, come on. Actually, I think let's call this DJ free. I think will work. Yeah, and so that shows a little picture based on your email address. And so I'll show you how all these things work. But again, we're talking multiple pages. Now, the couple things you'll see is we are changing the highlight of this. And so if I was to do a view source, these are completely different pages. And what you see is on the highlighted one, where was I? Page 2 is the highlighted one. I have a list tag for page 1, and then a list tag class equals active for page 2, and that's what makes this highlighted. So these are different pages.
So in this menu, we have to know what current page we're on, so we can look at the request path. It's page 2, so we know to put active on the page 2 one. So there'll be some logic inside this navigation bar. So let's take a look at some of the code. So I'm really going to do this all in templates. So you see I'm using template view in the urls.py, and I just have I got 3 pages that are all going to render the menu, menu/main menu HTML. And so there's nothing in the views of any importance. It's because I just got template view that I'm using. So let's take a quick look at the actual menu. So it's really quite simple, because one of the things you're going to do is you're going to have these pages and lots of them. So you don't want all of this HTML that's needed for this header sitting in every one of the pages. So we will use the extends mechanism in a template to say, oh, let's go and grab base menu.html and start with that. So we've been working with base Bootstrap, and Bootstrap uses all kinds of pages, but it doesn't have a menu, and it has areas that you can replace. So we've been working with base Bootstrap for a while, but now we want to do the menu. So what we're going to see is, instead of extending base Bootstrap, we're going to extend base menu, and that's our own local file. So you'll note that base menu extends base Bootstrap, and this is the same base Bootstrap we've been using all along. And what it basically does, this app tags, we'll talk about that in a second. That's how the Gravatar works. It is going to override this nav bar block, and you'll see that this goes all the way down. That's on just one big nav tag. And so the nav bar comes in right here, right after we say div class equals container. And then we have this welcome, we have these flash messages, area for flash alerts. Those are the messages that say, congratulations, you added a file. Congratulations, you deleted a file. And then the block content, and then the end of this container div. So block content is what we're going to override here. And the block nav bar is what we're overriding in menu. So block nav bar is being overridden. So we have one template that extends another template that extends another template. And so we're, just like any kind of object-oriented, we're sort of specializing and further specializing and further specializing. So Bootstrap can be used with or without a menu, but then once we add the menu to base Bootstrap, then we have base menu. Okay? So this is the top part of the page, and every page simply extends base menu and then puts whatever content it is. It says, just, I would like a menu here. So let's take a look at the menu. So the first thing you do is you go, I'm using Bootstrap. So if you go read up on Bootstrap, it'll tell you this is how you make a menu. And it tells you how to use the nav tag and what classes to put on the nav tag, how the container works, and the header, and the brand, and all these little classes. I didn't make this up. This is what Bootstrap said. This is how Bootstrap makes it pretty and dark and curvy little things, and they all line up nice, etc., etc. So I had to read that, and so this pretty much is taken straight from some sample code, except for one little thing, and that is the mechanism by which I, on different pages, can highlight which page I'm on, which is a very common